Hello and welcome to this course. I'm so happy that you're here. And before we dive right into the course, let's just make sure that you can get the most out of this course, because this is what you're here for, to learn SQL in the best possible way. So here are my top 3 tips that help you to get the most out of this course. My tip number 1 is to make use of the Udemy tools. This is an on-demand video course which enables you to work through this course on your own pace. So you can take out a little bit of time every day and work on this course in a very flexible manner. Of course, this also requires that you do take out a little bit of time every day and work on this course. So you need to have this consistency. And this course is structured in such a way that you have this daily structure. You can work on the course every day. You have these sections, and this will guide you step by step from the basic topics to an intermediate level, advanced, and then at the end of this course, I promise you that if you stick to it, you will be extremely proficient at the end of this course. So this is hopefully motivating you to just stick with it, take a little bit of time out every day and work on this course. Of course, this is an on-demand video player, so you can always visit the lectures whenever it suits you. You can skip back and forth in the lecture, go through all of the different lectures, and also you can adjust the playback rate of this video. So if I talk too slow for you, for example, you can increase the playback rate. Also, whenever you want, you can make notes on the second that you are currently in the video. So for example, here in lecture 103 at 1:30, I can just go to the notes section and select create a new note. And then I say, this is my note number 1, and then I can save this note. And now it appears in this section in the notes. So now I see at 1:30 I have this yellow icon where I see my note. And also I can always just jump to this lecture and this note, so it will immediately jump to the place where I have placed this note. Also, you have the Q&A section. So if you have a question regarding one lecture, you can just first of all search if the answer is already available. Somebody has maybe already asked this question. And if you can't find it in here, you can also just ask a new question. Also, I want to mention that very early in the course, you will be prompted to leave a rating of this course. I know this is very early and I have no influence on when this is appearing. So if you're bothered by that or you don't feel happy to leave a rating now, then you can just click on Ask Me Later or Ask Me at the end of this course. So it's totally fine to just skip this rating if you are not happy to do so. Of course, I'm always happy to receive your rating if you are happy to do so. And I hope that, of course, you are happy with this course, and I will do my best that you have a great experience with this course. And also, the best way to learn SQL is to learn it by doing it. And this is why this course is completely hands-on. So I want to encourage you to take advantage of that and work along all of the codings that we are doing. And also we have a lot of challenges that help you to practice. So I want to encourage you to also do these challenges and work on them. Even if they are sometimes a little bit more difficult, then you still benefit from working on them. And last but not least, I've mentioned you can always ask questions if you are stuck somewhere. And on the other side, it's also beneficial if you know the answer to a question someone else has asked, that you also help others, and this will also benefit you. And of course, I will also always stick around this Q&A section. So that's about that. And now we want to have a look at what we are learning in this course. And right after that, we want to jump immediately into SQL. So hope you're excited and see you in the next lecture. Let's just for 1 second talk about how this course is designed so that you will know how your journey will look like. This course is designed to guide you from a beginner level, this is where you are probably now at the moment, to the intermediate level, then through the advanced and the pro level. And this will be structured into different days. So every day you get a little bit better and you climb the ladder of your expertise with SQL. So of course, in the beginning, we will just cover the basic topics. Like we will set up a database locally on your machine. You will learn all of the basics about SQL and databases and tables. And then of course, also practically, we will work to write our first commands. So we will learn how we can query data, how we can filter it, and about the important group by statements. After that, we leave this beginner realm and we will learn about functions, conditional expressions, and how we can join define tables. So after that, you have a solid knowledge of SQL. So we are ready to dive into the more advanced topics like subqueries, unions, managing tables. This means we can create database objects and we define them, we can alter them, and we learn how we manage those. Also, we'll talk about so-called views, data manipulation. This means how we can update data and how we can insert data into existing tables. Of course, in the end, we'll also have a course project at this point. So we will dedicate one entire day to this course project so that you can again rehearse what you have learned and practice and test everything that you have learned so far. Of course, also in between, we'll have a lot of practice for every topic in every day. There will be enough practice for you, and I encourage you to also do these practice assignments so that you can really practice your knowledge. And then if you want to do the extra mile, you can go to the pro level as well. So this is really meaning what it says, because those topics, most people that are even quite proficient with SQL don't know about these topics. So this is something like window function, grouping sets, transactions, user-defined functions, stored procedures, and much more. And of course, in the end, there will be another advanced course project. So this will be now quite challenging, but this is how this course is built, so that you go from a beginner and step by step you acquire more and more knowledge, and your skill will advance step by step. So that's how this course is designed. Of course, if you are happy with being just at the intermediate or advanced level, then you can just leave it at that and maybe later on have a look at some of the pro topics, because you will have lifelong access to this course. So whenever you want, you can just say, now I want to go one step more and I want to also learn about these advanced or pro topics. So I hope you are now excited and ready for this journey. That's why we now want to start with the basics of SQL. How can we actually understand SQL? And that's what we are doing in the next lecture. Let's start with the question, why should we even bother learning SQL? And to understand the importance of that, we first want to answer the question, what actually is SQL and what do we use it for? So very quickly, SQL is just short for Structured Query Language. This means that SQL is the language we use to interact with a database. That means, for example, that we get data out of the database and we can, for example, also update or write data into the database. So let's have a look at how this works in practice. We all know that data is super important in all companies. And oftentimes, this is the most common scenario, data is stored in a structured form. And for that, we need to have databases. This means that in a database, we have a set of tables. So a table in a database is just a structured form of data. This means that in a table, we have columns and rows. So this is what we mean with structured data. And now, if we want to interact with this database, as we have mentioned, we want to use SQL for that, to, for example, get the data out of this database. But also, as we've mentioned, we can use SQL to analyze the data. This can, for example, mean that we join it with different tables. We'll learn later on what that means. We can aggregate the data, make some calculations, and with that get more insights out of our data. But of course, we can also write data back into the database and update existing data. So this is super important because a database is oftentimes behind many IT systems. And on top of that, we can also connect a database with different other applications, for example, Power BI, Tableau, or many other applications. So now that we have understood what actually SQL is and what we are using it for, let's come back to our initial question of why should we even learn now SQL? So we've learned data is everywhere and oftentimes it is stored in databases. And now my opinion and my statement that I'm super convinced of, that SQL is maybe the most important skill in a broad range of professions. And this is especially true if you want to become a data analyst, data scientist, business analyst, and even more professions that are not so specialized in working with data. So you can benefit from the knowledge and the skill in SQL in a broad range of professions. And in many, if you are working with data, it is, in my opinion, even the most important skill. And luckily, on top of that, it is also very easy and intuitive to learn. So this is a great combination because it's super important, super beneficial, but luckily it is not very complicated and it is very easy and intuitive to learn. And with that, mastering SQL is a great career booster, and this is why I recommend SQL the number one thing to learn if you are planning to become a data analyst, data scientist, or just in general want to advance your career and use this to do that. So with that in mind, and hopefully it was a good motivation for you, we now want to dive a little bit deeper and understand what is a database. So we now want to dive deeper, and after that we immediately want to get hands-on and start learning SQL. Now let's dive a little bit deeper and understand what actually is a database. We've already learned that companies use databases to store data in a structured form, in form of tables. So this means that we have data available in columns and rows. And we use SQL to interact with this database. That means, for example, that we want to tell the database management system what data we want to get out of the database. But now that we know that there are different tables in a database, we also want to mention already that there are also so-called schemas. And schemas is basically an additional layer that helps us to organize and structure our database. So you can think of this as, for example, on your PC, different folders. So in one schema, in one folder, you have different tables. And this just helps us to organize and structure the database. But we'll learn more about this later on in a more practical way. But we need to also now understand that if we have a database, we need to manage this database. And this is managed by a software, which is the so-called database management system. And in our case, we are using PostgreSQL for that. So this is the database management system. That is the software that is used to manage the database. But we, on top of that, also have a graphical interface. This is the interface that we use in a graphical way to create databases and to write our SQL queries in it. And if we are working on PostgreSQL, we use pgAdmin as our graphical interface. So both of these applications we are now also going to install on our local machine. But before we do that, we also want to mention that there are also other database management systems. And that's why in the next lecture, we want to also quickly talk about those other different database management systems and why it's a great idea to use Postgres just to learn SQL, because in the end you want to learn SQL. And that's why in the next lecture we want to get some clarity on these different database management systems and how we use them to learn SQL in general. In the last lecture we've learned that there's not one single database management system, but there are multiple of them. And this also means that the SQL that is used in those different database management systems is also slightly different. So we refer to this as different dialects, because in the end it is just one language, this is SQL, but there are just some slight differences. So this is why we refer to this as different dialects. But don't worry, if you want to learn SQL, you can just choose one of them, and then the differences are so small that the transition to the other database management systems is super easy. And in fact, Postgres is the one that is even the closest to the standard SQL. And this is one of the main reasons why we want to start, if we want to learn SQL, with learning PostgreSQL. Because this is the one that is the closest to the standard, and with that you are the most flexible, and the transition to the other dialects will be the easiest for you. So this is the number one reason why we want to use Postgres. And on top of that, why we want to use PostgreSQL to start our journey in SQL is because it is even completely free to download and use. It is one of the most popular database management systems, and in fact the most advanced database management system in the world. so you can learn all of the different functions and options you have available in SQL, and all of those reasons combined make PostgreSQL, in my opinion, the best database management system if you want to start learning SQL. So this is why in the next lecture we now want to get hands-on, start learning SQL, and that's why we want to start with installing, of course, PostgreSQL and then our graphical interface pgAdmin. Now let's get started with installing the tools that we are going to need in this course. So this will be one, PostgreSQL, our database management system, and then on the other side we also need pgAdmin, our graphical interface. And luckily we can install both of them together in one package. So let's go ahead and jump into our browser where we are going to search for PostgreSQL download. Then the first link, that is not an ad of course, should be PostgreSQL downloads. So this is the link that we are going to use, and in here we can now choose our operating system first. So this video is now of course for Windows. If you are on a Mac operating system, then you should of course just use the Mac video. In our case, we are therefore just going to select Windows, and in here we can now go ahead and download the installer. This will just make it a bit easier for us to install both of these tools together. So that's why we just click here on download, and in here again we can now just choose the PostgreSQL version for our operating system. So since I assume that you will probably also be on a 64-bit version, most of the Windows systems nowadays are 64-bit, that's why we are going to select this top link in here. And note that of course this version can be different in your case if there's a newer version available, but you can just go ahead and download your latest version. And if you should have some problems, then you can also try a lower version. But usually you shouldn't have any problems if you just go ahead with the latest version that is available for you. So in my case it's 14, and that's why I will just click here on this link, and this will now download this installation file. So once this has been downloaded, we can just navigate to the folder and open up this installation file, and this should now open up the installation wizard. So in here we can just start the installation by clicking on next. The directory where this will be installed we can just leave at the default, click on next, and for all of the components that are here checked we can also just leave them at the default. As I've mentioned, we can install PostgreSQL together with pgAdmin in one package, and those other two we don't really need, but anyways we can just leave them at the default. So once we have all of them checked, so we don't need to change anything in here, we can click on next. Also the directory for the data storage we can leave at the default and just click on next. Afterwards we have to set up a password for the database super user. So the username will be Postgres. And in here, this is not really a security issue, and that's why I recommend to just use a very simple password. So this is very important that you remember this password. So that's why I encourage you to use a very simple password and also to write it somewhere down. So I will just use the very simple password called password. And again, this is not a security issue because you are just installing this locally on your machine, and anyways, we are not using any sensitive data. So that's why I just use the password called password, and I click on next. Afterwards you have to select the port number, and also in here you don't need to change anything, just use the default setting in here. So in my case this is probably the case also in your situation, it is 5432, but even if you have a different number, don't worry, just use the default number that you see. So I'm just going to click again on next, and also the locale we can just leave at the default settings. And afterwards we just click again on next, and then the installation will be started. This installation might take a couple of minutes, but then afterwards it should be completed. And now we just need to uncheck this box, and now once we have unchecked this box we can click on finish, and we have successfully installed pgAdmin together with PostgreSQL. Now if we want to start up pgAdmin, we can do this by just going to the Windows search, and in here we can just enter pgAdmin. So this is what we are going to select. And then this will open up in a new window, and we have to, of course, now enter our password that we have chosen in the installation. So in my case, this was the password called password. So that's what I'm going to enter in here. Then I can just click on OK, and then I will see at the left side those servers. So in here I can expand them, and I will just expand also the latest version because I've installed also some previous versions, but if you don't see them, don't worry. Just click on the latest version that you see, and then once you expand this, in my case PostgreSQL 14, it will show the available database objects. So we don't need to be concerned with all of them right now, but we see that we can expand the database that's already installed, which is called Postgres. And in here, we can now also expand the schemas. So we have already talked about the fact that we have schemas in our database that we use to organize our tables and other database objects. So they are basically like folders. And the public schema is the default schema that is usually available always in the beginning. So this is all that we need to know. And now we, of course, want to also set up our database that we are going to work with. So that's why we want to set up this database in the next lecture and then get to know SQL and also get a quick overview of pgAdmin. So that's what we are going to do in the next lecture. Let's have a look now at how we can also install PostgreSQL and pgAdmin also on a Mac. So we in Google just search for PostgreSQL, and then we find the website postgresql.org. This is the one that we select. In here, we just have to navigate to download. We can also find this in the top navigation. That's what we select. In here, we can choose our operating system. We will choose macOS. In here, we select download the installer, and then we can download our versions. So in here, we just go to the latest version. In this case, we of course choose macOS. Then the installation file will be downloaded, and we can then just open that up on our local machine. Then this is opening up. Of course, we enter our password, and then the installation will start. In here we can just click on next. Then the directory we can leave. In here we can also leave everything as it is. This we can also leave. And in here it is important to set up our database user. So in here I just recommend, this is not a very sensitive topic. That's why choose a very simple password. I will just choose the password called password. This is something that we have to remember. And in here also the port we can just leave as it is. So if the number is different in your case, don't worry, just leave it as it is, and we can just here click on next. Usually it should be though 5432. So we can here just click on next as well. In here we can also leave everything as it is. Again on next, again on next, and then the installation will take place on your computer. And then after a few seconds or minutes, this will be done. We can uncheck this box to launch Stack Builder, and then we just click on Finish. And now if we want to open up pgAdmin, we can just search for pgAdmin. This is now the graphical interface that we use to manage our database and write our queries. So this is where we will write all of the SQL commands, and this is then just opening up like this. So we just search for pgAdmin and then it will open up. In here we can set a master password. I again recommend to just choose something very easy. This is not something that is very sensitive, so just choose again something very easy. I will just go again with the word password, so something super simple. This is not a security issue. So in here, we now have to enter our password for the Postgres user. So that's the one that we have chosen in the beginning in the installation. So again, I'm entering the password. And now here on the left side, we can open up our Postgres version. Below that, we have the databases. So we don't need to be concerned with all of them right now, but we see that we can expand the database that's already installed, which is called Postgres. And in here, we can now also expand the schemas. So we have already talked about the fact that we have schemas in our database that we use to organize our tables and other database objects. So they are basically like folders. And the public schema is the default schema that is usually available always in the beginning. So this is all that we need to know. And now we, of course, want to also set up our database that we are going to work with. So that's why we want to set up this database in the next lecture and then get to know SQL and also get a quick overview of pgAdmin. So that's what we are going to do in the next lecture. Now let's get started with setting up our database that we are going to use in our course project. In this course project, you will be hired as a data analyst for a company, and you have to analyze the data and manage this database in this company. So this will be our course project that we are going to introduce in the next lecture. In this lecture, we want to set up our database and all of the data that we are going to work with. So this is what we will do. But now I also just quickly want to mention that you can always open up pgAdmin by searching for pgAdmin in the window search. And I have also just maximized this window. So this is possible. But now let's set up the database. The first step that we are going to do is create the plain database as an object in pgAdmin. So we do this by just right-clicking on the database and of course make sure that you have expanded the latest PostgreSQL version, and then you will see the database where you can click on Create Database. In here we can now give the database a name, and this will be our name green cycles. For the rest, we don't need to make any additional changes. We can now just click on Save and the database will be set up. So we can see that now here we have again, if we expand the schema, our default schema called public. But now if we go down to the tables, which is the most important part of our database, we can see that there is currently nothing included. That's why we now also need to fill this database with some life. This means with tables and data in these tables. And this is why we now want to just download the resource file in this lecture. And then once we have downloaded that, we can also extract this file, and this will be now our file that we are going to execute in pgAdmin. So we can just open that folder up and we can see that there is this so-called SQL file. Basically, it is just a text file that contains all of the code to set up our database. So how do we do that? What we want to do is we want to now copy this folder path. So we can click in the Explorer and just copy that. And now this folder path we want to now also paste in pgAdmin. Let's jump over to pgAdmin to do that. We now first open up the so-called query editor. We do this by right-clicking on the schema, and in here we find the option Query Tool. And then this new window will open up where we can now write our code. This is basically where we enter all of the SQL commands, and we will do and spend a lot of time in here in this course. But for now, we just want to insert our SQL file that we have just extracted. We can do that quickly just by going to this little icon where it says Open File. And in here, we can just click on Yes. And then we just need to paste this folder path that we have just copied in here. And we should be able to see now this SQL file in this folder. If you don't see that, just make sure that you have all files selected in here and also that you have pasted in the right folder path. So now I'm just going to select this SQL file and then the file will be inserted in this query editor. And now we just need to execute this code, and we can do that by either pressing F5 or just clicking on this little play button. And then afterwards we will see that the query has been returned successfully. So now if we refresh our schema, we can do that by right-clicking and then going to refresh. We will see if we now expand the tables that now there will be tables included. So let's quickly also write our first query before we then go ahead and introduce our course project. So for that, let's click again into the query editor, and we want to hold Control A to select everything, and then we can delete everything, and we want to write now our first quick query, which we'll learn a bit more about later on as well. For now, we just want to write select star from public, which is our schema, dot actor. And if we do that, we hit F5, we will see that now this is returning us some data. This was our first SQL command, which we have used to return the table actor from the schema public. And we've just used a very simple command, select star from for that. But don't worry, we'll learn about that later on in much more detail and step by step. For now, we have successfully set up our database, and that's why we are now ready to introduce our course project. Let's introduce the course project. In this project, you are in the shoes of a data analyst that just got hired by a company that has recently acquired a business called Green Cycles, and this is an online movie rental shop. So this course will be super hands-on and as realistic as possible. So this is why you will play the role of a data analyst, and you have to help this company to operate the database. This means that you have to write queries and help the company to succeed, because this data in this database that we are going to work with is super important for the success of the company, and this is why your job is to work on this database, work on these tables, write queries, analyze the data, and basically help the company to succeed with this new business. This is why you need to gain insights and help the company to solve problems. And of course, step by step, your skills should also progress and get more and more advanced. So the database that you are going to work on is this database with many different tables. So you see that it's fairly complex, which helps you to get a real life scenario and learn SQL for real life scenarios as well. So step by step, your skills in this course should advance, and we will do this in this project where you are going to explore meaningful data, get insights to help the company to make the right decisions, and basically just help the company to operate. And as mentioned, step by step, your skills will become more and more advanced, the queries will become more and more advanced, and you will learn everything that you need to know about SQL and working as a data analyst on this database. So this is now the course project, and now that we have this in mind, we can start immediately with the first SQL statement, and this will be the select statement. That's what we are going to have a look at in the next lecture. Now let's get started with learning about the most basic keyword and statement in SQL. And this is the so-called select keyword. This is always present in all of our SQL queries, and we use that, as the term suggests, to select and return data. So this is always present in our queries, and this is also very easy to use. Let's see how this syntax works and how our most basic statement looks like. In the beginning, we of course use that keyword select, and then what columns we want to see. So in this case, it could be a column name, and then from, and then the table name. And now let's have a look at one example of how this could look like. We want to select, in our case, the column called first name from the table called actor. And the result of that would be just this column name first name with all of these data entries. So this is very simple. But now what happens if we want to see multiple columns? In this case, we can again, of course, just use the select statement. We use the first column name that we want to see, for example, first name, and then we need to separate the other columns with a comma. Afterwards, we use another column, for example. And note in the end, before we use our from statement again, we don't have a comma. So this is very important, just between the column names, but in the end, there is no comma. And then, of course, the result again is the data output for those two columns. But now we also have something that we can use to show all of the columns in a table. So let's assume we have 50 columns and we don't want to name them all separately. Then we can use select star from the table. So we use this asterisk, and this means just that we want to see all of the columns in this specified table. And then the result of that is just, in our case, all of those columns, in this case 4 columns of this table. So you see that this statement is not very complicated, and we'll see that now in action. But before that, I want to make one quick remark, and this is that the formatting of this code doesn't matter. This means that we can either write the code like this, as we have seen it in our example, or we can also just format it in a different way. That means we just start the new line here and we write the column names in one row, or we can also just write everything in one row, or we can even use some additional lines in between, and they will all be interpreted in the same way. So this is basically all the same. And now I think this is enough theory for now, and now we of course want to apply this knowledge, and this is why we now want to jump into pgAdmin. And in here we first want to get a few basics again. And this is why we first want to now close this window again so that we start from fresh. To do this, we just select this little X icon, we say don't save, and then our query editor, this means where we write the code, is closed. And also we want to just collapse all of these options here, and we want to start from fresh. So we want to expand our server. This is where all of the databases are included. And then we have, in our case, 2 databases. We can again expand them, and we see that we have our green cycles database. In this database, as we have learned, we can have multiple schemas. The default schema that is always available is the so-called public schema. And again, we use those schemas to structure and organize our database. In our case, we have just this one schema. And now if we want to open up our query editor, we can do this by right-clicking on this database called Green Cycles. And in here, we can now select the query tool. And in here, we see now that the query editor is opening, and we can in here now enter our SQL code. So let's see what we want to do. We can select, and then we can use just the asterisk to see everything in this table. And then and now what is the table that we want to see? We can also have a look at this by expanding the schema public. And in here we see that we have 15 tables. We want to see now the table called address. And this is why we want to say from address. And now if we want to execute this code, we can either press this little play button. Let's see how this works. Or we can also do the same thing by just pressing the F5 button on our keyboard. And this will also execute the code that we have entered in here. And now we see that we have this data, these columns, and all of those data entries in this table available. Let's assume we now only want to see the column address and district. How can we do this? This is very simple. We just enter the column name address, we use a comma, and then we use also the district column. And again, we press F5 and we see that the data is returned. And note again that it doesn't matter how we format this will always show the same result. So this is our most basic SQL statement. And of course, now we also want to practice that. And this is what we are going to do in the next lecture in a challenge. Now let's get started with your first challenge. This challenge will help you to apply your knowledge, and that's why I will urge you also to do these challenges and not skip them, because this is one of the most important factors for your success in SQL, and that's why we have a lot of challenges in this course, and we try to make it as realistic and helpful as possible. So hope you're excited for this challenge. In this challenge, now your first day as a data analyst has started. So this is your first day in the company, you have access to the database, and now the marketing manager asks you for a list of all of the customers of this rental shop. And they want to see the list with the first name of the customer, the last name, and also the customer's email address. So this is your first job, your first task in your new job, and now you should write a SQL query to get that list. So what you have to do is identify the right table and then also the right columns in this table. So hope you're excited for this challenge, and afterwards we'll have a look together at the solution. Now let's have a look at how we can solve this challenge and get this list of all of these customers with first name, last name and email address. That's why we want to, of course, jump into pgAdmin, and the first thing that we want to do is, of course, find the right table for that. And we can see a list of all of our tables. If we are in our database, in our schema that we can expand, we find, of course, our tables. We can expand that too. And now we just need to search for a table that could contain the customers. And we can see that here is this table called customer. So this is probably the table that we want to query from. Again, we can expand it and see that in the columns, we have those columns available. But we can also just use a simple select star to see what the data in this table looks like. So let's see how we can write this query. Of course, we want to use select, and now we can use star from, and then the table name in here is customer. And then we just execute it with F5, and we see that these are all of these columns in this table. And we see also we have the columns that we are looking for, which is first name, last name and email address. So that's why we can now specify our query even further to only see the columns that we are interested in. So we want to use first name. We want to separate this with a comma, go into the next line just to make it a bit more readable. Then we have a last name, and then again in the end, email. So we can now execute it like this, and note that we have no comma in the end. So we execute it and we get all of these results. This comma in the end is something that will cause an error, and this is one of the most common errors that we see, that there is an additional comma where there is no comma supposed to be, or just also sometimes a comma that is missing. And we can see this error message in here, that there's a syntax error near from. And also we get this line 5, and it is also underlined with these red dots. So this will help us to find where the error is occurring. And then if we see that, we can just remove this comma and like this fix this error. So this is how we can find out about the errors, and then we can easily also solve that. Now we have this list, and we can now even export this list. Of course, this is something that we have not learned yet, but we can very quickly see how this works by just clicking on this little button where it says save results to file. And of course, we just have to specify a location where we want to save this data output. And it will be saved, in our case, as a CSV file. So if we do it like this, we can save it, and then if we just navigate to this location and open up this file, we will see that now we have this list. And of course, this is a little bit easier for the marketing team to work with because they can't work on the database. So this is just some additional tip that you can get by just clicking this button to export basically the results to a CSV file. And now in the next lecture, we also want to learn how we can sort the data output by a column. And that's what we are going to do in the next lecture. Now let's have a look at the order by clause. This is the clause that we can use to order our results based on a column that we specify. And then in this case, we can order either alphabetically, numerically, chronologically, just depending on the data type of the column. So, for example, if we have a date column, of course, the results will be ordered in a chronological way. Now, let's have a look at how we can use this order by clause. Of course, in the beginning, we just want to select the columns from a specified table. And then towards the end of our statement, we mention the keyword order by, and then the column that we want to order our results by. Let's have a look at one example of that. In this case, we want to again select the first name and last name from the actor table, and now we want to order by the first name. This is why we just add the keyword order by and then the column name called first name. And in this case, the results will be now ordered by the column called first name. And Adam, of course, is in the beginning. Now, if we don't want to start with A, but we want to start with Z, for example, then we can also add the keywords descending, DESC, or ascending, ASC. So in this case, if we want to change the order in a descending order, we can just after the column that it should be ordered by, the keyword DESC. And in this case, we start now with a Z. And also, we can mention ASC, which is just the default value. That means that if we don't specify anything, it will be always in an ascending order. So it doesn't actually matter in terms of the result if we use that ASC or if we just leave it away. Now the question might be, why would we even bother mentioning ASC if this is the default anyways? And here we can just think of the readability, and this just helps to understand the code quicker. If you, for example, look at your code 2 weeks later, then you see that it was important for you to order the results in an ascending order. So this is just to make it a bit more understandable and readable. And now, if we see that there can be also duplicate values, we also want to order sometimes by multiple columns. So in this case, if we have a tie with Adam, so this is just the same value in the first name, in this case of a tie, we can have also a second criterion. For example, in this case, the last name, and then Grant comes before Hopper in this case. Of course, also, even if we have multiple columns, we can still use the descending or ascending keyword. We just have to attach it to the column. In this case, we have the first name in a descending order and then the last name in an ascending order. This is about the order by clause. Now let's jump into pgAdmin and have a look at how this works in practice. In our case, we first want to have a look at the payments table. This is why we first want to just select everything from this payments table. So this is why we just use the select star. And then we want to see what is actually in this table. And now we see that there's no specific nice ordering in terms of our customers. This is why we want to also order now by the column called customer ID. And then we see that we have now the ordering by the customer. And we see now we have all of this in a nice order. But now we also want to see always in the beginning of every customer what was the highest payment amount. And this is why we now also want to add a second criterion. In our case, this is the amount. So now if we have a look at the results, we see that the amount is now also ordered for every single customer. So first we have customer ID 1 and we start with the lowest amount and then we get higher and higher until we come to the next customer. But now of course we would like to see the highest amount in the beginning because this is most important to us. And this is why after the column amount we also want to use the keyword descending. And now if we execute that, we see that now still the customer ID is in an ascending order, but now the amount is in a descending order. So this is how we would like to have it. But now it's your time to put this into practice again, and this is your chance because you get another request from the marketing manager that we want to have a look at in the next lecture. Now the marketing team again needs your help and you want to help them to make their work easier. And that's why the marketing manager now asks you to order the customer list that you have already given them by the last name. And they want to start working from Z towards A in that list. And also, in case there is the same last name multiple times in the list, you should, as a second criterion, also order by the first name. And the first name, in this case, as a second criterion, should also be from Z to A. So this is now your challenge to make the work more easy for the marketing team and write a SQL query to get that list for the marketing manager. And afterwards, of course, again, we'll have a look at the solution and one additional trick that you don't want to miss out on. But first, of course, I hope that you will enjoy the challenge and find out the solution. Now let's have a look at how we can find a solution to the request of the marketing manager. First, of course, we want to select the columns, first name, last name, and also the email address from the table customer. And this is the result that we had already previously. But now, of course, we want to also order this by, and this is why we use the order by clause, and we want to order this by first criterion, the last name, and second criterion, the first name. And now, of course, the result is, as we have not specified any descending or ascending keyword, it will be per default in an ascending order. That means we start in the last name with an A. But of course, we would like to have the descending order. This is why we need to specify the keyword descending after the last name column. And in fact, since we want to have both columns in a descending order, we need to specify the descending keyword also in both of these columns. And then if we execute it like this, we get our desired result. But now I have promised that there's also a trick that we want to talk about in this solution. And this is to use, instead of the column names, the numbers of the column. And this is the number in the output. So in this case, the second column is the last name column. And this is why instead of the last name text, we can also use the number 2 for the second column. And then the result will be exactly the same. And also the same thing we can also do for first name. This is the first column in our data output, and this is why we can just replace it with the number 1, and in fact we get the same result. This is something that we oftentimes use if we are, let's say, a bit lazy and we just want to have a quick result. This is totally fine, and I do this myself as well, but in fact it is not really a best practice. And this is because, same with the ascending keyword, which helps to make the code more readable, it is actually a best practice to really use the column names as a text, because this helps with the readability. And like this, we can really quickly see what is the column that this is ordered by. Whereas the numbers don't really make it so easy to quickly understand what is actually now this column that is ordered by. And that's why, yes, you can use the numbers as well. This is just if you want to have a quick result, but if the code is important and should be more readable for other people as well, then it is just a best practice to really use the column names as a text. But now there can be still some duplicate values, and there is a way to get rid of those duplicates. And this is what we want to have a look at in the next lecture. Now let's have a look at a variation of the select statement. And this is to use select distinct instead of just select. And this is used, as the name suggests, to select the distinct values in a table. Now first let's have a look at how we use this statement. It is in fact just used in the same way as the select statement. We just use select distinct and then the column name that we want to select the distinct values from. And of course, we can also, as we later on see, use select distinct together with multiple columns. But first, let's have a look at a very easy example. And in this case, we want to select the distinct values of the first name column from the actor table. And the result will look like this. Of course, now there can't be any duplicates. We can also use it together with order by. And previously, we had Adam occurring twice. But now as we use select distinct, Adam, of course, only occurs once. And this is because we use now select distinct. But now, how does it look like if we use it with multiple columns? Now, if we use it like this, Adam can occur again multiple times. This is because it is different in the last name column. And as long as there is a difference in one of the columns, the row will appear as an own row. So this is important to note, that this distinct means distinct in terms of all selected columns. As long as there's a difference in one of the columns, the row will be displayed. So this is how select distinct works. Now let's see how this looks like in practice and jump into pgAdmin. In this case, we now are interested in our film table. This is why we want to use select star from film, just to have a look at this film table. And in this table, we see that there is this column called rating. And now we can see there are so many values, and we just would like to get an idea what are the different ratings that are available in this table. This is why we want to use the command select distinct and then the rating column, and then of course from film. And now we can easily see that there are these 5 different values. So this is how we can use the select distinct to just get a quick idea of what are the different values in this table. But of course, we can now, if we want, also combine it with additional columns. So for example, we can combine it with the rental duration. Rental duration. So if we, for example, just use rental duration itself, we see that there are now also 5 different rental durations in this entire table. But now if we combine it with the rating, we will see all combinations, so all distinct combinations of rating and rental duration. So this means now that the values in the column rating are not necessarily unique, but the values will be unique across all of the columns. So we can see this row number 2 is different in the rental duration. So this is important to understand, that distinct is across all of the columns. So this was our select distinct, and now you get another challenge from the marketing manager that has another request for you. Now let's practice again what we've learned about select distinct. In this challenge, one member of the marketing team asks you about the different prices in the business that have been paid in the past. And to make things easier for them, you can also order those prices from high to low. So this is your challenge, to write a SQL query to get those different prices. And now also to show you what the result looks like so that you can verify your result. This is how the output should look like. And again, I want to encourage you to really do this challenge, because this is what will help you to learn SQL in practice. So now let's go ahead and try to solve this challenge, and afterwards we'll have a look together at the solution. Now let's have a look at the solution to the select distinct challenge, where we are trying to get a list of the distinct prices that should look something like this. So we are going to jump into pgAdmin, and first of course we need to have a look at what is a table that we can pull this data from. So this is why we should also open up now the tables section, and in here we see a few things. So for example, we see rental and payment, and if we open up rental, we can see that there is no amount or no payment amount. So this is why we can also have a look at payment. And in here, if we open up the columns, we can see something that says amount. So this is something that could be what we are interested in. So that's why we first want to have an overview of this table. We can just use select star from payment, and indeed here we have the payment amount. So now what we can do is just use, we are only interested in the amount. So we only want to see amount. And of course, as we have mentioned, we also want to order this. That's why we also add order by, and then we can write amount, and we want to order that from high to low. This means in a descending order. This is why we also want to add descending. Now let's have a look at what the result looks like, and indeed we see now the highest prices at the top. We see only the amount, but we see that there are many duplicates, and this is because of course we didn't use select distinct but just select, and like this it's not really helpful. This is why we want to use select distinct to see only the distinct amounts, and again if we execute it like this, we get our desired result. But sometimes we are not interested in all of the results, but we want to limit our outputs to a certain number of rows. So for example, we only want to see the first 100 or the first 5 or 3 results in the output. And this is a very important command. That is the limit command, and this is what we want to learn about in the next lecture. Now let's have a look at the limit command that we can use to limit the number of rows in our data output. And the syntax is very simple, because this limit keyword is always at the end of our query. And we'll see soon an example, but oftentimes this is used to just get a quick idea about a table. So we just see a few rows, this will be executed very fast, and like this we get a quick idea about a table. But before we have a look at this example, we just want to see the syntax. And as mentioned, this is very simple because it is just at the very end of our query where we use the keyword limit and then the number of rows that we would like to see in the output. For example, if we would like to see those 4 first rows, we would use select first name from the actor table, and then of course a limit 4, because we want to see the first 4 results. And oftentimes this is used in conjunction with the order by clause. And again, limit is always in the end. This is why it is order by and then limit. So this would give us the result like this, and this is oftentimes used together with order by, because like this we can see, for example, the first results or the last results in a table. But now we want to have a live example, and this is why let's jump into pgAdmin. In here we see that we have this rental table. And in this case, we are interested in the last rentals that we have received. We want to see the last 5 rentals. This is why first we want to just have a look at this table in general. We therefore use just select star from rental. And in here we see now that there are a lot of results, and sometimes if we use select star from and then a table, this can take quite a while to be executed depending on the amount of data that is available in there. And this is why if we just want to get a quick idea about the table, we can oftentimes just limit the amount to, let's say, the first 10 or the first 100 results. And this will be then executed much faster. This is especially relevant if it's a huge table. So like this we see limit 100, and we'll see only the first 100 rows. But now in our case, we would like to find out about the latest 10 rentals. And this is why we want to order by the rental date. And then also we would like to limit the amount to the first 10 results. So if we use order by rental date, if we do this in a descending order, this means that the last date of the rentals will be at the top. We see the latest 10 rental dates. And if we do that, we see that this is at the top, and this is exactly what we would like to have. And now, as the last thing that we want to learn today, we want to have a look at the count command. This is very important because this can count the rows in a table. And we'll use those kind of aggregations quite a lot. This is why this is a very important function that we are going to learn about in the next lecture. Now we want to learn about our first function, and this is the count function. With that we can count the number of rows in a given table. Oftentimes, this count function is used in combination with other functions and methods such as grouping and filtering. And of course, more of these combinations and use cases we'll learn about later on. But for now, we just want to focus on the basics here. So how do we use this count function? Of course, first we start with select as always, and then we use count star to count the number of rows in a given table. What we can also do is, instead of count star, use count column names. Oftentimes this will return the exact same result, and this just makes it a little bit more understandable again what you had in mind when you wanted to count these rows in this table. But what you should keep in mind that there can be a different result as well. And this is when in this column that we want to use in this count, if there are null values. In this case, those nulls will not be counted, and this is why the result can be different. But usually this will be exact the same result, and in fact it is more common to just use count star to just see the number of rows in this table. So now let's have a look at an example of that. We can, for example, count the number of rows in the table first name. So if we do that, we get the result 200, and this is the exact same result as if we would just use count star. So count star is the common way of doing it, but we could also use first name in this count function. And if there are no nulls, it will also return the exact same result. But now there's also one additional variation, and this is using count in combination with distinct. Note that we have to also write this distinct keyword in this parentheses. So this should be then together with the column name. And in this case, the result in fact is different, because now we only count the distinct first names. So if there are some duplicates, they will not be counted again. So this is a variation of using count in combination with distinct. But now let's jump into pgAdmin and have a look at some examples in real life. So we want to again now have a look at the table of our customers. This is why we use select star from customer. And if we are now interested in how many customers do we actually have, we can just use the command count and then star from customer. And we see we have 599 customers. And if we now are interested in how many actual values do we have, so in the first name, if there are any nulls, we can also execute that. And we see this is the same result. This means that there are no nulls in this first name column. And now if we are interested in how many different results we have, then we can also add the keyword distinct. And in this case, we get a different result because now we have only 591 distinct first names. And of course, later on, we learn a lot more combinations and use cases for this count function. But for now, we have learned quite a lot for today. And this is why we now just want to summarize what we've learned and of course also have some more practice again. Now we are ready for today's challenge that you can again use to apply your knowledge and practice everything that you have learned today. And with that, I also want to note that this is something that you should really try to implement yourself, to just go over these challenges and find solutions to them. This will help you to think about what you have learned today and to really understand what we have learned today. So this is my encouragement that you really do those challenges. Now let's just quickly go over how you can go about those challenges. So in the beginning, we will just introduce the challenges, so the individual tasks for the day. And then afterwards, of course, then you should just go ahead and try to find solutions to them. So write the SQL code and experiment with the solutions. Then afterwards, to verify your results, you get the data outputs. So like this, you can just verify your solution. And then if you should have some doubts, we can again go together over the solution. And here I also want to note that this is just my solution, which means it is one solution and your solution could be different, but anyways, it could be correct. So it's more important to get the results that you wanted to achieve. And if this is a little bit different than what I have, this is not an issue because there can be always multiple correct solutions. But now with that in mind, let's go over this list for today's challenges. So we want to start with the first challenge, which is to create a list of all of the distinct districts of the customers. And part of the challenge, of course, always is also to find the right tables that we want to work with and of course the right columns. So this is always part of the challenge. And then the second question, what is the latest rental date in the database? So the latest rental date, and here I want to just make a quick note that you can limit the result because we are only interested in one data row, only the one latest rental date. So this is some optional additional thing that you can do to just limit the data output. Now the next question is, how many films does the company have? And the last question for today is, how many distinct last names of the customers are there in our database? So now you can pause the video and go ahead to try to find a solution to those questions. And now if you are ready, if you have finished these questions and if you have really worked on them, we can now together have a look at the solutions, or to be more precise, just the data outputs, so that you can verify your results. And we want to start with result number 1 and then result number 2. Again, here we have limited the amount of data rows to just one data row because we are just interested in the one latest rental date. But of course, it is not necessarily false if you have here multiple data rows. And then result number 3 is 1000, and then the last result is 599. If you have different results, you can have a look at your solution again. Otherwise, we'll now just quickly have a look at all of the solutions. So let's start with question number 1, which was create a list of all of the distinct districts. So of course we want to use select distinct because we want to see the distinct districts. We have the column called district from the address table. This was not super difficult, hopefully. Solution number 2, what is the latest rental date? Here we want to use just select, and then we want to see, of course, the column rental date from the table rental. And what we can do now as well is to order the results by this rental date, because we want to see the latest rental date at the top, and this is why we want to start with the latest date, which would mean that we have to sort it in a descending order. And of course, optionally, we can also limit the amount of data rows to 1 because we are only interested in the very top result. So this was question number 2. And now the question number 3, how many films does the company have? We therefore need to just count the data rows from the table film. And the last question for today, how many distinct last names of the customers are there? We of course want to use select and then count distinct last names. Make sure that you use in the parentheses distinct and then the column name that you want to count the distinct values from, which in our case is last name. Of course, table name is customer. So these were today's challenges. I hope that this could help you to again apply your knowledge. Hope it was helpful and see you in the next lecture. Now that we've learned so many things today, let's just quickly go over today's summary to just quickly summarize the most important parts that we have learned today. In the beginning, we have learned that SQL just stands for Structured Query Language, and we use that to interact with the data on our database. This means we want to, for example, retrieve data or update data in the database. So this is why we want to use SQL to work on the data in our database. Now, why should we learn SQL? We've also learned that this is one of the most important skills if we want to work as a data analyst, data scientist, business analyst, and that we can benefit in a broad range of professions from the skill of SQL. And on top of that, it is very easy and super intuitive to learn. So it's a great win that we can have if we want to learn SQL. So this is what we have learned. Afterwards, we quickly had a look at databases. So a database is nothing but a set of tables in which we store structured data. So this is the data that we have. We have columns and rows. And we, of course, we have seen we retrieve the data using commands in SQL. But now we want to work on these databases, and this is why we need to have a database management system. In our case, we use Postgres and pgAdmin as the graphical interface. This is just so that we can write our queries and that we can graphically interact with the tables and the database. So PostgreSQL we have used because it is the closest to the standard SQL, and with that we are most flexible, and the transition, if we want to work on other database management systems, will be the easiest. On top of that, it's a super popular database management system, free to use, and in fact it is still the most advanced database management system in the world. This is why we have then moved ahead and installed PostgreSQL as well as pgAdmin. After which we have then introduced our course project in which you are working as a data analyst for a movie rental shop called Green Cycles. So you are responsible to work on this database in which you will work on throughout the course, and you will have a lot of challenges, and moving forward your skills will get more and more advanced. So after that we have then started to learn about the select from command that we can use to just retrieve columns from certain tables. After that, we've learned also about order by that we can use to order the results in our tables. We can either order them in a descending or also in an ascending order. And then after select, we've also learned about the variation select distinct, in which there won't be any duplicates presented in the data output. Afterwards, we've also learned about the limit, which just limits the amount of data rows in our data output. And then last but not least, we've also learned about the count command, which we can use to count the rows in a specified table. So mainly we use count star, but we can also just call the column name, and then we get the amount of values that are not null in this column. And remember, null is just basically meaning that there's no data in this data row. So this is what we have learned. And then again, one variation is that we can also attach to the column name that we want to count the values from the keyword distinct, and then no duplicates will be counted. So then only the distinct values will be counted. So this is quite a lot for today, and with that we have a great foundation so that we can move on to a little bit more advanced topics tomorrow. Hope this day was helpful and you are excited already for tomorrow. This is now your second day at your new job at the company Green Cycles as a data analyst. And this day starts normally with you walking into the office, but there at your desk already the marketing manager is waiting for you and he doesn't look very happy. This is because yesterday we remember that we have used this command, select distinct amount from payment, to get the list of all of the different payment amounts. And if we scroll down, we find that there's one entry with an amount of 0. And this is why the marketing manager is now so concerned, and this is why he is asking you about a list of all of the payments with an amount of 0. And this is, of course, what we want to help him with, and that's why we today want to learn about filtering our data. This is where we want to introduce the where clause. So let's jump into first quickly the very short theory, and then we want to solve this problem for the marketing manager. So the where clause is the clause that we use to filter our data output. It's very simple. And it always also comes after and immediately after the from statement. Let's quickly have a look at how the syntax looks like. So we just select the columns, and then after the from, we use the where clause with a certain condition, and then all of the rows will be output where the condition is true. Let's have a look at an example. For example, we would like to filter the amount of only this amount, $10.99. This means we can just select everything from the payments table, and then we can filter the amount to the value of $10.99. Very simple. Also, if we want to filter a name, so this means a text string, so if it's a text column, we can again just use the same query, select from the customer table, and then we filter where first name is equal to Adam. And now, since this is a text, we need to enclose it in these single quotes. This is how we can filter also text columns. So these are the very basics of the where clause. Of course, later on in the next lectures, we learn a lot more variations and use cases, different operators and things that we can use in combination with where, but these are just the very basics that we now want to, of course, apply to give this list to the marketing manager. That's why we now want to jump back into pgAdmin and solve this problem. So what we want to do, we can first just query again, select star from payment, just to get again an overview of the table. And in here, we see now that we want to now filter this data. So we want to filter that to the column amount, where amount is equal to 0. And then if we execute that, we now get a list of all of these values. And now if we don't want to scroll down, because maybe it's just a lot of rows, and we just want to know how many payments have there been, where the amount is 0, we can also just again combine it, for example, with count star, and then we can count how many payments have the amount 0. So if we execute that, we see this is now 24 payments where the amount is 0. Of course, if we want to, for example, filter our customers, so if we want to filter some text, we can just again use the name, so first name, from the customer table. And now if we want to filter the first name and we want to search for Adam, for example, we can again use these single quotes because it's a text that we want to filter by. And then we can say Adam, and we can execute that and see first name. Of course, if we now also want to see the last name, we can also include the last name in our search. So these were the basics of the where clause. And in the next lectures, we learn a lot more variations and things that we can do in combination with where, different operators and different use cases. But now again, it's time for you to apply this knowledge and practice this in the following challenge. Now it's time again to apply what we've learned about the where clause. In the first challenge, the marketing team is planning some event where they want to give the customer with customer ID 100 some gift voucher where they want to give him $1 per payment that he or she has made. So this is the first task. How many payments were made by customer with customer ID 100? And the second one is that from the support team, you get a request to find out the last name of the customer with the first name Erica. So these are the challenges, and now it's your turn to write a SQL query to get those answers. And in the next lecture, we first have a look at the results and afterwards quickly at the solution. And stay tuned, because in this solution we'll also learn about one trick about pgAdmin and how we can execute multiple queries all in once. But now, hope you will solve this challenge and then see you at the solution. Now it's time to first have a look at the results so that you can verify your solution. So the first answer to how many payments were made by customer with customer ID 100 is 24. And the last name of our customer, Erica, is Matthews. So these are the answers that we should expect. If you have different results, then just go over your solution again. And now we together want to have a look at the solution. So first we want to find out how many payments were made by customer with ID 100. So of course we can first have a look at the payments table in general. So we execute the query like this, and now we see customer ID is here. So like this we can filter the data by the customer ID. So we use the where clause, customer ID equal to 100, we execute it, and we see that this is the data. Of course, now we don't want to see all of the columns, but we would like to count the results. That's why we use count star from payment and then filter it to those 24 results. And now we also want to find the solution to the other question. And we can in here write first name and last name from customer and then filter it again to the name. But what you note here is that I write now the second query just in the same editor. And this is possible because we can just highlight the code that we want to execute. So if I do that and press F5, I get the result of this code that has been just highlighted. And for example, if I highlight not everything, but just this, I will see I will get an error because this is a keyword that has not been recognized. So this is what we can also do if we have multiple queries and we want to write them all in one query editor. Note that we can also use a semicolon after each query. And then with this semicolon, we indicate that now this query has ended and a new query will start. So if we execute like this, in fact, both of these queries will be executed. But since this is the last one, we see just the output of the last one. So this is something that we can use to just have it a little bit easier to write code in our query editor. But now, of course, we also want to filter this customer table to the last name, Erica. So this is why we filter last name, and remember, single quotes, we use Erica, and now I just execute it like this, and I don't get any result. This is because I have used last name, but of course it is supposed to be first name. So this is something that didn't throw an error, but we just didn't get any result. Now let's try again, and we see this is the correct result. But now we need to filter in a more elaborate way, because the marketing manager now wants to find out how many payments did we have where the amount was less than $10. So this requires a little bit more advanced filtering, and that's what we are going to have a look at in the next lecture. Now we want to find a solution to the request of the marketing manager to only show the amounts that are greater than $10 or $10.99, for example, in our case. And we can see that this is the result that we want to achieve. And we can do that, of course, by filtering our data. And we need to filter on the amount column. And now we can also use other operators, such as the greater than sign. And this will also give us then the correct results of all of the rows where the amount is greater than $10.99. We can, of course, also use the less than sign. So then we will only see the results that are less than $10.99. And of course, as we can see now that it is not ordered by the amount in the output. And of course, we can always, again, as we know it, also add the order by clause. And like this, we could, for example, also order by the amount in a descending order. And on top of that, we can also use the less than or equal to sign, and same with the greater than or equal to sign. This works as well, and we can also use it. And last but not least, we can also use the not equal to sign. In this case, all of the results will be shown where the amount is not $10.99. This is something that we also want to use sometimes if we want to exclude certain rows with one specific value. And of course, we have also, aside to this exclamation mark and equal sign, as it is in also some other programming languages, we can also use as this not equal to sign, the less than, and then afterwards the greater than sign. This both means not equal to, and in fact, there is no difference, and we can use them both as we wish to. I personally use just this exclamation mark and the equal to sign because this is just what I'm more used to. And last but not least, we also want to talk about one option, and this is if we want to search for all of the values where we have nulls included. In this case, we use is null. So in this case, we don't use any equal to sign, but we just use is null. And you remember, null is just indicating, it's basically a value that indicates that there is no value in this specific row, in this specific column. So this is what we can also do. And of course, if we want to search for all of the values that are not null, we can just use is not null. And then we will see only results where in the first name there is no null value. This works as well. And that's why now we want to jump into pgAdmin and have now a look at how we can solve this request of the marketing manager. So we want to, of course, first have a look at the payments table. And from there, we want to just now filter the payments. So let's first execute that. We want to filter to the payments where the amount is greater than $10. And of course, we do this by just adding the where clause. And we want to filter by the amount. And now we want to state our condition. So amount should be greater than 10. And then if we execute the result like this, we can get all of these amounts. And of course, if we now also want to order that, we can add also the order by clause. We can say order by amount, for example. And if we don't specify descending or ascending, it will be, of course, in an ascending order. If we want to have it descending, we just add descending, and then we get the results in a descending order. And now, of course, it's your time again to practice. Let's practice again what we've learned about where and the operators. In this challenge, you get the request from the inventory manager that is asking you how many rentals have not been returned yet, which means that the return date is null. This is what it means, that the rentals have not been returned yet. That's the first query. Then in the second one, the sales manager asks you for a list of all of the payment IDs where the amount is less than or equal to $2. And they want to have a list with the payment ID together with the amount. So this is the challenge, and you should now write a SQL query to get those answers. Just to verify your results, this is what the answers should look like. And then you can verify like this if you have the correct result. So for the first question, the answer should be 183, and the list should look something like this. Of course, your results here can vary depending on some factors that we cannot influence, but in fact, the amount, of course, should be always less than $2. So this is what you should see in this list. So this is the challenge for today, and afterwards, we'll, of course, have a look at the solution. Let's find an answer now to those two queries. First, we want to start with finding out how many rentals have not been returned yet. Means that the return date is null. This means we want to first select everything from the rentals table, and we can just do this to quickly have a look at the data. And we see that there is this return date, which indicates when has this item been returned. And of course, now we want to find out how many. This is why we want to use count star. Rentals have not been returned yet, which means we want to filter the counting, the amount of data that we look at, by looking at the return date, and we also want to only calculate those columns where return date is null. And if we do that, we get the result of 183. So this is what we get, and of course if we use is not null, then we get all of the other ones where there are some values different from null. Now the second question is that the sales manager asks us for a list of all of the payment IDs with the amount, where the amount is less than or equal to 2. This means, of course, that now we have to have a look at the payments table. And we want to see both the payment ID and also the amount from, as we have mentioned, the payments table. And of course, we want to now filter by the amount, and we want to see where is the amount less than or equal to the value of 2. This is what gives us then the result. Of course, we can still order by the amount, and then we get the result also ordered by the way how we define it. But now what happens if we have multiple conditions that we want to connect? And this is what we now need to find out in the next lecture. Oftentimes, if we filter our data, we want to use multiple conditions. For example, in this case, we see a list of all of the payments of customer with ID 30. And for example, now we also want to see only those results of that customer where the amount is, for example, equal to 299. And this is when we want to use AND as well as OR conjunction. And this is what we want to talk about in this lecture. So this is used if we have two or multiple conditions that we want to combine, for example, when we want to filter our data. Let's see how this works. Of course, we select our columns and then we use our condition that we want to filter by. But now we can add a second condition using this AND statement. And this means that now both of these conditions must be true so that the data row will be present in the data output. Of course, if we want, we can even add more conditions, and this would then mean that all of these conditions must be true so the row will appear in the data output. But now let's have a look at this example. So how this works in practice. We want to see customer ID 426 and the amount should also be 1099. In this case, we just select all of the columns and then we use the first condition, amount is equal to 1099, and the second condition must also be met, customer ID is equal to 426. And now, of course, in a similar way, it also works if we want to have either or conditions. So we can, for example, see all of the data where the amount is either 1099 or we are also okay to see 1099. In this case, we use again where amount is 1099, and now we use the OR conjunction because either of those conditions must be met, and then we will see the result. So it's okay if it is 1099 or 999 works as well. Be aware that even if we use the same column names in both conditions, we always must use the full condition. So we always must include the column name. This means we cannot use something like this where we say amount is 1099 or 999. We always must include the column name in both conditions. But now let's make it a little bit more complicated, because for now it was quite simple. What happens now if we have a condition with OR and we also add the AND conjunction? So we say amount can be 1099 or 999, and also customer ID must be 426. The result is in fact surprising. At least to me, I would not have expected this result. It's not so intuitive because now we see in fact customers that are different from 426. And this is because of the order this query is processed. This means that the AND conjunction will in fact always be processed first. This means that first those two conditions will be connected with the AND conjunction. This means amount 999 and customer ID 426. Or the amount can also just be 1099. And this is why we see many results where the customer ID is not 426, because we have amount is 1099, and in this case this is enough and the query result will appear. So this is what we have to keep in mind. The AND conjunction will always be processed first. So it will be interpreted as if there would be just these parentheses around the AND statements. But of course, we can also deliberately change that by using the parentheses maybe in a different way. So for example, if we want to first say that the amount can be 1099 or the amount can be 999, and this should be interpreted first as one condition that should be then connected with this OR. And as a second condition, customer ID must be 426. Then we can use those parentheses, and then this will be interpreted first where we have the parentheses. And then this is the result that we might have expected earlier. This is maybe now a little bit more complex. This is why we now want to also see a few examples. So we have filtered our data by customer ID 30, and we now want to see also a second customer, which is customer with customer ID 31. And this is why we use the OR statement, because we can see both of them. Both of these conditions are okay, and we want to see the output. And now we also want to limit this to the amount 299. This is why I want to now also use the AND statement, where I say AND amount is equal to 299. And now I see there are more than just these results with 299. This is because, of course, first, this is interpreted. This means if we have customer ID with 31, then of course the amount must be 299. But if the customer ID is just 30, then it can be anything. This means it is interpreted like this. First, those two conditions will be connected. And this will in fact give us, of course, the exact same result. But if we want to, for all of the amounts, see only 299, we can just make the parentheses around the OR. So this will be interpreted first. And then we have the second condition, amount should be 299. This is how we can use multiple conditions. And now I think it's important to have some practice on that as well in the next lecture's challenge. In this challenge, you have now the chance to practice especially those more complicated combinations of AND and OR conjunctions. So in this challenge, the support manager asks you about a list of all of the payments of the three customers 322, 346 and 354. And also, we want to see only those amounts of those three customers where the amount is either less than $2 or greater than $10. And on top of that, the ordering of this list should be first by the customers in a ascending order. This means we want to start with 322. And as a second order condition, we want to also order by the amount in a descending order. So this is now where a few things that we have learned come together, and you can now apply this knowledge and get a query that answers these questions. And the result, just for you to verify if you have the right result, should look something like this. So just that you can verify your results, of course, we start with 322 of the customer, and then the first amount should be 199. And in the next lecture, we'll of course have a look together at the solution. Let's have a look now at the solution, and we want to create this list for the support manager. Of course, first we want to select everything without filtering, which we will apply afterwards, from the payment table. So let's have a look at the result. And now we can see that we first want to, of course, filter by our three customers, which are 322, 346 and 354. So this can be our first step that we are applying. And now that we can decide how we want to format our query. As we remember, the formatting is really up to us, and it doesn't make any difference in the query result. So we can design it like this, that it's easy for us to read. And this is why I want to write customer ID equal to 322. And now the OR condition, I just want to write afterwards in one line, so I have a better overview of that. And then I want to use customer ID is equal to 346. or we also want to see customer ID is equal to 354. And if I do that, I get now all of the customers filtered down. But I still see the amount is not accurate because we should only see the results where the amount is either less than $2 or greater than $10. This is why I now want to combine this with an AND conjunction. And as we have seen, this should be interpreted as one condition. So we make a parenthesis around that. And now the second condition will be with the AND that the amount, that is what we want to write, amount is either less than $2 or greater than $10. And if we do that, we get now the correct result with our basically two conditions. The first one is on the amount, that should be true, and the second condition is that we have all of these three customers. And now, of course, we also want to apply our ordering. This is why in the end we can add order by, and we want to first order by customer ID. This is why we start with that, and this should be in an ascending order. We can add it optionally, of course we don't need to, but it's just again easier to understand that it will be in an ascending order. And then secondly, we have the amount in a descending order, and this is what gives us our final result. And now sometimes we can make our query even much simpler if we want to see all of the values between a certain range of values. And this is when we want to use the between keyword that we are going to have a look at in the next lecture. Now your manager is asking you about a list of all of the payments where the payment ID is in between 17 and 18,000. So of course we can construct a where condition with basically two conditions using the AND conjunction. And we can say payment ID should be greater than or equal to 17,000 and the payment ID should also be less than or equal to 18,000. But now this is not the most elegant way because there's a much simpler and more intuitive way we can do that. And this is using the between keyword. And that's what we want to have a look at in this lecture. So between and we can use to filter a range of values. Let's have a look at how we can do that. For example, we want to have a look at the payment table and we want to filter now everything between $199 and $699. And note that the result now also includes $199 and $699. So those values will both be included. So this is important to remember. And we can also use the opposite of that. So we can say amount not between $199 and $699. And in this case, be aware that of course now $199 and $699 is also not included because we have just used the opposite of that. So this is one method we can do it. But now what happens if we want to filter on dates? This is also possible with this between keyword, and we just have to be aware that we use these single quotes and then we just use the format of year, month, and then also the days. So if we use this format, we can filter both date as well as timestamps where the time is also included. Be aware that if there is a timestamp where the time is also included, this will be internally transformed. So if we just write a date into 0 AM, this means that everything for this first date of 24th will be of course included, but if we have a look at the 26th in this case, everything that is after midnight in this case will not be included. This basically means that everything of the 26th, apart from when it is at midnight, will not be included. If we want to have 26 included, we just have to use either 27, or what we can also do is we can add manually another time. For example, we want to see everything till noon, for example. So this is how we can use the between statement. Now let's jump into pgAdmin and have a look at a few examples. In our case, we now want to have a look at the rentals table, and in here we now want to filter to a specific date where we see everything between 24 and 26 of May. So this is why we first want to filter the rental date. And now the keyword, of course, between. And we now want to use the single quotes, the year 2005, and then we have the month, and now we start with 24th, and then afterwards we have 26. So if we execute that, we see that if we also order by the date, order by rental date in a descending order, we see that as we have expected, 26 is mostly not included because there is, in our case, nothing where we have the time midnight. So this is internally transformed into 0 AM, and this is why in this case we would get exactly the same results. So this is the same result, but if we, for example, say we want to see everything of this day, then we can also include, for example, something like this. So we say everything from this day, and then we see now all of the rows that are also from the 26th. But now it's your time again to practice this in the following challenge. Let's practice again what we've learned in this challenge. In this challenge, your manager has found out that there have been some faulty payments, and now it is your job to help to find out how many payments have been affected. So the question that it comes down to is how many payments have been made on January 26 and 27, 2020 with an amount between $1.99 and $3.99. So this is now your task to write a SQL query to find out the answer. And the answer or the expected result should be 104. So now it's your turn, and afterwards we'll have a look together at the solution. Now let's have a look at how we can find a solution to this question. First of all, we can just query from the table and limit the amount to something small so that we just get an understanding of the table structure and all of the columns. So we see, for example, that we have the amount and the payment date, which is a timestamp in this case. So this is why we can now start to filter our data. We want to filter by the amount and the payment date. So let's start with the amount, where we want to see the amount between $1.99 and $3.99. And of course, if we do that, we still have not filtered to the payment date, which we also want to do. And this is why, of course, we want to use the AND conjunction, because both of these conditions must be met. So now the second one is payment date. And now we use again the keyword between. And now since it is a date that we want to use to filter, we use the single quotes, and we want to filter everything from 2020 January. We want to start from 26, and we want to see everything from 26 and 27. This means we need to either use, if we use 27, then we need to use the timestamp of 23:59, because if we would not use that, it would mean that we just filter to midnight, and this means that almost all of the data, in our case all of the data of 27th, will not be included, because internally it will be transformed just to 0 AM. This is why we either use 23:59, this is one option, so we can again also just use count star, and we get the result 104, or alternatively we can also just use 28, and since there is no payment at midnight exactly, then we get the same result. So this is why it would be actually more correct to use 23:59, but since there is no sale or no payment on midnight exactly, it gives also the same result, and I also would say this is a correct solution that we have here. So this was the solution, and of course there can be different solutions, but this is one solution, and I hope that it was helpful to apply your knowledge about between. Now again, the marketing manager is approaching you with a new task. Now he wants you to give him a list of all of those 6 customers with these customer IDs. So there are 6 customers, and he wants to have a list including the email address of those 6 customers. Now, of course, we know how we can solve this. We can just filter our data using where. We filter to the customer ID. And then, for example, we use the first one. This is 123. And then we can just add additional conditions with the OR conjunction. So like this, we could add all of those different values. But imagine if this is even more than just 6 values. This can be quite a tedious work. But luckily, there's a much simpler and more intuitive solution. So we can use the in operator. Let's see how we can make our task now like this much simpler. So we use the customer ID, and then we use the in operator. And here in these parentheses, we can now just paste basically all of those values in, and then this works as if there would be an OR statement between. This means that now we get a list or all of the rows where the customer ID is either one of those values. So if we execute it like this, we see that now we get a list of all of those customers with those customer IDs. So this is now exactly the same as if we would combine this with an OR statement. So we would write customer ID and then all of the other values combined with an OR statement. So this is now making our work much easier, especially if we have a long list of values. And of course, we can also write in different values. So for example, if we want to just filter by the first name, then we can also just enter here the first names. Of course, if we have now text values and, for example, we want to search by Lydia and then also, let's say, Matthew, then we can also do this. Of course, in this case, since it is a text, we just need to use those single quotes. And then if we execute that, we get all of these results that we are looking for. And of course, we can also add additional values in this list of the in statement. And this now makes it much easier, especially if we have a long list of values that we want to include in our where condition. And of course, we can also use the negation of that if we just add not in, and then every row will be presented where the first name is not Lydia and not Matthew. So this is how we can use the in statement. And now again, it's your time to apply this knowledge in the following challenge. In this challenge, the support manager is approaching you again, and she's telling you that there have been 6 complaints from customers about their payments. And now, of course, you have to find out about these payments of these 6 customers. So the customers that have complained have those customer IDs. So that's what we need to look for. And then also she's telling you that the payments that are concerned are all of the payments of these customers with the amount of $4.99, $7.99 and $9.99, and they have taken place only in January 2020. So this is what you need to filter to: January 2020, those amounts and those customer IDs. And then your job, of course, is to write a SQL query to get a list of all of those concerned payments. And so that you can verify the result quickly again, the result should be 7 different payments. So a list of those final 7 payments. So good luck with this challenge, and afterwards we'll again have a look together at the solution. Let's have a look at how we can find the list of these payments. So first of all, we start, of course, from the entire payment table. And then we want to filter, and we can start with the customer ID. And now, since we have a list of a couple of values, of course, we should use the in operator, because this is now much simpler for us. Then we open up the parentheses, and we can just copy and paste those values in here. And if we do that, we get now a list of, in this case, a couple of values. But of course, we need to filter down even further, because the support manager has told us that only certain amounts in the month of January 2020 are concerned. So this is why we want to add the AND conjunction, and we want to also filter the amount by a couple of values. So this was $4.99, we had $7.99, and also $9.99. And then, last but not least, we also had to filter for the month of January. So again, we want to add the AND conjunction, and we want to filter by the payment date. And now we can, of course, use again our between operator so that we can filter in a specific time range. And in our case, we of course want to start with January first, and then the end could be, in our case now, the entire January. So what we can do is just, for example, use 1st of February 2020. Of course, we could also use just the end of January and then add the month like this, but this would really give actually the same result. So this is why we want to make it just a bit simpler and use the 1st of February 2020. And if we execute this, we get our list of 7 different payments that is concerned, and this is now what we can happily hand over to the support manager. The company now wants to get a better understanding about what type of movies they have in their inventory. This is why we now first want to select everything from the film table. And in here we note that we have this description column with a descriptive text of our films. So for example, in here we can see that there's the word drama or documentary. And this is now what we want to match against. This means we want to search for all of those rows where in this description column the word drama appears. That's why in this lecture we need to talk about like and pattern matching. This like operator we can use to filter our data by matching against a specific pattern. And this pattern we can create using wildcards. So we have basically 2 different wildcards. The first one is underscore. And we'll soon see how this works in an example. So the underscore is just basically representing any single character. So it is one single character. And then on the other side, we have the second wildcard, which is just the percentage sign. And this represents now any sequence of characters. So it doesn't matter how many, and it can be even 0 characters. So it can also represent nothing. So this is really all possible. But now, how does this look like in an example? So, for example, in our case, we would like to search and output all of the actors where the first name starts with an A. And this is why we want to use the like operator. And as the first character, we use the uppercase A. And then the percentage sign, because there can be any sequence of characters afterwards. And note that this is also important, that like is always case sensitive. This means if we would search for a lowercase a, there wouldn't be any results, because in fact all of those texts are starting with an uppercase a. So this is why we need to be aware that this is case sensitive. In fact, we can, if we don't want to have this feature of case sensitivity, we can also use I like. And then it will be case insensitive. This means that also it doesn't matter if it's uppercase or lowercase, everything with an A in the beginning will be found. But actually the more common thing is to use like, which is case sensitive, because that's usually a feature that we would like to have. But now, how can we find something where the A is anywhere? It doesn't matter in the beginning, in the end, or somewhere in the middle. In this case, we can just add another percentage sign in the beginning. So this means that there can be just an A anywhere in the text, and then it will be filtered. But now, what is different in the underscore? Again, the underscore is just representing one single character. This means that if we search like this, we have any character in the beginning, but the second character now needs to be an A. And then in the end, there can be again anything. This is why the result would look now like this, that everywhere at the second position, we have this A. Of course, if we now use 2 underscores, this means we have 2 arbitrary characters in the beginning, and then the third one needs to be an A. So again, as you can see at the percentage sign in the end, this also includes nothing at all. For example, we see the second row, there is an A in the third position, and then afterwards there's nothing anymore. And this is also matched by this percentage sign. So this can also mean nothing. Now, before we have a look into the examples in pgAdmin, we also want to mention that we can of course also use the negation of that. And if we, for example, search for anything where there is no A included, we just use not like and then again our pattern. And then all rows will be output where in the first name there is no A appearing. But now let's quickly see how we can solve now our challenge in finding all of the dramas in our film. So in this case, we want to select everything from the film, and we now want to filter with where, and we want to filter on the description. And now, of course, we want to use a like operator, and we want to match against the drama. So we want to use the percentage sign, and note we are using the uppercase D because this is also how it's written in our database. So we see that drama is always with the capital letter in the beginning. So this is why drama like this. And then if we search like this, we see all of the films where there is drama in the description. Of course, we can also now combine this with all of the movies that, for example, start with a T. So start with a T, and then afterwards there can be anything. This is why we use the percentage sign. So if we do that, we see we get here a few movies, and now we can also check if there are any titles where in the second place there is the T. And also there should be drama included in the description. So if we do that and execute that, we see indeed we also find 3 of those movies. But now I think this is enough of theory, and now it's your turn again to solve the following challenge. Let's have some practice about the like operator. So in this practice, you again need to help the inventory manager, and this time you need to find out how many movies are there that contain the word documentary in the description. So your job is again to write a SQL query to find out the answer. And to verify your results again, here should be the result 101. This is the first challenge, and now there's also a second, a little bit more playful challenge. In this one, you should find out how many customers are in the database with a first name that is 3 letters long and either an X or a Y as the last letter in the last name. So this is now a little bit more playful, but you have to combine a few things that we have learned previously, especially also about and or, and how we should use the parentheses. So this is the second challenge, and again here the result, just to verify that your query is correct. Here the data output should just be 3. So now hope you will enjoy the challenge, and we'll have a look together at the solution in the next lecture. Let's find out how we can solve those 2 challenges. We want to start with the second one, which is how many customers are there with a first name that is 3 letters long and either an X or Y at the last letter in the last name. So for this one, we just want to first quickly query from the customer table. So we do this, of course, just to see what the data looks like. And in this case, we now, of course, want to filter first the first name, and there we want to, of course, filter to any first name where there are only 3 characters. So that's why we start with first name. We use the like operator to match against the pattern, and then, of course, single quotes. And now we can use these underscores, and if we use exactly 3 underscores, we get all of the results where there are exactly 3 characters. So if we execute a query like this, we get all of the first names, so the complete list, where we have only 3 letters exactly in the first name. This is what we want to have as our first criterion. But now also the second criterion is that we also now need to have an X or a Y as the last letter in the last name. So this is why we now want to combine this with an AND conjunction. And now we have the last name should be, so we have again like, and now the last letter should be a Y. This means that we have everything in the beginning, so any sequence of characters in the beginning. That's why we use percentage, and then we have an X, for example. And now, of course, we also want to have the second option. Last name can also have the Y in the end. So we use exactly the same thing, just we replace the X with a Y. And now, if you think about this query, will this give already the correct result? And the answer is no, because if we execute that, we see that there are now first names that are more than 3 characters long, because the AND conjunction will be processed first. This means that the first option that we have is first name is 3 letters long and the last name ends with an X. Or what can also be the case, and then the data will be returned, just the last name needs to have a Y in the end. So if we find something where there's no Y in the end, for example this one, then only we need to have the first condition also be true. So this is basically how it's interpreted, that now we have these parentheses. But this is not what we would like to have. We would like to use the parentheses like this, so that first we have this 3-letter condition and then we have this OR condition. And since AND is processed always in the beginning, we need to use those parentheses to change the order of how these conjunctions are processed. So if we execute like this, we get these 3 results, and of course now we can also just use count star to get the answer of 3. So this was our first challenge, where we had to also use our previous knowledge about AND and OR and setting the right parentheses. And now if we have a look at the first challenge, how many movies are there where documentary is in the description, we can also just use select count star from film, and now we want to filter by the description, and we use again like. Now somewhere should be just documentary in the description. This is why we use 2 of these percentage wildcards, so in the middle there can be just the word documentary. And then in the beginning or in the end there can be also other things. So just documentary should appear, and if we execute the query like this, we get our result of 101. And before we finish off with this day, we just quickly want to talk about how we can make our code more readable and more understandable by adding comments and using aliases in our code. That's what we're going to learn in the next lecture. The more complex our queries get, the more important it is to make our code readable and understandable. Not only for ourselves, but even also for other people that don't know what your thoughts were when you were writing this code. And this is why we now want to learn about comments and so-called aliases. Let's start with the comments. Comments we can use to make our code more readable and understandable. This means it will be readable and visible as code in our editor, but it will not be executed as SQL code. Now, how does this work? We have basically 2 ways of doing that. The first one is to use a single line comment. We do this using a double hyphen. And then everything after this double hyphen in this particular line will not be executed as SQL code, but it is still visible for humans to be read. And we'll soon also see an example of that. Another method is to use a multi-line comment. In this case, there are multiple lines that are just not executed as code. And this is all done to explain mainly our code, or just have some parts of the code not being executed. So let's see an example of how this works in practice. We can, for example, write in the beginning or in the end of our code some comment that is just explaining and giving some information about the code that we have written. But since you see we use the double hyphen, which is just for a single line of code, and since we have 2 lines in here, we need to use it at every single line that we want to comment out in our code. If we would use the multi-line comment, we could also do that in this case, and we just use this /* in the beginning and then */ in the end again. And this will then, as mentioned, not be processed by SQL, but it will be still visible for us humans, so we can read this comment. Oftentimes, a comment is also actually used to comment out parts of the code so that it can be easily later on reactivated again. So like this, we can just quickly activate some code and deactivate it as well if we currently don't need it. Of course, we can do that also for multiple lines of codes if we use either at every single line the double hyphen or this multi-line comment as well. If we talk about aliases, we can also use them to rename the column in the data output just for this single query. So this is important to understand, that this will not rename the column in the database, but just in the data output for this specific query. And again, we can use that to make our column names sometimes a little bit more descriptive. But now we have enough theory, and let's jump into pgAdmin to just quickly see a few examples. For example, in this case, the column name description is not really what we would like to have. And this is why we use now here an alias, and we want to say this is not description, but it should be description of movie. And then if we execute it like this, let's not forget about the comma in the end. We can see that now this output has changed, and we see now description of movie. Of course, in the database, the column will still be called description. This is only changing the alias, basically the column name here in the data output. And now if we want to comment out a few lines of code, so for example, we don't want to see the title, then we can also execute it like this, and the title will not be visible. Something that I want to mention here as well is that we can use different formats. So if we have the commas always in the end of our line, then we cannot comment out the last line, because then the last column will have the problem that there's a comma in the end and there will be another column expected. This is a minor issue, but sometimes this is the reason why we don't use the commas in the end, but we use the commas in the beginning of the column name, and this just makes it easier to comment out every single column, and this will not cause any issues. So if we do it like this, then it should work, if of course we don't have the comma in here. So this is something that I'm also not always doing myself, but this is of course up to people, and this is just one way of doing it that I also wanted to mention in here. So this is how we can use these aliases and comments. And oftentimes this alias is used if we have some column name or something like the count star that is not so descriptive. So in this case, who knows what this count is supposed to mean if we just see the data output? And this is why we can give aliases that are just more descriptive. So we can say this is, for example, the number of movies, and then everyone will understand what we meant with that. And if we don't want to have this where condition, we can easily also comment that out, and then if we need it again, we can activate it again. So this is how we can use the comments and aliases to make our code and our data output just more understandable and more readable, which is something that we should learn as soon as possible. Before we finish off today and we go to our final challenges of today, let's quickly summarize what we have learned today. So today was all about filtering our data. We do this using the where clause. This is what we just use after from and then the table name. So it will be right after from. And then we can just use a condition which usually just contains our column name, and then we can match, for example, against a specific value. This can be done, of course, in different data types. So if a column is, for example, a text column, we can also match against a text. We just should then enclose this text into the single quotes. But of course, we can also use different operators such as less than or equal to, and also, of course, not equal to with the exclamation mark and the equal sign. But even if we want to match against nulls, we can do that just by using the keyword is null, or if we want to match against all not nulls, of course, we use is not null. And then after that, we've also introduced the different conjunctions. So this is and as well as or, where the and conjunction means that both of these conditions must be true so that the data will be returned. Of course, afterwards, we've also introduced the or conjunction, which means that if any of those conditions, either one of them is true, the data will be returned in both cases. But then what happens if we have both of them included? In this case, we just need to be aware that the and conjunction will always be combined first. This means that internally it will be processed as if there would be parentheses around the and conjunction. This means they will be combined first, and then only afterwards the or conjunction will be combined. But of course, if we want to have a different order, so if we would like to have the or first, we can also always use these parentheses to change that order as well. Afterwards, we've also learned about the between statement that is now matching against a range of values. And again, we can of course also use the not between, which is then just giving everything that is not between this range. This between keyword can also be used for dates if we just be aware of the right format, and then it can also be used to match against timestamps. In this case, we just have to be aware that if we only use the day, it will be internally transformed into 0 AM. So basically midnight, which is exactly just the beginning of that day. So everything that will be after midnight will in this case not be included. Then we've also learned about using wildcards to match against a pattern in a text. So if we don't want to have one specific exact string, but a specific pattern that is included in the text, we can also use like together with those two wildcards. So we have the underscore for single character and percentage for any sequence of characters. And like this, we can just match against specific patterns. And last but not least, we've also learned about the comments and aliases. So comments we can just introduce by using the double hyphen for a single line comment, or we have also the multi-line comments. And then of course, similarly, we can also use the aliases, which will just be used after the column name and then with the s keyword and then the alias. And this will now just change the column name in the data output just for that specific query. Note, this will not change the name of the column in the database, but just in the output for this specific query. So that's what we've learned today. And now let's go to our final challenges for today. Now let's have a look at the final challenges for today, where you can again apply everything that you have learned today. So in the first challenge, you are asked how many movies are there that contain the word saga in the description and where the title starts either with an A or ends with an R. And you should also use the alias number of movies in the data output. In the second challenge, you should create a list of all of the customers where the first name contains ER and have an A as the second letter. And the results should be ordered by the last name in a descending order. And the last challenge for today, you are asked how many payments are there where the amount is either 0 or is between $3.99 and $7.99. And in the same time have occurred on 1st of June 2020. These are the 3 challenges, and now it's your turn. You can pause the video and solve those challenges. Afterwards, we'll have a look first at the results. So once you have the results, you can now verify those results just by looking at the data output. And afterwards, we'll have a look at the solution. So if you're ready, let's have a look at the results that you should expect. First, we have the number of movies, which should be 14. Then in the second result, we should expect a list of values and rows that should look something like this. And in the last challenge, the number should be 27. So if you are ready and if you have tried and worked on those challenges, we can now have a look at the solutions if you are ready. So let's have a look at solution number 1. How many movies are there that contain saga in the description and start either with A or R in the end? So first, we of course want to see how many movies are there. So we count star and we give also the alias, and we of course also want to query from the table film. Then we want to start to filter our data using the keyword like. So we want to search for saga. This is why we use percentage in the beginning and in the end. And be aware that this is case sensitive. So we should also include exactly this uppercase letter in the beginning, and the other ones should be in lowercase. But now we have also a second condition, and this second condition is now basically a combination of a OR condition. Because the second condition is that the title starts either with A or ends with an R. And this is why in this condition we need to use those parentheses so that these two conditions will be combined first. Because otherwise, per default, it would first combine the end conjunction. And since this is not what we want, we need to use those parentheses. So that's solution number 1. Let's have a look at solution number 2. Of course, first we want to select everything from the customer table, and our first condition is we want to have ER included somewhere in the first name. And then we have the second condition that also the second letter should be an A. This is why the first letter is an underscore, so we use a wildcard for any single character, and then it can end with anything. This means any sequence of characters, and this is why after the A we can use this percentage sign. And of course, we should also order the result by the last name in a descending order. So this comes after we have defined our where condition. And last but not least, we also have solution number 3, where we want to see how many payments we have that have the amount, which the amount should be either 0 or the amount should be between $3.99 and $7.99. And since this is our first condition and we have the or conjunction between them, we should use again the parentheses so that this is combined into our first condition. And then the second one is that the payment date should be on the 1st of June 2020, which means basically that it's between 1st of June, the beginning of the day, and the beginning of the next day. If we would be really more accurate, so if we want to be 100% accurate, we could also just use the timestamp as well, but this is basically giving exactly the same result. So this is really close enough to be absolutely correct. So these are the challenges for today. I hope they were helpful, and congratulations on mastering the second day, and tomorrow we will have new learnings and new challenges. Welcome to day number 3. In this day, it will be all about grouping our data. That's one of the most important things that you can learn if you want to apply and work with SQL. In today's lessons, we will answer questions like how many payments did we have for each of those amounts? Of course, we could also count and just filter our data, but we would like to have now a list with the amounts for every single amount. So how many payments did we have for every single amount? Or also, how much is the total amount of each of those individual amounts or for each of our individual customers? So, for example, which of our customers has spent the most amount in renting the movies? And this is what we want to start with. How can we aggregate data? Apart from counting, we of course also have sum and other aggregation functions. That's what we want to have a look at in our first lecture. And afterwards, of course, we want to have a look at how we can group data. Oftentimes, if we work on our database, we need to calculate values. And one of the most important things to do that is to use so-called aggregate functions. For example, if we have the amount column, we would like to sum up all of these values to get the total amount. This is why we in this lecture want to talk about these aggregation functions. That's one of the most important things we need to learn about today. So aggregating basically means that we have multiple values in the beginning, and then we turn all of those values, for example, by taking the sum, into one single value. Of course, we can also just take the average or do any other aggregation and also get one single result, so one single value. Now let's have a look at the most commonly used aggregation functions. Of course, we've already learned about count. But also, of course, very important is the sum function. And then aside to that, we also have the average, minimum, and maximum. So these are the functions that cover really almost 99% of all of our use cases. So if we know those functions, we are good. And now let's have a look at how we use those aggregate functions. For example, let's say we want to indeed sum all of the amounts in our payment table. In this case, we just use, as mentioned, the sum function and then the column name in the parentheses that we want to sum. And then, of course, as we know it, from the table name. Of course, we can also, and that's what we've learned about, use the count function. This is just to count the rows in this table. And actually, the count function is the only function where we don't need to specify necessarily a column name, but we can also use just the asterisk. In this case, we would just count all of the rows in the table. But for all of the other aggregation functions, we indeed need to use a column name. So for example, the amount that we want to sum up. And now one thing that we cannot do is to use, if we use an aggregation, use also another column that is not aggregated. This is not possible. Of course, logically this makes sense. If we want to have one value that is aggregated, we cannot use another column that contains just many values. So this is not possible to use a column that's not aggregated together with an aggregation function. The only exception to that is if we are grouping our data. So this is something that we are going to learn about in the next lecture as well. So this is not possible, but what is possible indeed is to use multiple aggregation functions in the same time, because they all result in one value, and like this we can indeed use multiple of them together. But now let's jump into pgAdmin and have a look at a few examples. So in our case, we have mentioned we want to aggregate the amount. So this is why we want to use the sum function, and we aggregate the amount from the payments table. And in this case, we get this result, which we are expecting. Now let's have a look at what we can do to take the average. In this case, of course, we just take the average. And indeed, actually, we can use both of them together. So let's do that. So we sum the value in one, and in the other one, we take the average. And now we see that this is a very long number with a lot of decimal places. So it can make sense to round our values. That's why we also quickly want to see how we use this round function. We can use it around the average. So we want to round this value, and then there's a second argument expected, and this is to how many decimal places we want to round that value to. So for example, if we use the value 3, we get to 3 decimal places the rounding, and in our case it makes sense to round it just to 2 decimal places. And of course, now we see that the column name is called round, and we've learned we can just use an alias. So for example, we can say this is the average, and then this will be also the column name. And of course, as we have seen, we cannot use additional columns, for example, the payment ID, and this will then result in an error. So this states this payment ID, this column, must appear in the group by clause or be used in an aggregate function. And this is why we now want to also learn about grouping our data. So that's what we are going to do in the next lecture. But first, of course, there's again the challenge that you can do to apply your knowledge about aggregate functions. In this challenge, your manager now again wants to find out more about the films in your store. And this is why you are asked to write a query to find out more about the replacement costs of the film. And that's why you should find out what is the minimum, the maximum, the average, rounded to 2 decimal places, and the sum of the replacement cost of the films. So this is now your task to write a query to find out the answers. Of course, also this includes to find out what is the right table that you should find these options in. So that's part of the challenge. And now you can of course pause the video, jump into pgAdmin and find out the solutions. If you have done those challenges, then you can now use those results to verify your solution. So here are now, if you are ready, the solutions, so the preview of how the solution should look like. We have those 4 values aggregated, and these are the values. And if you are ready, we are now going to have a look at the solution. Of course, after you have done the challenge yourself. So of course, we select first it doesn't matter the order, but here we first choose the minimum, then the replacement cost. This is the column that we want to aggregate. Then we have the maximum of the replacement cost, and then of course the average that is rounded to 2 decimal places, and then we have given the alias average again. And then last but not least, also the sum of the replacement cost from the film table. That was the challenge, and now we want to dive deeper into grouping our data. Usually if we aggregate data, we also want to group it by a specific category. So what does that mean? For example, if we have this payment table and we are aggregating the amount, we just get the overall total amount. But maybe we would like to see how much every customer has spent in total. That means we want to group by the category of customers, so that for every customer we see the amount, the total amount that this customer has spent. And that's why we want to talk about grouping our data. We can do this with the so-called group by clause. This is used, as we have mentioned, to group our aggregations by a specific column. For example, this means that if we have the list of customers, so we have the different amounts for the different customers, we now want to group every single customer ID value and get the total amount for this specific customer. And this, of course, for all of our customers. So the result would look something like this. Of course, in here we have also already ordered the data by the customer ID, but we see for every single customer, we now get the sum of the amount. This is what we want to achieve with the group by clause. Let's have a look at how we can now achieve exactly this result. So this time we want to indeed use the customer ID column, even if it is not included in an aggregate function, and we are also using the aggregation of our amount. So since we are now using the customer ID not in an aggregate function, we need to include it in the group by clause. So here we have the customer ID column and also the customer ID now in the select. Of course, what we can also do, so usually the group by comes right after the from clause, but we can also, if we want to filter our data before we group it, we can also use it after the where clause. Of course, we know where comes always immediately after from. This is why group by comes either after from or just after the where clause if there is a where clause included. So of course, also we can order our data as we see it in this case. In this case, order will always be in the end of our statement. What we should keep in mind about this group by clause is that every column should be, if we are using an aggregate function, should be either included in the aggregate function, such as the amount, but if it is not included in the aggregate function, in this case it must be included in the group by clause. This is the most important thing that we need to know about group by. It needs to be either in the group by or in the aggregate function. This is the one thing that we need to make sure. Whenever we aggregate, either the column should be aggregated or it should be in the group by. Now, let's have a look in pgAdmin to see how we can make this work. So in our case, we wanted to group by the customer ID. This is why we can now include the customer ID as an additional column. And of course, like this, it won't work because every column, this column here, is not included in the group by and has not an aggregate function. That's why we now also want to add group by, and of course we now also include the customer ID. And since we see this is not in a nice order, we can also now order this. So for example, we order by the customer ID, but what we can also do is just order by the sum amount. So this is also possible. If we do that, we see, let's say we want to see the highest column in the beginning. In this case, we can say in a descending order. And like this, we see this is the customer that has the highest amount spent. And of course, we can also, for example, include the maximum. So this is also possible to include multiple aggregations, and they will all be aggregated by this customer ID column that we are grouping by. And now it's your turn again to prove and practice your knowledge in the following challenge. In this challenge, your manager wants you to find out which of the two employees, which basically means the staff ID, is responsible for more payments. On top of that, your manager wants you to find out which of those two staff members is responsible for a higher overall payment amount. And then lastly, also you should find out how would those numbers change if you would not consider the amounts that are equal to 0. This means this would be a second query that you should write. So your task now is to write 2 SQL queries to get answers to those questions. So you can pause the video now and jump into pgAdmin to solve those challenges. And if you have now solved those challenges, you can now compare your results to the expected output. So this is how you can verify your results, and this would be the first query where we did consider the amounts that are equal to 0. And then if we would write a second query where we don't consider the amounts equal to 0, we would get a result like this. So you see that the count has indeed changed, whereas of course the sum has remained the same. So these are the results, and in the next lecture we are now going to have a look at the solution together, of course, after you have hopefully completed those challenges yourself. Now let's have a look at how we can find answers to those questions. The first step that we can always do is just quickly have a look at the table. We can also just limit the results to a few rows, and we can now see that there is this staff ID. So this is the number for the employees. And of course, we also want to aggregate the amount. We want to take the sum and we want to count the number of payments. So this is why we would like to first use the staff ID, and then we want to aggregate the amount, and we also want to count the rows. So we can use count star because one row is just equal to one payment. And of course, we have the payment table, and we now need to group the data because staff ID is not included in an aggregate function. This is why we need to group by the staff ID. And if we execute that query, we get this output that we expected. So this is great. What we can do now, this is just a quick tip. Of course, we can also always order our results. This is true even if we group our data. So we can either, for example, order by the staff ID, but we can also order by the sum amount. This is also possible. If we decide, for example, to use a descending order, we would get the same results like this. If we would use an ascending order, it would be different. But what we can also do is we can, just to make our work a little bit quicker, it's not something that's recommended, but if we want to do it quicker, we can also use the number. So for example, amount is the second output column, and this is why we could also use just the number 2, second output column, and this would then order the results also by the amount, because amount is here in the second place. So if we would do that, we would get also the same result. This is what we can do. But now, how could we solve the second challenge where we would not consider all of the amounts, where the amount is equal to 0? In this case, we would of course use a where clause, and then this would be executed or processed before the group by. This means that if we use where amount is not equal to 0, those would not be considered. So those would be cancelled out before the grouping. And we always, this is what we should remember, use the where clause immediately after from. This is why it is now in between the from and the group by. And if we execute the results like this, we see that the sum should not change. We can again verify this by commenting that out. So the sum should be the same, but the count will indeed change. So this is how we can solve those two challenges. And in the next lecture, we are going to learn how we can now group by multiple columns. That's what we are going to learn in the next lecture. Of course, sometimes it is necessary and important to group our data and our aggregates by multiple columns. So this is why we first want to quickly again have a look at our payment table. I can just write this query like this and then just highlight this query, and if I now execute the results, only this what I have highlighted will be executed. And now if we have a look at this, we can of course, as we see, group our data actually by multiple columns. So there are multiple options. And maybe we would like to find out which of our employees has had the highest amount of payments with one specific customer. This means that we need to group by both the staff ID and the customer ID. So let's see how this would look like. This means that we need to include in our select both the staff ID and also the customer ID. And now that this is also not included in an aggregate function, of course, it should also be included in a group by. And we do this the same way. We just use a comma to separate the columns. And now also we just mention the customer ID. And if we execute that now, we see that now the results are aggregated and grouped by both the staff ID and the customer ID. Of course, if we are grouping our data, it usually makes sense to also order the data. So if we, for example, would like to order by the count star, and we can write that in capital letters, then we see that now if we order it in a descending order, we see that staff ID number 1 wins because this has the most payments for a specific customer. So staff ID number 1 was responsible for 26 payments for customer 176. So these were the most payment amounts that one of our employee was responsible for with a single customer. So this is how we can group our data now by multiple columns. Of course, we can also use the rental ID, for example, and then in this case, we can group our data also by multiple columns. So there is basically no limit for how many columns we want to group our data by. It is just important that if we use one of the columns in the select without an aggregate, it needs to appear also in the group by. And then oftentimes it can also make sense to order our data. And now again, it's your turn to apply this knowledge and practice it in the following challenge. Before we introduce the next challenge, we just quickly want to discuss one function, and this is the so-called date function. This function, and don't worry, we'll talk later on a lot more about dates and timestamps, how we can work with those dates and timestamps, extract different parts of the timestamp, but for now, we just quickly, just for this challenge, want to introduce this date function. So what this date function does, it's basically just extracting only the date from this entire timestamp. So if we execute the query like this, we can see, and if we also want to see still all of the other columns, we can just use count star for all of the columns that are included in the table. And then additionally, this date column, we see that if we execute it like this, that we have the date column now, and we have just extracted from this timestamp this date. But as I mentioned, don't worry, this is just quickly for this challenge, and later on we'll talk a lot more about dates and timestamps. But for now, let's quickly introduce the challenge for today. So there are now two competitions between the two employees. The first competition is which of those employees had the highest sales amount in a single day. And the second competition is which of those employees had now the most number of sales in a single day. And for this query, we want to not count the payments where the amount is equal to 0. So your challenge now is to write 2 SQL queries to answer both of these questions. If you want, you can also just write one query and modify this query just a little bit, and then you can find the answer to both of these questions. And now it's your turn, of course. Pause the video, and if you want, you can also already see the result, which could look something like this. So, of course, there can be, again, different solutions that are all correct, but this could be one expected result. Of course, now it is your turn, and in the next lecture, we are going to have a look at the solution together after you have figured out, hopefully, the solution yourself. Now let's have a look at how we can find the answer to those questions. First, we want to group by the date and also the staff ID. This is why we can first in the select include the staff ID and then the date. So this is the payment date. Of course, then in this case, we also need to include both of these columns in the group by. So we can just copy and paste them, and then they are also included in the group by. This is of course only necessary if we want to make aggregations. But indeed, we do want to aggregate the amount column. This is why we use sum amount. And for the second question, we also want to include count star to count how many payments have occurred on a specific day. And indeed, this might have been a little bit tricky. Let's not forget about the comma. tricky to find out that we can indeed use this entire column, which is a date of payment date, also in the group by, even though it is enclosed by this date function. This is absolutely possible as well. And now, of course, we would also like to order these results. But first, let's quickly have a look at the results, so that we can see which is now the winner. We want to, of course, as mentioned, order by, and now we can just order, for example, by the sum of the amount. And we want to order this, of course, highest value at the top in a descending order. And then we see for this first challenge, the staff ID number 2 is the winner for 30th of April. So this is now the first competition. But now what happens if we want to order this by count star? And we also should be aware that for this challenge, we don't consider the amounts where the amount is equal to 0. This means that we need to filter the underlying data. That means after from, we use amount is not equal to 0. So in this case, we get, in fact, still the same result. So in fact, this is the same day, the same staff ID that also in the same time where it was the highest amount in total, also this was the highest payment numbers. So this is something that makes sense, and this is why in this case also competition number 2 goes to staff ID number 2. So we have seen in this challenge that, of course, we can filter the underlying data using the where clause. But now what happens if we also want to filter by the aggregate functions? This means that we want to influence how many output rows, for example, we want to see. Do we only want to see, for example, those rows in the output where count star is higher than 300, for example? And this is something that we cannot do using the where clause, but how we can do that, we want to have a look at in the next lecture. If we are grouping our data, sometimes we want to limit the number of rows only to those that really matter to us. This means we want to somehow filter our output, and we want to do that by some of the aggregation columns. So for example, we only want to see those rows where count is greater than 400. And this we cannot do using the where clause, but we need to use the having clause. So that's why in this lecture we want to learn about the having clause. The having clause is used in group by statements to filter by aggregations. This means, for example, we have seen we have such a data output where we've grouped by staff ID and date. And now we want to limit the output to only those rows where count is greater than 400. In this case, we need to use having count star greater than 400. And in this case, we would now then limit the output to only those rows where count is greater than 400. And note that this is only possible to use if we are grouping our data. So only when there's a group by clause, we can immediately after group by use the having filtering. If we are not grouping our data, then we can just filter our data as usual with the where clause. But now let's quickly have a look at an example of how this works in practice. We, for example, in this case, want to group by customer ID and sum the amount, but we only want to see those sums or those customers where the sum is greater than 200. This means we just use customer ID and sum amount from payment table and group by customer ID. But now we want to filter also by the sum of the amount. This means we need to use the having clause right after group by, and we can use now our aggregation or basically our condition. So sum amount is greater than 200. Now let's jump right into pgAdmin and see how we can now also solve this problem here where we want to filter to only those rows where count is greater than 400. Of course, as mentioned, we need to use it right after group by. So we introduce having, and now our condition, count star is greater than 400. And in this case, we now only get those two results. Of course, we can now also use something like we only want to see those that are, for example, less than 50. Or we can also say we want to see only a specific number, so for example only those with the value 28. Or we can even combine multiple conditions. So for example we can say or count star can also be, for example, equal to 29. This works that we can also combine multiple conditions. In this case we can see that now we see both 29 and 28. And now it's your turn again to apply this knowledge in the following challenge. In this challenge, we now want to combine a lot of the things that we have learned in the previous lectures. This is why this challenge will be a bit more complex and a bit more difficult. But this is why it's called challenge, so that you are indeed really challenged. So in this challenge, we have first found out already that in 2020, the days April 28, 29 and 30 were days with very high revenue. And that's why we want to focus in this challenge only on these specific days. That means you should filter your results accordingly to those 3 days. And now the challenge is to find out what is the average payment amount if we group by customer and day. And on top of that, we should limit our outputs to only those days and customers with more than one payment, so per customer and per day. And now, of course, the results should be ordered by the average amount in a descending order, so that we see the highest average payment amount for a given day customer combination. So this is the task. I know it's a little bit more challenging, but this is what we want. And of course, your job is to write a SQL query now to find out these results. And also what I can recommend is before you do this challenge to, of course, round the average. And you can also give an alias to this average amount, and you can choose what alias you want to give. And now, if you want, you can already see the result that we expect, just so that you get an idea of what should be the output that we expect. So if you're ready, we are now going to have a look at the results. So this is how the result should look like. We have the customer ID, we have the date, and then average amount, which we have renamed in the data output and also rounded. And of course, in this count column, we can show, but we don't need to show it. So this is optional to show it, but in this case, it is just a little bit easier to verify our results so that we are sure we only see the counts where count is greater than 1. So this is the challenge, and in the next lecture, we are going to have a look together at the solution. Now let's have a look at how we can achieve that desired result from the challenge. Of course, we want to start with select, and now we want to group by customer ID as well as the days. And this is why we call the date function on the payment date. And of course, never forget the commas in the end. And now we also want to use the average amount, and we can also round that. So we know these results will be not rounded to 2 decimal places unless we use the round function, and that's why we want to round the average amount to 2 decimal places. And we can also give an alias. For example, we want to call this average amount, and again, not forget the comma in the end afterwards. And then we are using also, this is optional, the count star, so that we just see how many payments have there been for this specific customer day combination, so that we can just verify that indeed our having clause, so our filtering of the results in the end, will work correctly. And this is of course all what we want to take from the payment table. And now we remember also that we want to filter this to 3 specific days. And this is why if we want to filter the underlying data, we do this right after from. And in this case, we want to filter, of course, the payment dates. So we can also use that in the where function. And now we can either combine those 3 conditions using an or conjunction, or we can also just use the in clause. This is also possible. So in our case, we have those 3 specific days we wanted to mention. And then after we have done that, we can now group the data as we have said. So we want to group by the customer ID and also the payment date. So this is the date of payment date. And now in the end, of course, also we would like to order the results. So we want to order by the average amount. We can either use this specific column like this. So we can do it like that. Or we can also just use number 3. So then the 3 will just be representing the average amount because it's the third column in the output. So if we execute the results like this, we see that we have here a little error, which we can see also in the error message, as well as it is underlined in here. So we can correct that. This is customer ID like this. And now if we execute this query, we will see this is not ordered yet in a descending order. So let's do that again. And then we are seeing those results. And of course, we have now many results where count is not greater than 1. So if we also want to add that, we use having. And now we can use this count star is greater than 1. And now if we execute that, we get the desired result. So this was now bringing a lot of elements together and a lot of things that we had to combine. But hopefully this was a challenge that could help you to apply those different things and was indeed a little bit more challenging. Now, of course, we want to get more practice. And for that reason, we also want to set up an additional database. This will just give you the opportunity to practice more with more different data. And the first step in which we are now going to set up this database, you have to just navigate to the resources in this lecture and download this zip file called flight database. That's the database that we are going to set up in this lecture. And afterwards, you can also practice with this new database. So after you have downloaded this database, just right click on it and go to extract all. Afterwards, we are going to extract it, and then if we are opening that up, we have now these two files. So this is now the SQL file. So this is basically a lot of code that is all going to set up our database. We don't need to do anything with that. The thing that we need to do is only open up now a text file. So you can, for example, open up Notepad, and in here we now want to paste the file path of this file, because this is what we are going to paste later on into pgAdmin. So for that reason, we go again to our folder and we can right click on this SQL file. We go to properties and in here we find this location. And just as a quick note, if you have multiple hard drives on your machine, put this file into the hard drive where your operating system is installed on. Usually, if you just leave it in the downloads folder, as I have done, this should be absolutely fine, because this is usually on the same hard drive where also your operating system is installed. So if you leave it there, it should be all good. So this is what we are going to copy, and then we add another backslash, and we now also want to add this file name. So we can right click and go to rename, and then we can again just copy what we find in here and paste it again. And now we also want to replace those backslashes with forward slashes, because in the command line of pgAdmin, instead of this backslash, they use a forward slash. So that's why we go to edit and then we find replace. So in here we want to replace those backslashes with a forward slash. We can select replace all, and then everything will be replaced. And all that we need to do now is add also the extension .SQL. We want to end this with a single quote, also a single quote in the beginning, and now again one backslash and I. And also don't forget about this white space. So we have backslash I white space. This means that we want to execute this file. So this means we want to execute this file that we see in this path. And now we can just copy all of that, and now we need to paste that into the command line in PostgreSQL. So how do we open up this command line? It's very simple. We can just right click on any database, for example Green Cycles, and in here we have this pSQL tool. So this will be our command line. And in here we can now just paste all of this entire code, and now we just hit enter, and like this, all of that code in this file will be executed in pgAdmin. All of the data will be copied and inserted, and then after just a few seconds, our database should be ready. And once we see demo equal to hashtag, we are set up with our database. We don't see it yet, but if we right click on the databases and say refresh, we see our new demo database. So we can now open this database up, and then we see that under schemas, we have the schema bookings, and in here we also have our tables. So these are now the tables that we can use to practice. So what we want to do is we can now open up the query tool from the booking schema, and in here we can now, for example, have a look at our tables. So for example, we want to select everything from the seats, or let's say the flights table. And if we do that, we see all of our flights, all of that data that we now have available to practice. And in the next lecture, we are going to have a few challenges to apply the knowledge that we have learned today. Today was a very important day because we've learned about the very fundamental concept of grouping and aggregating data. This means that we have started in the beginning just with aggregating data. This means we take a lot of values and combine them, condense them using some aggregate function like sum into one single value. And these were the 5 most important aggregate functions that really cover almost all of our requirements. So we've seen if we do this, we can aggregate one specific value. What we cannot do is, if we are using an aggregate function, use another column that is not aggregated without including it into the group by clause. And that's why we've introduced the group by clause. This is to group aggregations by a specific column. And like this, we get, for example, the sum of all of the amounts for every single customer. So we group by the customer. This means that now, in conclusion, if we are aggregating data in our query, every column in our select must either appear in an aggregate function, or if it does not, it needs to be included in the group by clause. And in the end, we were also learning about the having clause. This is not used to filter the underlying data like with the where clause, but it is occurring and filtering after the data has been already aggregated. So with having, we are filtering based on an aggregate function. So the condition is in this case an aggregate function. So this is what we have learned today, and tomorrow is the first day where we are entering the intermediate level. So congratulations on that, because tomorrow will be an exciting day where we are learning about functions, time calculations, strings, substrings, positions, and different types of functions. So it's going to be an exciting day tomorrow, and I'm looking forward to see you back tomorrow. Welcome to today. Today we are going to learn about the different functions we can use in SQL. So today we are going to structure it that we first learn about the text-related functions. So for example, here we see in the email that the name is written in all caps, and we want to see how we can transform the texts, and also, of course, how we can extract data, how we can work with extracting different parts of the string. For example, we want to extract, in some cases, the email address provider. And this is what we are going to learn about in the beginning, after which we are then going to learn about working with dates. So we see that we can also, of course, from the dates, extract certain parts like the month, the year, or also, of course, work with timestamps, as we can see in this case. And then last but not least, we are also going to learn how we can use mathematical functions and operators, so that we can also calculate with numbers. So we've got a lot to do today and to explore and learn, and that's why we don't want to lose any more time, and let's get started with working on the text functions. We want to start with the string functions. One of the most common and basic string functions are the upper and the lowercase functions. So for example, in our case, we see the email address. The first and last name is in uppercase, whereas the rest is in lowercase. And we can now manipulate this data output using functions as upper and lower. We want to start with the upper function, which is just making all of the text of this column in uppercase. case. So in our case, we therefore just call this function called upper, and we include the column name in the parentheses. So if we do that, we see that the result is now this email column where everything is in all caps. Of course, we can also rename this email upper by just using an alias, so it's a bit more descriptive. And the important thing to note is that this will not change the column in the database itself. It will only change the output of this specific query. This means that if we still call the normal column email, in this case, it will still give us our original result, because the column in the database is not affected, just the output of this specific query. And now, if we also, for example, want to use the lower function, we can do that in the exact same way. So we can also give it an alias, and we should not forget about the comma. And then we see we have now all options, and we can choose which option we would like to use. In my case, I think this email lower is the nicest option. And we also in this lecture want to learn about one last function, which is the length function. That's also a string function that is just returning the length of the string. So for example, if we use again email, then we see in the end we have, so for example, in our case, we can just get rid of this first one. So we see here we have now the length as well. So this is the number of characters in this text string. So like this, we could, for example, now filter to only those customers where the length of their email address is, for example, less than 30, for example. So like this, we see only the customers with very short names. And at this point, I also want to mention that, of course, it is not important to memorize all of those functions. That is really not necessary. But in the daily work, it is a very important skill to just research the function and how you do something. Of course, we are here to learn the basics and the fundamentals and all of these practical skills. But in your daily work, it will still be necessary that you sometimes Google something. So this is why, for example, if we want to make something uppercase, we can also just Google. For example, we can search PostgreSQL, since we are working with Postgres, and then we can just search, for example, uppercase. We can just do that, and then we will see immediately the uppercase function, and we will find something about that. If we also add the word documentation, we can immediately see here on postgresql.org the official documentation where we have now all of these string functions in this list. For example, if we now want to make something into lowercase letters, we can just now on this page search for the lower function. And in this case, we find, okay, we have this lower function, how this function works, and what this function is doing. So this is something that we can just always do. And I want to just stress that it's not necessary to memorize every single function by head. So these are these three first functions, and now it is your turn again to apply this knowledge in the following challenge. In this challenge, there was a problem in the company's email system in such a way that with names where either the first name or the last name has more than 10 characters, the email will not be sent. So this is why in this case, your task should be to create a list where all of these customers occur. So where either first name or last name has more than 10 characters, including the email address. And all of this should be in lowercase letters. So this is your job to write a query to find out those results and to compare the results again to see what the expected solution should look like. Here are also now the expected results. This is how the results should look like. And now it's your turn to write this SQL query, and in the next lecture we are going to have a look at the solution. We want to, of course, first start with selecting the first and the last name, both in lowercase. So we have the first name and then also the same thing, also for the last name. And of course, also the same thing we want to do for the email address. And this all, of course, comes from the customer table. And now we want to filter this data to all of those results where either the first name or the last name has more than 10 characters. This is why we use, of course, the filtering. And in here we want to now filter using this length function. So we first want to have our first condition. So first name is greater than 10. So the length of this is more than 10. And the other option, since we have an either or condition, we use or, and then again we use the length function, and this time we want to use the last name, and again here it can be greater than 10. In this case the result will appear. So now if we execute this query like this, we will get our expected results. But now, what happens if we only want to see a certain part of the string? For example, the email provider, or the first letter in the first name, or the first letter in the last name. In this case, we need to learn about left and right function, and also how we can combine text from multiple strings. So that's what we are going to learn in the next lecture. Oftentimes, if we are working with text strings, we want to extract certain parts of a text. And one of the most commonly used functions for that is the so-called left function, as well as the right function. Let's start with the left function. The left function is used to extract a part of a string starting from the left side. So for example, if we want to extract MA from the name Mary, we can use the left function. This means we want to insert in this function the column name. So it is first name. And then we can have a second argument, which is specifying how many characters should be extracted. So in our case, we want to have 2 letters extracted. This is why we use the 2. And then, of course, we can just to verify our results also include this first name column. And then we see that indeed we have now just extracted the first 2 letters of this column. Of course, we can change this up to how many letters we would like to have. So for example, only 1, then only the first letter is extracted. And now, of course, the same thing works with the right function. This is just basically working exactly the same way. So this is very easy. We have now in this case just extracted the last letter, so Patricia, the A, Linda, the A, and so on. So this is not very complicated. But now what if we want to extract, for example, only the second letter? So we want to extract only the second letter of the first name. In this case, there is also another solution that we are going to talk about later, which is a little bit more intuitive. But in fact, we can also solve that only with the left and the right functions by nesting those 2 functions. This means that first, if we want to extract only the second letter, we use first the left function. So the left function is there to just go, we want to extract the second letter. So this is why this has to be included. If we execute that, we have here our A. And now, since we want to get rid of this first letter, we can nest now the right function. This means that we want to now apply the right function so that we only get the first letter from the right side. So this is now the argument that we put into the right function, and we want to extract only 1 character. And like this, we will, if we execute that, get now only the second letter. So if we now make a comma in here again, we see that indeed we have just extracted now this letter. And if we want to now, for example, get the third letter, we can use a 3. And then we have extracted the third letter. So this is how we can use the left and the right function. And of course, if we, for example, want to extract the initials, we might also want to concatenate strings. This means that we want to combine multiple strings and bring them together in 1 column. But before we learn about that, it is now again your time to practice what we have learned in this lecture. In this challenge, your task is to extract the last 5 characters of the email addresses. This is your first challenge. And the second challenge, for this challenge, be aware that the email address always ends with .org. You want to extract this dot from this email address. So this is your task. How can you extract only this dot from the email address. Of course, you know that you can nest the functions left and right together in a specific way so that you can extract this dot. So your task is to write a SQL query to exactly do that. So this is what the results should look like. Of course, first the last 5 characters extracted will look something like this. And then if you extract only the dots, of course, only the dots should be visible. So this is your challenge, and in the next lecture, we are going to have a look at the solution. Now let's have a look at how we can solve those two challenges. First, we want to extract the last 5 characters from the email address. So for that, we want to use the right function because we start from the right side, because it is the last 5 characters. And of course, the column that we are using is the email column. And how many characters? Just 5 characters. We can also include the email address itself, and then we see that this is now what we are supposed to do, and this is not very difficult. And now the question is, how can we extract only this dot in here? We can do it, of course, in 2 ways in a way. The first one is to start from the left side, but this is a little bit difficult because the names have different length. So we cannot say that we want to extract the first 15 characters and it will be always the same. This is because the length of the names, of course, is different every time. But we can also just start from the right side first. And in this case, we extract the last 4 characters, and this is always the same. So this is always now with the dot in the first place. So if we now nest the left function around that, and then we extract the first characters, we get exactly our desired result. But now, what happens if we, for example, want to extract the initials? So we want to extract one part from one string, another part from another string, and we want to bring them together. This is what we want to learn in the next lecture. It's very common to combine different information from multiple strings, and we want to bring them together in one column. For example, in our case, we would like to extract the initials. This means the first character from first name and first character from last name. Of course, we can do that very easily using the left function, so first name, first character, and then the same thing we can also do for the last name. So we just say the last name and also first character. In this case, we can extract those first character strings. But now, if we want to bring them together, we can just combine them using the double pipes. This is called concatenation and just means that we add this string to that string. So they will be now combined. If we do that, we see that now they are together. Of course, we can also include the first name and the last name just to see the results are correct. And this is really indeed correct. So we combine this string with that string just by using these 2 pipes, and that's called concatenation. Of course, we can add many more strings. This is not limited to a specific amount. And for example, if we now also want to include the dots in between, so a dot after the M, for example, then we can also just concatenate a text string as well. And a text string that we manually type, we do with using those single quotes. So for example, we want to include this dot manually, then we can also just concatenate that. And then we see that now after the first letter of the first name, we also have this dot. And now, of course, if we want to also do that after the first character of the last name, we again use the double pipes, and now again a second dot in the end. And of course, if we want to give it an alias, we can also do that, for example, initials, and then this is much more descriptive. And like this, we have now extracted also the initials by concatenating multiple texts. And now in the following challenge, you will be again prompted to solve a challenge for the manager that you are working for. So that's what we are doing in the next lecture. In this challenge, you should now anonymize the email addresses. So you should create a list of the anonymized version of the email addresses. This means Mary Smith, for example, should be in the following form. First, the first character of the email address, then these 3 asterisks, and then the email provider starting with @sakilacustomer.org. So this means the first character first, afterwards these 3 stars, and then the last part that starts with the @ And note that always the email address provider is the same, so the email address always ends with @sakilacustomer.org. So this is your challenge to write a SQL query to get this list. And the result, of course, should look like this. So just that you can verify again your results. So good luck with the challenge, and afterwards we'll have a look together at the solution. Now let's see how we can create this anonymized version of the email address. We want to have a look at the customer table. And first we want to, of course, extract the first character of the email address. So we use the left function, we use the email address column, and 1 because it should be only the first character. Now we want to concatenate this with the 2 double pipes, and we want to add now these 3 asterisks. So if we do that, we see that now we have M and then these 3 asterisks. And then afterwards, we again want to concatenate now the last part. And now we know that the email address always has the same structure, and we can use therefore the write function from the email address to get the last parts of this address. And of course, we can count how many characters are there. And indeed, these are 19. So we can also, of course, test and find out like this by just testing different numbers. For example, if we try 20, we see it's 1 too much. Therefore, we can try, for example, 19. And then we see this is exactly the result that we want. And of course, we can also give this an alias as well. So anonymized email. And like this, our column is again more descriptive. But now what happens if there would be a different structure? So if we would, for example, have different lengths because the email structure would be different, we have different email providers, how could we then find this last part, which always starts with the @ if we could not use this left and right function? For that, we would have to find a different solution. And this is what we are going to find out in the next lecture. Oftentimes in practice, the structure can be different in every single row. And this means that sometimes we need to search for one specific character or one specific string. And for this reason, we are usually using the position function. This position function we want to have a look at. So if we use this position function, we can now specify what type of string we are searching. So for example, in our case, we are searching for this @ sign, and then we can specify where we want to search this in. So we say in, then the string that we are searching this in. So in our case, this will just be the column email. And then everywhere we get the position of this character in this column returned. So if we, for example, also add the email address, then we see that now we have in the first row at the 11th position this @ sign. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the 11th position. And of course, now what we can do is we can nest this into the left function, for example. So this means we want to extract from the left side from the column email address. And now this gives us the value 11. This means we want to extract all first 11 characters in this email address. So if we close the parentheses of this left function, we get now, of course, here the first 11 characters extracted. But of course, the 11th position also includes this @ sign, but this is not a big deal because we can just subtract a specific value, like for example 1, and then this @ sign will also be removed. But we can not only, of course, specify our own custom string that we denote with these single quotes, but we can, for example, also search for a specific value of a specific column. So for example, we can search for the value in the column last name. And if we do that, we see if we also remove maybe this 1, we see that now, of course, we get the position where the last name starts. So this also includes this first character of the last name. And therefore, if we now subtract 2, we remove this first character of the last name as well as this dot. And then we can, like this, for example, extract only the first name of this email address. So this is something that we can do. And oftentimes this position function is used in combination with the so-called SUBSTRING function. And this function is super interesting. That's why we want to have a look at this in the next lecture. Now let's challenge your knowledge about the concatenation as well as the position function. So in this challenge, you have only the email address and the last name available. This means that you have only this email address and this last name, and you cannot use any other columns for this challenge. So what you need to do now is you need to extract the first name from the email address, and then you can concatenate this with the last name, and the last name you have just normally available. And it should be the output in the form last name first, afterwards separated with a comma and a white space, and afterwards there should be the first name that you have extracted from the email address. So your task is to write a SQL query to get this form of the last name and first name. So the result should look like this, that you have the last name, comma, and then the first name. So good luck with this challenge, and afterwards we'll have a look at the solution. Let's have a look at how we can find out how we can get this form of last name and first name, while we have only the email address and the last name available. First, of course, we want to extract the first name, because this is a little bit more difficult. So for that, we want to extract first the first name, and one thing that we can do that is using this dot, because we know this dot basically separates the first name from the last name. So if we do that, we use the position function from the email address, and we are searching for this dot in the column email address. If we do that, we get the position of where this dot occurs. And now, of course, we want to use the left function to just extract this first name part. So we want to again use the email address until position where this dot occurs. And since we don't want to see the dot itself, we can just calculate -1, because then it will just not include this dot. So it will be one position earlier. So this is now already the first name. And now we can simply concatenate this with the last name. So of course we said we want to have the last name first. And now if we immediately concatenate this, we will not get exactly the correct result, because in between we also want to have a comma and a white space. This means that we need to also concatenate that. So we have first a comma, afterwards a white space, and then we can after that concatenate the first name from the email address. So if we execute that, we now get this result in the desired format. So this was another practical example that hopefully could help to practice your knowledge about concatenation as well as position. But now we want to dive a little bit deeper into another version, that is the SUBSTRING function. This is a very helpful and practical function that we are going to have a look at in the next lecture. It is a very common requirement that we need to extract some substring of a given string. And oftentimes it's not very convenient and elegant to work with the left function or the right function, because maybe we just want to extract some part of the string that is right in the middle. And like this, it could be very complicated or even impossible to work with just the left or the right function. That's why in this lecture we want to have a look at the substring function. This is used to, as the name suggests, extract a substring from a given string. For example, we have the email address and we would like to extract the substring, which is just in between this point and this @ sign. So some part that is here in the middle. So in this case, we would get that substring extracted from the email address. So let's see how this syntax works for the substring. We have first the string that we want to extract from. This is basically, for example, the column email address. This is where we want to extract from. And then we have afterwards the position, so the starting position where we want to start extracting from. So we don't want to start maybe right at the beginning of the string, but we want to start at some point in the middle of the string. And then last but not least, we also have the optional argument for how many characters we want to extract. Do we extract 10 characters or do we just want to extract 3 characters? And note that this is an optional argument. If we don't specify this at all, we just get until the end of the string. So we extract everything till the end of the string. Let's have a look at this example. For example, we want to extract from the email address and we want to start from position number 2. So we want to start at the second position and we want to extract 3 characters. The result for that would be like this. We start at position number 2. This is why we have from 2. And then we start with 3 characters. 3 characters we want to extract starting from position 2. And if we would not specify this for at all, which we remember is just optional, we get everything extracted until the end of the string. So this is sometimes also helpful. But oftentimes the from argument is not used with a plain number, but this is more dynamic with the position function, because this gives us the starting position of where we want to extract from. And if we now want to extract starting from this point, then we can use the position function to just start at this position where this point is. So this would be the first position. We could also, if we don't want to have this point included, but just start one position later, add the number 1, and then this is just the result of position plus 1. So then we will start just with this last name. And in a similar way, we also oftentimes don't use a fixed number at 4, but for example, we can also use the length function. And for that, we want to jump into pgAdmin to just see a practical example. We have seen that we can extract the email from the position, so where we start with the point, and we start one position later. And now, for example, we could use the length function because we want to see how many characters we want to extract. And in this case, we could use, for example, the last name, because this would now indicate how many characters we want to extract, because this is the length of the last name. And then if we execute that, we get, in fact, just this last name extracted as we were planning to do that. Of course, if we use a very simple example, then we can also just use SUBSTRING, then where we want to extract this from, email, and then we want to see this is starting from number 3 and we want to extract for 2 characters. Then we get this result. But now, what would be another way of achieving that same result if, for example, we don't have the length of the last name available? In this case, we can also work with the position function in a different way. So stay with me, this is a little bit more complex, but we can do that also with the position function. We have to keep in mind that we want to have the length of this last name. And we can get this length by subtracting the position of the dot from the position of the @ sign. And then we get basically this difference, which is the length of the last name. So we can do that by just using the position, and then we have again what we are searching for is the @ sign first, and this should be in the email, and then we want to subtract again the position, and now we want to search the dot, and again this should be in the email address. And if we execute that, we get this, but we see that in fact the length is 1 too long because it's also including this @ sign. So we can also just manually add or subtract a value, for example 1, and then we get very dynamically this last name subtracted from within here. So this is how we can just extract a string that is in between 2 different characters. So we can also use the length and the position function in this substring. But now it was enough theory, and now it is again your turn to practice and apply your knowledge. Now let's again challenge what you have learned in the previous lectures. In this challenge, you should again create an anonymized version of the email addresses. And the first version, we are going to have 2. The first one is in the following form. So you should create now some kind of SQL query that gives us a list of the anonymized versions of the email addresses in this form. In the second query, and this is going to be a little bit more difficult even, is that you should create a second version in the following way. So in this case, we want to have just the last character of the first name, dot, and then the first character of the last name, again, followed by these 3 asterisks, and then add the email provider. So this is your task, again, to write a SQL query to find out how you can do that. And after you have tried this yourself, in the next lecture, we are going to have a look at the solution together. Let's have a look now at how we can solve first our first challenge. In that, we first want to extract the first character of the email address. So in this case, the M, and this is of course something that we can also do with the substring, but in fact, it's just very easy if we want to use the left function. So in this case, we are really good to go with the left function, and then of course, this should come from the customer table. So after we have that, we want to concatenate this with the string, which just includes 3 asterisks. And afterwards, we want to now continue to extract this dot and then this first character of the last name. So for that, we want to concatenate this again. And now we want to work, of course, with the substring. In this case, email is where we want to extract from. And now we want to specify using the position how we want to, or where we want to start extracting from. So we want to extract using the position, and we want to search for this dot in the column, of course, email address. So this is why we use email. And now if we have specified that we want to start at this position, we can say we now want to extract a substring of the length 2, because we want to have the dot as well as the first character. So this is why we can now use for and include 2. And if we execute the query like this, we see that we have some error, and this is because we just have a little typo, which we can also see because this is not in this color. So this is why position was not recognized as a function. And if we execute again, we see that now we have the correct result. Of course, after that, we again want to concatenate this, and don't worry, we can even go in another line if we want to, so that we have a better overview. This is not an issue at all. So we could also do that. And then we want to have, in this case, again, these 3 asterisks, and then afterwards, this should be again concatenated with the substring. So we can just, in our case, copy that. And in this case, we want to start at the position where the @ sign is, and we want to have this till the end. We know this is in fact just 19 characters long, but since we know this is the complete end of the string, don't even need to specify that at all. So if we concatenate it like this, we get that we have all of the correct concatenations and we get our final result. Indeed, it is correct. If we would not want to see, for example, this dot, we can also add here the value +1. So we start 1 later, and we can also just reduce this to 1, and then we would get it like this. But in our case, it was good as we had it before. But now, how can we solve also this second challenge? In this case, we know that we want to start with these 3 asterisks, and then we want to concatenate this with, of course, now the substring, and we want to, of course, start with the email address, and we want to start from position, and in this case, we are searching for this dot again. This is our reference point. That's why we use the dot. And then we can say that this should, of course, be in the email. And now we don't want to start with the dot as our first character, but we want to start 1 position earlier. This is why we say we want to have -1. And now we know we have 1, 2, 3 characters. This is why we can now just add for 3. So we are only adding 3 characters in here. And afterwards, we can again just add these 3 asterisks. And then after that, we again want to use a substring. So we can again use the double pipes. And in this case, again, we can just copy that. So we don't need to type so much. And in this case, we don't want to search for the dot, but we want to search for the @ sign. and we want to now extract everything till the end. So we can completely remove that optional argument. And if we execute it like this, of course, we also need to add from customer, and then we should hopefully get the correct result, which indeed we get. So this was a little bit more tricky. It involved a little bit more trial and error maybe as well, but hopefully it was a good practice. And in the next lecture, we now want to dive deeper into extracting parts of dates and times, which is super important. So that's what we are going to do in the next lecture. In this lecture, we now want to talk about dates and timestamps and how we can work with them. For that reason, we first want to query everything from the rental table, and we are now asked from our manager to analyze the rentals, so the rental date. And we can see that this is a timestamp, and we now need to analyze how many rentals did we have in every single month. Or also maybe on what hour of the day we have the most rentals. And to be able to analyze and do all of that, we need to be able to work with timestamps and dates. And in particular, we need to be able to extract certain components, certain parts of a timestamp or a date. And that's why in this lecture, we want to talk about dates, timestamps, and in particular about the extract function. This is the function that is used to extract certain parts of a timestamp or a date, or in some cases also an interval, which we are also going to talk about. So, for example, we have this rental date, which is in a timestamp, and now we would like to extract just the day of the month from this timestamp. So, if we want to do that, we can just apply the extract function in the right way, and then we get all of the dates. So, for example, in this case, 24, 25, 25, and 25. But also, we can extract different parts. For example, we can extract the seconds, and this is also possible with the extract function. But before we talk more deeply about how this extract function works, we just want to get a brief overview over the different date time data types. So, first of all, we have the date type. This is just a regular date without any time. And in here, we have one example of how this can look like, and this is the standard format. So we have year, month, and then we have the days. This is the standard format. Note that there are also other formats accepted, but this is the standard format, and that's why I also recommend to just work with this format if possible. Then also, we have the time. And in this case, the time can be with the time zone or without the time zone. This example is without the time zone. If we would have the time zone included, we have plus, and then in this case it is plus 2 hours UTC. So we can see just the local time, and then we have also the time zone. So this is 2 hours plus in this case. And then also we have a timestamp, which is now just a combination of the date including the time, and again this can be with or without the time zone. And last but not least, sometimes we also can have intervals, which is basically just a difference of two different dates. So we're also going to see an example of that. But now let's have a closer look at how we can use this extract function and how it works. So we have this function, and it is very easy in the syntax. First, we need to have the field. This is basically just a part of the date or the time. For example, we want to extract the day, then we just type in the field, we type day. And then also from, and then we have the column, which can be date, time, timestamp, interval. And this is then where we want to extract from. And now in the next slide, don't be overwhelmed. I just have an overview of all of the possible fields, so all of the possible parts. But don't worry, you don't need to know all of them by head. So this is just something that you can easily look up, which I just recommend, and this is what we are all be doing if we are working in the real world. We just need to, for example, find out we want to extract the day, and then we see this is the day. In this case, this is very easy, and the most important ones are highlighted in here. So this is actually very intuitive. So usually they are used in singular. So we have day, we have hour, month, quarter, week, year. So just what we want to extract. And in some cases, like in the seconds, so the second itself actually is also in singular, but the microseconds, milliseconds, these are just some exceptions because they are not in singular. But all of that is then what we have in singular, and actually it is not so important to memorize them all, even though it is quite intuitive. But now we have enough of the theory and we want to dive into a few examples. So in our case, we would like to find out in which day of the month we have the most sales. This is why we want to use the extract function, and we want to extract, in our case, the day from, and then we have the rental date. And note that this from is in not all caps, but it's in lowercase. This is to just make a difference from this regular from, so that it is used in a function, and this is just some best practice that you can use to just have this distinguished from the general normal from. And now that we have that, we can also use an aggregation function such as count, so that we can count how many sales we had in each of these hours. And then of course we need to group our data. So we want to, in our case, just group by this exact same column, and then we get our results. Of course, now we are interested, if we are grouping in that way, to order our results by, in our case, the aggregation function. And we want to have this, of course, in a descending order, so that we see the highest day at the top. And in our case, we can now see that this 19, 18, and 20 are actually the days in the month where we had the most sales, so the most rentals. Of course, now we can also just change that into, for example, month. And then we see this is not working because this is different from where we have it in our group by. So we also need to change that. And then if we execute it, we also see our most successful months. So this was now a lot of new things, and that's why it is now your time to apply this knowledge and practice the extract function in the next lecture in the challenge. In this challenge, you can now again apply what you've learned about the extract function. So in this challenge, you now need to analyze the payments table and find out the following three things. First, you need to find out what's the month with the highest total payment amount. Afterwards, you need to find out what's the day of the week with the highest total payment amount. And note here that 0 is equal to Sunday. And last but not least, you also need to find out what is the highest amount one single customer has spent in a week. So that's the last challenge that you should now find out, and now it is your turn to apply your knowledge and find out the answers to those questions. Also, we now want to just quickly have a look at the expected results, just so that you can quickly also immediately verify your results. So we now want to see the answer to the first question should look like this, to the second question should look like this, and to the last question we have this payment amount. And note also that in this case we have used some aliases just to make the output, the columns in the output, a little bit more descriptive. So now enjoy your challenge, and in the next lecture we together go over the solution. Now let's have a look at how we can find the solution to our questions. So first of all, as we always do, we just want to quickly see the entire table. This is just that we know what columns we are working with and how does the data look like. So in this case, we see we have the payment date with our timestamp, we have the amount, and maybe later on we also need the customer ID. So first we need to find out what's the month with the highest total payment amount. That's why we want to, of course, work with the extract function. We want to extract the month from the payment date. And note that in this case, I'm writing from in lowercase letters. This is just to distinguish it from the from where we have the table. So this is just a best practice that helps to make the code a little bit more readable. So if we use from within a function, it's a best practice to not write it in uppercase letters. But of course, if we now want to also sum the amount, we need to group also our data. And that's why we also want to use the group by. And now if we want to group by that same month, we can just copy that and also then get our results. But what we can do as well is just give this an alias, for example, month, and then this alias can in this case also be used in the group by. This is because the alias is evaluated before the group by is evaluated. And that's why this month is already known and we can then just group by the month. And in this case also the month is in a special format as it is also a special keyword. So it can be used also here in the function. And this is not a problem if we have it like this. If we don't want to have this appear like this, we can also just write it in these double quotes and then it will be just not highlighted in that format. But in our case, it really doesn't matter and we are not really bothered by that. But now we also would like to give the amount a alias. So we can say, for example, payment amount. We can also say total payment amount. And then, of course, we also would like to order this in a descending order. So we can order this by the total payment amount. And we want to do that in a descending order, and like this we get our expected result. And now if we want to get not the month, but we want to get the day of the week, we can just use the field day of week. Of course, we can rename this into day of week, and the same thing we can also then do here, of course, in the group by, otherwise it wouldn't work. And like this, we now also get the result for the best day of the week. In this case, it is the 4th day. So this is what we wanted to know. And now, last but not least, we also want to find out what's the highest amount one customer has spent in an entire week. For that reason, we also need to include the customer ID. And of course, we also need to group by that customer ID. So we also need to include it in our group by. And then if we execute our results like this, we see we have an error. This is because we have forgotten about the comma, which is one of the most common mistakes we can do. So we can quickly fix it. And then we also get our results. And of course, what we have forgotten is to change the day of week into the regular week. So we need to do that as well so that we get the correct results. So if we now execute it again, we get the results that we expected. So hope this challenge was helpful, but we could see, for example, if we have now multiple years, then we would not see from which year this is coming from, but all of the years would be aggregated. So we cannot distinguish, for example, if we have again our months, we cannot distinguish what year this is coming from. So we need to find a solution for that. And that's why in the next lecture, we are going to have a look at how we can format our dates in a very custom way. So that's what we are doing in the next lecture. In the last lecture, we have seen how we can extract certain parts of a date or a timestamp, and this is what we can do with the extract function. If we want to create our own very specific custom format though, for example, the year together with the month in one column, this is not possible with the extract function. For such very custom formats, we can use the so-called toChar function. This is the function that we use to get custom formats from timestamps, dates, intervals, or even numbers. For example, if we have the rental date in a timestamp, then we can, for example, extract our very specific format. In this case, the year, then we have a hyphen and the months. We can apply this toChar function and get exactly this format out of that timestamp. Or alternatively, we, for example, can also just get the month, and then this is also written in a plain text. Note that the output of this function is always a text column. So it's not a timestamp, not a date, but just a plain text. But we'll learn more, of course, about what specific formats we can use and how does this work. First, we, of course, want to see how does this toChar function work. We have just two arguments. The first one is typically a column in a date, timestamp, time, interval, or even numbers format. And then after the comma as a second argument, we have our very specific format that we can choose. For example, we want to use the rental date, and as a format, we want to have the months, then a hyphen, and then the years. We can just type that like this, and later on, of course, we see how this format works, but then the result would be just exactly that format that we have specified. So let's see how we can do that now in practice in pgAdmin. So in this case, we can just add another column, and this would be our to-char, and we can now, in this case, use the payment date, and we can now just choose our own format. We do that in this single quotes. So for example, we can do the month and then the year in these letters. But we can also, if we execute that, do it in a different way. So for example, we can also just turn that around. So we have that maybe a different sign even, and then in here the months. This works as well. But now, how does this work, and what can we choose, and how does this all work? For example, we can even use the day, and then we have the weekday. And again, those keywords that we can use, we don't need to know them by head. We can usually just Google that. So Googling anyways is a very important skill if you're working as a data analyst, data scientist. And since it is impossible to remember all of them, since you probably just use them once per month or once per quarter even sometimes, then this is just very easy to look up. So I'm just going to the documentation of Postgres, and here we have the data type formatting functions. And one of them, the most important one, is the to-char function. We also have something like the to-date, which we can use to create a real date out of a format that is in a text and maybe which is a little bit specific, so we can just turn that into a date. But for now, we want to focus on the to-char. And if we scroll down in here, we see all of those patterns. So for example, we have the year with those 4 Ys. And in this case, it will be just a year with 4 or more digits. And also, we can, for example, just use 2 of them. And in this case, if we use 2 of them, of course, we get just the last 2 digits. And now we can use either those very specific patterns, or we can also just use our own signs. So for example, if I want to use that /, I can use that. And if this is not included in this list of very specific patterns, it will just be displayed anyways. So in this case, I will see it then after this pattern. So like this, I can, for example, create the day, and then I can, for example, use a white space. I can use the month, and then I can again, for example, use the year in this format. Maybe we want to use 4 of them, and then we get exactly our specific result. And of course, what I can do is I can now, for example, also group in that way. So for example, I want to take the sum of the amount, and then I want to use this format, and I can now also, of course, group by this exact format. And in this case, I have a mistake. Of course, again, what happens usually, we forgot about the comma. And if we are a little bit bothered by these white spaces, this is because this is in the specific format. If we have a closer look to the day, we see that this is blank padded. That means if there is a very long day, this will be padded up to 9 characters, because sometimes we have longer weekday names, and this is why in my case I would prefer to use this abbreviation so that this is not blank padded like this. And if we do that, we get now this specific format. So this is how we can work also with our custom formats. In this challenge, you are now again asked to analyze the payments. So you need to aggregate, basically sum up the payment amounts and group by very specific formats that are according to the guidelines of the company, and we need to get that insights. So first we want to group by, of course, this day format, and we want to, of course, as mentioned, sum the payment amount. Afterwards, we want to group by the month and the year, and don't worry, the alias, of course, you can choose differently. And then last but not least, also we want to have the weekday and then the time with only the hours and the minutes. So these are three different, very specific formats, and we want to find out what are these different values. Of course, the order can be different. I have ordered those first two in an ascending order and then the last one in a descending order. But the order is not so important as long as we have the right format. So that's your challenge, and in the next lecture we walk together over the solution after you have tried it, of course, yourself. Now let's have a look at how we can find out those answers. First of all, we want to have a look at this format. So we need the weekday in this short format, then the day, the month, and then the year. And in between we have commas and these forward slashes. So what we are going to do is, of course, first we need to look up those formats. So we have first this abbreviated weekday. So this is exactly the format that we need. And then afterwards we have a look at the days. So this is not very complicated. We see the days is like this. This is the day of the month. Then we have the months, which is just an M. These are very easy, so we don't even need to look those up. We can just use them. So that's why I'm using to char, and then I'm using the column payment date, and now our format in single quotes. So we have the day in short, afterwards a comma, and then again a white space. So this is also necessary to use, otherwise we wouldn't have that white space. And then we have, of course, the day, now the forward slash, then we have the months, again with a leading 0. This is why we use 2 M's. And then afterwards the years in this format, and if we do that we get exactly that. But now of course we also want to sum the amount, and we can give this a name like total payment, and then of course the comma, we shouldn't forget about that. And of course we need to group that by, and we can in this case give this a name, which could be in our case the day, so we can just leave it at that. And then we execute it, and we get, because we have not used the keyword as. Now let's try it again, and we get exactly the result. Of course, we can now also order that by the sum amount. We can use, just for example, that keyword, and then we have a different order as well. So for example, we would like to have that in an ascending order or descending order. It doesn't really matter. Now we have the second challenge, in which we want to use now the month and then the years. So for the months we can also find this one. So we have the month in a long version, and then we have abbreviated capitalized month's name. So that's exactly what we are looking for. And if we want to include that, we can just say we want to have the month abbreviated like this, and then we just want to see the years, and in this case we can say something like month and year. And again, we can use that in our group by. And then if we execute that, we get the results that we wanted to have. So in this case, we have those results. Of course, depending on if it's ascending or descending, we get our different results. And the last option is now just the weekdays, which we've already seen. It's like this. Then we have the time in hours. And then the minutes. We need to check the minutes because it is a little bit different from what we expect. We have to search for the minutes. And if we do that, we see that the minutes is actually this MI. So that's what we want to use as well. And then we can also change that to day and time. So day time, we can copy, and then if we execute that, we get our desired results. Of course, again, if we want to do that in a descending order, we get our expected results. In this lecture, we just quickly want to mention a few helpful and interesting things about timestamps and intervals. So we can, whenever we want, just use the current date, and then we will just get the current date. So this can be done just by having select, and we don't even need to, of course, mention a specific table. The same thing we can also do with current timestamp, then it will not be a date, but just the exact timestamp. But if we now want to do that and also query from a specific table, because maybe we also would like to see the rental date, then we can still have this current timestamp also included. Then just both of them will be included. And of course, the same thing we can also do with the normal date. This is just fine. But if we now want to, for example, subtract the rental date from the current timestamp, then we get the difference. And this will then automatically create an interval. So we can see if we execute that, we will get an interval. And this is now an interval that we can also use within the functions like extract as well as toChar. So we see that if we, for example, want to do that, we can also just replace it with the return date, for example. This is maybe more interesting. And then we can just extract now specific values. So for example, we can extract the day. In this case, we can write day from and then this interval that we have specified in here. And of course, if we do that, we get now this number 3 extracted. And of course, now since this is an interval, we have not so many options, but we can, for example, extract the hour, we can extract the minute, and so on. So for example, if we would like to change that into the total number of hours, we can calculate that ourselves. So for example, if we say we have the day, then we multiply this, for example, with 24, because we want to convert everything into hours. And then we say plus, and then we want to extract again. So we can also write that in the next line. And we this time want to just extract the hours. And if we do that, we have everything transformed into the number of hours. And now we would also like to see the hours in a text, and we can do that by concatenation. So if we concatenate this numeric value with a text string, such as whitespace and then hours, everything will be just concatenated, and then basically just this 92 will be internally also converted into a text, and then this will be concatenated with hours. So this is something that we can do as well. And same thing we can also do with toChar. This also works with intervals. Just be again aware that this just has not so many options available as well. We can just, for example, use the days, but most of those options, for example minutes, we can also extract. This works, but not everything is possible. So for example, if we want to extract, of course, this weekday, then this will not work because this interval is not tied to something that is specific about a calendar date. So that's just something to keep in mind, and that's why actually this toChar function is not so super useful. But we can work with those intervals and also calculate them from timestamps and dates, and then we can also just extract specific values from it. So this was the wrap up about the timestamps and dates in SQL. In this challenge, you are now asked by the support team to create a list of all of the rental durations of the customer with customer ID 35. After that, you're also asked by the support team to find out which is the customer with the longest average rental duration. So this is something they need to find out so that they can solve some problems. And your task, of course, is to find out how you can answer these questions by writing a SQL query. And the results that we can expect should look like this. So for the first question, we are expecting just a list with the rental durations, all of the individual durations, and afterwards we have the list of all of the customers, and the highest value should be in the beginning. So this is the average rental duration. And of course now it's your turn to find out the answers to those questions, and then together we have a look at the solution. First of all, we want to find out what is about this customer with customer ID 35. So we just first mention the customer ID so that everyone knows. And then afterwards, we want to create a calculation of the return date minus the rental date. And then if we do that, we also want to filter that by the customer ID with ID 35. So that's what we get. And like this, we get this list. And of course, we can also just name it, for example, rental duration. And then once we have that, we can have a look at the second question. So in this question, we also need to find out which customer has the longest rental duration. So for that reason, we want to group by the customer ID, and we want to aggregate, so we want to take the average of this rental duration. And if we execute that, of course, we can also order this by the rental duration and in a descending order so that the highest value is at the top. And if we do that, we get the expected result, and customer 315 is the one with the highest average duration. So far, we've talked about functions with strings and date and time data types. So there's one data type left, and of course, this is the numerical values. So in that context, of course, we are talking about mathematical functions and operators. So the most important operators are just very basic operators, and this is also super intuitive. So of course, we have the addition, and this works exactly how we expected. We add, for example, 4 plus 3, and the result is 7. The same goes with subtraction, multiplication, and division. What we have to be aware of division is that if we use integer numbers, then the result will be truncated. This means, of course, 8 divided by 4 is 2, but for example, if we would not do that, but we would divide 9 by 4, then the result, since this is both integers, will be also truncated to the integer number. So in this case, it would be 2. And of course, if we now would use numerical values with a decimal place, then we would get the exact correct result. Of course, again, we could just round our results if we would like to do that. But now we have also a few other operators such as modulo, which is basically just the remainder. So 9 modulo 4 is just 1 in the remainder. And then also we have the exponentiation, which is in some cases also needed. And this all works as we expected. So for example, we can have a sum and we multiply this with a specific value. We can also add the value 1 or also just make a division of 2 aggregations. This all works and we can just do the calculation exactly as we would expect it. So that's very simple. And the same goes for the functions. There are not really a lot of functions that we should be aware of. So the basic one is just sometimes we need an absolute value. In this case, we can use the function, but also we can round our values sometimes. This is what we've already learned about. We have one specific type of rounding, and this is the ceiling function. This is just, as we can see in the example, rounding always up to the next integer. And the opposite of that is basically the floor function, which is just always rounding down to the next value. So you see, these are very basic functions, and I want to stress that you don't need to learn them all and memorize them all. This is again what I have mentioned before. The ability to Google something if you need it in a specific use case is what you should go with. So in this case, we know about the basic operators, of course, maybe the very basic functions like absolute. And then if we have some specific use case, for example, we need the trigonometric functions, then we can just go either to the documentation or make a quick Google search. This is the way I would suggest. So let's dive into a few quick examples. In our case, we want to have a look at the films, and we want to, in our case, increase the prices of our rental rates. So we have the rental rate, and we can just use that in the select. So we have the film ID and the rental rate, and we would now like to increase, for example, the rental rate by $1. And then we can also say as new rental rate. And of course, we can also still include the original rental rate, and we can also rename it as old rental rate. And if we do that, we see that now just the prices have increased. So this would be our calculation. But then we see, for example, here it is a lot more, and we would like to have some percentage increase. So for that reason, we can just, for example, also multiply it with a percentage. So for example, 10%. And then of course, again, we can just round our values, for example, to 2 decimal places. And then we see this could work as well. Now maybe we want to increase it by 40%, we can just change that as well. But now maybe we are not so happy with these values of $4.19, and we would prefer to always round up to 99 cents. In this case, we can, for example, experiment with the ceiling function. So in this case, we don't need the second argument because it's always rounded up to the next integer. And now we can just subtract, for example, the value of 1 cent. And you see that in this scenario, we are sometimes a little bit creative in how we can achieve our results. So in this case, we have achieved our results and we have calculated a new increased rental rate for our company. And again, I want to stress that usually you don't need to make super sophisticated calculations. It's enough to know the basic operators and how to work with them. In this challenge, your manager wants to increase the prices for films that are very expensive to replace and where the rental rate is not so high at the moment in relation to the replacement cost. So for that reason, you should create a list of films including that relation of rental rate and replacement cost, where the rental rate is less than 4% of the replacement cost. So that involves some kind of calculations. And for that list, you should also include that relation or that percentage value of the rental rate in relation to the replacement cost. And this percentage value should be rounded to 2 decimal places. So the result should, for example, look like this, 3.54. And this would mean 3.54%. So I know this is now a little bit more complex, and especially because we can have some pitfalls that we should not tap into. So the result should indeed look like this. So it should be for our, if we take the order in an ascending order, then it should start with 3.30. So we don't want to have this with 4 decimal places, and we also don't want to have this. So that is something that could occur as well, and we should not tap into this trap. So it's indeed a little bit tricky. We might want to have a little bit of trial and error. And you can take this chance to just experiment a little bit with the calculations and the roundings. So good luck with this challenge, and in the next lecture we are going to have a look together at the solution. Let's see how we can calculate that relationship of the rental rate and the replacement cost. So in our case, we therefore, first of course, we can include the film ID, and now we just want to calculate the rental rate, so the relationship between rental rate and replacement cost. So this would be then just the percentage of the rental rate from the replacement cost. So in that case, we can also give it an alias, so for example, percentage. And of course, we would like to now round the result as well. So we can, in our case, round it to 2 decimal places, as we mentioned that. But now if we do that, we don't round actually in the way as we want to have it. Because now if we multiply with 100, everything will be 0.00. So that's why we don't want to round like this. This is the first pitfall. So we should not do that, because then if we, for example, not have that 100, we see that we should actually round, rather in this case, to 4 decimal places, because we also want to have this 4.72. In this case, we can now multiply with 100, and then we see again we have 4 decimal places. Of course, now what we could do again, we could round all of that again. This would work, and it is not so elegant actually. So what would be a much more elegant solution would be to just include that multiplication of 100. So we have that first, and then afterwards we are rounding. So we first do that calculation of 100. So we can just, for example, remove that. and then afterwards we have the rounding. So first multiplication with 100, and afterwards we can round by 2 decimal places. So if we do that, we get now the result that we want to have. And of course, now all that we need to do is filter by this percentage value. And if we try to do that, we have to be also a little bit aware that we cannot use this percentage alias now in the where clause. So if we now want to do that, less than 4%, we will see that this won't work because where will be evaluated and processed before the aliases will be evaluated. So that's the reason why at the moment where the where is evaluated and processed, this name does not exist yet. But we can just use this exact calculation in here as well. This is not a problem at all. And then we get the values. And indeed, we have to use now in this case the value 4 because we said 4%. And then if we now also order this, for example, in an ascending order, so we use 2 because it's the second column in the output. Of course, we should not forget about the by. We get the result that we wanted to have. So this was a little bit more tricky because you had to test a few things out probably, but hopefully it was also teaching you something about rounding and the calculations. Welcome to today's session about the case statement. This is one statement that I'm 100% sure you are going to use so frequently throughout your career because it's so powerful, and I'm very sure that this is something that you are going to use so frequently in your career. And it is a little bit tricky sometimes, just at first to understand, and that's why we want to go step by step through all of the nuances and all of the practical applications. And of course, we are also going to include enough practice so that you can fully understand the power of the case statement. But we now want to start just with understanding what actually is this case statement. So basically it just works like an if-then statement. This means it's a conditional expression where we just go through a set of conditions, and then once a condition is met, a specific value is returned. Let's understand this with looking at the syntax. So first of all, we always start our case statement with the keyword case, and we always end it with the end keyword. Missing this end keyword and not writing the end is maybe the most common mistake why our code is not working in the case statement. So it's just frequently forgotten, and we should always think about this end in the end. And then, of course, in between, we have our conditions and then also the according results. So we start, for example, with condition 1. When condition 1, and then if this condition is evaluated to true, for example, amount is less than 2, then in this column, there will be in this row the result number 1 that we specify in here. And then we just go through all of the conditions and note if multiple conditions are met, then the result of the highest condition. So in this case, for example, if condition 1 and 2 are both true, then the result of condition 1 will be returned. So always the first condition that is true for a specific row, this result will be returned. And then if none of those conditions are met, we have the else result, which is basically just the alternative result. So this is just the theory, and now let's have a look at a practical example. We want to select the amount, and then we start our case statement. Our first condition is amount is less than 2. In this case, for this specific row, we want to have the output value low amount in our output. And then we have our next condition. If amount is less than 5, we want to have medium amount as an output. And note, for example, if the amount is equal to 1, both of these conditions are met. So both it's less than 2 and also 1 is less than 5. Then in this case, of course, the first result will be used, and this is a low amount. So this makes sense. And then we can also define an output for all of the other values, which can be, for example, high amount. And of course, we should never forget about our end keyword. And the result will be then just as we expected and as we have defined it. Let's have a look at another example to demonstrate that we can also use multiple functions, different conditions, different operators, and this is just a broad range of conditions that can be used. So in this case, we have the first condition where we are using the toChar function. And we want to just define the weekday like this. And if the weekday, so this is the output of that function, is equal to Monday, we will have the output result Monday special. And then in the next condition, we can use a different function, a different column, so a different condition. And in this case, we want to check against the month. And if that is July, then the output will be July special. Of course, we use the end and then the output of that. If both of these conditions are met, so if it is a Monday as well as July, as in this case here, we see that the output will be, of course, Monday special, because this is the highest condition, the first condition that is met. And that's why the output is Monday special and not July special. So that's what we just have to keep in mind. And of course, if none of those conditions is met and we also don't have the else keyword, then the output of these rows will be just null. So this is something that we can avoid by using the else condition. If we use else, then basically all of the nulls will be filled up. So that's just what we have to keep in mind. And of course, we can use, as mentioned, many different functions in the condition. We can also combine it with different columns, with all of the operators basically that we already know from the where filtering. So we have seen all of the conditions that we can use there. We can also use in our when statement. And of course, we can also just use some calculations, and this is also a valid condition. And one last tip regarding the formatting is that, of course, we have mentioned the case and the end is always the only keyword in the row. This is just to visually see all of the conditions and to make it easier to read the code. And sometimes we also see that those conditions are indented. So that's again a little bit more easy to read, and that we know where our case starts, where our case ends, that we didn't forget anything, that we have set all of the commas, and so on. So that's enough of the theory, and now we of course want to dive into a few practical examples as well. Now let's have a look at a few practical examples of the case statement. For these examples, we are going to work on the flight database. This means that we need to go to the demo database, right click on it, and open the query tool from there so that we can work on this database. And in here, we first want to have a look at the flight table. So we select everything from the table flights, and in there we remember that we have our scheduled departure as well as the actual departure. And like this, we remember that we can calculate the difference and like this calculate how much this flight is delayed. So we have the actual departure and we can subtract the scheduled departure. And like this, we get the interval between them, and this is in that format. And like this, we see how much time the flight is delayed. And since we remember we have the interval in this format, we also need to be aware of this when we use this interval in our condition. So now what we want to do is we want to create buckets. That's a very common use case for case statements of how much our flights are delayed. So we want to say a flight is on time if it is less than 5 minutes late. So let's define this as our first condition. So we have case, then we start with when, we use that as our condition, and now we say if this is less than 5 minutes, and remember we need to use these single quotes for all of the time, timestamps and intervals and dates. And then we also need to stick to that format of the interval, which looks like this. So we see that there are also the seconds, and if we don't use the seconds, then it will be just removed, and this just counts then as 5 minutes. So that's 5 minutes, and this is 9 minutes, 1 minute, because it also has these seconds, which we don't necessarily have to have. So this is our condition, and now in this case, we want to have the output on time. So this is our first condition. And then of course, if we don't specify anything else, we can end our case just with the keyword end. And then we get our result. And then for some of the flights, we have that they are on time. And we also want to use this entire column so that we can just verify our results. We should copy it and use also, of course, the comma. And now if we execute it again, we can compare the results. So we see that, for example, this flight is on time because it's less than 5 minutes, and this one has no output, so it's null, and this is because this condition is not met and we don't have anything else. So we can, for example, say else is, for example, late. And if we do that, for all of the other ones, there will be late. But of course, if the interval is not defined, this should be our first condition, and then we don't want to say that it's late, but then we just want to say that actually we don't know. So there's no arrival time yet. So that's what we want to define then as our first condition. So if there is no actual departure time, if this is null, that's also a condition, then we want to say no departure time. And like this we get for all of those nulls, just no departure time. And of course, now we can create additional buckets. So if we say we want to specify how late the flight is, we can also, for example, say the condition when it is more than 5 and maybe in our case less than 1 entire hour. So we could do it like this. Then we can say that we are a little bit late, and then for all of the other conditions we can say we are very late. So if we execute that, we have also a distinction between a little bit late and also, for example, as in this case, very late. And if we find also a little bit late, we see, for example, this one is exactly 5 minutes. So this condition is not met because it's not less than 5 minutes, but afterwards the next condition is then met, so it's less than 1 hour, and that's why we get this result a little bit late. So this is what we can do. And of course, something that makes this statement super powerful is that we can now also group by this statement. So we want to count the number of flights, so we can say this is the name as flights, of course the comma, and then we can also give our case an alias. So this is, for example, the flag is late, and then we can now group by exactly this case. So we say group by, and of course we could just copy this entire statement, but we can also just use that alias in the group by, and if we execute that, we see that now we know how many flights are late, how many flights are on time, and like this we have created our own categories, our own buckets, which makes it just much more easy to get real insights from our data. And of course, now it is again your turn to apply this knowledge and practice what we have learned regarding the case statement. Now again, let's use these challenges to apply your knowledge about the case statement. So we are going to have 3 different challenges, and every new challenge will become a little bit more challenging and difficult, and the last one will be the most difficult one. So we are just going to introduce those 3 challenges. In between, you can just pause the video and do the challenges, and then you can move on to the next challenge. And now we want to start with the first challenge, in which you need to find out how many tickets the company has sold in the following price categories. So we have the low price ticket, which is less than 20,000, mid-price ticket between 20 and 150,000, and high-price ticket, everything else. So that means greater than or equal to 150,000. And the answer that you should help the company with is how many high-price tickets the company has sold. We are now going to have a look at the result, what we should expect, and this is looking like that. So this is the first challenge. You can now, of course, pause the video and find out how you can solve this challenge yourself. And once you have solved this challenge, we can have a look at the second challenge, in which you can now again help the company to find out how many flights have departed in those following 4 seasons. We have the winter season, spring, summer, and of course the fall season. And the result is looking like this. Yes, we have only 2 seasons, so that is fine, and that's the result that we should expect. So again, pause the video and do this challenge. Find out how you can write this query like that. So the last challenge is the one that is a little bit more difficult, because now you need to apply different operators, and this is what you should do. So in this challenge, you want to create a tier list of the movies. So now we are again in the movie database. So this tier list should start with tier 1. These are all of the films where the rating is either PG or PG-13, or the length is more than 210 minutes. So this would be the best movie basically, because it is in tier 1, and this should get the category great rating or long, and then also tier 1. The next category, if the first category is not matched, should be that the description contains drama and that the length is more than 90 minutes. This should get the title or category long drama assigned to. And then we have also the description contains drama and is not more than 90 minutes. So that's then a short drama. And last but not least, we have also a low rental rate of less than $1. Then it would be still in tier 4. So of course, as mentioned, if one movie can be in multiple tiers, always it will be in the higher tier. So for example, if a film can be in tier 1 and tier 2, it will be in tier 1. So that's what I mean with higher tier. So the better tier basically. And one additional challenge to that is, how can you now filter to only those movies that appear in one of those 4 tiers? So if a movie is not assigned any tier, how can you filter that out? So this is a little bit more challenging, and that's also what should be included in the query. So let's quickly have a look also at the result. You should also have the title next to it. This just helps to get all of the titles together with their tier. So now these are the challenges, and I wish you good luck with them. And afterwards, after you have done them, we can have a look together at the solutions. Now let's quickly have a look at the solutions of our 3 challenges. Of course, first of all, we want to open up the query tool from our demo database, because we are working on the database about the flights. And now we want to create the list of all of the different tickets, so the price ranges and how many tickets we have sold there. So that's why we first want to create our case statement in the bookings table. And I have already created this case. So basically we have 3 different conditions: the low price with less than 20, and then since this is at the top, we can just make the second condition less than 150,000. We don't need to mention that it should be greater than 20,000, because if it is not, so if it is less than 20,000, anyways, it will get this category low price ticket assigned. So that's why it is just enough to mention it should be less than 150,000. And then it's in the mid price. So basically, this is how we can do it. And then last but not least, for everything else, since we also don't have any nulls, we can just assign to everything that is not less than 150,000 the high price ticket. And now if we execute that, we get the result. But of course, we now also want to count those values. This is why we can also introduce count star. And then of course, we also need to have a comma. And afterwards, we want to group the data by, and then we can just use the ticket price. This is the alias that we have chosen. And of course, in the group by, we can always also use just the alias, which will in the end give us our result. And now if we want to have a look at the next challenge, we can just get everything very similarly, because now we again want to just define our different seasons. We want to use, of course, the extract function. We can also use, for example, the toChar function. This would work as well. So we could also, for example, create toChar, and then we want to use the scheduled departure, and we can define the output, for example, month. But we just have to be a bit careful if we are using month like this. The outputs might not be so accurate, because if we now would say, for example, is equal to July, then this would not work, because there is always this padding up to 9 characters. And then we would also have to include that, or we just would have to use a like, and then starts with, for example, July, and afterwards there can be these different characters. So that's just some very specific thing that we should keep in mind, but we can also just make it a little bit easier for us and use the extract function as we have defined it before. So there are, again, as I've mentioned, many solutions that work and that are all correct. So this is what we can do. And then, of course, we need to also group by the season. So this is the alias that we have given. And then we can get the correct results if we execute the query like this. And now we have the most difficult challenge in the end. In this case, we have our first condition. So let's remove all of that. Our first condition, which is that the rating is either one of them, or that the length is more than 210. In this case, we have our first condition, and then the second condition is that the drama is included in the description, and in the same time the length must be greater than 90. Then it will be a long drama. Otherwise, if this condition is not met, so this is again something that we don't need to mention, that it's less than 90 minutes, because anyways, if long drama is not assigned and we go to the next condition, then anyways the length will not be greater than 90. This is why we can just use one condition in the next when statement. And also in the end we have the last condition, which is then the rental rate is less than 1. Then we have our last condition. And of course in the end we need to close it with end, and then we can use from film and we will get our result. Of course we can also use the titles in the beginning. And what did we forget? We are just in the wrong database. So we see relation film does not exist. This is why we need to change into the according database. So we right click on the green cycles, and then if we paste our code in here, we see that now it works. And now we still have those nulls. The question is now, how can we filter that? Because if we give this an alias, for example, we say tier list, then we get this alias in the output, but now we cannot filter by this alias. So if we use tier list is not null, we will see that the column tier list does not exist. And this is because in the where filtering, we cannot use the aliases. Because at this point where is evaluated, this alias has not been assigned yet. This always follows after the where filtering. That's why if we want to filter that, we can only use this exact same column. This is possible. So we can just copy all of that. So this will be also a specific output. And we can say where this is not null. So where this value, which is returned by that statement, is not null. And if we do that, we can filter all our results to where only the tier list is not null. So this was a little bit of a longer solution, but hopefully this could give you the chance to also verify your results easily. In this lecture, we want to have a look at a very special practical application of the case when statement. That's very commonly used, and that's why we want to have a look at this practical application of case. So that's like a special use case. So in our case, we just first want to have a look at the film table, and in here we see this column called rating. Now imagine the two best ratings are PG and G. And that's why we want to just count how many of those ratings we have in our database. So for that we want to use, or we want to solve that with the case statement. And that's a very common thing, to count actually using the case. So like this, we can combine, for example, multiple conditions, multiple values, and count how many of them occur in our database. So let's see practically what we mean by that. We first want to include also the rating column so that we can also compare the results. And now we want to start our case. The condition we can very easily define. So that is the rating is, we can have two conditions or two values. That's why we use in. And now we of course want to have as condition pg or alternatively g. And now this is the trick. We can now as a result give the value 1 in that case. So like this, later on we can count how many ones we have. We can, for example, create the sum, and then all of those ones will be added up. But let's see how this works in practice. Because all of the other values will have the result 0, so we can say 0, and then we can also end our case. And like this, if we now execute that result, we see this is just the rating, and whenever there's PG or G, there is a 1, otherwise there's just a 0. And now the cool thing is that we can now around this case column create the aggregation of a sum. So we can sum up all of those values, which will result in the number of PGs or Gs. So that's now the trick. So we can create the sum around all of that. And now if we execute that, we get this count if we did not make any mistake. Of course, now with the rating, we cannot use the rating without an group by, because we have the sum. That's why we can again remove it, and now it should work. So now we have this value 372, and of course we can now also give this a little nicer alias, for example, number of ratings. So that's now the trick, that we can just use a case when, and for a desired result, something that we want to count, we can just use the value 1, and otherwise in all other cases we can give the result 0 and then just sum all of those ones up. That's a very common use case. And now for you to practice, I want you to create something like this. So that's some other use case, but it works basically the same way. So what we want to do is, we have now this count, and now of course all of the ratings are counted, but now what we want to achieve is we want to basically pivot this table. This means that the output result should look like this. We have now 5 columns, and for every column, for example, the column G, that's a separate column, we want to count how many G ratings we had. So this is now the challenge for you to practice this use case. But I want to also mention one thing that you need to know. This is for the aliases, because in this case we have the uppercase letter aliases, which is actually not possible if we are not using those double quotes. So if we would not use them and then we would give the alias with an uppercase letter, it will just default to a lowercase letter. So this would only work with these double quotes. And this is always when we want to have a very special column name. So usually we should not use something like this with different uppercase, lowercase letters. We should just use a normal column name without these quotes. But if we want to have, for some special reason, a white space included or a hyphen included or an uppercase letter included, this would only work if we use those double quotes. Again, we should usually not do that. For example, we should not use those white spaces in a column name. This can cause all kind of problems, and that's why we should only do that if we really want to have a very special column name. So this is just something that you need to know for the uppercase letters and the hyphens in the column names. But now it's your turn to try to get this result, which is pivoting that table. And now, after you have done that, let's quickly have a look at how we can solve that challenge. So we do that by, again, just creating a case for every single of those columns. So for example, for the G column, the condition is when the rating is G, then we give the value 1, otherwise the value 0. And like this, we can add all of those ones up basically and get the result 178. And also then we can just give this here in the double quotes, so this alias, and then this will be the column header. So this is how we can use the case within the sum aggregation, which can be a very useful application of using the case statement. So hope it was helpful and see you in the next lecture. One issue that we are oftentimes dealing with is null values. And oftentimes, if we, for example, want to make a calculation, so actual arrival minus scheduled arrival, just to calculate how late a flight is, will be a bit problematic because we get many nulls, and sometimes maybe we would like to replace those nulls or just have an alternative value for the case if there are nulls. And in such situations, we can work with the so-called COALESCE function. This function just returns the first value of a list of value which is not null. So for example, if the list of values would be actual arrival and scheduled arrival, we would expect that if the first value is actual arrival, then in the first row we get this result, so 1901. And also in the second row, we would get 1934. But in the third row, we see that the first value that is not null is actually, because the first value is null, the second value, which is then 1220. So let's have a look at the result, and this is what we would actually get. So 1901, first value, 1934, first value, and in here first value is null. So the first value that is not null would be 1220. So it's not so complicated, and if we would like to get such a result, we can use just that syntax of actual arrival, first value, and then the second value. And note that we can also make more than 2 values, more than 2 columns. This is totally possible. And also what we can do is, if we don't want to use an alternative value from a column, then we can also just use a fixed value. So the only thing that we need to take care about is that if we want to do that, we need to have both of those data types aligned. So if actual arrival is of the data type timestamp, then this alternative value also needs to be in the format of a timestamp. So otherwise this would cause an error. So now let's see if we can use this COALESCE function to create something where we don't have these nulls included. So that's why we want to create the COALESCE function around it. And this will be now our first value. And if this value is null, we can have an alternative result. And of course, we cannot use a text string such as not arrived yet, because this would not match the data type interval. This means we would have to use something like that. So for example, like this, or we can also use any other dummy value that we want to pick. And then if we do that, we see that now all of the nulls would be filled up. So this is how we can fill up the nulls. But if we now indeed would like to use some text string like not arrived, we see that this would cause an error because this is an invalid input for the data type interval. So if we would like to do that, we would have to change the data type. And how we can do that, we want to have a look at in the next lecture. Oftentimes it is helpful to change the data type of a specific column. So for example, because we want to match the data type, for example, if we want to use a function that only works for a specific data type, and in all of these cases, we want to change the data type of a column. And this is why we want to talk about the cast function. This function is used to just change the data type of a value. So for example, if we have the column scheduled arrival and we want to cast these values into a text value, then we can just use the cast function to define that we want to change it to text, and then it will be a text column as we can see in here. So note that in this case it looks still the same, but now just the data type behind is a text. So let's have a look at first the syntax and then a few examples. So first, the syntax is very simple. We use the function called cast, and then the value or the column in the beginning, afterwards the keyword as, and then the data type that we want to use. So for example, we want to cast the scheduled arrival column into data type text. Therefore, we use varchar. This is the most commonly used and probably the most suitable data type in regards to text. So we use varchar usually for text. And then the result will be like this. So now character varying is the data type of this column. And also what we can do if we are changing, for example, the data type to date, this works as well, even though this is actually a timestamp. So then in this case, it will just cast it into a date and this time will be just lost. So this is possible sometimes, but of course it needs to be able to somehow cast the data type. So not everything is possible. So for example, we cannot cast the value ABC into a number. This would not work. So therefore we have to use something that is really possible to cast. So now let's have a look again into pgAdmin to see if we can now use the cast function to solve that problem that we can use now this text not arrived. So what we need to do is we need to make this value into a text value. So we can use the cast function and we can say as a varchar. This is how we use the cast function, and then this should match now this data type not arrived. So let's see the result, and indeed we see that now we have the value not arrived, and sometimes we have this value of the difference, but this is now also of the data type varchar. And with that data type, we can now, for example, also use some functions. For example, if we want to calculate the length of a value, for example, actual arrival, then we cannot do that if this is a timestamp. So if we do length of actual arrival, we get an error because this function does not work in our case. But if we would cast it into a text, so we say cast as varchar, then we can actually get the text. So if we now see those results, we see that now we get those results. And of course, if there's a null, the output will be just null. So like this, you can see that sometimes if it's necessary because we want to use a function or the data type is not matching, we can change the data type using the cast function. And something that can also happen, if we have a look at the tickets table, for example, we can see that in this case, we have the ticket number, which is actually a character, but we see that this should be a number in fact. And we can now also use again the cast function to change the ticket number into a integer, or we should use for large integers the big int data type. And if we execute that, we see that now it's an integer, and in this case, this can be a more suitable data type. We can now make calculations with that, and so on. But sometimes it is not possible to cast values. So for example, if we have a look at the passenger ID, so if we use the passenger ID and we are trying to cast that because we see this should be a number as well. So then we try to do that as big int. We see that this will not work, and this is because we have this white space in between. And this is why we sometimes also need to replace values from a string so that we can really clean our data and, for example, change the data type of it. So that's why in the next lecture we want to talk about the replace function. But before we do that, you have one more quick challenge to practice COALESCE and cast in our previous movie database. So that's what we are doing in the next lecture. Let's now apply and challenge our knowledge about COALESCE and cast. If we have a look at our green cycles database, so if you have not opened that yet, just right click on the green cycles and open up the query tool. Then we see if we query from the table rental and we have a look at the rental date and the return date, we see that many times the return date is not filled with data. So there are many nulls, and this is why we would like to replace those nulls with the value not returned. And be aware that not returned, of course, is a varchar, whereas this column return date is actually a timestamp. So this is why you need to combine COALESCE and cast. And now I wish you good luck with the challenge, and afterwards we'll have a look at the solution together. If we are trying to replace the nulls with the COALESCE function, we will see that if we try to do that, and we now, for example, write the value not returned, that this will not work, of course, because this is not matching in the data type. So for timestamps, this does not work. That's why we can, if we want, change the data type of return date using the cast function into varchar. And if we close the parentheses on that and everything is closed, then we execute it, and then we see now indeed we have not returned for some cases, and then for the other cases, if we are not ordering that by the rental date like this, we see that now we still have those values included of the return date. So this was just a quick challenge, but now we want to deal with some problems if we cannot cast a value, for example, because the structure is not so clean. That's why we need to sometimes replace characters, and this is why in the next lecture we want to have a look at the replace function. Oftentimes we need to replace certain values. This is mainly to clean up our columns and bring it in a shape that we can work and process this data. So this is why in this lecture we want to talk about the so-called replace function. So this replace function, of course, just replaces a text from a string in a column with another string. So for example, if we have the flight number, we would like to replace this PG. We can just apply this function to replace, for example, PG with FL, then the result will be like this. So it's a very simple replacement. Of course, what we can also do is replace PG with nothing. And this will basically then just remove PG. So in this case, we have now this text, which now can be transformed, for example, casted into a data type of integer. So this could be, in this case, useful. Let's have a look at how the syntax of replace looks like. So again, it is pretty simple. We just have the column that we want to work on, what is the text string that we want to replace, and then new text, what do we want to replace this with. For example, in the flight number, we want to replace PG with FL. So then this would result in this output. And of course, if we would replace it with nothing, we just use the single quotes and then close the single quotes immediately. So this would then just replace PG with nothing, so basically remove PG. Now let's have a look into pgAdmin to see if we can use that knowledge to remove this white space from passenger ID so that we can change the data type into a big integer number. So we want to first use the replace function, and we want to insert, of course, passenger ID. We want to search for the white space, so we insert a white space, and then afterwards we replace this with nothing. So we just use the double quotes and nothing is included. And if we execute that, we see that now it is replaced, and now we can easily cast this output of that function into a big integer number. So we use big int for bigger integer numbers. And now if we execute that, we indeed get this as a result, and we have achieved what we wanted to achieve. And of course, the same thing we can also do for the flight number. So you can take this as a quick challenge to try to replace PG of the flight number. So here we can also, for example, just use the cast function. We want to replace now in the column flight number the value PG again with nothing. And then we want to cast this value of the replace function into a integer number. So we use int, and then we get the result of the flight number. We can also compare the results. So if we use flight number as well, we see that indeed the results are correct. So you see, these are functions that we can work with to change the data type, and this is not very complicated, but still it can be quite helpful. Today we are going to talk and learn everything about joins. That's a super important concept, and we are going to discuss everything from theory to practice, and of course again include a lot of challenges. But first of all, why do we actually need joins? What do they do? So far we've only worked on single tables. But sometimes we need to combine information from multiple tables in one query. And this is exactly what joins are doing. So we can understand this with a practical example. In this case, we have our payments table, and in this payments table, we have information, of course, about the payments. So for example, the customer ID, the staff ID, the amount, the payment date, and so on. And now we also have the customer table, in which we have the information about the customer. So in fact, we see that in this payment table, we reference with this customer ID the information about the customer. So for example, if we see that in the payment table we have customer ID 269, we can also see that this is the customer Cassandra Walters. And now what we would like to do in this query with the join is combine those information into one single output, so that we have also in this payments table, for example, the information of the first name and the last name of this customer who has made this payment. So this is the broad idea about joins. And in the following lectures, we are going to discuss how joins work, how we can use them practically, and we are going to talk also, of course, about the 4 different join types. So we are going to talk about inner join, outer join, left join, and also the right join. And before we dive into each of them, I want to say again that joins are super important, and that's why we are going to spend enough time to understand all of the different perspectives, all of the different options that we have with joins. In the beginning, I also want to say that these can seem a little bit complicated at first, but once we get the hang of it and we have a lot of practice and theory, I'm pretty sure that you can feel very confident in the end, because we are going to have many examples, again, practical applications, and of course enough challenges so that you can practice everything that we are learning about join. So let's not lose any more time and let's dive into our first join type, the so-called inner join. Let's have a look at our first join type, the so-called inner join. This is the easiest join type, and that's why we are going to start with that, because this helps us to understand also the general concept of joins, because later on we can apply this understanding also to the other join types. So an inner join is best understood with a practical example. That's why we are going to have a look at this sales table, where we have a couple of employees that are in different cities and they make different sales amounts. And now some of those employees get a bonus and some of them don't get a bonus. And that's why we have a separate bonus table. But now what we want to do in a given query, we want to combine those tables and the information of both of these tables in one given query. And to be able to do that in a join, we always need a so-called reference column. This is basically a common column, our join column, that helps to combine the table in the right way. And in our case, of course, we see that we have the employee column. So this is the common column that helps to reference the values and join the table correctly. So let's see what kind of data we have, because we notice in this case that we have Michael and Frank that are in the sales table, but they do not appear in the bonus table. And on the other side, Simon is appearing only in the bonus table, but not in the sales table. So in this case, we are left with those 4 employees that are occurring in both of these tables. And what is now specific about the inner join is that only those rows appear in the final result, where in the reference column, the value appears in both tables. So in this case, Michael, Frank, and Simon are only in one of the tables, and that's why in the final result, they will not appear. So we are just left with those 4 employees. And now we want to combine all of those information together in one output result. So in this case, we have, of course, Sandra at first. So we have the information Frankfurt and sales. This makes sense. But now what is the bonus value? We can now see that easily by using this common column, because we have Sandra from the one table, and now we can just use and go to the bonus table, see where is Sandra, and we see Sandra has a bonus, so she has the value yes, and this is why we also get now yes in this row. And like this, we can now proceed. We just use all of the values from one table. We use this reference table to check what is the bonus, and then we can just combine this information together in this table. So this is the basic principle of a join. And we can also visualize this. This is oftentimes done to help to understand the differences between the different join types. We're using such a Venn diagram. So this inner join basically uses in the output table only those rows that occur in both of the tables. To be more specifically, only those rows where the value in the reference column appears in both of the tables. So in our case, we have seen that the output is then only those 4 people, because these are the people that occur in both of the tables. But now the question is, what happens if we have one value multiple times? So for example, Peter has sales in Hamburg and Munich with different sales amounts. Now, of course, in the output result, we need to have still all of the information available. And this is why also in the output table, we have now 2 times Peter. So this means that the level of detail will match the maximum detail of those 2 tables. So if Peter occurs twice in one of the tables, then also we will have it in the join result twice. And this is true even if we would not want to include in our query the columns city and sales, because potentially we could, and this is why we will always have this maximum level of detail. But now let's just have a look at the practical syntax and how we can use this join, because later on anyways we are going to see practical examples. So in this case we want to combine table A and table B. So we start with just, in our case, selecting everything from our table A. And now after the from and the table name, we just use the keyword inner join, and now the second table that we want to join. And of course, as we have mentioned, we need to use a common reference column, and we introduce that right after the join using the on keyword. And we use the employee column, so we say where basically employee is exactly matching. So we use the full table name, table A, dot employee is equal to table B dot employee. And we have to mention this table names because employee is a column that has exactly the same name in both tables. This is why it makes sense that we have to reference here also the entire table name. And now what is specific about the inner join, we can also see this on this diagram, that it doesn't matter whether we are using table B in the beginning or table A in the beginning. So this doesn't matter because it is just in the end everything that is in both of the tables. So we have no difference between those 2 queries because this operation is basically symmetrical. This means we can just swap them around and we get the exact same result. But now sometimes this full table name is a little bit long and it's not so nice to use that full table name. This is why we can also use aliases for the tables. We've seen that also that we can do that for columns, but we can also do this for tables. And this is very common for the joins, because like this, we can give shorter or maybe more descriptive table names, and then we can just reference those aliases in the join before those columns. So this just helps to make the code more readable and easier to write our query. And what I want to emphasize, we've already mentioned that a little bit, that if we want to select a column that has the same column name in both table A and table B, then we also, if we use that in the select, we need to also then reference the table name. So if we are using aliases, we can also just use this alias, because otherwise it would be ambiguous which column is meant from which table, because we can have, of course, a column with the same column name and they have different values. This is why if we have a column that is in both of the tables, we need to specify from which table we want to use that column from. But if we have a column that only occurs in one table, then it is not necessary to use that table reference in the query. And now this was enough of the theory. We just quickly want to summarize what we've learned in this inner join, and afterwards we want to immediately jump into pgAdmin for practical examples, and afterwards, of course, the challenge that you can now train this yourself. So we have learned that for a join, we always need a common column. This is the reference column that helps to create the join in the correct way. In our case, it was the column employee. And now, specific for the inner join, we only use those rows where in the reference column the value occurs in both of the tables. Otherwise, it will not appear in the output table. And we've also learned that the order in the inner join is not important. It doesn't matter whether we start with table A or table B. The results will be always the same. And last but not least, if a value occurs multiple times in a given table, the same level of detail, so the same number of times, it will also occur in the output table. So that's enough of the theory. Let's jump right into pgAdmin for practical examples. Now let's practically apply our inner joins. We want to achieve that we have in the payments results, so all of the payments, also the information about the first name and last name of the customer that has made this payment. And of course, we can use the customer ID as a common join column to get also the first and last name from this customer table. We see we have also the customer ID, and there we get the first name and last name, and we can now combine this with the results of the payment table. So all of the payments should afterwards contain the first name and last name of this customer that has made this payment. So we can remember that we just after from and then the table name, we introduce the inner join keyword and we specify what table we want to join that. And this is in our case the customer table. Afterwards, we introduce on and we specify the common column. And since we have, of course, the customer ID, and this is the same name in both of the tables, of course, therefore we also need to specify the table name. So this is the payment table, and then this should be equal to, again, the customer ID, but now from the customer table. So therefore, we say customer.customer ID. And now let's see how our result looks like. So we see now we have used just star. That means we have every column from all of the tables, from both of the tables. And this is too much. We don't want to have that. This is why we can say we only want to see everything from the first table. So this is the payment table. And note that we can use this asterisk also in combination with the table name. So like this, we see only those columns from the payment table, plus from the customer table, we use the first name. And since the first name and last name are only anyways in the customer table, we don't need to reference the table name. So we can only say first name and last name, and then we get the results exactly as we wanted to have it. So now we have Cassandra Walters, we have Jenny Castro, and so on, all of the first names and last names. And of course, again, we can change the column names. So we can say payment ID. We want to also see maybe the customer ID. And now again, customer ID occurs in both tables. So therefore, we need to specify the table name, payment, and then maybe also the amount, first name and last name. And these are the columns that we now would like to see. So this has worked pretty well. And of course, we remember that we can also use aliases. So for example, PA for payment, and for customer, we can use CU. And like this, we can just use this alias also in the table references. So it's a little bit shorter, it looks a little bit easier to read, and we still, of course, get the same results. And now again, it doesn't matter what is the order. So if we say we have first the customer and afterwards the payment, so we swap that around, we should still get exactly the same result because this is exactly symmetrical and there is no difference. But now let's have a look at another example. So from the payment table, we can see that we have also the staff ID. So if we would like to join now the information about the staff, we can also again use an inner join. And there we can then also now join the staff table. So we can see that we also have the table called staff. And if we would like to get additional information now on the staff, we can also join that using the staff ID. So we have staff.staff ID is equal to payment.staff ID. And like this, we get now also those additional columns. Of course, now the staff ID occurs twice, but this is not really what we need. So we can say we only want to see maybe everything from the payment table, and then also, let's say, the first name and the last name of the staff table. So this would work. Maybe also the email address. This is working as well. And of course, we can also filter our data. So for example, if we want to filter to only those rows where the staff ID is equal to 1, we can also introduce the where filtering. So we can do that after the join, because basically this from works together with all of those joins, and then afterwards we can filter. So for example, where staff ID is equal to 1. And of course, staff ID can occur in multiple tables. So we use the staff table, and we get then only those results where the staff ID is equal to 1. So like this, we can see that now we can combine information from multiple tables. And now it is your turn to apply this knowledge in the following challenge. Let's have a look at this challenge to practice what we've learned about the inner join. In this challenge, the airline company wants to understand in which category they sell most seats. So the category of the seats. So the question is, how many people choose seats in the category business, economy, or comfort? So this is what you need to find out. You need to write a query to answer this question. And also, as a little hint, you need to use the seats table as well as the boarding passes table. And also, again, of course, here is the expected output. So that's how the result should look like. And now I wish you good luck with the challenge, and afterwards we'll have a look together at the solutions. Let's have a look now at how we can get this result that we would like to get. So we, of course, first want to have a look at the tables. So we can say we want to see the seats table just to get an understanding of which column we can use. In here we see we have the seat number, the aircraft code, and the fare condition. And now also we can have a look at the boarding passes table, and if we can find some column that we can use. So we see there is also the seat number, which is a common column. So this can be a column that we can use to join those tables. And again, it is not important which table is the first one, since the inner join is symmetrical. This means that it doesn't matter which table is the first table and which one is the second table. So we can just now join this with the table seats. So the first one is boarding passes, the second one seats. And now our common column, we join this on the seats number. And of course, we can also give aliases. So this is making it just a little bit easier to work. So we have B, which is the boarding passes table, and S for the seats table. So we can also use that in our join columns. So we have seats, and then also we have this same column from the boarding passes. And like this, we can now execute the result and already get this join right. So now we have all of those columns included. And now we can just group by this fare condition column and count basically the rows. So this is now no different from what we have learned before. We can use this fare conditions column, and we can of course also now count the rows. And then we can, of course, we need to actually group by this fare conditions column. So we can just copy, paste that, and see if we get the right results. Indeed, this is what we have expected. And this is now the analysis of how many flights we have booked in the different fare conditions. So I hope it was helpful, and see you in the next lecture. Now let's have a look also at the full outer join. We've already understood the basic principle of the joins when we had a look at the inner join, and now it's pretty easy for us to understand also the full outer join. We have seen in the previous lecture also the Venn diagram, and this can help to understand the differences between the different join types. So now in the full outer join, we get all of the rows from both tables, even if they are only present in one of the tables. So we get all rows from both table A and table B. So to understand that a little bit better, let's again have a look at our example to see what this full outer join would result in. Because we have now here two rows in the sales table that only appear in the sales table, and Simon that only appears in the bonus table. So let's have a look at how the result of the full outer join would be. Of course, we have those 4 rows that we also had in the inner join. So for them, the result is pretty clear. But now what happens with Michael and Frank, for example? here we can say also, of course, Munich, Frankfurt, and sales are available, so we can just take them. But what happens now with the value from the bonus table? So the bonus. And since it is not available in this table, we have to just fill those values up with nulls. So that's what happens. And now, of course, also what happens with Simon? Of course, Simon has no bonus. So that's why there is a no. And city and sales are also nulls because this is just not available in the table. But now what happens with the column employee? And now it's a little bit surprising at first, but we'll also understand why this happens. So here there's also now a null value. And this is because it is actually just the employee column from our sales table. And therefore, even if they have exactly the same name, both are called employee, they are still different columns. So one of the employee columns is the column that is from the bonus table. And then we have one employee column that is coming from the sales table. And like this, we have just all of the columns, so all of these 5 columns from both of these tables combined. And if one column has the same name, it's still in the output, of course, always in all of the joins actually appear anyways. So they are both always present, even if it's just exactly the same name. We can, of course, use some logic, like for example the COALESCE function, to merge them into one column. So if the first value is null, just take the second one. So we are just left basically with one column. But now also let's have a look, before we get a practical example in pgAdmin, at how this syntax works. Because now, of course, we've seen already the inner join, so that's very easy now for the outer join. Just instead of inner join, we use the keyword full outer join. And of course, also we then use an on keyword and we define the matching column so that we have our join condition. And everything else, just that we use full outer join instead of inner join, is working exactly the same way. So now let's quickly also jump into pgAdmin to see a practical example of that. So for this purpose, we want to just right click on the demo database, select query tool, so that we get an example of the flight database. And in here we can have a look at the tickets table. So we want to select everything from tickets. And there we have the tickets and the ticket information. And now also we have the boarding passes. So we can also have a look at the boarding passes, and we see that there is also this ticket number, so we can create a join for that. But now we have to keep in mind that not for every ticket there's already a boarding pass issued. So there can be some tickets without a boarding pass. And this is what we would like to find out using this full outer join. So let's see how we can do that. So first we can start with the boarding pass ticket. It doesn't matter because this is again symmetrical. And then we can make a full outer join and we can now use the tickets. And of course our join condition is the ticket number, and again we need to use the name of the table, and we can also use aliases, so B and T for example. So we can say b.ticket number, and then we can just copy that and say T of ticket number. And now if we have a look at the results, we can see that now those tables are joined. But how can we now find out what are the tickets that have no boarding pass attached to them? So what are the tickets that have not a boarding pass attached to it? That is your challenge that you can find out now. And in the next lecture, we want to have a look together at the solution of this challenge. In this quick challenge, you can find out how can you see the tickets that have no boarding pass related to them. So this is your challenge. If you have not tried it yet, then pause the video and try to find the solution to that. So if you're ready, we are going to have a look together at the result of that. And we can do that, of course, by filtering the data. So what we need to find is we need to find tickets that have no boarding pass attached. This means the columns from columns of the boarding pass tables, they need to be null. So that's why we can just filter any column from the boarding pass table to nulls, and then we get the result. So for example, if we want to use b.ticket number, this is not important what column from the boarding pass table, since if one is null, all of them will be null. So that's why we use the ticket number and we say it's null, and then we see that this is not working, of course, because we just did not use the where clause. So let's use that. Let's try it again and see that now we have 128,000 almost rows that have nulls in all of the columns. So these are these 5 columns from the boarding pass table. We can also see that the ticket number is available twice, because once it comes from the boarding pass table and the other one comes from the ticket table. And now, for example, we can just count the results as well, how many of such rows we have. And then we see, okay, indeed, it's almost 128,000 rows. So this is indeed true. And of course, we can also now verify, and we can just again use everything. And we can now try to see what happens if we change that to the ticket table. So now we want to see if there are any boarding passes that have no ticket related to it. This means there would be boarding passes where someone did not buy a ticket. So this should not occur, and that's why if we try that, we hopefully get no results, which indeed we don't get any rows. So this is good, and this is how it's supposed to be, because all of the boarding passes also have a ticket. So with this type of filtering of any column of table B, where we say this should be null, then these are all of the rows where we have only values for table A. This means they are only appearing in table A and not in table B. So this is just some special case. Maybe it's not so super common to use that, but this might just also help you to use this where filtering in conjunction with the outer join to find only specific rows that appear only in one table. After we have understood the full outer join, it's now also very easy to understand the so-called left outer join. Let's quickly have a look again at our Venn diagram. And here we can see that the left outer join basically takes all of the rows from table A, and also, of course, the overlapping that are both in table A and table B are included. But if there are some rows that only appear in table B but not in table A, those rows we won't consider. So let's see how this looks like in practice. We have again our 2 tables, sales table and bonus table, and the result of those. Now it's very important that the left table is always, in our case, table A. So this is always the first table that is included in our code. So that's always the first table that is the left table. And the result is, of course, that we get all of the rows from the left table and not the ones that are only in the right table. So for example, Simon, as we can see, is not included in that output because it is only present in the right table. So the ones that we can see in this Venn diagram that are not in table A, so that are only in the right table, are not included. And of course, the syntax is again very easy. This is nothing new. Now we just use left outer join instead of full outer join or inner join. But now, again, let's quickly jump into pgAdmin for a few quick examples. Because the left join we usually use, and in fact, this is the most commonly used join type, because usually we want to make sure to have from one table all of the rows included. And for the other ones, it's okay to take only the matching ones. So in this example, we will see that we want to now have a look at our aircrafts. So we can see that we have from the table aircrafts data, all of the aircrafts and their according models. And now we want to count in how many flights these aircrafts have been used. So we want to make sure in this example that all of the rows, so all of the aircrafts, are in our output, even if they are used in no flight at all. Then we still want to get this information. This is why this aircraft's data will be our left table. And now let's quickly have a look at the flights. So if we have a look at the flights, we will see that there should be also this aircraft code. So this is the one that we can use to create this join. So now let's again use the aircraft's data as the left table and now create a left outer join. In fact, a left outer join can just be abbreviated with a left join. So we don't need to mention left outer join. This is just short left join for left outer join. And now again, we can give this an alias like A, and we want to now join this with the flights, and flights can be the table F. And now we of course want to join this on the 2 columns as we have mentioned, A aircraft code, and also we can just copy that. We can say that we want to have this equal to F aircraft code. And now if we execute that, we get all of the models, all of the related flights, and we can now check if there are any aircrafts that have no flights, so that have not been used in any flights. This means we would have to filter them to any column of the flights, so for example F, and we can use, for example, the flight ID. It doesn't matter which column we are using, is null. And if we do that, we see that this will not work because we have not used the flight ID. So let's try again. And indeed, we see that there is one aircraft actually that is never been used in any flight. So this is now something that is interesting. We have all of those values being null. And of course, if we would have used the inner join, then we would not get this row with this aircraft. So if we would execute like this, we of course wouldn't get any row. So this only works because we have used the left outer join, and like this we get all of the rows from the left table, so also all of the aircrafts, even if they have not been used in any flight yet. So they don't appear in the flights table. Let's now apply the knowledge in this challenge. In this challenge, you need to help the flight company to find out what are their most popular seats. And therefore, you need to find out which seat has been chosen most frequently. Of course, you need to join tables for that. I'm not going to say which one, this you have to find out, that's part of the challenge. But you need to make sure that all seats are included, even if they have never been chosen before. So this is just something that you need to keep in mind. So this involves which table you have to use, what join type you have to use, and which is the left and the right table, of course. And after that, you just also need to answer the question if there are any seats that have never been booked before. And now we just want to quickly have a look at the expected output, which should look like this. So this is the output that we should expect. And now, after you have done this challenge, we also have a quick second challenge. So for this challenge, you now need to find out not what seat is the most favorable, but which line. So this means we have different seats, as we can see in here, and the letter in the end, this is basically what we mean with the line. So you have to create now a query that is showing us how many times each line has been chosen. So the expected result should in the end look like this. So of course, you need to again use now some functions and create a query that is returning this result. So again, you need to use functions for that as well. So that's the challenge. Good luck with them. And in the next lecture, we are going to have a look together at the solution. Now let's have a look at how we can find the solution to our two challenges. So first of all, what we want to do is we want to query from the seats table. So we need to make sure to have now a count of all of those appearances of those seat numbers in one of those tables. So how many of these seats have been booked? And therefore, first, of course, we need to find out where does this data appear of the seat number. So because of the seats table, we only see the available seats, and we want to make sure they are all included. This is why we want to start our left join with this seats table. But first, we now want to also find out where do these occur. So we can have a look at a few tables. So for example, the flights table, we see these are only the flights with departure and arrival. Then we can have a look at, for example, tickets and bookings, and we see they all do not appear in there. But then we see in the boarding passes, indeed, we have this data now appearing. So if we execute that, we see that in here we also have the seat number. Now, one might say, and they might be right in a way, that we can just now immediately from here group by the seat number, which is true. But now, if we would do that, there might be some seats that appear in the seats table that are not in the boarding passes table. So that would mean that we have some seats in the seats table that have never been used. For some reason, this might be the case. And this is why we want to join starting from the seats table. So this is now where we want to start. And then we want to make a left join on the boarding passes. And of course, we can give also aliases and join this now with our condition, which of course is the seat number. So this should be the same. We have seat number from the other table. And like this, we are now sure that all of the seats are included, even if they would not appear in any of the boarding passes. Then we would just have nulls as well. But now in our case, we want to check that if there are actually seats that have never been used. And we can do that by looking for nulls in the boarding passes. So any column of the boarding passes, we can check. So let's say, for example, B seat number. If there is any null, then this would mean that there are some seats that have never been used in any boarding or any booking. But indeed we see that this is completely empty, so we could now just also group immediately by the boarding passes. But in our case, we can also do this now with this left join. So we can say group by, and now we want to say by the seat number. Again, this time it doesn't matter which table we take the seat number from. We can just group that by the seat number and also count, of course, the results. And like this, if we also order it, for example, in a descending order, then we can get now the top seats at the top position. And indeed, if we also actually sort it descendingly, we get the top seats at the top. And now, of course, we can also, if we want to find out which line is most favorable, then we can also just use the right function. This is also possible because we want to see that last letter. This is what we want to extract. And this can be also included in the group by. And if we execute this command, we see now these are the top lines. So hope this was a helpful challenge to practice the left join, even if we would actually not have needed that join. So in this case, as we can see, it is actually the same if we are using an inner join, because anyways, all of the rows are appearing in both tables. But this is oftentimes the approach that we start with the left join, even if we might get the same results. So this is just some default that we are going with because we want to make sure all of the data from one given, in this case, the seats table, is included. And of course, we could now also use information from the seats table. So for example, the fair conditions, we can just also use that. So we can, instead of this value, can use the fair conditions, and then we can also copy that and paste it into the group by. And if we now want to evaluate the fair conditions, we can do that also using this join, which would not be possible if we, of course, only would have considered the boarding passes, because this information was not included in the boarding passes table. Let's now also have a look at the right outer join, which will be very easy if we've already understood the left outer join. Because in this case, just all of the data rows from the second table will be included. And if there are some rows that are only in the first table, so only in the left table, they will not appear in the output. So in our case, if we again have a look at our two tables, we will see that again, if the employee bonus table is the right table, this will be the row that is included, and the ones from the left table, they will not appear in our data output. So this is very simple. And of course, regarding the syntax, this is now also very simple. This is now just right outer join, and then if we have table A, which is the left table, and table B is then the right table, all of the rows from the right table will be included. So this is basically exactly the same thing as if we would change table A and table B and use a left outer join. Because like this, also table B would be the left table, and then again all of those rows will be included from table B. So this is exactly the same thing as right outer join, and if we start with table A. Now let's quickly also have a look at an example. In this case, we have a look at the aircraft's data with the alias A. And previously we've already used the left join on the flights table to count how many times those aircrafts have been used in flights. And of course we have done that using the column aircraft code, so a.aircraft code, and we can again copy that and paste it to have it also in the other column, so f.aircraft code. And now if we execute that, we see that there is f not given as an alias. If we execute again, we get the result. And now we can see that there is an aircraft that has never been used. So we have seen that by filtering to where, and then something from the flight table. So if something from the flight is null, this means that aircraft has never been used. So we filter to is null and we find this table. And of course, this would now not work with the right join, because with the right join, we would not even have this column included at all, because our right table is the flights table. And since this row does not even exist in the flights table, we would not get any result. So of course, we would see nothing in here. But now if we would change them around, then the flights table would actually be the table that is the left table. And now the aircrafts table is the right table. And of course, we also need to change them around. So then in this case, we get again this result. And now, of course, just the ordering is a little bit different, but we get exactly the same data rows as a result. So left and right join we can just use interchangeably, and actually it's enough if we are just always going with the left join. This is what I'm personally doing. I'm actually never using the right join because it's in the end just the same, just the other way around as the left join. Let's have a look now at this challenge in which the company wants to run a phone call campaign on all of the customers in the district Texas. So the question is, what are these customers from Texas, including their first name, last name, phone number, and also including their district? You can solve this challenge using the left join, right join, inner join, or whatever you think is appropriate. So all of the join types are allowed, and you should of course find out which is the most suitable one. And in the end, of course, just the result matters. So there can be, of course, again, multiple correct solutions. And on top of that, there's also the question if there are any old addresses that are not related to any customer. So these are the two questions, and the expected output results are looking like this. So we have for the first question those 5 customers with these 4 different columns. And regarding the old addresses that are not related to any customer, we also have 4 of those old addresses. So these are these addresses. So now enjoy this challenge, and in the next lecture we'll have a look together at the solution. Let's have a look at the solution of how we can get all of the customers from Texas. If we have a look at the customer table, we see, of course, first name, last name, this is what we want, and phone number is not included, and also the address is not included. But what we see is here the address ID. And if we have a look at our tables, we can see that there's also this address table. And therefore, we can now create a join. So for example, a left join to make sure we have all of the customers included. But in fact, in our case, it would not matter if we use left join or inner join or outer join. This would all be the same. But we want to create a join to the address table. And we can also, again, give aliases like C and A. And the join condition, of course, is on the address ID. So this is our condition. And of course, we want to do the same thing. Also a.addressID. And if we execute that, we get now those customers. And this now includes also the address and the district. So we want to, of course, filter now for the district. So we can say where district is equal to Texas. And then if we do that, we get those 5 customers. Of course, we can now also just say we want to see the first name, we want to see the last name, and also the phone as well as the district. And then we see the results, and this is now just looking much cleaner. But now, how can we find those addresses that have no customer associated? So these are basically old addresses that we don't need anymore because there is no customer related to that. We would have to make sure that for this, the left table where we want to see the rows in any cases is the address table. That's why we copy that. And here, in fact, we can also just use the asterisk. This is not important. And we want to make sure just that the address table is the first one. So let's change also the alias. And then we have the customer table as the right table. Because like this, we can also get the addresses where we don't have any customer for. This is why this is the first and left table. And now we can create our where condition where we say now anything from the customer table, customer ID, for example, and this is from the customer table. Let's make sure to use the C as the alias here as well. And if we execute that, we see that, of course, the condition is null we have to add. So like this, we see indeed we have 4 rows where we have data that only appears in the address table, but this is not associated to any customer. So this address ID is not occurring in any of our rows in the customer table. Sometimes we need to make multiple join conditions. This is when we have multiple columns that make up a join between tables. Because so far, we've of course only seen that we can create a join using one common column. So for example, in this case, we have the employee column, and now we can join those 2 tables. But what happens if we have a table or two tables where we have two columns that make up a join. So for example, the first name alone is not enough because in here we have, for example, the first name Sandra, but this is actually a different person. And this is when we need to use two columns. So first name as well as last name. But this is not a problem at all, and we can do that also in SQL. So how we would do that is just we use the first column. So first name is equal to first name, and then we just add and then just the second condition. And like this, we can even create 3 or more conditions to join tables. It is, of course, more rare to have more than 2 conditions, but theoretically it is possible. And now one more expert tip. We can also use a second condition, not only for a second join column, but also to filter the data. And you might now ask, what is the difference to a regular where condition? Because, of course, we can also do that. And in this case, also, of course, the result would be the same. But now we have to keep in mind, and this is now an expert tip, so don't worry, this is not super important in the beginning, but once you have queries that take a very long time to be executed, then you can benefit from this and filtering, so this condition, because this is more performance efficient. So this will be executed faster, and this is just an expert tip that you can keep in mind, so that this and filtering with this second condition is more performance efficient in joins than adding just the additional where condition. So this can be some tip if we have performance issues. But now let's jump into pgAdmin to see this practically applied. So in this case, we have the ticket flights table, where we see how much the ticket for one specific flight was. So this is a little bit different from this bookings table, because in this bookings table, we can have multiple tickets, multiple flights in one booking. If, for example, a person makes a booking with 2 tickets, return flight, and for example, including the return flight. So we would now like to find out, using this ticket flights table, how much a seat was costing. So we want to find out how much a specific seat costs in average. So we need to use this tickets flight table as well as the boarding passes table, because this is the table where we have the seats actually. So if we select this table, we see that here we have the seats number, and we also have the ticket number and the flight ID. And in here in these columns, we see, as we have already learned, the data type. So this is character, 13 characters. We have then an integer, and here varchar. And also on top of that, we see in these brackets PK. This stands for primary key. So this means that with those 2 columns, so these are both primary keys, and if they are both primary keys together, this means that we can only identify every unique row using those 2 columns together. So usually, if we, for example, have a look at the tickets table, we see that we have 1 column that is the primary key. So this primary key's purpose is to uniquely identify every single row. So if we get the ticket number, so this value of the primary key, we can uniquely say which row this is, so what data there is. But for the boarding passes, we cannot do that, because in fact the ticket number is not unique. We can see that by ordering by the first column. Then we see that if we scroll down a little bit, it seems all unique, but at one point we find that there are some duplicates. So for example, in here we see that there is 40, 40, and this is just now for different flights. So the same ticket number can also appear in different flights. So we need to have both of those columns to uniquely identify every single row. And in that case, we also need those 2 columns to create a join to, in our case, also the ticket flights table, because in there we have the same situation. But we know how to do that, and this is why we can create this join. To now create the average amount, so the average price for every different seat. So this is your challenge now, to create these joins between those 2 tables and calculate now the average price, so the average amount for every of those single seats. So good luck with this challenge, and afterwards we'll have a look together, of course, at the solution in the next lecture. Now we want to calculate the average amount for every single seat. That's why we now want to use an inner join, or we can also use a left join. It's not so important. And there we want to join the table ticket flights. And now we have our two columns. Of course, we can again use the alias B and T. And we want to use the column ticket number is equal ticket number. And now our second condition is now the flight ID. So flight ID is equal to T flight ID. And now if we execute that, we have successfully combined those two tables, and now we can create our grouping on the seat number. So now we can say the seat number, and we take the average of the amount. Of course, now we also need to group by the seat number. So we say group by seat number, and we can see if we can get a result. This looks pretty good. Of course, we can also now round those results to 2 decimal places. And then, of course, we could again also order this in a descending order. So I say 2 for the second column. And now we have, of course, order by. Let's quickly correct that and execute again. So we see that now we have the most expensive tickets in 5H, 3H. So this is all in this H line. So this is sometimes necessary if we have multiple columns that we need to use in a join. So far, we've only joined 2 tables. So for example, the sales table and the bonus table. But we can also sometimes have multiple tables that we want to join. So for example, in this case, we have the sales table and the city table, and of course we can join them together using the city column. But now, what happens if we also want to get the information about the country? In this case, we would also have to join those tables, the city table and the country table, with this country ID. So this also is sometimes necessary, for example, in order to get a result that looks like this. We want to see all of the employees and the names of all of those countries. So if we want to do that, we can also do that. Let's see how we would go about that. The first step of doing that would be to first join the sales table and the city table, because then we get the result with employee, for example, and the country ID, because we have joined those 2 tables using the city ID. And then this result we could now again join using this country ID with the country table and then get our final result. So this is how it would work. Let's see how we can implement this in SQL code. The first step, as we have mentioned, is just joining those 2 tables, the sales table and the city table. And like this, we get the name of the employee and the country ID. And now if we want to join another table on that, we can just add that below that query. So just after the last join, we can just add inner join, then country ID on the column names that we want to join. And now, of course, we can use also columns like the country from this country table. So this is now possible. And what we have to keep in mind that this join, so everything that comes from sales, inner join with this table, inner join with that table. So everything from that join is belonging together. So if we want to add a where filter, we would have to do this in the very end after all of those joins. So all of those joins always need to be together. So it's not super complicated. We can just join multiple tables with each other. What we have to keep in mind is again that if we are using an inner join, in fact, this helps with the understanding, I think. It doesn't again matter which order we are doing. So, for example, if we would just change city and country, for example, we would get exactly the same results. And the same is also true if we would change sales and country. We can just swap them around. And since these are inner joins, it really doesn't matter in which order we are joining those tables. So that's very important to understand. The output will always be the same. So that's the first idea. But now, of course, this is different for the left or the right joins, because there we have remembered the order matters. Let's assume, for example, we have in this sales table also Frank with city ID number 4. In this case, if we also want to have Frank in the final table result, of course, country can only be null, but then we would have to use a left join starting with the sales table. So in this case, if we would swap the order around, so if we, for example, would start with the city and then do a left join again, then we would, of course, lose this result Frank, because this will not be included in the first join, and therefore in the final result, this will also not be included. So this is the theory about using multiple joins. And I think it makes sense again to jump into pgAdmin, have a look at a practical example, and afterwards have again a challenge so that you can practice these joins with multiple tables. In this practical example, we now want to create a query where we want to have for every single ticket, including the passenger name, the column of the scheduled departure. So from the flights table, if we have a look also at the flights table, we see that for every flight, there's a scheduled departure. But if we have a look at the tickets table, we don't have any connection, or at least any direct connection to the flights table. We only have this ticket number, we have potentially also the booking ref, and now we need to create a query to get for every single ticket number, including the passenger name, also the scheduled arrival. If you want, you can also now try this challenge yourself, so use it as a challenge. So pause the video if you want to do that. Otherwise, we are going to do this step by step together. So let's get started with this ticket table. If we want to see how we can create a connection to the flights table, we can have a look at the other tables, and we here immediately see the ticket flights table. So this sounds like a good table that we can use basically as a bridge table to come from the tickets to the flights table. Because in here indeed we see we have the ticket number and we also have this flight ID. So we can first create a join from the tickets to the ticket flights. Let's do that first. So we can create a join. It doesn't matter, we can use an inner join. So we want to use the ticket flights, and we want to use as columns the ticket number. So we can again give this aliases, so T and TF. And now we use, of course, the column ticket number. And also in the other table, we want to use the ticket number. And if we have a look at the output of that, then we see if we have a look to the right. So we can, for example, only use the ticket number and also, of course, from the ticket table. And we can also use now the flight ID. So the flight ID can come from the ticket flight table. And then from there, we can now create a join using this column flight ID. So let's continue the inner join. And now we want to go to the flights table. We can call this F. And again, on the column f.flight ID. And this should be equal to, and now from the table TF, the flight ID. And of course, now we have access to the additional columns. So now we can also use the column from our flight table. So we can use the scheduled departure. And if we execute that, we see that we have now also the scheduled departure, including the ticket number. And of course, if we want to also include the passenger name, then we can also include that now, and we have now exactly what we wanted to have. Of course, we can also, for example, just remove this column, flight ID, and then we have only ticket number, passenger name, and scheduled departure. And again, the order in this case is not relevant, so we could also swap them around. So for example, we can change the tickets table and the ticket flight. So if we would swap them around, we would still get the same result. And also, for example, if we would use this one first, so we want to make this join first, then we can again try, and we should again get the same result. So this should always be the case. Of course, if we have no mistakes and if everything is named correctly, then this should work. But we can just anyways do it intuitively and start with a table where we want to start, and then work our way step by step up to the table where we want to arrive. So hope this was helpful, and now it is your turn to practice and apply this knowledge in the following challenge. In this challenge, your company wants to customize their campaigns to customers depending on the country that they are from. And this is why you need to find out which are the customers that are from Brazil. So what you need to do is write a query to get the first name, last name, email address, as well as the country from all of the customers that are from Brazil. So this is the challenge, and the expected output should look like this. So I wish you good luck with this challenge. Hope you'll enjoy it, and afterwards we'll quickly have a look together at the solution. Let's have a look at how we can get this output. So we first want to have a look at our customers. So we can select everything from the customer table, and there we see, if we have a look, of course, first name, last name, we can have this included already. So first name, last name, what else can we find? Of course, we also see the email. And now if we scroll to the right, we see that we can use the address ID. So this could be something that we can use. And therefore, we want to create a left join so that we have all of the customers included for sure. And then we want to make this join to the address table because we use the address ID to make this join. So we can use that column. Of course, we can again give aliases like CU and ID. And then from the customer table, we use the address ID. And again, in the address table, we also, of course, use the address ID. We assume that there is also this column. Of course, we can also have a look if we go to the table green cycles, and there we have also the address table. So of course, we also have this address ID. And now if we execute that, we can see what this is looking like. Of course, now we can include also things like the city ID. So this can be now also included from the address table. So city ID. And of course, if we have the city ID, we could also now use a join to this city table. So because in here we have also this city ID. And that's what we are doing actually. So we want to now create another join to the city table. We call this table CI. And of course, this should be CI city ID is equal to the AD, so from the address table, the city ID. And in this city table, we also have now this country ID. So the country ID we can again use to go finally to our country table. So we use again the left join now to the country. We can name this CO, and in this case we use the columns country ID, which we have available, of course, in the country table, but also in the city table. So therefore we use CI country ID to create this join. And now if we execute that, we see there should be some mistake. And of course, this is now, in this case, we have city ID multiple times. So we would have to use, for example, CI. So we have to specify from which table this column we want to take. And in our case, we actually don't want to see the city ID, but we want to see from the country table actually just the country itself. And now if we execute that, we get at least already all of these values for this entire list for all of our customers. And now we can filter, of course, by this country. So what we can do now is we can use, of course, a where filter. This would work. Country is equal to Brazil. Let's execute that. We see this works, and this should give us the correct result. I know this was a lot that we have learned today, but this is super important about the joins. That's why now you have also the possibility, of course, optional, to apply your knowledge and practice a little bit in the following challenges. But of course, I want to already congratulate you that you've made it so far, and especially this day today was a lot that we've learned. So that's why congratulations, and again, hope to see you, of course, tomorrow. Welcome to today's first lecture where we want to talk about union. Union is a little bit similar to what we have done yesterday, because yesterday we have also combined two tables using a join. But yesterday we have combined effectively columns. This means in this example in the final table we have 5 columns, 3 columns from the first table and 2 columns from the second table. But today we don't want to combine columns, but we want to use union to combine rows. So in this example, we see that we have our first table, for example, New York, with people and their sales. And then we have our second table, Delhi. And those are now 2 select statements. So we can select the first table and also select the second table. And now with union, we want to combine multiple select statements into one final output. So the result of that should look like this, that we have now combined effectively the rows into one table. And now the syntax of that is also very simple. We just use our first select, and afterwards we use union keyword and then the second select statement that is now combining those 2 tables. So you see that this union command is very simple, and there are just 3 very easy things to remember about it. The first one is regarding the question, how are the columns matched? So if we have a look at these two tables, we see that they are, of course, with the same column names, but even if the column names would be different, they would still be matched, because they are not matched by the column names, but they are matched by the order of the columns. So even if one of the tables would have a different column name, so for example first name, and the other one is just called name, then still they would match because they are in the same order. So the first column is the name, this is here the first column, and then from the second table we will just use the first column and place it below the first column in here. We just have to keep in mind that the name of the columns, if they are different, will be used just from the first table. So in this case, if we would swap it around and if we would use Delhi as the first table, then of course also the result will be from the first name, the same column name as in Delhi. So then first name would be the column name. And therefore it is super important in our union command to have all of the columns in the same order. So we need to be aware of the correct orders of those columns so that we can really create the correct results. So for example, if we would have swapped that around like this would not give us the correct results, because then we would see that this would not match because we have not used the correct order. So this would then not work. And actually, if we have a look at this result, we would also see that this would actually also not really work, because the data types must match. So if the first column of the first table is of the data type text, varchar for example, and the second one would be an integer, then this would not work. So then they would conflict and it must be the same data type. Otherwise the query won't work and we won't get any result. And of course also, just as a little side note, as this is obvious, the number of columns must also match. So we need to use the same amount of columns in the first table as in the second table. And of course we can also use multiple unions and union multiple tables together. And the last thing that we should be aware of is that if we have duplicates, that means if we have one value occurring multiple times, then this will be decoupled. And this is also the case if one value is occurring multiple times, even in the table New York. So then in the output, there will always be only one value. So this is completely decoupled, and in the output, there won't be any duplicates. So that's what we have to keep in mind. And if we don't want to have that, so if we want to have all of the duplicates still present that are naturally occurring, then we can use the union all command. And this is also very simple. Just instead of union, we are using union all. So this is everything that we should keep in mind. The first one, the order is responsible for matching the columns. Secondly, the data types must match. Of course, also the number of columns must match. And with the union command, the duplicates are decoupled. So if we don't want to have those duplicates decoupled, we should use union all instead of union. So this is everything that we need to know about union. And now let's jump into pgAdmin and have a look at a practical example. Now let's have a look at how this union command plays out in the real world. So in our case, we want to combine multiple rows. So we have the actor table. So this actor table contains a first name. And if we order this by the first name, then we see that there are actually also some duplicates that we need to be aware of. Of course, if we use the last name as well, we see that these are just different people with the same first name. So therefore, if we now would union this with the first names of the other table called customers, then we would lose those duplicates. So let's use union, and we can use the same syntax just now in this case from the customer table. So if we execute like this, we see that now Adam occurs only once. And now we see that this is maybe not exactly what we want. And therefore we could decide to use union all. So if we would use union all, we see that now actually Adam occurs 3 times. But now we are not sure how many times it comes from the actors table, how many times it comes from the customer table. And this is why we can use also a little trick. If we are using such unions, we oftentimes want to understand where are these values coming from. And this is why in all of those original selects, we can add a fixed value. So a fixed value means we just, for example, write the text value actor from the actors table. And of course, if we would do that, so let's just select the first line, we see that this is just adding the value actor to this entire first select. Of course, we also would have to do that in the second select, because if we wouldn't do that, we get the error that the queries must have the same number of columns. And if this would not be the case, then we would get an error. So we also would have to add something like this, for example, in this time, customer, to the second select. And if we do that, we see that now we get the information where these values are coming from. And now we see that the duplicates were already also present in the first table, the actor table. So Adam is occurring twice in the actor table. But now if we wouldn't use union all, but just union, we would also note that now Adam is not a duplicate anymore, because there is a difference in this second column. And we don't like also this column name, so we could also just give this an alias like origin. And note that this is not necessary to give this alias now in the second select, because it will just per default use anyways this first column name. So if we execute like this, we get just this column name origin. And if we would use another name, for example, test1, then this would still be the same column name and it wouldn't change anything in our data output. And of course, what we can also do always, use multiple unions. So we can say we also want to now union with the staff table. So union, and then select first name. Then we have the staff table from the table staff. And then we have combined all of those tables. So now if we want to see, for example, order by the last column, let's say by 2, and then in a descending order, we see the staff people at the top. And of course, if we want to make some modifications, like we want to have these names also in uppercase, we can also use our function. This is not a problem at all. So we use, for example, the upper function, and then we of course should be aware to name this properly, because if we do that, this just turns into the value upper, and therefore we should also just rename it again to first name, so we have a proper column name. But we see that this doesn't work actually, and this was because we have used it in the wrong place. So let's use it here at the bottom. We can use the upper function, and now we should get the correct results. So you have seen that there can be some small details to be aware of, but actually in practice, union is a very, very simple command. And as you see, it's not super complicated to use it. Now your manager is asking you to return a little bit of a complicated query. Your manager is asking you to return all of the payments where the payment amount is greater than the average payment amount. So now we are not quite sure how we can do that. So of course, what we could do is create multiple steps. So we can first calculate the average amount. And then if we do that, we can double click in here and then copy this amount. We can say we want to now select everything from the payment and now use a fixed filter. So we can say where now the amount is greater than this specific value that we have just found out in the first query. So now we can use this fixed value, and of course we get now our result with 7,746 rows. But now of course this is changing. We get new data, the values change, and this is why we want to use a more flexible, more dynamic approach that will always give the correct result. And for this, we are going to use so-called subqueries. A subquery is basically a query within a query. So what we could do is, instead of using this fixed value, just calculate the select ourselves. So just calculate the average amount ourselves. So we can just say we want to select the average amount from the payments. And then we know if we execute this query within the parentheses, we will get this value. And now when we want to use subqueries, we just have to keep in mind that we always need to enclose them within those parentheses. If we wouldn't do that, this would not work and we would just get an error. But now if we denote it as a subquery using those parentheses, it can just actually calculate this value first, which is in our case 420. And then the result of that will be used in our other query. So if we now execute this, we get exactly this same result with 7,746 rows. So this means that we can now get this dynamic solution. So that's how subqueries work. Let's see another example. So for example, we want to get all of the payments of our customer called Adam. So we can again say we want to select all of the payments, but now the customer ID should be, and now we can say equal to, and now we want to go and filter by another table. which of course is also possible. So we can use the customer table for that. And now we want to use that customer ID, but now of course we want to get only the customer ID of Adam. And this is why in our subquery we just filter this using the where clause, where first name is equal to Adam. And if we execute that, we now see that we get only the payments of customer with customer ID 367. And if we execute this query alone, we see that this is exactly the single customer ID that we get when we execute the subquery. Of course, if we use the asterisk for all of the columns, then we see that this is exactly the customer that we are looking for. But of course, now we have multiple values, so multiple rows. And then of course, this will not work. So we can only have one single column. So customer ID. And of course, if we do that, it works again, but only because it is one single value. And again, the same thing if we would use something like this, where we have now multiple rows returned, like we can say starts with an A in the beginning, then we see that this will also not work if we have now multiple customer IDs. So this does not work because we have now multiple values. And of course, in this case, it is not working with the equal sign. But what we could do instead is just use the in operator. The in operator we know works with multiple values. So again, we can say that these are all of the customer IDs that we want to see from our payment table. And now these are all of those IDs that we have used in here. So this is how we can use a subquery in the where clause. We can either use the in operator if we have a list of multiple values, or we can use an equal sign, greater or less than sign if we just have one single value. And now it is, of course, again, your turn to apply this knowledge in the following challenge. Let's apply now what we have learned about the subqueries in this challenge. So in this challenge, you need to select all of the films where the length is longer than the average of all of the films. So this is when you want to use, of course, a subquery. And the result that we expect in this challenge should look like this, just so that you can verify your results. So that's the first challenge. And of course, in the next lecture, we'll have a look together at the solution. But now there's also a bit more difficult challenge. And in this challenge, you now need to return all of the films that are available in inventory in store 2 more than 3 times. So this is, again, a little bit more difficult. In this challenge, you need to also combine the subquery with something that we have learned previously. So again, you need to return all of the films that are available in the inventory in store 2 more than 3 times. So the result that we expect for this a bit more difficult challenge should look something like this. So now, of course, this is a challenge a little bit more difficult, but you can try yourself and find out if you can solve it and work on it. And of course, in the next lecture, we'll have a look at it together in the solution. Now let's have a look at the solutions. In the first challenge, we wanted to find all of the films with a length that is longer than the average length. So let's first have a look at the film table. And in here, if we scroll to the right, we see that there's this column called length. So that's what we want to filter by. So we say length is greater than, and now the average length of all of the movies. So we can do this using a subquery. So we say select now average length, and this is from the film table. And then if we execute just this query, this will give us the average length. And then if we use it as a subquery, of course, we know this will be executed first. And this value of 115 will be now compared against the length and used as a where filter in our main query. And then the result is exactly what we expected. But now there's also the challenge that is a little bit more difficult. And in this challenge, we wanted to return all of the films that are available in the inventory in store 2 more than 3 times. So let's see how we can step by step also solve this challenge. So the criterion is that the inventory, if we have a look at the inventory table, then we see that there's a film ID, and this just means we have multiple inventory, so the movie is available multiple times, and it is available, for example, film ID 1 4 times in store 1 and then a couple of times in store 2. So now if we want to find out how many times a movie is available in a given store, we can, for example, just group the data, group by the film ID, and then we can say we want to see, of course, the film ID, and we can now count the values. So if we count the values, we see how many times the movie occurs in the inventory. So of course we can also now filter this, and this of course needs to happen after from. So we can say where now store ID is equal to 2, because we want to see only how many times it occurs in store ID 2. So if we do that, we get this list. And of course, we can now filter this using the having clause. So if we want to filter an aggregation like count star, we always need to use the having clause. And now we say more than 3 times. So if we do that, we see now those are all of the films. And of course, we have 2 columns now. This means that this cannot be used in the where clause as a subquery. This is why we should remove this count star, and then this is the list of all of the film IDs that we are interested in. So now if we make this into a subquery, and we see that we filter now all of the movies, so select star from film, where, and now the film ID is appearing in this list in here. So since this is a list of multiple values, we use the operator in. And if we execute that, we get exactly the result that we expect. So this was a little bit more difficult, but hopefully it was some opportunity for you to just work on it a little bit, try a little bit, and get a little bit challenged, even if you could not find out the result yourself. Because this, as I mentioned, was indeed a pretty difficult challenge. And now in the next lecture, we have again a few more challenges to again just practice what we have learned about the subqueries. Now let's have a look at a few more challenges, and in the first one we want to return all of the customers' first and last names that have made a payment on the 25th of January 2020. This is the first challenge, and the expected result should look like this. So first name, last name of those specific customers. And the next challenge is that you need to return all of the customers' first names and email addresses that have spent more than $30 in total. So the expected result, again, a list of the first name and the email address of those specific customers. And now the last challenge, which is again the most difficult challenge so far, is now asking you to return all of the customers' first and last names that are from California. So this is the district in the address, and on top of that have spent more than 100 in total as a payment amount. So these are 2 criterions now, and this is the expected result. So this is a little bit of a more difficult challenge, but hopefully it will help you to apply what you have learned and get a little bit more challenged. And of course, in the next lecture, we'll again have a look together at the solution. But of course, you should try this yourself. Even if you cannot find out the solution, it's important to work on those challenges. So good luck with these challenges. Now let's again have a look at the solutions of those additional challenges. First of all, we want to return all of the customers' first and last names that have made a payment on the 25th of January 2020. So let's jump into pgAdmin and see if we can find the solution. So of course we can already say we want to see first name and last name of the customers. So we can say first name, last name from the customer table. But of course, these are now all of the customers. And that's why we now also want to filter this to all of the customer IDs. So customer ID is in, now we want to provide a list of all of the customers that have made a payment on 25th of January 2020. So we can make this list by using a subselect. So we have our select, and then we say now the customer ID, and now we want to filter this. So we say, of course, from payment, and we want to filter this using a where clause, where payment date, and now we can use the function called date to filter exactly on the date, and we say that this should be equal to 2020, 25th of January. And in the end, we need to also close the parentheses of our subquery. And now if we just execute this subquery, we will see now all of the customer IDs where we have the payment happening on this day. And now we can use these values in the filter of our main query. So if we execute that, we get this list, which is exactly the list that we wanted to get. So this is exactly the correct result. And now again, we want to see what is the solution to the next challenge. So in here, we wanted to get again all of the first names and the email addresses of the customers that have spent more than $30 in total. So in this case, we can say first name and email. And of course, we need to change also the filter. So we can say where customer ID. And now we just have to change our subquery. So we do this by grouping the data. So we say from payment, group by, and now the customer ID. And we want to now filter this grouping using the having clause. And we can now say our criterion, sum of the amount should be greater than 30. And if we do that, we can just verify the results. So let's execute that and quickly also have a look at the expected output. So we have Mary, Patricia, and Linda, which is in fact correct. So this is the second challenge. And now with the last challenge, which was a bit more difficult, we have two criterions. So we now want to get first name and last names where the people are from California and have spent more than 100 in total. So let's see how we can make this work. We can first of all say have spent more than 100 in total. So we can just modify this a little bit. So the sum amount should be greater than 100. And now as a second criterion, we can write this in the beginning. We want to have a second condition. So we say and customer ID also needs to be in. And now a second subquery, because now we want to get all of the customer IDs that are in the district California. And for that, we need a join in our subselect. But this is not a problem at all. So we want to say from the customer table, and this needs to be now joined with the address table. So we say inner join, and then we want to use the address table. On the columns, we have the address dot address ID, and this should be equal to the customer dot address ID. Dot address ID. And now if we have those two tables joined, we can filter using the district column. So in here, the district column should be equal to California. And now, of course, we need to close the parentheses for the subquery. And if we execute the result like this, we get this result that we wanted to have. So again, this was a little bit more difficult, but hopefully it could help you to practice a little bit more on the subqueries. Now that we've already learned about the subqueries in the where clause, we are ready to see two more applications of the subqueries. And the first one is in the from clause. So instead of querying from a table, we can also query from a subquery. And now we want to make it practical immediately. So we want to find out, because our manager is asking us to find out the average lifetime spent per customer. So we remember we have our table called payments, and in here we have now a couple of customers, and now we could, for example, say we want to sum the amount, and we want to do that by all of the customer IDs. So we can just group it as we have learned it, group by customer ID, and then we get the list of all of the spendings, so all of the lifetime spendings of our customers. But now, how can we calculate the average of those sums so that we have the average lifetime spent per customer? So if we wanted to do that, we can use again a subquery. But this time we use it in the from clause. This means we now create the average of this sum amount. And if we want to do that, we need to give this an alias first. So we know an alias we can give with s, and we can say total amount. And now this can be used. So if we say this should be from that subquery. So this is where we want to query from. And now we can use this column. So if we execute that, we can use the column total amount. So now we can place it in here. So we can say total amount, and we can take the average from that. So again, the subquery will be executed first. It will return this result, and then we can use the average and apply it on that total amount. So if we now execute the query, we see it will not work. And this is because in PostgreSQL, we can only use a subquery in the from clause if it is named with an alias. So this is why we need to give this a name. So we can say subquery, this works, or we can say as subquery. This is again something that we can leave. It will work as well, but it is just a little bit more descriptive and easier to read if we also write as. But again, it is not necessary. So if we execute it, we get the average amount, and of course we can now also round the result to 2 decimal places, give it also a new alias. So for example, we say lifetime spent, and this is then our result. So we use now a subquery in the from clause to make a 2-step calculation. So sometimes we need to do that. So this was the example of how we can use a subquery in from. And now again, it is your turn to apply this knowledge in the following challenge. Let's now also practice what we've learned about subqueries in the from clause. So in this challenge, you need to find out what is the average total amount spent per day. So this basically is referring to the average daily revenue of our company. And the expected result should look like this. So we should have a value of 1,644.31. So good luck with this challenge, and afterwards we'll have a look together at the solution. Now let's have a look at how we can calculate this average total amount spent per day. So the first step that we want to do is we can, of course, first create the sum of the amount per day. So we can just group this by the payment date, so the day of the payment date. And we do this just by using group by, and we can of course use the function date on the payment date. And if we execute that, we get just the amount spent for every single day. And now we want to calculate the average of that. This means that we want to create a subquery, and this should be our subquery. And then from this query, we want to use that sum amount. We can give this an alias. So for example, amount per day. And then we can use this in our main query. So we say select average from the amount per day. And this will give us now the average of those values. So if we execute that, we should get the correct result. But of course, we have forgotten about the alias of our subquery. So if we just give this a name like A, then we get the result. And of course, we can also just use a round function so that we don't see so many decimal places. And we can also say this is daily revenue average, for example. So of course, we can give it a different alias as well, but the important thing is that we get this correct value. And now that we have this, we want to have a look at one last place where we can use a subquery, and this is within our main select clause. Let's see how this works in the next lecture. In the last few lectures, we've seen how we can work with subqueries, and we've seen that we can use them in 2 different places. The first one was in the filtering, so in the where clause. And then we've also seen that we can use subqueries in the from clause. We only have to be aware that we give this subquery an alias, and then it works as well. But now there's also one last place where we can use subqueries, and this is within the select clause. So this works very similar to what we already know. So for example, we have our payment table. Let's query from that. And we have also already seen, or we might know, that we can add values. So for example, if we add one single value, for example, hello or 3, then this works, and this just places all of the same values in all of the rows. So for example, the value 3 in this column and the value hello in this column. But now we can make this a little bit more dynamic using, again, subqueries. So in this case, if we have a subquery and we want to use it in the select clause, then this also needs to be just one single value. So for example, we can create an aggregate. So let's say select average amount from the payment table, so from payment, and then we see this again just gives one single value, and of course we can, if we want, round that, so we say round, and this should be to 2 decimal places. Then this value will be also added to all of the rows, so one value that gets added in every single row. So this is how we can use a subquery. And now what doesn't work is if we have something like this. So we have just the amount from the payment table. And if we just use this query, we see these are now multiple different values. Of course, as a main query, this works. But now if we want to use this in the select, this does not work, because it is multiple values, which is not possible to execute. So then we don't know where which value should go to. And that's why this is not possible in a subquery if we use it as an expression in our select. But what we could do, if we just want to limit this to just the first row, then again we have just one single value, and then this will work again. So like this, we can get this result. So this is what we have to be aware of if we are using a subquery as an expression in our select clause. So that's very simple, and also the use cases are not super common. But anyways, in the next lecture, we will have a quick challenge that you can also apply what we have learned now about using subqueries in the select clause. In this challenge, you need to show all of the payments together with how much this payment amount of that specific row is below the maximum payment amount. So for this, you of course need to use a subquery in the select. And the expected result should look like this. So you have all of the payments and then the column called difference, which is basically just the difference between the maximum amount of all of the payments and this specific payment in that specific row. So that's the challenge, and in the next lecture, we'll have a look together at the solution. Let's now see how we can get this result of that challenge. Of course, first of all, we can select everything from the payment table. And afterwards, we can add one additional column. So we can just say comma, and then we want to create a subquery, because now we want to calculate the maximum payment amount, and we want to subtract the amount from that maximum payment. So we say select maximum amount, and this should be from the table payment, and we want to now subtract from that the amount of that specific column, because the maximum, as we will see in here, is just $11.99, and then we want to always subtract the amount from $11.99. And if we do that, we can also of course give this a name, so for example as difference, and then if we execute that, we get this result that we expected. So this is how we can use the subquery just within our select statement. But we can get even more advanced and elaborate by using so-called correlated subqueries. So how this works and how powerful this is, we will see in the next lecture. Now let's also have a look at the so-called correlated subqueries. To understand that, we first want to summarize quickly what we could do with the normal subqueries. So we could see we have a table with people and their sales, and what we wanted to get now is all of those people that have sales that are higher than the average. That's what we could do with the standard subqueries. So we see the subquery is just getting the average of the sales, which is 300, and then we get all of those people that have sales higher than 300. But now what happens if we have the following situation? Now we have an additional column called city, and now we want to get all of those people that have sales that are higher than the average in their city that they are living in. So then we do need the correlated subqueries. This is now not possible anymore with the standard subqueries. So let's see step by step how this works. So our select in the beginning is exactly the same. We have then our where condition with the filter on sales, and then we just have our correlated subquery. So this correlated subquery also starts exactly the same way. We select the average sales from the employees. But now we also need to add a where condition, and we need to name our two tables. So we have E1 and E2, for example, and then we define our filter. So this is now E1.city is equal to E2.city. Now this looks a little bit complicated, but let's see how this works. The key thing here is that now every single row gets evaluated independently. So let's see how this works. Let's have a look at our first row, for example. And here we have sales of 600. So the sales value of this row is 600. But now the question is, what does this subquery here evaluate to? We see that E1 city is in our case Delhi. So that means that now we take only the average of all of the cities of Delhi. So we say that now this is an average, in this case, of 366 around, and this now means that we get this value indeed. So 600 is greater than 366, and that's why we see this value. And now if we are in the next row, again, we check, okay, the sales value is 400. We are currently in the city Delhi, and again, the average of that same city Delhi is 366. So 400 is greater than 366, and like this we also see that value. But now for the next one we have 100, so that's not greater than 366, so this value does not appear. And now the same thing is also going on with Dallas. So Dallas, we have an average of 266. So the first row and the second row will appear and the last one not. And also, of course, it works the same way with Berlin. And here we have a value of 250. So the lower one with 400 appears and the other one not. So the important thing that we just need to remember in here is that in this subquery, every row gets evaluated independently. So we just check, in this case, the cities. So we take the average for the city, and then we check if this sale of this row is greater than the average of that city. And also what we need to know is that a correlated subquery does not work independently. So if we would just execute this subquery itself, we would see that it doesn't work, because in here we are referencing, and this is related to our outer query, so our main query E1. And that's why if we would only execute the subquery, it would not work. We would get an error message. So that's the a little bit complicated theory about the subqueries. And now let's quickly just jump into pgAdmin to see a few examples of that. So in this first example, we want to show only those payments that have the highest amount per customer. So for example, if we see customer ID 269, then we see, okay, what is the highest amount? Let's say it would be this one, and then we would only want to see this row in here. So not all of the other ones, but only this row, because this is the highest amount for this customer. If you want, you can pause the video and try to find the solution yourself. So like this, you could already practice and challenge this, what you've already learned. But now we'll also have a look at the solution together. So we start, of course, with our select. We can select everything actually from payments table. And now we say we want to filter this by the amount. And we want to now use a correlated subquery. So we want to say the maximum amount of one specific customer. So we say from payment. And now again, since this is a correlated subquery, we should name our tables. So we have P1, and in here we can say this should be P2. And now our filter condition should be based on the customer ID. So we want to see the highest amount per customer. So that's why we want to use P1 is customer ID is equal to P2 customer ID. And then if we execute that, we should get now the correct result. Of course, we can also order this by the customer ID. Order by customer ID, and then if we execute that, we should now see for every single customer the highest payment amount and also the related information to that. So this is how the correlated subqueries work, and in the next lecture you'll have another challenge to practice what you have learned about this correlated subquery. Let's now practice this topic of the correlated subqueries. So on the first challenge, you need to show those movie titles, their associated film ID and replacement cost, with the lowest replacement cost for every single rating category. So you should also include the rating itself. So the output, so that you know how it should look like, should be like this. That's the first challenge. And now let's have a look also at the second challenge. In this one, you need to show only those movie titles, their associated film ID, and the length that have the highest length in their category. So also, again, you should show the rating itself. And again, the result should look like this. So we should have all of those titles with the highest length in each of the categories. So good luck with this challenge, and afterwards, as usual, we'll have a look together at the solutions. Now let's have a look at how we can find the solution to our two challenges. In the first one, we want to find those titles, film ID, replacement cost, and the rating of all of those films that are the lowest replacement costs in their category. So we want to select, of course, the title, film ID, and the replacement cost, and of course also the rating itself. And then we can say this should come from the film table. Of course, this is nothing new, and this we already know. But now we of course want to also filter this to only those movies where the replacement cost is now the subquery is the lowest in their category. Therefore we use select, and then we have the minimum and now replacement costs. So we can also write this in another line. So for example, like this. And this should come from the other film table. So we query again, and that's why we call it F2 and here F1. And now our correlated filter, basically, we have F1. And now the grouping that we want to do is about the rating. So we have to rating as well. And now if we select it, we get our desired output result that looks exactly as we expected. And now the second challenge, in here we want to see only those movies with the highest length in their rating category. So if we just want to modify this query, we just need to do the maximum, and this time it is not the replacement cost but the length, and of course also in here the length that we compare against, and also we want to see not the replacement cost but the length. And now if we execute that, we should again get the result that we wanted to get. So these were the solutions to our correlated subqueries. But now there's also another way to use a correlated subquery, and this is not in the where condition but in the select clause. So let's see how we can do that in the next lecture. Similar to the standard subqueries, we can also use the correlated subqueries in the select clause. We cannot use them in the from, but we can use them in the where and also in the select clause. So let's see if we want to get also an additional column with the minimum sales amount for every city. How could we achieve that? Again, we would just use this correlated subquery in our select clause. And now we just have to be aware that we have now 3 times, in our case, this employee table. So we have 3 selects. So the first one is E1, then we have the second one in the where clause, and now if we again use this employee table E3, then we just need to name it also with another name. And now we can just use, again, in this case, the minimum sales, and now the where condition is just, again, the city. And then for every single row, the minimum of the sales of this city that we are currently in will be displayed in this row. So this can now give us additional information for these people, and that's also what we can do with correlated subqueries. Let's jump into pgAdmin to quickly see an example of that as well. So what we want to do is we want to get the maximum amount that a customer has spent next to all of the payments. So we see we have all of those payments, and now for every single customer, we want to see also in this additional column the maximum amount that this customer has spent in a single payment. Let's see how we can add this in here. So we just need to use a comma to add another column, and then we say select. We want to get the maximum amount, so we say just maximum amount. And this should now come from the payment table. And we can name this P2. So the first one was P1. And now our correlated where condition. This is where, in our case, it will be grouped by the customer. So we have P1 customer ID should be equal to P2 customer ID. And then we should get the correct result. So let's execute that. And we should see we have now also this maximum amount of each of those customers. So for example, this customer has a maximum amount of $10.99. So we should find it somewhere in this list. Of course, this is not completely ordered by the customer ID. But if we would do that, customer ID, then we would see that now the maximum amount should be in here. So for example, this customer with that amount. So this is how we can also use correlated subqueries in the select. And now again, it's your turn to just apply this knowledge in a few challenges. Let's now have a look at a few more challenges that are also now a little bit more difficult, just to apply what you've learned about the correlated subqueries. So in this first challenge, you need to show all of the payments plus the total amount for every customer. So the sum of the amount for this specific customer of this specific row. And also the number of payments of that same customer. And the result should look like this. So we have all of the payments with the payment ID, and then we have the total amount. You can call that sum amount or something else, and then the number of payments of that customer. This is the first challenge. Now the next challenge, in this one you should show only those firms with the highest replacement cost in their rating category. Plus on top of that an additional column with the average replacement cost of that same rating category. So again, the result, just that you can imagine the result, should look like this. We have the titles, then the replacement cost of that title, and again only the highest replacement cost of the category should be displayed. And then we have an additional column called average, in which we have the average replacement cost of that rating category. So now on to the last challenge. In this last challenge, you should show only those payments with the highest payment amount for each customer's first name. So now you need to also use joins. I know we have not done that before, but still you can apply that and try it out, because you should actually know everything already about that, but it's some new thing that you have to just put together, and this will be good for you also to practice and find out about that. And also you should of course include the payment ID of that same payment. So all the payments with the highest payment amount for each customer's first name, including the payment ID. And now another question on top of that. How would you solve this if you would not need to see the payment ID? So only the highest payment amount for every single first name of the customer. So this would be then much easier to solve, and that's why we have also this additional question. And again, the result should look like this. So we have first name, amount, and also the payment ID. So these are the challenges. I wish you now good luck with those challenges, and in the next lecture we'll have a look together at the solutions. Let's now also have a look at the solutions of those additional challenges. In the first challenge we should show all of the payments and the total payment amount for every customer, as well as the number of payments for each customer. We'll first have a look at the result, and afterwards we'll have a look at the solution and how this solution works. So if I execute that, I see this is the result, and we start by first selecting, of course, payment ID, customer ID, staff ID, and amount. So everything that we want to see. And then we want to also add the sum amount. And this we can do with a subselect, so a subquery in the select. And this should be now a correlated subquery, because we want to see that sum amount just for every customer. This is why we use sum amount. We can give this an alias here already. And then we use payment P2. We need to give this a new name. And then our condition where P1 customer ID, because we group by the customer ID, is equal to P2 customer ID. And the same thing we can also now do for the payments. So we have here this grouped again for all of those customers. So for example, customer 1 and then customer 2. That's why we basically use the same syntax, apart from the fact that we use count as an aggregation. But the rest will be just the same. And then just after we have this complete select, so all of those columns, we say this should now come from the payment table P1. And then optionally, we can also order our results. And now the next question is where we have to show now the highest replacement cost for each rating. So all of those films we want to see. So let's first again select everything and then quickly also explain how this query works. Because we have two things in here. First of all, we only want to see those films with the highest replacement cost. This is why we need to use in the where the condition about the replacement cost and a subquery. So we use max replacement cost from our table film, and we use F3 because this is the third time that we are using this table. So we have F1, this is the first one, then we have F2 in our select, and then we have also F3. And now, of course, this should be a correlated subquery. This is why we use F1 rating is equal to F3 rating. This means that we group by the rating and we want to see only the maximum replacement cost for every rating type. So in every rating type, we see the highest replacement cost value. And also this average we can calculate using a correlated subquery in our select. So we just use the average replacement cost from the film table and then our correlated condition. So this should be based on the rating. That's the solution of the second query. And now the last query in which we should also use a join. So in here we should show the top payments, so those payments with the highest payment amount for each customer, including the payment ID and also the customer's first name. So again, we use first name, amount, and payment ID from the payment table. And now, of course, we need to join this with the customer table because we also want to see the first name of the customer. Let's quickly select it so we can see what we are doing. So this is the first name coming from the customer table. This is why we can first make an inner join using, of course, the customer ID from our payment table. And now on top of that, we have, so if we would just use this without the where condition, we would just have all of the payments with the first name. But we now also want to filter this to only those payment amounts where we have the maximum payment of that customer. This is why we also use a correlated subquery based on the customer ID. So like this, we see only the maximum payments for each customer ID. And of course, also the first name of that customer. And now the additional question, how would you solve this question if you would not need to also include the payment ID? In this case, we could just group our data and use the maximum. So if we would not have to include the payment ID, we could just use first name and we could get maximum amount. So let's use maximum amount, and then we can just group by the first name. So we can just remove that and say group by the first name. And then if we execute that, we can also just get that result just without the payment ID. So if we do that, we also get that, just we cannot see like this the payment ID. So this would be an easier solution just with grouping, but then we don't see all of those other informations. So then we don't filter the data, but we group the data. So these were now a lot of challenges, and again, there can be different solutions that are all correct. So don't worry if you have another solution. This is also totally fine as long as you get the results that you are expecting to get. I know this was a long day, this was also a challenging day, but congratulations on completing this day. You've come already super far, so congratulations on that. And hopefully, of course, see you again tomorrow. You have now learned so many things and improved your skills so that it is time to prove your skills and evaluate your skills in this mid-course project. So you remember that you were working and you were hired as a data analyst in the company about the movies. And so far, this company is very happy with your work. You have developed your skills, and this is why they want to now promote you from a junior data analyst, and that's what they are thinking about, of promoting you to a senior data analyst. On top of that, they also have a few changes going on in their company. That's why they want you to help them with a few questions and challenges. So you need to do some analysis for them and solve a few challenges for them. So if you can solve 10 out of 14 challenges, then they will promote you. So this is the goal, and I know this is not something super simple, but you have, of course, multiple tries. If you cannot figure out one, then just try it again, and by the end, the goal should be, and this would be an extremely good achievement, if you can solve 10 out of these 14 challenges. Because the last one, the 14th challenge, is actually more of a bonus challenge because it's extremely difficult to solve that, and I don't expect you by all means to solve this bonus challenge. So if you can make it for 10 out of 14, this would be already absolutely great. And now also I want to just mention how this course project works. So in the beginning, you have a list of the questions with a few information. So for example, in the next lecture, you will see all of those questions. So we have question 1. There is the difficulty level ranging from simple over moderate to a little bit difficult to very difficult. And then, as I mentioned, one question that is extremely difficult. And that's the bonus question that you are not expected to solve actually. And then also we have the topic, which helps you just to understand what this question is about. And then you have the task. So this is the SQL query that you should write. And associated to that, there's also a question and an answer, which should just help you to verify your solution that you are doing then, of course, in pgAdmin. And then after you have done those questions and solutions, you can verify the solution. So you only need to do that if the question is not correctly answered, or if you cannot find out the answer yourself. In this case, we have in the following lecture the solution sheet with all of those solutions presented. And also, if you don't understand one specific solution, in the following lectures, we also have a video walkthrough through all of those solutions, just so that you can refer to them if you don't understand one solution. But if you have the answers correctly, you should actually not even worry so much about my solution, because your solution is the correct one. And if my solution is different, this doesn't mean that yours is wrong, because you should just judge that by the fact if you have the answer correct or not. And now, before we start with those questions, I also want to just mention a few things. I know 14 challenges, this is quite time consuming, and this is why I just want to mention that if you need more than one day for this, don't worry, just take your time, do it in 1, 2, or 3 days. The important thing is just that you do these challenges and that you evaluate your knowledge and practice those skills. Also, I've already mentioned multiple solutions are possible. So sometimes, for example, I'm using a left join or an inner join where you could also use another join, and this would give exactly the same result. And then in the end, you can use this project, as I mentioned, to evaluate your skill level. We've already mentioned that the overall goal is to have at least 10 out of 14 challenges correct, which would be a great result. But if you have another result, here is how I would evaluate your skill level and what I would recommend you to do. So if you have less than 6 questions right, don't worry, you do have some skill level. And I would just recommend that you just walk through the lectures again of those questions that you couldn't answer right. And then, of course, also do those questions again to hopefully then improve your result and just work on those topics that you can improve on. And afterwards, we have between 6 and 8 questions right. Here, this is already some decent skills. You know what you're doing. I would just recommend to work through the video solutions of those questions that you didn't get right. And then afterwards, try them again yourself if you are able to solve now more questions than before. And then everything above that is really good skills. So here I can just say congratulations on what you have achieved in such a short amount of time. And even if you have less questions right, I want to say congratulations, because you've made it so far through this entire course. And this is really a great achievement within a short amount of time. So just work your way up, work on those challenges, go through the lectures again of the topics that you didn't fully get right. And now, of course, if you have at least 12 questions right, well, what can I say? These are outstanding skills. And yeah, I hope you'll just continue to enjoy the course. And this was it about this course project. And now I wish you good luck with those challenges and hope you'll enjoy them to practice your knowledge. Welcome to the walkthrough of the solutions of those challenges. I hope by now that you have tried those challenges yourself and you don't need to watch those solutions unless you are stuck with some question or you just have the feeling that you want to have some explanation on the solution. So here is the first solution of question number 1, in which we want to practice the distinct command, and you should create a list of all of the different replacement costs of the film. So the question also is, what's the lowest replacement cost in our company? So to do that, we just can go to pgAdmin, and if we want to select all of the different values, we can of course just say replacement cost from the table film, and we can now make also a distinct select. So if we just do it like this, we can of course again just order the results in a descending order by the replacement cost. descendingly, then we would also get all of these costs. We can make it actually even ascending. It's not super important, but we have also now many duplicate values. This is why it makes sense to use the distinct select. So if we do that, we see now all of the distinct values of the replacement costs. So this was challenge number 1. Let's have a look at question number 2, how we can get the solution. In here, we need to write a query that gives an overview of how many films are in each of those replacement costs categories. So we define the categories by the cost range. We have the first category called low, between $9.99 and $19.99, and then we have also those 2 other categories, and we need to answer the question, how many films have a replacement cost in this low category. So let's jump into pgAdmin and see how we can solve this challenge. First, we can have a look at the film table where we have our replacement costs included. And now we want to solve this challenge by, of course, defining those categories using case when. So we define our conditions. The first one is our category that is in between 9 and 19.99. We can define this either using the between operator, or since we know that 9.99 is our lowest value, we can also, for example, just say replacement cost is less than or equal to 19.99. And then we have the outcome, which should be then low. And then we have our other cases, which we can just copy. So we say when replacement cost. And now we can use, this is the easiest option, the between operator between 20 and 14.99. Then the value should be medium. And then we have also the last condition, which in this case is then just the category high. And this is now if we are greater than 99, then we would be in the category high. And if we select that, we have now not the solution, because what is always the problem? We forget the end clause. And we can also give this an alias. For example, this could be the cost category. So this is just an example. And then we execute that. We see now only those categories. But of course, we would also like to just now count those values. And this is why we can now also use count. So we can use, for example, count star. Of course, we should not forget about the comma, another very common mistake. And now this is not working because we need to now group the data. We can try to also use that cost category in here, and this will work as well. So if we execute that, we now get those results and our solution of 514 movies in the low cost category film. So this was challenge number 2. Hope it was helpful, and see you in another lecture. Let's have a look at question number 3, in which you should create a list of all of the film titles, and included should be the title, the length, and the category name. And this should all be ordered descendingly by the length. And on top of that, it should be filtered to only the category drama and sports. So let's see how we can solve this challenge. So we first can start with selecting everything that we want. So we have the title, we have the name and the category basically. So that's the name. We have also the length, and this is everything that we need. And now we need to do some joins, because we have the film table where of course the title and the length is coming from, but then we also need to have the category name included. So if we scroll up, we see that there's one table called category, and in here we have the category ID as well as the name. Unfortunately, in the film table we don't have a category ID. So we cannot directly join those two tables. But what we can do is we can find this so-called bridge table. This means we have a table film category, which has both the film ID and the category ID included. So we can join this table to our film table, and then this film category table in this category table. So we can make basically two joins together. And then we have also this category included. So let's start with the film table, which we can give the alias f. And this we will now join. We can use a left join. The result will in our case not be different. This we want to join to film category. We call this FC. And we join this using the column film ID. So this should be equal then to film ID of both tables. Afterwards, we can now make the join to our category table. We can give this again the alias C, and now we can use the column category. So we have the category ID, and now this is the column that we can use to join this together. So we have again category ID. And now if we execute that, we have all of the information that we need. But of course, we now can also filter this. So we want to filter it only to the categories of sports and drama. So where name is equal to sports or name is equal to drama. And now if we do that, we get our result. But of course, now we want to also order this in a descending order by the length. So we add this at the bottom of our query. And we can say this should be in a descending order so that we have the highest result at the top, which will give us our output. So hope this solution was helpful and see you in another video. Let's have a look at question number 4, in which we should create an overview of how many movie titles there are in each category. And then we should answer the question, which category name is the most common one among our films. So we have already done this previous challenge where we have created a join from the film table over film category to the category table. And now if we don't use this where filtering, we have all of the information that we need. And in here we can now just count the values. So we can not have the title included and just group by the name, and then we can just count the number of values. So if we now count those values and we group by the category, which actually is just called name, then we should get our result. And now if we want to find out the highest category, so with the most movies, we can order by count star in a descending order to see the highest value at the top. And then we get our results, which is sports, and we have 74 movies. So this was the solution to challenge number 4. Hope it was helpful and see you in another video. Let's have a look at question number 4 and how we can find the solution to that. So for this challenge, we want to first get everything from the actor table. So if we do that, we see that there's the first name, last name, as well as the actor ID. But if we query from the film table, we see that there are the movie titles, but we don't have anything that is called actor ID. And if we have a look into our list of the tables, we can again see that we have a table that is called actor, and this should be somewhere here, film actor. So that's what we can use as a bridge table again, because in here we have the film ID and the actor ID. So we can make two joins from film to film actor to actor table. So let's see how we can do that. We have film with the alias F. We can use an inner join, a left join. There is not a difference in our case. And then we add also the film actor table. We can call this FA, and this should be then on the film ID. So we have the film ID should be equal, and then the next join is now the actor table. So this is now working, and now we can use the actor ID to join those two tables from the film actor to the actor table. And if we have that, we get all of the columns that we need, and now we can group by the first name and the last name. So we can say first name and last name, and now we can also count those values. So we count basically the number of movies, so the movie titles. And then we get the result. Of course, we need to also use group by, and then those two columns that we want to group by. And then if we do that and we execute it, we should get the correct results. Of course, we can again just order our results just at the end of our query. We can say order by 3 or by count star, and then this should be also, of course, in a descending order to see the highest value at the top, which gives us the desired result of Susan Davis with 54 movies. Let's have a look at question number 6, in which we want to create an overview of those addresses that are not associated to any customer. And the question is, how many of those addresses are in the database? So let's have a look at how we can do that. Of course, if we query in the beginning from the address table, we cannot exactly see if there are any addresses that are not associated to a customer, because we don't even have a customer ID in here. But we have the address ID that can also appear in the customer table. So if we have a look at the customer table, we see that there's also for every customer this address ID. But some of these address IDs of the address table might not appear in any of our customers. And this is why we can start with this address table and make now a left join. So this is now important because we also want to see those addresses, so those rows that are not associated to any customer. So they will have blank values, and we can then see exactly those addresses where there are blank values for the customer. So let's see if we just add the customer table, and we can also, of course, as always, give a few aliases so we have it easier to create the join. We have a.addressID is equal to c.addressID. And now if we see that, we have all of this combined, and now there can be some values where we have no value, so nulls, in the first name or last name. But of course, we should filter this, because looking like this is not the way to go. This is why we want to now add a filter. So if we say where c dot and now just any column of the customer table, and ideally it's the primary key actually, because it could be that there are nulls in the first name or in any other column, but actually there would be a customer ID available. So if we say where customer ID is null, we can now see that these are indeed all of those addresses where there is no customer associated to, and we see there are actually 4 addresses that are not associated to any customer. Let's have a look at question number 7, in which we should create an overview of the cities and how much sales we had, so the sum of the amount, have occurred there. So let's jump into pgAdmin and see how we can do that. Of course, we want to have a look at the payment table, because here we have the amount that we want to aggregate. And of course, we now also want to get the cities. So how can we come from the payment to the cities? We can do that via the customers. That's why we first want to create a join. Let's just use an inner join. Ideally, we would use a left join, but in our case, there wouldn't be a difference. So let's just use a left join. So we have the customer table. We can also give these names. And now we use the columns for the join customer ID. So we have p.customer_id is equal to c.customer_id. And then we also, from the customer table, use a left join to the address table. And again, here we want to use the address ID. So again, the primary key. And this should be equal to the c.addressID. And from there, we can then create a join again. We will see that if we have a look at the columns to the city ID. So now we can create a join to the city table. We can call this CI. Be aware that this needs to be, of course, a different alias than C, because C already appears. And now again, we have the columns. In this case, city ID is equal to city ID of the address table. So if we do that, we get all of the necessary columns, and now we can just group all of our amounts by the cities. So we use the column city, and then we just sum the amount. And of course, we need to then use the group by the city. If we do that, we have an error. Let's see where it occurs. Of course, we have done this little mistake. We should put it right at the bottom, and then we get the correct results. Of course, now we can again order the results by the amount. So we say sum amount. And then if we do that, we get the results. But of course, it should be in a descending order, which gives us the expected solution of Cape Coral with 221.55. Let's have a look at question number 8, in which we should create an overview of the revenue again, grouped by a custom column. And this custom column should be this time in the format country, whitespace, city. The question associated to that, which country city has the least amount of sales? Let's jump into pgAdmin and see how we can find the solution. In this case, we of course can start with what we already have. And here we have everything grouped by the city. But now we also need to involve the country, because currently the country is not available in here. So let's first join the table of country also here together. So we have country, we give the alias CO, and then we use, of course, the country ID as a join column. This is available in both the city and the country table. And then if we have that, we can now create our custom column. So this is now called country, and the concatenation we do with those double pipes. Also be aware we want to have the comma including the white space, and afterwards we concatenate the city. And this we can give now an alias as country city, for example, and now we can just copy that and paste it in our group by. The order, in this case, we can just sort in an ascending order, and then we have our expected result, and we have now the city-country combination with the lowest amount in total. Let's have a look at question number 9, which is now already a difficult question. In this task, you should create a list with the average sales amount of each staff ID per customer. So you should answer the question, which staff ID makes in average more revenue per customer? And now we want to jump into pgAdmin to see if we can figure that out. So first of all, we of course have a look at the payment table. So we see everything in the payment table that we actually need. So first of all, we want to include, of course, the staff ID. And then we have also the customer ID, and then we can create our aggregation of the amount. And this should be now, of course, grouped by the staff ID and the customer ID. So we can just copy that, and this will now give us a list of course, we have the sum amount without the comma. So this we should also include. And then we see that now we have all of those staff IDs and how much revenue was made of this staff ID for a specific customer. So if we, for example, order by the customer ID, we see that, of course, one customer has a certain revenue at staff ID 1 and a certain revenue at staff ID 2. And now, in average, which staff ID makes a higher revenue per customer in average? So to find out about that, we need to further aggregate this one here. So we need to now create the average across all of those customers, grouped by still the staff ID. So let's see how we can figure that out. We have already this query, and now we need to, since we have a second aggregation step, use a subquery. So in this query, so our main query, we want to take now the average of these values in here. But this should be grouped by the staff ID. So we can just call this total, then we need to give this an alias, which can be total. And now this is our subquery. So we can say from, and here we have our subquery, which is the result that we can see. The order by, we can leave or not leave. This is not important. And now this should be, as we have mentioned, grouped by the staff ID. And we take then the average of all of those values grouped by the staff ID. Let's see if we have some mistake. We have, of course, used this subquery in the from clause, so we need to use an alias. We can call this, for example, just sub, and then we get those two values. But of course, we should also, to understand where which value is coming from, include the staff ID, and we can also just round it, so the result is a little bit more readable. And then let's see what the result is. We can see staff ID 2 has a higher average revenue with 56.64. And this is exactly the result that we wanted to see. So in here, we have seen this was a little bit more difficult, really, but hopefully this could help you to understand the solution. Let's have a look at question number 10, which is now already pretty difficult. In this question, we need to create a query that shows the average daily revenue of all Sundays. Let's see how we can approach this challenge. So we first want to, again, select everything just from the payment table, because in here we have everything that we need. We have the payment date and we have the amount. So this is the first step that we can already group by. So we have the column and the function date, which is making everything to a daily aggregation. So we have the sum of the amount per day, and then we can, if we group by the payment date, we can create this aggregation per day. So that's the first step. But of course, we should not stop there. We can continue after that. So now we first take the group by, and then if we execute that, we get our first result. But now we can also add, just on top of that, the weekday. So we can say extract, And now the day of the week, we can search that on the documentation. This is nothing that we have to memorize by head, but this will be day of the week from the payment date. So this will be the column that we want to extract the day of the week from. And now if we include this in our select, of course, we should not forget about the comma as always, and we need to also have it included in our group by statement. So this is what we need to do, and then we can execute that and have a look at the result. So basically, we just have an additional column. But now we can limit this to only the Sundays, because we are only interested in the Sundays. And we remember, if we want to filter using the where clause, we should do this after the from and before the group by. So now we can say where, and we can use this column and we can paste it and say this should be equal to 0, because as we can read in the documentation, 0 is equal to the Sundays. And now if we execute again, we see only the Sundays. And now we can easily take the average of these daily revenues, because now everything is just limited to the Sundays. And if we now want to further aggregate this, of course, we need to create a subquery. So this will be our subquery, and from that we want to calculate the average. So we say that's the subquery. Of course, we should give this a name, for example, sub. And now we want to take the average. So in this case, we say the average of the column, we can again call it total. So we need to name it in here as well. We say total, and now we have everything that we need. Of course, we should start with select, and afterwards we say from. And now if we execute that, we get our average value. Of course, again, we can round it, we can give this a nicer alias as well, but I'm sure that you already know about this by now. So this was a pretty difficult challenge, but hopefully this explanation could help you to better understand how you can solve this challenge. And if you couldn't figure it out, just tomorrow try it again and then see if you can figure out the solution this time yourself. So hope it was helpful, and see you in another lecture. Let's have a look at question number 11, in which we should now create a list of movies, including their length and their replacement cost. And now we should limit this to only those movies that are longer than the average length in each replacement cost group. So this is what we need to limit our results by. So let's see how we can figure this out in pgAdmin. We can first create our select. This is not very complicated. We know we have the title. So we know we have the title, the length, and also the replacement cost. And now this should be limited to only those movies that are longer than the average in each replacement cost. So let's see how we can do that. Of course, we have first from our film table. And if we execute that, we see just the regular results. But now we should also limit this. So we have the where filter on the length. So we should only see those values where the length is longer than the average of these replacement costs. So this is something we need to do using a subselect. So we say select, and now we have the average length, and now this should be a correlated subselect. Of course, we say from film. This can be film, so we say F2, and in here we have just F1. And now we have our correlation condition. So this should be grouped by, so this average calculation should be based on the replacement cost. So this should be included. That's why we have F1 replacement cost should be equal to F2 replacement cost. And this should give us the correct result. Let's see where we are in here, replacement cost. And now if we execute that, we see this limited. And now the question that we need to answer is, which two movies are the shortest in that list and how long are they? So now we have, of course, the results limited. And now if we order this by the length in an ascending order, then we should see the two movies that are the shortest. And this is here Celebrity, Horn, and Seattle Expectations, which should be the result that we expect indeed. So this was our challenge that we could solve with a correlated subquery. Let's have a look at question number 12, in which the task is to create a list that shows the average customer has spent in total. And this should be now grouped by the different districts. So what are the average customer lifetime values for the different districts? And the question to that, which district has the highest customer lifetime value in average? So that's what we want to find out. And of course, first we can start with everything from the payment table, and then we see what else we need. So first we have the payment table. In here we don't have the district. That's why we can first join, we can use an inner join or a left join. This is not so important in our case, to the address table. But again, we first need to use the customer table because we have no direct connection from payment to the address. So let's first also give these a few aliases, and then we can join this on the column customer ID. That's available in both of these tables. And then again, we can now go to the address table. So we have the address table, and this is now based on the address ID. So we have address ID in both the customer table as well as the address table. And now if we have a look at this, we see that now we have already something that is the district. So that's something that we can use now. So we have now the district, and then afterwards we also want to see the sum of the amount. And of course, we should also see this per customer. So we can use the customer ID. And now if we have this aggregation, we need to group by those two columns because these are the columns that are not aggregated. That's why we can include them. And now if we see that, we see there is some mistake. Of course, we have a column reference that is not unique. We can just make the customer ID. We can say c.customer ID, and up here also c.customer ID, and then it will be not ambiguous. And then we see now all of those customers, including their districts. But now we, of course, also want to aggregate further. So this was only our first step in this aggregation. Because now, if we want to take the average of all of those customer lifetime values, we need to use a subquery. So our main query will calculate the average. We can again call it total. And then we say total in here as well. And this is then our subquery. So now if we say from that, we also have to give it a name. So this can be the subquery, and this should be now grouped by the district. So now we can also include the district in our main select. And then if we do that, let's see if there are any mistakes or if everything looks good. So this looks fine. Of course, we can again round the results to make it look a bit nicer. And we can give this again a name like total. And also we want to order this. So we want to see the highest average lifetime value of the districts. So we say order by 2 in a descending order. And now if we want to see the results, we see that this is indeed the value that we expected. So this was a little bit of a more difficult challenge, which is always the case if we are having subselects, subqueries included. So the key thing here is to understand that we have basically a two-step aggregation. We have our first aggregation in which we are just aggregating all of the lifetime values of the customers. Because if we don't have them, we cannot calculate the average of that. But now, of these already aggregated values, we again need to aggregate them. And that's why we need to have a subquery. So that's why we use it in the from, and then from there we again take the average. So this was the challenge. I know it was difficult, but hopefully this explanation could help you to understand how you can solve this challenge. Let's have a look at question number 13, in which we should create a list that shows all of the payments, including payment ID, amount, film category, and also on top of that an additional column that is the total amount that was made in this category. And the results should also be ordered ascendingly by the category name and by the payment ID. Question associated to that: what's the total revenue of the category action and the lowest payment ID in that same category? Of course, those two questions we should answer only using this query that we are creating in here. Let's see how we can find out the answer to that. First of all, let's just select everything that we want to see. So we have the title, we have the amount, we have the payment ID, and also we have the name of the category. Also, we want to see this additional column, which we want to use, of course, a subselect for, but let's leave that for now and let's do that later. First, we want to just include all of the tables that we need for this query. So we start with the payment table, but also we need to see the title and the category name. So we want to create a join to the category table and the film tables. So first of all, how can we go to the film table? Because from the film table, we can go to the category table. We do this, of course, via the rental table and then the inventory table to the film table. So let's use a left join first to the rental table. Afterwards, we can move on from there. So the column that we are using for that is the rental ID. So we have the rental ID of the rental table and then also the rental ID of the payment table. This works fine. So after that, we want to have the left join again to the inventory, and we use the inventory column, so inventory ID from the inventory table and from the rental table. Then we have again a join, and now we can join it directly to the film table. And in here, we also use now the film ID, which is now available in both the inventory and the film table. And from here, we can now go to the film category table. So we have FC, and then we have, in this case, the film ID should be equal in both of the tables. So film ID, and then we have another left join, and now we can use the category table, which can now be CA, because C, we could even use C actually, because the customer table we did not use before. So we have C dot category ID. This is now the column that we can use, and this is now also in the category and the film category table. So these were a lot of joins. We can now see those joins are working if we have no mistake. Let's check. We have inventory, just a little typo here. Let's check again if everything works. And we see now everything works. So that's now great. But now what we want to do also is we want to also include the sum of the amount that was made in each of those categories. Of course, we can already order our results if we want, order by name, and then we see that this is now ordered already. But we also want to have the overall amount. So the overall amount that was made in this category. And we do this using a subselect. So this can be now included in our main select. So this should be the sum of the amount. This is it. And this should be later on, of course, by the category. So this will be now a correlated subquery. And this should be what we want to do. So we can already say in the end where, and now we have the name. So we have name. This occurs now twice. We have it once in our main query. So let's say this is the category table 1. And then we have also the category table 2. So this will be now the next one, which will be included in here. So here we have again all of those joins. We can actually just copy all of that because we need all of that as well to get access to this category. But in here, we now just don't want to call it C1 as in our main query, but this time it should be C2. So let's make a little break in here so we see that here starts our main query again. And now we can say, since this is C2, we have now where C.name1 is equal to C2 name. So like this, we can create a correlated subquery with all of the sum of the amounts next to it. So this was a little bit complicated, but let's just first have a look at the result and then let's go over the solution again. So in here we see there's still some mistake. Where is it occurring? We see we have from just twice. And now let's try again. Of course, now that we have renamed our tables, we also need to do it in our join. And also, of course, in here. Let's try one more time. And now indeed it works. So these are some mistakes that can happen. So that's why it's also nice to just see where some of these mistakes can occur. And this query can now really take a while because these joins and this calculation of that subquery has to be calculated now in every single row over and over again. So this is a query that really takes quite a lot of time. And of course, the overall result, we should also now order not only by the name, but also we have this ascendingly, which is anyways the default, but we have this also by the payment ID as second criterion so that we can easily answer this question. And like this, we get then the result that we were looking for. Let's have a look now at the bonus question, which of course you are not expected to solve. So this is extremely difficult, and that's why we just want to have this as a bonus question so that you can work on it and hopefully also learn something from the solution video. So that's just something to keep in mind, that you are of course not expected to solve this very, very difficult question. And in this question, the task is to create a list with the top overall revenue of a film title. So this means the sum of the amount per title for each of the categories. So we want to limit our results to only those film titles and the overall revenue of them for the top value in each of the categories. And then the question, what is the top performing film in the animation category? So let's jump into pgAdmin and see if we can find the answer to that. First of all, we can just select every column that we need. So basically, it's not very complicated. We have the title, we have the category, and then also the amount that this film title has made in the total amount. So that's the first thing that we want. So if we execute that, and of course we also need to have all of those joins so that we can use the title and also the name of the category. And then if we execute that, we have just all of the titles with all of their categories and also all of their total amounts. But now we also need to limit those results to only the top performing movies of each category. So we can do that, of course, since we want to filter by this column, which is an aggregate. That's why we need to use the having clause. So we can say having some amount is now equal to the maximum of this sum amount. So that's why we use again a subquery. So we say select, and we now want to use the maximum. And we have done something that is just here an alias. So we can do the same thing in here. So we say total. And now since we want to get the maximum of this list, which is already aggregated, we want to use again a subquery in here. Because like this, we can take the maximum of this sum. So we can basically just copy everything that we have already here, because this gives us just this entire list, of which we then want to take the maximum. So this is why we can just again paste that into that subquery. So this is then where we want to take the maximum from. And we can also just again indent that a little bit so it looks a little bit easier to read. And now if we have that, we still need to take the maximum per category. And this is why we need to create a filter, which is making this into a correlated subquery. And of course, since we have here a subquery in the from clause, we need to name that also. So we can, for example, just say this is sub. And now what we need to do is, of course, we need to add our where filter, so our correlated condition. And this should be based on the name, because we want to get the top revenue title per category. So we need to correlate it with the name category. And of course, the name from our main query is coming from this category table. So we can say where c.name is equal to, and now the question, where is this other name coming from? And this is coming basically just from this subtable, because in here we have our query. So this is basically our main query from the table, which is called sub. So that's why we need to use sub.name. And if we now execute that, we will get exactly the result that we want to achieve. So then after just a few seconds, we get all of the titles that are the top titles in their category. And then we can see animation and the total number, which was the result that we were looking for. So again, this was a challenge that was really, really difficult. And you were, of course, again, not expected to solve that, because this was just something to work on, some little trick, something that is really taking things to the extreme. And that's also not something that is very frequent in the daily work. So don't worry if you couldn't solve this challenge. Hopefully this solution video could show you how you can work on something like this. So hope this was helpful, and see you in another lecture. So far, we've only worked with data that already exists in our existing tables, databases, and so on. And in our daily work, this is actually also the most important part and the most time we spend on this. But we now also want to enhance our skill set and also learn how we can manage tables. This includes that we learn how we can create databases, tables, schemas, and other database objects. We also learn how we can alter those objects. This means we can change the properties, the names, and so on. And of course, last but not least, this is something that's very simple. We can also drop those objects. This means we are basically deleting them, which is something we should be, of course, very careful with in the daily work. This is a very simple command, and actually also it's very rare that we just drop objects. And then this is something that is called data definition. And data definition is actually just dealing with the data structures. So the table name, the table properties, the database properties, and this is all not dealing with the data itself. If we want to change or insert data itself, we refer to those commands as data manipulation. So this includes insert command, which of course inserts data in a table. And also we can sometimes update specific rows in our tables. And similar to dropping an entire object, we can also delete specific rows in a table. And all of that, as I have mentioned, we refer to as data manipulation. So again, data definition is just dealing with the properties of the tables and the database objects, so all of the data structures. But data manipulation then is dealing with the data itself. And of course, we are going to learn everything about data definition as well as data manipulation. But also, we learn other things that are related to that and that are in practice important to know. So we talk about data types, something that's super important, but also so-called constraints. So these are things that we can define on our table that can be very important in practice. So one constraint, for example, is a primary key. So we are also learning, of course, about primary key, foreign keys, but also about views and other important things that are relevant in practice. So after that, you have a very comprehensive understanding and skill set also about managing tables. So data definition and data manipulation. And now that we have this out of the way, let's start with learning about the create command and creating our new database, which we will then also use to insert data, update data, and basically we want to build up this database and learn how we can manage this database in the following lectures. Let's have a look now at how we can start with using the create command by using it with creating a database. That's the most simple process because most of the properties will be defined in a table. So creating a database is usually a super simple and straightforward process. We just use the keyword create, then the object will be a database. So we say create database and then the name of the database. So since that is so super simple, we want to jump right into pgAdmin and see how this works in practice. So if we are in pgAdmin, we see that we have our databases on the left side. And of course, we can always create a database by using the interface. So we can just go right click on the databases, select create, and then database. And here we can now just enter a database, for example, company X. We can also give a comment. This is our database. And then we can just create this database. So it is very simple. And now we see this database is created. So that's now just the data structure itself. Of course, we can define later on tables and other things in this database. But for now, we want to focus on just creating the database itself. So we see we can do that using the interface. But we can also do that, as we have seen, using SQL commands. So if we want to do that, we can use create, database, and then the database name. So, for example, company Y. So we can not use white spaces unless we use the double quotes. So if we wanted to name this company Y, then we would have to use these double quotes. So that is something that is actually very uncommon in databases to have names with a white space. So usually we would rather use this underscore if there would be the need to have white spaces included or multiple words. Then we would use this underscore. Also, it is very uncommon to mix uppercase and lowercase letters, which would again only be possible using these double quotes. But again, this is something that is very unusual, so we should just stick usually with one thing. So we use, in this case, lowercase, and that is the default also. So if we wouldn't use the double quotes and we would use any uppercase letter, let's quickly execute that. This would also be interpreted as a lowercase, since we are not using these double quotes, which is again what I recommend. So let's quickly refresh the databases, and then we see this database object has been now created. So that's basically all that we need to know, but we can also add a few more parameters. This is something that is not super important, but I just want to mention that this is possible. So we would do that using the with command, and then we can add, for example, a different encoding. So encoding is basically just how the characters are interpreted, how their formatting works. So if we are in a specific country with a specific set of characters, we could use, for example, a different type of encoding. The standard encoding, so the default also, if we don't specify that at all, is UTF-8. So that is what we could specify, or just something else. But again, if we wouldn't specify it, it would use just UTF-8 anyways. So if we do that, we would create this database. But this is now, of course, not working since we already have used this database before. And there can be only one database with the same name. So this is why we would use another name, and then we could create this database. But now, how can we add also a comment on a database? This is something that we can do on also other objects. We just use the comment command. So we say comment on then the type of object that we want to make a comment on. So comment on database, and then the database name. So for example, company X. And then what is the comment? We say is, and then what our comment is. So that is our database. And if we again execute this command, we will have a comment on this database. So let's quickly refresh our databases. So we have now our company X. Let's have a look at the properties, and we see that there is now also our comment. So this is how we can define a database. Super straightforward and very simple. But now in the next lecture, we also quickly want to see how we can now drop a database again. Again, super simple, and that's what we are going to do in the next lecture. Before we are ready to create our tables, we need to talk about data types, because every column in a table that we define, we need to set a specific data type. That's why it's good to have an understanding of the data types. We will talk about how are these data types different. So they can be different in the storage size they need. They can have different values that are allowed to be entered, and also different operations, different functions are possible for different data types. Then we want to use this knowledge to decide which is the appropriate data type for our specific columns. So for example, we want to answer the question, how should we store zip codes or phone numbers? And we want to choose the right data type for that. We have numeric data types. We have also strings and date and time related data types. We have a few more. We will also see a few more examples, but in general, we will talk about the most important and the most common data types. For the complete list, you can also refer to the documentation or make a quick Google search. And yes, Google searches are something that you are anyways doing in your daily work, and that's a good and important skill to have. So we want to give the foundation so that you are ready to do that and implement that in your daily work. So first of all, let's start with the numeric data types. The most typical one is the standard integer. This is just a data type that is used for whole numbers. We have also small integers, which is just a little bit smaller in the storage size. So this is a little bit better in terms of performance. If we have very large numbers, then we can also use the data type big int, and we can see the allowed numbers are just a lot larger. Then we have the so-called numeric or also decimal data type. They are used if we want to have decimal places. So they are a little bit specific because we need to give a so-called precision and a so-called scale. The precision is the total count of digits. So for example, here we have 4 digits. That's why the precision is 4. And then we have the so-called scale. This is the count of decimal places. So in that example, we have 2 decimal places, and that's why the scale is 2. So if all of the values would be 24.99 or 10.99, then we could use the data type numeric with precision 4 and scale 2. So as I've mentioned, decimal, numeric, this is exactly the same. Behind the scenes, this works exactly the same way. Then we have also the so-called serial data type. This is just an integer number with a feature that it's auto-incrementing always one by one. So we don't need to specify the value if we insert a new row, but it will automatically be just incremented by 1. So whenever we enter a new value, the next value will just be 1 bigger than the last one. This is oftentimes used for ID columns or so-called primary keys that we are talking about in the next lectures. Then we have the so-called strings. In here we have the most important one, which is the character varying and the text data type. So they are just very flexible because their length is not fixed. With the character varying, we have an upper limit, so we cannot enter, if we say character varying 10, values that have more characters than 10. So this is a little bit less flexible than the text, and in my opinion, this character n, which has a fixed length, is something that I would not recommend to use. Some use cases of that could be M or F, so this could have the character 1 data type. And if we have then less characters used than the fixed length specified, all of the other remaining characters will be just space padded. And in my opinion, this is actually not a very good feature. This is why, in my opinion, and even the character n is not better in terms of performance. So there are some tests, and this is not better than the other data types. So again, we can go with the character varying or the text. They are both great choices, just the text is still a little bit more flexible. But we are good with both of those data types. And now, what is the appropriate data types for something like a zip code or phone numbers? We can see that with zip codes, we can have things like leading zeros, and also we need to keep in mind that those values don't have a numerical meaning. We don't have 142 items of something. So this is just not a numerical meaning, but it's just characters that are used in here. And this is why we should not use a numeric data type, but we should rather use strings. Because phone numbers, zip codes, and anything else that is just coded into numbers, but does not have a numerical meaning, should rather be stored as strings. So this is just a quick tip that is helpful, hopefully, in your daily work. And now, lastly, we've also already talked about the date and the time data types. So we have date and time can also have a time zone. So here we have +2, so this is the UTC offset, which would be the same as 12 o'clock in UTC time. So then we have, of course, timestamps, date and time together, as well as so-called intervals. And now we have a few more data types, so they are in your daily work, not that relevant, but still to make it complete, I want to give you a few practical examples of some other data types. So the Boolean data type is a logical data type that can be either true or false, and also a null value is also allowed. Typical example of that is something like an indicator that is indicating if something is yes or no. So is it available, for example, yes or no? Is it in stock, yes or no? And then we have also the so-called enum data type. This is an example that we have seen also in our database. So the movie rating is something where we have only specific values allowed. So only G, PG, and all of those ratings that exist. So we can define them in our enum data type. So this is a special data type that we can define ourselves. And also those values that we have created and that are allowed will be in the specific order. So if we want to order our table using this rating column, they will not be ordered alphabetically, but in this specific order that we have given. So maybe G is the best rating, PG the second best, and so on. So that's what we can use. And again, this is a little bit advanced and it's not so commonly used, this enum data type. Another one that is also not so common, but we want to mention it, is the so-called array. Sometimes we can have, for example, a phone number where one person has multiple phone numbers. In this case, we can store multiple values of the phone number. And then we can just get all of those numbers using this phone column. And we can also just get one column. So if we wanted to get just the first number of each person, then we can use this one inside these brackets. And like this, we can access those values also independently. We can even use them in searches. So if we want to search one specific value wherever it occurs, we can also use the any operator. So I know this was a lot of theory, and we now want to make sure you have understood and memorized the important parts in the following quiz. And then we don't want to lose much time so that we can get into practice again. When we are creating a table, we need to define the column names as well as the data types of those columns, and then we can also set so-called constraints. And that's why in this lecture we want to talk about what is a constraint and how can we use them. So a constraint is defined when we create our tables, and we use them to define rules for the data in our table. So how the data is allowed to look like, what values we can insert, and this will just prevent the insert of invalid data. And we can define those constraints either on a column or on a table level. So what kind of constraints we have available? As column constraints, we have the so-called not null constraint. This just ensures that there cannot be null values inserted in the specified column with that constraint. So if that would be inserted a null, then this would just cause an error and it would not be possible. It would not be allowed. Then we have the unique constraint. This just ensures that all of the values in a column are different. We cannot have any duplicates in that column with a unique constraint. We can also set default values. This can just say, for example, a value of 0. And then if we don't specify any value that is inserted for a specific column, per default, the value will just be the one that we have specified. Then we have the so-called primary key that we are going to talk about later on in the next lecture in a bit more detail. But basically, this combines both the not null as well as the unique constraint. So primary keys need to be not null as well as unique. And then we talk about this in the next lecture in a bit more detail. We also have the so-called references constraint. This is used for foreign keys. We also talk about that in the next lecture, but for now we just also want to mention that this ensures the so-called referential integrity. This means that if we create a reference to another column in another table, in this column with this reference constraint, only those values are allowed that appear in that referenced column. So we, again, as I've mentioned, talk about that in the next lecture. And if we would try to insert something, for example, that violates this reference constraint, we would just get an error. And in this case, it would be violates the foreign key constraint because a value is occurring or want to be inserted that is not present in the reference table, in this case, the address table. And then lastly, we also have the so-called check constraint, where we can just specify a condition that needs to be fulfilled so that value can be inserted. For example, only values that are between 10 and 100 can be inserted. We'll talk about this in another lecture in a bit more detail as well. But we can also define those constraints on a table level. So for example, if we want to define a primary key on multiple columns, we can also set it as a table constraint and just insert all of the columns that should be part of the primary key. And the same we can also do for the unique constraint. So we can just enter all of the columns that should have this unique constraint. So that's just a way that is sometimes a little bit faster if we have multiple columns that should have this unique constraint. And the same thing we can also do with the check constraint. So that is just a very brief theory. And of course, afterwards, when we create our tables, we will see how this works in practice. And we see many examples of that. But now we also want to talk about the so-called primary and the foreign key. That's what we are doing in the next lecture. Now we have almost everything to be able to create our tables. We just need to talk about the so-called primary key and the foreign key. Those are two very specific constraints and also very important general concepts of databases. So let's start with the so-called primary key. A primary key is usually one, but can also be multiple columns that uniquely identify each row in a table. Usually we have an ID column that is serving as a primary key. So for example, in this table, it is the film ID. We can see that also that there's this PK, which indicates that this is the primary key column. And uniquely identify each row in a table means that if we know the film ID in this case, so the value of this column, for example 2, then we know exactly which row is meant by that. So usually, as I've mentioned, it is an ID column. And to be able to serve this purpose, we need to have two conditions. The first one is that this column needs to be unique. This means we cannot have any duplicates, because if we would have a duplicate value, of course we could not identify each row uniquely anymore. And also the second constraint that is included in the primary key is that the values null are not allowed in primary key columns. So this is a primary key. We also have a so-called foreign key. And this is now, again, usually one or also in some cases multiple columns that refer the primary key of another column. So for example, in this case, we have the payment table. And in this payment table, we have also the customer ID. And the customer ID is just referring the customer ID of the customer table. So this is the primary key of the customer table. And we have the values from that customer table. And we call the table where we have the foreign key included the referencing table, or also child table. And the parent table is the reference table. This is the parent table of the customer ID. These are already the most important things about primary and foreign key. But I also want to add a few more notes. So the first one, if we have a look at this table, we can see that the foreign key, in this case, customer ID, staff ID, and rental ID, do not need to be unique. So foreign key does not need to be unique. And of course, we can also have multiple foreign keys in a given table. And also, the primary key and the foreign keys are usually used to create joins between the tables. So we've already seen that if we want to join to this payment table, the customer table, we use the foreign key of the payment table as well as the primary key of the customer table. And now, last but not least, the primary key and the foreign key we can also set basically as constraints in the table creation process. And now that we have this knowledge, we are ready to start to create our own tables. This will be the most important command in this entire section. So, hope you're excited for the next lecture. Now that we have the knowledge about data types, constraints, and primary and foreign keys, we are finally ready to dive into the most important command in this entire section. That's the create table command. We use that, of course, to define our tables in the database. The command for that is pretty simple. We use create, database object is a table, and then afterwards the name of the table. But of course, always we need to insert the columns of the table. So the columns we can just enter after we open up the parentheses. Then we can just specify the name of the column, including after a white space, the data type of this column. Of course, we can also have multiple columns. We just separate them with a comma, and in the end, of course, again, there is no more comma. So for example, we want to create a staff table. That's why we name the table staff, and the first column could be the staff ID of data type integer. And the second column could be the name of the person with the data type varchar 50. And as we have learned, we can also use constraints in our table creation. So these are optional, but we could mention them after we have specified the type of the column. For example, in our case, the staff ID could be the primary key. And as we have also mentioned, the best data type or common data type for the primary key is the serial data type. This just auto-increments the value automatically. So we don't need to enter any value in here. It will just auto-increment one by one, so we don't need to bother with inserting any value in here at all. And now we can, for example, also at the name column, use the constraint not null. And we can even use multiple constraints. For example, we can combine the unique constraint with the not null constraint. And if we want to make work a little bit easier, and for example, we have one constraint that should be on multiple columns, we can just make this a little bit easier if we use it as so-called table constraint. Like this, we would just in the end mention unique, open the parentheses, and then insert all of the columns that should have this constraint unique. This is how we can create tables. So you see, it's not super complicated because we have already all of the knowledge. And that's why we now want to jump into pgAdmin to implement this practically. We want to create now an additional directors table. So if we want to create that table, that should have the name director. And then we open up the parentheses. Our first column will be the director ID. This will be our primary key. That's why we use the data type serial and the constraint primary key. Then we have the next column. This will be the director account name. So we can have some account name, and that's what we want to use. The data type varchar 20 for that. So only 20 characters will be allowed. And for this account name, we require the constraint unique. So we cannot allow duplicates for the account name. Then we have also the first name, which can also be varchar, in our case maybe 20 or even 50. And then we can have also the last name, which can also just be the same data type, for example, varchar 50. And don't even worry with setting a too high value here. This will be anyways variable, and you will not need more storage for that if you have a higher number in here. This is just the upper bound that is allowed. And we could even use a default for that. So if we wanted to use a default, we could say, of course, this needs to be in accordance with the data type. We could, for example, say, if there's nothing entered, we could say not specified, for example. And then we have also another column, for example, the date of birth of this director, which could be of the data type date. And lastly, we also want to create a foreign key, so a reference to the address table. So we would use the column address ID, which can be a normal integer. And now we use the references constraint. So references, now we use the table name. So this will be address, and now the column that should be referenced in the address table, which of course should be the address ID. So this is how we can create basically a foreign key in our table. And this is all that we need for our table definition. If we now execute that command, we have created our director table. So if we now go to the tables and make sure just to be in the public schema of the Green Cycles database, we have now, if we right click on the tables and click refresh, we should see now our director table. And if we open that up, we see under columns all of the columns that we have created, and under constraints we can see the different constraints that we have defined. So for example, we have the address ID as our foreign column. If we want to see what that is referencing, we can right click on that foreign key and say properties, go to columns, and then we see that this address ID column is referencing the address ID of the address table. And now we have also the unique constraint of the director account column. And we have the primary key, which is the director ID. So we can again right click and see that in the definition that the column is the director ID. So like this, we can create our tables, set the data types, and define our constraints. And now again, it's your turn to apply this knowledge in the following challenge. Now that we have learned how we can create a table, we also want to learn how we can insert data into this table. This also helps us to better understand the different constraints, the different data types, and makes things just a little bit more practical. So how can we use the insert command to insert data in a table? We just start with insert into, and afterwards the keyword values, opening up the parentheses, and then using the values that we want to insert. So let's make this a bit more practical. If we have this table with these 5 columns, and then we want to insert the values in here, we use, of course, table name online sales. That's the table name. And then we need to insert these 5 values, and we need to use the same order that the columns are in this table. So the 1 will go into the transaction ID, the 269 goes into customer ID, and so on and so forth. Of course, the data type must match the column that we have defined, and also the constraints that we have defined need to be fulfilled and cannot be violated. So this is something that we need to do, and afterwards the values will be entered and visible in the table. But sometimes we only want to enter specific values in specific columns, and the other columns we don't want to enter anything. So then we can also open up the parentheses right after the table name, and then we mention the columns that we want to insert values to, and all of the other columns that we don't want to enter values into, we don't even mention in here. So this is also possible, and then afterwards the values just need to be again in the same order as we have mentioned them above, and then the values will be entered accordingly. And in this case, the value none was entered into promotion because we set the constraint that there's a default value which is none. And also in the transaction ID, we were using the data type serial, which just is auto-incrementing an integer number. So the next value would have the value 2 in this column if we would not mention it. And of course, if we leave only these 2 values and we don't mention anything for the film ID, then this can also just still have the value null. If, of course, this is not violating any not null constraint. And now if we even would change those 2 columns, then we would just also have to change the order of the values so that they are again inserted in the right way. And if we would, for example, do something like this, customer ID only, then we would violate the not null constraint of the amount, because this would only enter 1 value and then we have 2 default values, but we would not have entered a value for the amount, and this would just violate the constraint, the not null constraint of the amount column. So that's something that we also just have to keep in mind to not violate our constraints. And if we want to add now multiple rows, we can also do that just by adding a comma after the first set of values, and then we go with the next set of values. So in this case, we can enter 2 values. And as you see in here, this is now the value 8 and 9 at the ID. This is because I have deleted rows before, and the auto increment, so the serial data type, works like this, that even if we delete some values, it will just still auto increment from the last value that was inserted, even if we delete those values again. So that's a very good property actually of the serial data type, because this also helps us to see if there is some data deleted. So this is how we can insert data using the insert into command. And now again, it is your turn to apply this knowledge in the following challenge. We have seen in the table creation process that we can define all of the table properties in that process. And now all of that properties we can also alter afterwards. That means that we can add or delete, that means dropping columns, and we can also add and drop constraints. We can also rename entire columns or even the entire table, and we can also, of course, alter the data types. So this process works very simple. The syntax for that is just alter table, the name of the table, and the action that we want to perform. So for example, we can drop a column. We use alter table, the name of the table, and then just the action drop column and the column name that we want to drop. For example, first name from the staff table. And we can even add the keyword if exists. So this will then prevent an error message if that column first name would not exist. So maybe we have multiple steps that we want to perform, and then if there would be an error message, this would just stop the entire operation and the entire command would not work. But if we just add the keyword exists and this column does not exist, this will just give a little notice, but it will not stop this complete command. And also we can add a column. Similar to when we have created the column, we also, of course, need to define the data type. And in here again, we can add the keyword if not exists. So if that column already exists, then there will be not an error message like this. And the command will still work and we will not stop this entire command. Also, we can change the data type of the column. We use alter table, table name, alter column, column name, type, this is the keyword we have to use, and then the new data type. For example, we want to change the address ID from the staff table into the data type small integer. And we can also rename a column. For example, the column previously was called first name, and now it should be renamed to the column called name. And we can also add constraints. So for example, we can set a default. In this case, we have to be aware that we have to use additionally the keyword set default. For example, we want to have the default value 1 for the store ID in the staff table. And if we can set a default, we can also drop that default again. And the same thing we can also do for the not null constraint. We just use the same syntax and we say set not null. If we want to drop that constraint, we again use the column name and then drop not null. But we can not only add the standard constraints on the columns, but we can also add the table constraints. This just means that we have a name of the constraint and we can add it in once to multiple columns. So for example, we can have column 1, column 2, and a few more to be added to the unique constraint. So that's something that we can do as well. And of course, we can also add primary keys. And as you have seen, we can even add multiple of these action steps in one alter table command. So that's something that is useful because we don't want to do all of these steps alone, but we can say, for example, all of those steps should be performed in one command. And that's why you see it can be helpful to sometimes add the, for example, add column if not exists, so that this will not cause an error message and will stop all of those commands to be executed. And these action steps we can all combine apart from the rename step. This is the only step that we have to perform in a single action. So we always need to use that individually. And also if we want to rename an entire table, we can also do that like this. So we alter table, the old table name, and then this should be renamed to the new table name. For example, the table director should be renamed to director table. These are all of the steps that we have seen. It seems now like a lot, but we've actually already seen all of those things. And now, of course, let's put that into practice in pgAdmin. Now we have seen that there are many different steps that we can perform to alter our table. And now we want to, of course, apply this knowledge practically. So in this challenge, you need to change the director table. If you should have not created that before, you can still create that using that command. If you should have created that before, of course, you would get an error message that the relation director already exists. So a table in a relational database is just called relation sometimes. So that's what already exists. And now if we have a look at this table, so the director table, we see that this already exists, and now we might want to do some changes. So these are the steps that you need to perform in this challenge. The first one, change the data type of the director account name column to varchar 30 from varchar 20. The second step, drop the default on the last name column. This should be dropped. The third step, add the not null constraint to the last name column. Here we should add this not null constraint. And then we have also add the email column with the data type varchar 40. The fifth step is rename the director account name column just to account name. And then the last step, also rename the entire table from director to directors. So that's the challenge. I wish you now good luck with that. And afterwards, of course, we'll have a look together at the solution. Let's have a look now at how we can perform those alter steps. We of course start always with alter table and then the table name. So this is the director table. Afterwards we can list all of the steps that we want to do. So director account name, we can just copy that to the varchar 30 data type. So we say alter column, this is what we want to do when we want to change the data type. Then we use the keyword type, and then afterwards we use the new data type. So in this case, it's varchar 30. And then the next step we have to introduce after a comma. And then we can go with the next step. Drop the default on last name column. We again alter the column, and then we have the last name column, and we want to drop the default. So we can just say drop default. Afterwards, the next step would be the third step, add the constraint not null to last name. Again, we can just copy that and we say alter column last name, and now we want to set not null. And of course, default we should remove. And now the fourth step is add the column email of data type varchar 40. Let's already copy that. So we want to say now add column, and this should be the email column, and the data type should be varchar 40. Here we don't need to have the keyword type. This is only when we want to alter the data type. So of course, if we just add the column, we have the column name, and then right afterwards the data type. Afterwards, we have our fifth step. So the fifth step would be to rename the director account name, which we have mentioned. This cannot be combined with other action steps. So if we would do that, we can try rename the column director account name to account name. Then we would see that this would not work. And then afterwards, we see that this was causing actually the error. So let's select everything, perform it, and we see already here there is this syntax error. So here the error already starts because this will not work. So let's just remove that and perform just all of those steps. We see now it works, and we can of course again select everything from that table just to see that the steps have really been implemented. So director, and now we see we have changed the varchar in the director account name column. And of course, we could now also check that there is now no more default on the last name column, for example. This is what you could check if you just would insert values here. And of course, if you want, you can do that as a little side practice to insert those values. And then afterwards, we now want to also rename this column. So we have learned we need to have an additional step for that. So we say alter table, the director table, and now rename column. So this should be the account name column, director account name, and this should be then renamed to just account name. So let's do that now, and now it should work. So we see this has been changed. Let's also execute that, and we see now it's called indeed account name. And now also we want to rename the entire table, so we can just say rename the entire table. So we use alter table director, rename to directors. So we say rename to directors, we select everything and we execute it. And now if we would select from the director table, which is now renamed to directors, of course we see this table does not exist, but if we use it with an S, then it should work. So you see that this is not super complicated to alter our table properties. And now that we know all of that, we also want to have a look at one very specific and interesting constraint that we have not talked about yet. And this is the so-called check constraint. Let's see what that is and how that works in the next lecture. In this quick lecture, we want to have a look at the drop and truncate command. First of all, let's have a look at the drop table command. With the drop table command, we can delete the entire table. And the syntax for that is very simple. We just use the general syntax drop table and then followed by the table name. And in general, we can use this drop command to delete any database object. So for example, drop database, drop schema, or whatever we want to delete. So for example, if we want to delete a schema, we just use the keyword drop schema because the object that we want to delete is a schema and then followed by the schema name. And this will always then delete this entire object. So of course, with drop, we need to be super careful because it is not possible to get this object back once it is dropped in the database. So just keep that in mind to be very careful with the drop command. Then also we have the so-called truncate command. With that, we can delete not the table object itself, but all of the data in a given table. So we can use the command truncate table and then followed by the table name. In fact, we don't need to mention in here table, this keyword, because truncate only works on tables. So we can use either truncate table followed by the table name, or we can also just use truncate followed by the table name. So let's quickly have a look at a short demonstration in how this looks like. Of course, you can also find the code, the commands that we are using in here, also attached in the resources in this lecture. So before we drop a table, let's create this emp table with two column names. So we have now created this table, and of course, now we can select from this table. So we see there are those two columns, and of course, at the moment, there's no data included. But we could now also decide to drop this entire table. So we would use the command drop, and then of course table, because the object is of type table, and then the object name, so in our case the table name. So we say drop table employee table, and then if we do that, the table has been dropped. And of course now this table is not available anymore, and if we would want to query from that, we would get this error message that this object does not exist. Of course, we can now just quickly recreate this table, and now we also want to insert a few rows. So if we do that, we execute that command that just inserts 2 rows in this table. And of course, again, the table is there again with 2 data rows. And now we could decide to just truncate the table. This would delete all of the rows in this table. And again, with truncate, we also have to be careful because we are deleting all of the data in this table. So keep this in mind, and now we just want to use this command. So we say truncate, and in here again, as I've mentioned, we can use table or we can do it without. So I'm going to use truncate table and then the name of the table. I'm going to execute it, and now again, if I select from this table, it is completely empty. Let's quickly insert those values again, and now if we use just truncate and then the table name, we also truncate this table. So you can see we execute it, it works, and now there's no more data in this table. So this is how we can drop entire objects and also how we can delete the entire data in this table. So we say we truncate this table. And of course, as I've mentioned, with those two commands, we should always be very careful that we really want to delete the data or this entire table. Now let's have a look at this a little bit special type of constraint, which is the so-called check constraint. With that, we can define what values we want to allow to be inserted in our tables. So we can set a condition that must be met if we want to insert values. The syntax for that is again very simple. We know already how we can define constraints, and the same way we also define our check constraint. So in the create table command, after the data type, we specify check and then the condition. And if this condition is met, the row will be allowed to be inserted, and if the condition is not met, there will be an error message. So for example, in the table director, we want to only allow names that have a length greater than 1. And on all other cases, we want to get an error message and the row should not be inserted. So this is what would happen if this constraint would be violated. If we, and that's now something new, want to give our constraints a name, we can do that by just entering the keyword constraint and then the name of the constraint, and then followed by that the definition of our constraint. Like this, we would give our constraint a different name, but anyways, there will always be a default name assigned. So every constraint that we define always has a default name. In this case, it will be table name, column name, and then underscore check, because this is a check constraint. So this will be the default name in this case if we don't specify the name. And actually, now don't get confused by this, but this name or this column here in the name doesn't come from the column that we put this constraint on. It comes actually from within this condition. So if we would use something different in this condition, for example, the start date, then we would have also the start date here in this default name. So of course, this doesn't make so much sense, but I still wanted to mention it. And even if we have, for example, two different columns included in here, then we will have as a default name only the table name and then afterwards check. So I don't want to confuse you with this, but I just wanted to mention it. And this is also demonstrating that, as we can see in here, we can use even columns, start date and date of birth, that are not even associated to this column. So this is just actually telling us that a constraint is always something like a table constraint. So for every row that will be inserted, there will be a check if this condition is met, and it's not really actually associated to a specific column. Even though we define it like this and it looks like this, behind the scenes, this check is just a table constraint. But this was just a little bit of an advanced information. You can just go about your checks as we have seen it in here. So the common practice is just to use them as if it would be connected to a specific column name. And if we now want to add a constraint to a given table, we can use the alter table command. So we say add constraint, the name of the constraint. So here we have to mention it, and we can see that it's actually not really associated to a specific column. We have just the condition that we define in here, and we can give the name of this constraint. If we want to drop a constraint, we can also do that by just using drop constraint. And this is actually how we also modify a given constraint. We would first drop it, and then afterwards we recreate it, so we add it with our new definition. That's how we would modify an existing check constraint. And we can lastly also rename a constraint. So we use the normal syntax, alter table, rename, constraint, old name to the new name. So this is how the check command works. And now we want to jump into pgAdmin to apply this knowledge in a practical way. In this challenge, you now need to create an additional table that's called songs with the following columns. And also the data types, you can see also that's a primary key. And you should now add the following conditions. So first, during the creation, you should add a default value not defined to the genre. And then afterwards, you should also add a not null constraint, so also during the creation process, to the song name column. And then afterwards, you should also add a constraint with the default name of the constraint, so we don't need to specify any other name, to ensure the price is at least $1.99. And afterwards, we also want to add a constraint with the name date check to ensure that the release date is between today and 1st of January 1950. And then after that, we want to insert a row. At least we try to do that. We want to insert this row, but we will see that there will be a problem with the price column because this constraint will be violated. And that's why we need to modify this constraint so that we can have 99 cents as the lowest possible value. And then after we have modified that, we want to insert that row again and see if it works now. So I know we have only learned about this in theory, but hopefully you can still figure that out or at least work on this challenge. And of course, afterwards, we'll have a look together at the solution. Now let's have a look at how we can figure out the solution to this challenge. First, let's create the table called songs. We open up the parentheses and our first column is of course the song ID. The data type for that can be serial and this will be our primary key. The next column is our song name. And for this we can use the data type varchar 30 and we want to place a not null constraint on that. So we just say not null. And afterwards the next column is the genre. Again, the data type for that is varchar 30 and we want to have a default value for that. So the default should just be not defined. And then our next column is the price column. This will now be a numeric and we have the 4 as precision and 2 as our scale. And now here we want to add our check constraint with just the default name. So we don't need to specify an additional name. And the condition should just be that the price is at least $1.99. And then our last column is just the release date. And this is of data type date. And now we want to give here also a constraint, but we want to specify a special name. That's why we need to use the keyword constraint. This should be called now date check. And the constraint in here we can define by using check, and our condition is now release a date between and then our first date and then afterwards the second date. And here we say this should be to date. So to date, we have already learned a while ago that this is just used the current date. So this will then always be today. We can use that in here as well. So this is the last column. Now let's quickly create this table and have a look at if this works or if we need to adjust something. So we see we have release date. So we have some little mistake. Yes, here we have forgotten the E. So let's again try it and see if that works. So now the table was created. We can select it from songs and we can see if there is everything correctly created. And now of course we want to insert values. So we know we do this using insert into, the table name is songs, and now the columns that we want to use is song name, the price, of course the release date, and everything else we have per default or we don't even need. So this is why we can say now, let's maybe remove that to here, and then we want to insert the values. We said the name of the song should be SQL song. And then the next one will be the price. Here we wanted to try 99 cents, which is violating our constraint. So we expect that this should not work. And for the release date, we use the 1st of July 2022. And now if we insert that, we see that this is violating our constraint. So it's violating the price check constraint. And this is why we want to now modify this constraint so that this is allowed to be inserted. We do that by dropping a constraint. So we always have to first drop the constraint and then afterwards we can recreate it. That's how we modify a constraint actually. So let's use alter table. The table name is of course songs. And now we want to drop the constraint. Drop constraint. The name we now have to figure out. So this is not specified in our definition. That's why we use the default name. So the default name, we remember, is the table name. Then we have the column name, which is in our case the price, and then afterwards check. So this will be dropped. We can already execute that, and afterwards we wanted to also add that again, but now with a different condition. So now we can actually just maybe copy that. So we have this one, check, and now we want to again alter table name and then add the constraint. So the constraint, in this case, we need to specify the name, but it's actually just we want to use the default name again. And then we have, of course, to modify it so it's at least 99 cents. Let's try to add that constraint. And actually, if we refresh our tables, we can, in the table that we have just created, also see now our constraints. So we see if we have something like a check, this is a check constraint. So we see that we have the song price check and we have the date check constraint. And if we want to see the properties, we can just go to properties, and in here we see the definition of this check. And we can even see that actually also in the songs table itself. So if we go to the table properties, we can go to constraints, and in here we will see all of those constraints. So we have primary key, we have check constraints, and so on, so forth. So here we could also, if we wanted to, modify those constraints. And if we now try to insert these values again, this should work. And now if we again select this table, so we say select everything from songs, then we should see now that now we have these values entered. And you can even see that the ID is already 2 because there was one insert that was tried, but this didn't work. And that's why we have already ID number 2. This is how the serial data type works, that even if the insert does not work because of an error, this ID will be used, and then for the next insert, the value will be incremented by 1. And now you have learned a lot about the check constraint, so this is already pretty advanced, but it's pretty cool to know about this type of constraint. We've already seen how we can insert new rows in an existing table, but what if those rows already exist and we want to update values? In this case, we need to use the update command. The command is very simple. We just use update, the table name, then the keyword set, the column where we want to update the values, and then to what we want to set the value of this column to. So let's have a look at an example. In this case, we have our songs table, and the genre is at the moment not defined. That's why we want to set it to country music. So we just use update table songs, set genre to country music, and afterwards the value will be updated in this column. So this is the basic syntax of this command, but usually it is used in combination with the where clause, because usually we don't want to update all of those values in the entire column, but we want to just update specific rows, for example, or specific values. And that's why we can use this where clause in combination. So if we want to just update one specific row, then we can just use the primary key column. So this is very common because we know this column is unique. And if we, for example, say where song ID is 4, and then we have the value pop music, then only this row will be updated. But we can also use other columns. So we can make this a little bit more dynamic. We can have calculations. So for example, we want to set the price to whatever the song ID is plus 99 cents. So for example, song ID 2, then the price will be $2.99. That's just an example of a calculation that is also using another column. So that works as well. But now let's immediately quickly jump into pgAdmin to see a few practical examples of that. For example, this person, Mary Smith, is renamed because she has married to Brown. And that's why we want to update this value of customer ID 1. Let's see how we can do that. We use, of course, update. Afterwards, the table is customer. And then set, we want to change the values in the column last name. And then we want to set this value to Brown. But now we don't want to do this for all of those values, of course, but we only want to limit this to the customer ID with the value 1. So only the first row in our table. Let's quickly do that. This has been successful, and now we see that now there should be Brown. But now we see it is reordered, but we can just still order it by the first column, so by the customer ID in an ascending order, and then we will see that this has worked well. We can also just not make everything in the email address in all caps. So that's really not what we want. And we can also update this in a little bit more of a dynamic way. So let's say update customer, set the email address, so set email, and now we want to just make everything in lowercase. So we can say lowercase, this is the function lower, and then email. And if we then execute that without a where filter, so let's just remove that, then we will see that this has worked. And now if we again select everything, we see that now all of those email addresses are in lowercase. So this is now much better, and this is how easily we can update values. Either we update the entire column or we use an additional where filter. And of course, we can make this dynamic by using columns also and functions that is possible. And now it's again your turn to put this into practice in the following quick challenge. In this challenge, you need to do two updates. First of all, we want to increase the rental prices from the films that are 99 cents to a rental price of $1.99. And afterwards, we also want to modify the customer table. So in here, we first want to add an additional column that is called initials to that table. And the data type of that should be varchar 10. Afterwards, of course, all of those rows don't have anything in the column initial. That's why we need to update those values to the actual initials. For example, if the first name is Frank and last name is Smith, the value in here should be f.s. That's what you have to update these values with. So good luck with this challenge, and afterwards we'll have a look together at the solution. Let's have a look at how we update those values. So first of all, we want to update the rental price in the film table. So that's why we can first of all have a look quickly at the film table so that we know how these values look like here. So we have in here this column called rental rate, and some of the films have the value 99 cents, and those prices we now want to increase to $1.99. So this is why we use the command update. Our table is the film table, and now we want to set the column rental rate to a new value, to $1.99, but only for those values where the rental rate currently is at 99 cents. So we say where rental rate at the moment is just 99 cents. And then if we update the values like this, and we again have a look at the table, so we select everything from that table, then we should see those values updated. Of course, always when we update the values, this internal order with how those values are automatically returned will change. So this is why we won't see that immediately in here, but we can again order by the film ID, and then we should see this reflected. So if we now have a look at the column, we see now it is at $1.99. And now we also want to add in the customer table the column initial. So if we again select everything from customer, then we see that now we need to add an additional column in here. And that's what we can do, of course, using the command add column initials with the data type varchar 4. This has worked well. Now we can see if we select it that this column is now added, but the values are just nulls. So if we want to update that, we use update table name set column, and then we use the just concatenation of those four values. First, the first character of the first name, so from the left side. Afterwards, a point. Afterwards, the first character of the last name, and then again a point. And we don't need to have a where condition because we want to enter those values in all of the rows. So let's execute that, and we see there's some problem. So again, we have this concatenation at the end, which doesn't make any sense because we don't have any additional value. And now if we execute it, it works, and we can have a look at our table now again. So now we have all of those initials included. So that's great, and this is how we can update values in a table. Now that we've already seen the update as well as the insert command, there's just one more command left in the data manipulation. So this is the delete command to delete rows from a table. And the syntax for that is very simple and in fact a little bit similar to the update command. We use delete from the table name where we want to delete rows from, and then we can add a condition using the where clause to specify which rows should be deleted. So whenever this condition is true, that row will be deleted. An example of that would be if we want to delete one specific row from, for example, the song table. In this case, we use the ID column song ID because we know this column is unique. So if we just use the value 4, we can be sure that only this specific row will be deleted. So that's very simple. And we can also use the in operator to just specify multiple rows. So these rows will then also be deleted. And if we want to delete everything from this entire table, we can just leave this where clause completely away, and we just use delete from the table name, and then everything from this table will be deleted. So you see that this delete command is not very complicated. We can just add one additional thing if we want to see which rows have been deleted. So we want to see this entire list of the deleted rows. Then we can use the returning operator. In this case, we can add the columns that we want to have returned of those deleted rows. So in this case, I want to show the song ID of the deleted rows. And since I've deleted rows with song ID 3 and 4, I get in return the 3 and 4 returned here. And of course, if we want to use multiple rows in the returning operator, we can do that as well. And even we can again use the asterisk to just return all of the columns of our deleted rows. So in this case, again, with song ID 3 and 4. So this is how the delete operator works. Let's quickly jump into pgAdmin for a few examples. In here, we now want to delete a few rows from this song table. And this is why in this case we also want to insert a few rows in this table. So we use insert into, then the songs table. We have the column song name, genre, price, release date, and we just want to insert those values in here. And then afterwards we can delete a few rows from that. So let's quickly just use everything, insert these rows, and now we see if we execute again, we have now these additional rows. So for example, now we can use the genre column to remove those two rows. So we want to say everything with country music in the genre should be removed. So that's why we use the command delete from, the table name is songs, and now our condition where genre is equal to country music. So for example, we want to remove everything that has country music in the genre, and then we can do that, and we see if we now select everything again, these data rows have been removed. And of course, we can also use the returning operator. So let's say we want to just remove row with song ID 4 and 5. So we use song ID in, and now we can use 4 and 5. But we also want to have returned, so we use returning so that we see which rows have been actually removed. We want to see again the song name and also maybe the song ID. So these two columns we want to see. And if we do that, we see, of course, this is song name, song ID of the removed columns. And now if we have a look, of course, those rows do not appear anymore in our data. So that's very simple, and now again you have the quick chance to practice this knowledge. I know this command is very simple, but anyways, I want to just give you the quick chance to practice this and at least apply it once. So in this example, there have been two payments that have not been correct and they need to be deleted. So these are the payments with payment ID 17,064 and 17,067. So those two rows should be removed and deleted from the table. That's your challenge, and afterwards we'll have a look together at the solution. Now let's quickly have a look at this delete command. We first, usually when we want to delete rows, want to make sure that our where filtering is really filtering the correct rows. This is why we should in the beginning rather use a select command so that we really can verify before we remove those rows. That's why I also do that using select star from payment, where now payment ID is, in our case, we want to delete two rows. So we want to say in 17,064 and also 17,067. And now we can just use this command to quickly verify these are the rows we really want to remove. And then we can just replace select star with delete. And then we can also just use returning to also again see the rows that have been deleted. And now if we do that, let's quickly do it. We see, in fact, now those rows have been removed. So now if we would select again, we would not see any result. And then if we do that, we have successfully removed those rows. We have already seen that we can create table and we can manually insert rows into that table. But we can even make things a little bit easier for us. So in practice, oftentimes we use create table as commands. This means that we just create a table from an existing query. So we can ideally just define exactly what should come from this table by using another query. So this means that we use the command create table, the table name, and then we just add the keyword as query. And this query could be something simple as just a select star from customer command. Like this, we would just create a new basically copy of that table just from the same customer table. Or we could also just make it a little bit more sophisticated. So we can just say that we only want to see those two columns and we also want to filter those rows. So we can use basically any statement, any query, and out of that query, we can create a new table. So in practice, this is something that is very common because like this, from an existing query, we can just create a new table. That's why we just quickly also want to see that in practice. We now want to create a new table with the first name, last name, email address, the address of a person, and the city of the person. So we first do that by just creating that query itself. So we start with select, and then we see we have first name, last name, the email, and we have also the address as well as the city. And now this comes from, we start with the customer table, and now we need to make a join. So this is why we use left join, and we need to join this with the addresses. So left, of course, let's not forget about the join, and this should be using the column address ID, and this should match the address ID of the address table. And we also need to have the city. This is why we use another left join, and we do this now based on the city ID. So this should be equal and again city ID. And now we can test this query if this is really doing what we want. And now we see this is exactly the result that we want to get. So afterwards, we can just add above that, create table, the table name. So this should be customer address. And then we just use as, and then afterwards just our statement. And if we execute that, we see this has been successful. We have 599 rows. And now if we just try to select from that table, so this is customer address, then we see now the data is indeed included in this table. In this quick challenge, you should create a table with the first name and the last name of a customer, and then their total spendings that they have done in the payments table. So just as a quick tip, if you create this customer spendings table, first of course create that query and see how you can, of course you can also use functions, operators, everything that we have learned before to create the query like this. And afterwards, of course, out of that query, you can easily create this table with the name customer spendings. Good luck with this challenge. Afterwards, we'll have a look together at the solution. Let's have a look at how we can create this table. First, of course, we create our query. So we start with select, and now we can see that this is the concatenation of first name, white space, and the last name of the customer table. So we use first name, then we concatenate this with a white space. So we use white space, and then afterwards we again concatenate this with the last name. And then we have to also give this another name. So the new name is as, so this is an alias, and this will then be used also later on if we create this table out of that query. So that's important that we choose the right name in here. And then our second column, so we can also use that, is now an aggregation. So we want to use sum, and then we use the total amount. So we sum amount of the payments table. We can again give this an alias, so total amount, for example. And afterwards, we use from. Now, of course, this is from the customer table, and we have to join that with the payment table. So we use a left join to the payment table, and we use, of course, the column customer ID for that. and this should be equal to customer ID. And then afterwards, we of course still need to group the data. And this is now done by the first name and the last name. And we can even just use exactly this definition as our group by column. So again, let's quickly test that and see if it works. And indeed, it looks correct. So this works well. And now we can just create this table out of that query. So we say create table, and now this is customer spendings. And now as we have tested that already, we can immediately, of course, we have to add as, then our statement. And then if we do that, we can like this create our table. And now let's again quickly just see if that has worked well. So we have customer spendings, and this should be then all of these rows with our definition. So hope this challenge was helpful to show you that you can create your own custom query and create a table out of that custom query, and you can control also the names with using these aliases. But sometimes we don't want to create new physical tables, but we still want to in some way save this query. And for that we can use so-called views. And that's what we are going to have a look at in the next lecture. In the last lecture, we have seen that we can create new tables out of an existing query. Like this, we can make our work sometimes a lot simpler. But there are two problems with it. The first one is that if we, for example, use this query very frequently and we decide to store this query result into a new table, we have two problems. The first one, there's additional physical storage needed because this new data is now physically stored in the database, which is a little bit redundant because we have all of this underlying data already available. And the second downside of that is that, of course, in the underlying table, the data can change. So for example, we can have new customers, and then out of this saved data, the data will not update because we've just created this new table independently as basically a snapshot of how the data has looked at the moment when we created this table. So we need two things. First, we want to avoid redundant data storage. And secondly, we also want to have our table dynamic. So if the underlying data of this query changes, then also our table should be updated automatically. And for this reason, we can use so-called views in databases. So a view basically works as if it would be a table in some way. So we can just query from it. We can say we want to see this columns. We want to make some operations. So it looks like from outside, from the user perspective, as if it would be a real table. But there is a big difference because the data will not be stored physically, but just the logic. This means we just basically store the statement that we have used. And then whenever we query from this view, this query that is behind the view will be executed behind the scenes. This also means that if the underlying query is very complex and takes a lot of time, then in this case, also if we would query from this view, the time will also be very long. So this is important to understand that we in a view just store the statement itself, so the logic, and no data is physically stored, but we always, just whenever we query from the view, this statement that we have stored will be executed. And the syntax for that is super simple. It's exactly the same as we have done it also in the create table as command. So instead of table, we just use a view and then the query. So for example, we create a view called customer anonymous, and then we want to have this statement here saved. And now, of course, we can just query from this view as if it would be a table. Just behind the scenes, of course, always now this statement will be executed. And if this takes a long time, then this still needs the same amount of time. And for that reason, the main use cases for views are queries that we use very frequently, but they are not super complex. For that very complex queries, we have an alternative. So that's just what we have to remember. The view takes as long as the underlying query takes. But now let's quickly jump into pgAdmin and see that in action. So we have created this customer spendings table, and we have done that out of that existing view. So we can now just query from this table, but maybe we don't want to store that redundant data, and we also would like to have the data updated. This is why we decide to drop that table customer spendings and make a view out of that. Just drop that table, and now if we use that command, but instead of table we use view, we can execute that. the view has been created. Also, we find that now here in our views. So if we refresh quickly, we see that there is now also the customer spendings view, and we see those are the columns in this view. And now if we just again use that same select command, we should see now those rows also appearing. But sometimes a view is not really ideal, because we can have very complex queries that take a lot of time, and we could decide to just create a table, for example, out of that view or out of that query. This will now be much faster, but the problem of that is that now the data will not be updated if the underlying data changes. And for that reason, we have also a solution. These are the so-called materialized views that we are going to have a look at in the next lecture. In the previous lecture, we have seen that if we create a view, this view is depending on the performance of the underlying query. So the query, the statement that we have saved in that view. And of course, we don't want to create a new table because that table will not be updated. And this is why we have the concept of so-called materialized views. The statement for that is just that we create and then materialized view, the name of the materialized view, and then again we use a query to create this view. And now with those materialized views, we combine both the benefits of a physically available table and a view in some way. So of course, with the materialized views, now the data is stored physically, and this ensures the performance. So if we have a view with a very bad performance because this view, the underlying query, is very, very complex, in such cases we can use materialized views. And then of course we need to update those views, which we can do with the command refresh materialized view and then the name of the view. And then once we have executed that refresh command, the data will be again up to date in that materialized view. And yes, indeed, we do need to update this data either manually or we can use a so-called trigger, which we'll learn about later on. But this is just important to keep in mind that this view needs to be updated. It will not be able to update automatically. So let's quickly jump into pgAdmin to see how this works in practice. We have seen this query before where we just create a list of the films, including their category and the length of those films. And now we want to store those results in a materialized view. And this is what we can do by using a create, of course, materialized view command, and the name of this view should be film category. And then we will see that this will now actually not work because, of course, let's also add the S, and then we try that, and this will not work because a view, a materialized view, is also a so-called relation like a table, and they cannot be in duplicate names. So this is why oftentimes if we create a view just out of a table or that is doing something very similar, we use the prefix v, or we can also use mv for materialized view. So that's just something, a practical best practice that we do sometimes just to avoid to have this duplicate name, and also to indicate, of course, that this is a view. And now if we do that, we can try it again. And now we have created this materialized view. Let's quickly query from this materialized view. We use mv. And of course, now if we don't update this view, so let's just update the value Saturn name, then we have this updated, which will not be reflected yet in our view. So if we again query from that, we see that still Saturn name has still the value 182, even though we have already updated that. So this will only be visible after we have refreshed our materialized view. So if we refresh it, then we will see it will be now updated, and now it should be visible also in our query. So now if we try again, we see indeed now Saturn name is at the top because we have also ordered that by the length, and now we see that it is with 192 minutes. So this is how we can create a materialized view and also how we can refresh a materialized view. By now we have understood what views and materialized views are and how we can create them. But also, similar to the tables, we can also alter those views. And we can also drop them. The same goes also, of course, with the materialized views. We can also use the alter materialized view command to alter the properties of the materialized view. And of course, we can also, that's very simple, drop the materialized view. In normal views, we have the option to replace an existing view or even use it together in the create or replace view. And this we will also have a look at. So that's some option that is very easy if we just want to modify the entire view, so the select statement basically. And unfortunately, this is only possible for the standard views. So let's go through those operations quickly, and afterwards we'll put it into practice. So of course we can drop a view. That's very simple. And the command we already know. We just use drop the database object, view or materialized view, and the name of that object. And this will just then drop this object. So that's very simple. If we want to alter a view, and I'm just using now the example of a view because a materialized view will work exactly the same way. So if we want to alter a view, we can basically either rename the entire view or we can rename columns in that view. So this is some property that we can change in a view. If we want to change the select statement of the view, we can use the create or replace command. And this we can actually, if we want, even use as a create statement. So it works like this, that this view will be created with that query, or if it already exists, then it will be replaced by this newly created view. So this is a command that works only with the standard views. It does not work with tables and also not with materialized views. But luckily, this option is available for our views, and like this we can quickly replace an existing view with a new query. And now, as these commands should be already somewhat familiar to us, we immediately want to put this into practice in the following challenge. In the previous lectures, we've seen how we can insert data using commands into our tables. But we can also use the so-called import functionality to import external data from an existing CSV file, for example. And this helps us to immediately get some data into the table if we have it already available, for example, in a CSV file. But sometimes we also need to export data from a table so that, for example, other people that don't have access to the database can also work with this data. If we want to import data from a CSV file or a text file, we need to be aware that this table needs to be created first in pgAdmin. So this is not done during the import process, but we need to do this manually ourselves first. At the moment, there is no other way around that, so this is something that we have to do. And also, what we need to be a little bit careful with is that the format, the data types, all really match the table in our database. So this is sometimes a little bit tricky, and oftentimes we need to adjust maybe a data type, or we need to maybe change something in the CSV file as well. So sometimes this can be a little bit tricky, but if we are aware of that, we should usually be able to do that. So let's not theorize about it and immediately jump into pgAdmin. So we have seen that, of course, first we need to create this table. This is the table that we are going to use. So I'm just going to execute this code. Of course, you can also type this code out, or if you want, you can also just download that same code from the resources in this lecture, copy, paste it, and execute that as well. And now if we refresh our tables, we should see our sales table now in here. And of course, if we now query from the table, at the moment, it is completely empty. But now we have also some CSV file that contains this data that we want to insert, copy in this table. So this table we find also in the resources. That's a CSV file, and if we are going to open that up, we will see that this contains now exactly those columns that we have available also in our database table. You can maybe see that some of the column names are not exactly the same, and this is now not a problem because the data and the columns will be not matched by the name, but by the order of the columns. So the order of the columns in our CSV file, as well as the order of the columns as we have created them and set them up in our database management system. So that's what we have to keep in mind. And now let's see how we can import this file. We need to have the file path. So where is this file located? We can find out about that by right-clicking on the file, going to Properties, And in here, we see that in my case, this is on the desktop. So the location we can just copy, and then we will paste that into pgAdmin. But first, let's see how we can come to this import-export functionality. On the left side, we see our table sales. In here, we just right-click and we go to import-export data. Here we have two options, import or export. The default is that this is set to export. So the first thing that we want to do is set this to import. And now we can just paste in this file path. And also we want to add the name of that file. So we want to add another backslash. And in our case, this is fact_sales.csv. We can just do that manually, or we can also just navigate to the folder using this little folder icon. But I'm just fine with pasting that in here manually. The format is CSV, and we can have, as we've mentioned, other options as well, but we are going in our case with CSV. The encoding is usually good if we choose UTF-8, depending on the country. If you have another type of encoding in your country, you can choose a different one, but the default is okay if we just use UTF-8. Then we have this important option of the header. This means that our data contains a header. So we see in the first row, this is the header. So this should not be inserted and considered as data. Therefore, the first row will be skipped if we choose this header option in here. And afterwards, we have to select a so-called delimiter. In our case, if we open up that file by right-clicking and going on Edit, we see that the delimiter in this case is a comma. This means that every value in the next column will be delimited by a comma. So after a comma, the new value starts. So in a CSV file, as the name suggests, the delimiter is usually a comma. So we are also selecting, in our case, the comma, and then we are fine with all of the other options. So then after we have done that, we can immediately go to the columns. In here, we also don't need to make any changes. We could add, for example, some not null constraints, but we don't need to make any more adjustments. So if we have checked everything, that everything is fine, we can now just click on OK. And again, make sure that you have pasted in the correct file name, you have gone to import, and then afterwards we can click on OK, and now the data should be imported. As mentioned, there can be sometimes some issues, so just make sure that you have used the correct file path. And in our case, we have seen now this successful message. So now if we again select from the table, we should be able to see now the data in here. So this is really great. And now we also want to quickly see how we can also export the data. So if we now, for example, want to make some adjustments, and then we now want to also export this data. We've seen that if we right click on a table, we have also the option to go to export. So then we can again paste a file name, and in our case we say sales.csv. The format should be also a CSV. The encoding can be again UTF-8. We do want to have a header in the output file included. That's why we check this header box. And also the delimiter that we want to have in the file should be a comma. And then afterwards we have the columns. In here we can, in our case, select all of the columns because we want to have them all included in the output file. And afterwards we are good. So now we can just click on OK, and the data will be like this, exported. And now if we have a look at the location that we have specified, we can now see that there should be this file and the data should be in here included. So this is how we can use the import-export functionality in pgAdmin. Now let's have a look at a super powerful type of function that we can use for really deeper analysis. And this is the so-called window functions. To understand the concept of those window functions, let's have a look at the following example. We have our payment table. So this is a sales table just with one row per transaction. We have a payment type, customer ID, and then also the price of that transaction. And now what we would like to achieve is to get the same level of detail, but an additional column that is now aggregating the price in transaction per customer of the entire table. So this is what we would like to achieve. That means that we don't want to influence the number of rows, so the same level of detail, everything should be the same, but we also want to add an aggregation column that is containing aggregated data. But we don't want to group the data because this would get rid of this level of detail and all of those other columns. Actually, we have already seen one method of doing that. And that would be using correlated subqueries in the select. So in this example, we can use that and we can use the correlated subquery on the customer ID. But this is actually, if we think back to that, pretty complicated for us to develop. And also in regards to performance, this is actually very, very cost intensive and it slows down our performance a lot. This is because we have to iterate through every single row, and that's very, very bad in terms of the performance. There's a much easier way than using that subqueries, and this is to use the window functions. So this is very simple. We can just use an aggregate function, and then we use the over clause, and we say partition by, and now what we want to group these aggregations by. So this will be the customer ID, and then we can still use all of those other columns. So you see that the number of rows and the level of detail is not affected, but we have still this aggregation column. This is very important to understand. You can see we use sum and we have other columns, but we don't use any grouping here in this select. So this is what we can achieve using those window functions. And instead of the sum, we could also use, for example, another aggregation such as the count, and then we have the number of transactions. So you can see we can easily use different aggregations, or we can also partition by another column. So for example, by the payment type, and then we get again a different result. And this is very easy to modify, very easy to develop, and very strong in terms of the performance. So the key thing again is that the number of rows are not affected. We can just use all of the columns in every level of the detail, so just as we are used to. And then we also have one aggregation column that is aggregated by a certain partition. And this is what we can do using these window functions. So that's basically the over clause. And with that, we can combine all of the aggregations we already know, but typically there are also some more aggregation functions used, such as the rank function, first value, lead, lag, and all of those functions we are going to have a look at in the following lectures. But before we do that, let's again just quickly have a look at the general, very basic syntax. We have an aggregation function with the column that we want to aggregate. And afterwards, we use the over keyword to open up our so-called window. And afterwards, we define what should be partitioned by. And then this is, of course, our partition column. And that's what we call the window, because we don't group the data really, but we just open up basically a window of aggregation. This is how those window functions work. And now let's immediately put this into practice and have a look at a few examples. So we want to have a look at our payment table. And in here we have all of the payments. What we now want to achieve is the sum of the amount for each customers, but still we want to see all of those individual payments. So we can do that using, of course, a window function. We want to, as mentioned, just sum the data. So we sum the amount, and now we open the window function. So we say over, and we want to partition by the customer ID. And then if we execute that, we get our desired result in a very, very short time. So here, for example, for customer ID 1, we see amount 118 and all of the transactions still. And what we see in here as well is that if we use this over clause, usually the results will be also returned in the order of this column that we partition by. And if we still want to have another order, we can of course still use the order by clause. So I want to see still ordered by the payment ID. And then we have this additional column in our query result. And now, of course, we can just replace that, for example, with another aggregation function. So we just count the values, and then we see the result of the count of how many transactions did we have per customer. And what we can also do now is we can not only group by one column, but we can partition by multiple columns. So for example, we want to see how many transactions did each customer have for each of the staff IDs. So how many sales did occur for each staff ID per customer. Then we can just add both of those columns to our partition by clause. So for example, staff ID as well as customer ID. And then if we execute that, we can see that, for example, for customer ID with 269, it's the same. But if we have a look, for example, at 274, we see that the amount was a little bit different. And even what we can do, this is something that is also possible. We can not even mention this entire partition by, and then what we get is just the total count of our query. So we see that the count is now the total number of transactions, of payments that we have in this entire table. So if we again execute it, you see we have 16,047 rows, and this is exactly that count that we see in here. And I want to mention one last thing, that is, if we of course want to use the average, that is totally possible. But if we want to do that, we will see that the results are not really that nice. So of course we would like to round it. And what we can now not do is just use that round around that average like this. This would not work because we have to use that round all around that entire expression. So if we would like to do that, we need to end that round after the over clause, because this is the entire expression. And if we wanted to do that, we need to do it like this. And then we can again get our desired result. So this is how the window functions work. And now again, it is your turn to put this into practice in the following challenge. In this challenge, you need to write a query that returns the list of the movies, including film ID, title, the length of that movie, and also the category. So this is the name column, but you should rename it to category. And then also the average length of movies in that same category. And again, the results should be ordered by the film ID. So that means that the expected result should look like this. We have all of those information, plus also this column average length in category that should be rounded also, and it's just returning the average length of the films in that specified category of that row. And now we have also a second challenge, in that you should write a query that returns all of the payment details, including the number of payments that were made by this customer and that amount of that current row. And again, the results should be ordered by the payment ID. This should in the end look like this. So we have all of the payment information plus one additional column with the number of payments with that specific amount for that customer. So for example, customer 269 has one payment. This is the only payment with amount 199. And 99 cents has 3 payments for this customer. So these are the challenge. Good luck with them, and afterwards we'll have a look together at the solution. Let's have a look at the solution of those challenges. First of all, we want to create a query that is returning this result with all of the films, including the average length of the movies in that same category. So we create our select, and we want to first get the film ID. So film ID, and then afterwards we get also the title as well as the name of the category table, and we can even give this immediately an alias called category. And afterwards we also want to have the length included. Again, we can give this an alias. And afterwards, we want to create our window function. And in here, we want to take the average of the length, and this should be partitioned by, so we create our window over and then by the name column, so by the category. So we use partition by and then the name. And now this should be also rounded. So we want to use the round function around that entire expression. So after this is closed, we round by 2, and even we can give this now as well an alias. So average. And afterwards, of course, we don't need a comma because this was the last row that we need. And now we start with the film table. We need to make some joins. So we give this an alias f. And now that there are multiple film IDs actually, we also need to give this here a specification of where this film ID should be taken from. Otherwise, it will be ambiguous and it will not work. So then we make the join. So we can use a left join on the column film category. So film category, we give this an alias fc, and this should be on the columns film ID. So we can just use that. And afterwards we create another join. So this will be now on the category table. So we can also create the join using the category ID. And afterwards, if we execute that, we see that the order is not exactly what we want, but we can still order by the first column. So we can say order by 1. This will do the job. And then if we execute everything, we get the result that we were trying to get. So this was the first solution. And now with the second solution, we want to also have a look at the payment table. So we want to go to payment, And in here we have seen that we want to get now this additional column that is grouping by the amount and the customer ID. So that's why we can just add an additional column, which will be a count. So we can use count star. Now a window that we are going to open over by, we want to partition, and now by 2 columns, so by the amount as well as the customer ID. And this is everything that we need. Of course, we can now still order by a few columns. We will see that in a little bit. So if we have that, we can now still order the results, for example, by the customer ID, and then the results just look a little bit easier to read. So if we execute that, we can get the desired result. And these were the solutions to our challenges. Hope it was helpful, and see you in the next lecture, in which we dive a little bit deeper on the window functions. Now that we have seen how the window functions work using also over and partition by, we now want to see how we can dive a little bit deeper into these window functions, because we have one additional option that is super powerful. And that is, instead of using partition by, we can use also order by. So what we are trying to achieve now is to get a so-called running total. This means that in the additional column, we step by step want to add up those values if the rows are ordered by this payment date. So we want to get the running total of this amount based on the order of the payment date. This means that in the first row, we have 299. This is just the value that we have here. And then in the next row, we have 598, which is now just adding up also this value to 99. And then after that, so based on 598, we get then plus 399, which should result in 997. So basically, this value 997 is just the sum of the current value plus all of the previous values. And the same thing again for 1496, just the sum of all of those values, or basically 499 plus 997. So this is the running total that is super impressive to calculate, because in many analysis, this is an important number to calculate. And how can we achieve that now? So we do that also using the window functions. We just want to start now with everything from the payment table. And now we want to add this additional window function. So we just use some amount and now open up the window using the over clause. And now, of course, we don't need to have any partition, but we want to use order by and now the payment date. And if we do that, we get exactly that result. So this is the behavior of this order by in the over clause, that step by step, all of the previous values will be added up. So if we are here in 997, all of the previous values, including the current ones, are added up. And you can see that if we use this order by in this over clause, then also per default, the ordering of that entire query is based on that payment date. So you can see that in this case, it's not ordered by the payment ID. But of course, we could change that. So we could say that we want to make this calculation, this running total, based on the payment ID. And in this case, we can also get that calculation. And now it's based on the payment ID. And even we can make, of course, all of the other aggregations. But what's more interesting now is that we can use that even in combination with partition by. So that's what makes this now super powerful in our analysis. So if we wanted to also partition, for example, by a customer, then we could also add partition by, and this needs to be in the beginning, partition by customer ID, and then right after order by the payment ID in our case. And if we execute that, we have now a running total that is ordered by the payment ID, and then we have this for every customer. So we see this running total for the customer, and then once a new customer starts, so once all the rows are done for this customer with ID 1, we have the next customer, and this is now where we start over again, because we have used partition by the customer ID. So if you have really understood this window function and how this partition by and order by works, this is a super impressive skill, and you can make really powerful analysis with it. So this is the principle, and of course we can again order by multiple columns. So for example, we want to order by the payment date first, and then afterwards, as a second order criterion, we want to order by the payment ID. So for example, we say payment date first and afterwards the payment ID. We can even use that in another row, so it's a little bit easier to read. And then we have now the order by 2 columns. So first payment date and afterwards payment ID. Of course, again, we can use ascending or descending. So of course, if we use the payment date, usually it makes sense to use the default ascending, but we could also change the order of that calculation. So this is how we can create running totals using the order by, and we can even combine it with partition by. Now it's your turn to put it into practice again in the following challenge. Let's have a look at the following challenge. In this, you should write a query that returns the running total of how late the flights are. So this means the difference between actual arrival and the scheduled arrival, ordered by the flight ID. And including in this query should be also the departure airport. And as a second query, you should create the same running total, but now partitioned by the departure airport. So this is the challenge, and the expected result should look like this. For the first query, you should get a result that looks like this. So you have flight ID, departure airport, and then this running total of the difference between actual arrival and scheduled arrival. And then if we also add this partition, you should get a result that looks like this. So good luck with this challenge. Hope it helps to practice what you've learned about order by, partition by in the window functions, and afterwards we'll quickly also have a look together at the solutions. Let's have a look at the solutions. So we want to calculate the running total of the difference between actual arrival and scheduled arrival. And as you can see, we use, of course, the sum. And if we calculate the difference between actual and scheduled arrival, these are 2 timestamps. So we've already seen that this will create an interval. And with such intervals, we can just also easily aggregate them. So we can also sum them up. And that's why we first want to start, of course, with selecting the flight ID. And then also, of course, the departure airport. And now we can calculate our sum in a window function. So we use sum and now the difference between actual arrival and then the scheduled arrival. So this is the 2 timestamps that we can just calculate the difference from, and then we aggregate them. And of course, we need to now also use our over so that we calculate this running total ordered by the flight ID. And of course, we could give this an alias, but we don't want to do that now. Let's also make this a little bit easier to read. And this, of course, comes from the flights table. So if we execute that, we get exactly our result. And now we can also calculate this based on the partition of the departure airport, because we don't want to add up maybe all of the flights from the different airports. So we want to partition this by the departure airport. Partition by departure airport. So we just add the partition by before the order by, and then we have this partitioned also by the departure airport. So this is how we can calculate a running total together with a partition. Oftentimes, we also want to rank our data. This means, for example, we want to create a ranking of the shortest or the longest films for every single category. So we have in the category action a specific ranking, and then in the next category, we will have another ranking. So if we are in the next category, the ranking starts again at 1. So this is what we oftentimes want to achieve, create a ranking in a specific partition. So this is why we, of course, also want to use again the window functions. And we use the very commonly used rank function. Let's see how this rank function works. First of all, I want to say that this is just a very simple query. So we have just 2 left joins. We just take the title from the film and the length from the film, and then also the name from the category table. So we make 2 joins to the film category and then to the category. And this will immediately give us, let's execute everything, this very simple query. And now we want to create this ranking. So let's start with understanding the rank function. This is just an aggregation function, same as the sum or the count, and we want to now, of course, open up the over window. So in our case, we want to order this by the length. And this is how that function works. It will create a ranking in a particular order. So based on the length column. And now we see that if we execute that, we get now all of the film titles and their rank in terms of the length. If we want to have the longest film in the beginning, we can also make the order in a descending order. And like this, we will get the longest film at rank number 1. And then we see we have here a bunch of films that have the same length. So in this case, it will be exactly 10 films. So we have 10 times rank number 2, and then of course the next rank, which is the 12th value, will get rank number 12. So this is a behavior that we sometimes don't want to have. And if we don't want to have this behavior, we can use the dense rank, because then we will immediately see that this is the third longest value in terms of the length. So if we execute that, we will see that now the longest value has value number 1, all of the second longest have value rank number 2, and then afterwards we come with rank number 3. So this is the dense rank function. And of course, now what we also would like to do is we would like to partition this by the category. So this is why we of course can also again create the partition by, in our case, the name column. And then if we do that, we see that now we have also this partitioned by the category. So in the action category, we have again the first 2 longest films, afterwards the second longest, and then this goes down until we are arriving at the next category, which in this case is the animation. So then we have the next ranking here as well. So you see that this rank function, if we have understood the window functions, it's actually not very complicated to understand. There's just one specific thing that we need to keep in mind, and this is that we cannot use these functions in the where filtering. So this is not possible because the where filtering takes place before the window function will be evaluated. So that's why it sounds a bit complicated, but this is the reason why if we want to filter by the rank function or by another window function, we need to use a subquery. So for example, we could say that we want to use this column, so this expression, as a filter. So we want to see only the top ranks of each of the category. So we could just copy that and we say in the where condition where this expression, so our rank, is equal to 1, for example. Then we will get this error message that is just telling us what I've just explained. Window functions are not allowed in where. This is because this window function will be evaluated after the where, and this is why it is not possible to do that. But if we want to do that, of course, we can again create a subquery. So we can just use select star from, and then this will be our subquery. So we open up this subquery. Of course, in the end, we need to again close the parentheses and give this an alias, for example, just a. And then we can use our where filter. So then we could, for example, say where rank is equal to 1, and the rank does not exist yet, but we could just give this an alias in here, so as rank. Now if we execute it, we get all of the rank 1s. We could also say we want to see all of the rank 2s, for example, and then we see all of the rank 2s. So this is what we need to know about the rank function and the dense rank function. Hope it was helpful, and now it's your turn to apply this knowledge in the following challenge. In this challenge, you should now write a query that returns the customer's name, the country, and how many payments those customers have. For that, you should use the existing view customer list. So this will make it a little bit easier. We have the name, the country, and then how many payments those customers have made. And now, once we have that, we can now create a ranking of the top customers. So this should be ordered by the count column. So the top customer with the highest sales should be in the beginning. So the most amount of sales. And this should be now also partitioned by the countries. And then after that, we should filter the results to only the top 3 customers per country. And the result should, of course, look like this. And now it's your turn. Good luck with this challenge. Afterwards, we'll have a look together at the solution. Let's have a look at how we can achieve this result. First of all, we want to use the customer lists. So if we select everything from the customer list, we have almost everything that we need. So in here, we have all of the customer information. Of course, we only need here the name. And then we have also here the country, so we can use that as well. And afterwards, we also want to count now the values, but we want to count from the payments. So we need to use also a left join to the payments so that we can also count the payments, because in here, this is only the customers. And if we do that on the column ID. So this is the ID column, and this should be equal to the customer ID of the payment table. These columns are not ambiguous, so customer ID only occurs in payment and ID only occurs in the customer list. This is why we don't really need these aliases in front of those column names. So if we do that, of course, we also need to group by, in our case, the name and the country. And then we have already our first task done. So the result is like this. And now we can add our ranking. So if we now want to do that, we create rank over, and this should now be ordered by the count star column. So count star, and of course in a descending order. And this should now also be partitioned by the country. And then if we execute that, we get our result. Of course, if we now want to filter that as well, we need to create a subquery because the rank cannot be used in this window function in the where filtering. But we can easily do a subselect. So we say select everything from that query. This has an alias, for example, A, and then we filter where we can say rank is in 1, 2, or 3, or we can say is between 1 and 3. And of course, also if we use that name, that alias, we need to give this alias also in our subquery. So this is then the alias, so we can say as rank. And now if we execute it, we see that everything is filtered to only the top 3 customers per country. Instead of using the rank function, we can also use just the function first value. And then we don't get the rank, but we get the first value of, in our case, this partition, for example, the countries, and then also, of course, the first value ordered by this count in our case. Let's see how this works. We have, in our case, the function first value. And we have to now decide what value we want to see. So do we, for example, want to see the name, so the first name ordered by the count? We could do that. So if we try to do that, first value name by the partition country ordered by count star, we will then see what we get. Let's quickly execute it. And we see, for example, for Algeria, we see the first value in name is June Carroll. So in this entire partition, the first name will be June Carroll. And of course, this is now ordered by the count star, so by this column that we have ordered. And now we can give, for example, also this count star here into this function. So we could also use that. And if we do that, we see the first value in this partition. So in this case, we see it is, of course, the top value. So we could, of course, also change the order. So we could say this should be in an ascending order, and then we will always see the lowest value in the beginning. And now the value 25 will always be the first value in this partition. And this can be now used for calculations, for example. So we could now create a new column, and we can say what is the difference to the first customer, for example. So we can just use count star, and we could subtract this entire expression. And then let's just make sure that we remove also that alias. And then we can see if we have the comma, let's also add that. And then if we execute it, we should get the result, which should now be the difference for every single customer to the first customer. So let's go to Argentina. For example, in here we see 7. This means the first value in this partition is 23 and now 30. So the difference is 7. So you see that if you already know how you can use those window functions, how you use, for example, also rank, then it is very easy to use also the first value function. We just define what value we want to see, and then of course we can specify our partition and our ordering. Now we want to have a look at, in my opinion, one of the most interesting window functions. And this is the lead or the lag function, because with that we can create really meaningful calculations. So that's oftentimes something that people don't know how they can achieve such results, but we can do it using lead and lag. So let's have a look at how this lead and lag function works. So what we use is just the function lead in our case. We start with a lead. We use the same query as we have done before, so we can just remove everything from here, and we can also remove the comma. So we have just now the function lead over the partition country and ordered by the count. And what this will give us is an error, because we have to add again a value in here. It's in the same way as with the first value. We need to enter which value we should see. So this in our case could be, for example, the name again. Let's start with that. And then we see in this case, the lead is the one that comes afterwards. So for example, we are in the partition Algeria, and currently we are in row number 2, Judy Gray, and the next value will be Mario Cheatham. So this is now the lead. It gives us the next value ordered by the count and in the partition that we have specified. Of course, this will also generate nulls if there is no logic lead. So if there's no logic next value in our partition, which of course makes sense. And this becomes now very meaningful if we don't enter here such a value as the name, but something like the count, for example, because then we can make really calculations. So if we do that, we see always the next value, in this case 28, which is the next value is 28 in here. So this is now possible to be used also in calculations. So again, we have seen we can now use just this column. Let's copy it, and from that, let's also remove as rank, we can subtract the count. And like this, we see the difference to the previous value. So if we execute that, let's see, we have some mistake somewhere. Probably we've forgotten about the comma. And now we see the difference to the previous value. And this is now so cool, because we can create now so interesting calculations. Of course, we can also use, instead of the lead, we can also use the lag function. This is exactly the same, just that we get the previous value. So if we use a lag instead, let's just replace it with lag, and we get again the count. And this is then giving us the result. We can see the value that was before. So 25 was the previous value, and that's why we see in here 25. So for example, if we need to calculate the growth or the difference to, for example, the previous year, then we can just use this kind of calculation. So in practice, many people don't know how they can create something like this, but now you know about the lag and the lead function. Let's apply this again in the following challenge. In this challenge, you now need to use the lag or the lead function to calculate a percentage growth compared to the revenue of the previous day. So let's have a look at this challenge. In that, you should now write a query that returns the revenue of the day. So you need to aggregate it, and then also the revenue of the previous day, and also the difference from the previous day to the current day. And now from that, you need to calculate also the percentage growth compared to the previous day. So the result should look like this. We have, for example, in the second day, a growth of almost 800%. So this is how the output should look like. It is a little bit tricky, but I wish you good luck with this challenge and applying your knowledge. And afterwards, of course, we'll have a look together at the solution. That's now a very interesting calculation that we now want to see how we can create that. First of all, we want to aggregate the data so that we just see the sum and also the sum of the amount for that specific day. So we use sum amount. Afterwards, we use the date function to give us the day. So this will be the payment date. And now if we do that, we can say that's from payment. And of course, we group by the date column. So we can also, of course, give this an alias, for example, as day. And then we have already the revenue from that specific day. And now we can also add the previous value. We use sum amount, and we want to do that over the ordering of the date. So we can again use date, payment, date. And then we have already the previous day. So we can, of course, again give this an alias like previous day. And afterwards, we also, of course, want to add a comma, and then we can now calculate the difference. So the difference is not complicated. We just use what we currently have. So in the current row is just some amount, and from that we just subtract what we have in the leg. So this is not very complicated. We can give it another name. So for example, it would be a difference. And then if we remove the comma, we should get also the previous day as well as the difference. And now if we want to calculate the percentage growth, we can just copy this column, which is the difference. And this should now be divided. So we use divide. And then this should be divided by the previous day. So this difference divided by previous day will be our percentage growth. So let's just execute it first. Let's just check also that we don't have some comma forgotten. Of course, after difference, we need the comma. And now we see this looks already not so bad. But in this case, we won't get the correct result because we need to use parentheses. Otherwise, it will be first this division. So this leg by this leg will be divided. And this is why we need to use also in here these parentheses. So that's something we should make sure that we have that. So now if we execute it again, we get now more accurate values. And of course, now we want to see this as percentage. This is why we can just multiply as well by 100. And afterwards, of course, we can also round that entire result. So we say round this entire expression, and this should be by 2 decimal places. Then we close the round. And of course, we can also give this now a name, for example, as percentage growth, which will give us now our final result, which is now the percentage growth from the previous day to the current day. And this is what we want to calculate. So in my opinion, a very helpful yet pretty advanced way of calculating differences, growths, and so on. So hope this was helpful, and see you in the next lecture. In this challenge, we now want to create an additional column that is now calculating, it's basically building on what we've done before, and it's calculating the percentage of the revenue that each of the customers makes per staff ID. So this is how the result should look like. Here's our additional column, and we should have the percentage shares in this column. So that's a little bit more tricky, but if you want, you can also use this additional challenge to just again practice what we have learned in the previous lectures. So good luck with this challenge, and afterwards we'll have a look together at the solution. Let's have a look at how we can create this query where we want to build on the previous solution. So what we want to add now is just an additional column. We can just give this an alias, in this case total. This is not so important, but we want to now add also the first value because we want to calculate the percentage. This is why we first want to get the highest value, and then we want to use the current value of the staff ID of the customer and divide it by the top value, which is the total value. And this is why we use first value and then some amount. And this should be now over our partition is just the first name and the last name. So we can use, of course, 2 columns also to partition. We've seen that before. Partition by, and then afterwards also we want to order by. So this is what we want to do as well. Order by, and in this case it can be also our aggregation column, so some amount. Just have to make sure that we close again the parentheses after that, which we have done. And now this is not everything that we need, because if we execute it just like this, we see that of course we need to correct this little mistake. Then we see that this is just now the first value. We want to have the last value, basically the highest. This is why we want to change the order. And now based on that, we can now calculate this percentage, because now we just need to divide the total column by this first value column. So we can just in this case add the total, so some amount, and divide this by the first value. Of course, we can also give this now a more descriptive alias, for example, percentage. And if we execute it, we get now our very long commas. So this is why we can also just round it, multiply it by 100, and also then give it 2 decimal places. So that's what we want, and this will give us our final result. In my opinion, this is a pretty cool calculation, and hope it was helpful for you as well to practice your knowledge. In this lecture, we now want to see how we can group by different sets of columns. So what we want to achieve is we want to make an analysis on our staff IDs. So how was their performance for each of the months? So what we want to get is a query that is returning us the revenue made in every single month per customer. But also what we want to add is the overall revenue of this specific month. And then also what we want to see as well is the overall revenue of the staff ID in total. So of staff ID 1 and staff ID 2. And that all should be combined into one single query. Of course, what we can do is we can already create the individual groupings. So we can, for example, say we have this first grouping just by the staff ID. We can have a second grouping just, for example, by the months. We can see that as well. This works also. And of course, we can also have a grouping of the both columns. So this is something we also know how we can do it. And now the question is, how can we create this grouping together? So how can we combine those different groupings into one single query? Of course, we have already learned about union. So there would be a way to do that using union. If we, for example, want to union the first two queries, we have staff ID in here. And then also we have this one, which is just grouping not by staff ID, but by the date. Then we could actually just union those two queries. We can also give this an alias like month. And now if we want to combine them, we can just use again the union. But of course, since in the first query there is no month, we need to give here an null. And this is what we need to add manually in this query. So we need to say null as month, and then we can create a union to the other query. And of course, in here as well, we need to add a null for the staff ID. So as staff ID. And this is then now giving us the combination of those queries and also, of course, the nulls if there is no value. So this is the combination. And now if we also want to add the last query where we have the combination, then we can also add that as well. And you see we have now 3 different queries that we combine. And actually, yeah, the result is not really so nice. It is not nice to develop. It is not nice to read. And also in terms of performance, it is actually very bad because this grouping has to be done over and over again. And this is really not the ideal solution. So how can we get a better solution, a much easier solution for that? This is by using so-called grouping sets, because this is what we have actually done. We have grouped by the months, by the staff ID, and by the combination of those. So we have, in fact, 3 different grouping sets. So let's see how we can create an easier query using so-called grouping sets. We just use, again, the sum amount. And also we use, of course, we have used the date. So we use toChar from the payment date. And we have used the month. And then we have also the staff ID. So this is everything that we need. Of course, also the sum of the amount. And this comes all from the payment table. And we now want to group this by the grouping sets now. This is why we use now the keyword grouping sets. And now after we have defined that, we can say what should be those grouping sets. Our first grouping set is just the staff ID itself. Afterwards, our second grouping set is just the month itself. Of course, we have to write this in the parentheses. So this is the month. And then the last grouping set is the combination. So in this case, staff ID and also now the month. So these are our grouping sets. Let's see if we can get a similar result. Of course, we have not given the alias month yet, so let's also add that. And then we will see that we get now the grouping sets. So we have now everything that we have achieved also with our previous very complicated union column. So this is now much, much easier. And of course, we can still order by a specific column. So for example, first by the months, then afterwards by the staff IDs. And afterwards, we have now the results month by month, and we can compare how have the different staffs performed in each of the months. So this is now much, much easier than using just the different unions, which is really not the way to go. So with these grouping sets, we can just define all of the different combinations that our data should be grouped by in one query. And now again, it's your turn to apply this knowledge in the following challenge. In this challenge, you should now write a query that returns the sum of the amount for each of the customers. This means first name and last name, as well as the staff ID. And we should also add the overall revenue per customer. So we get a list of all of the customers, their revenue per staff, and their overall revenue. That's the challenge, and I wish you now good luck with it. Afterwards, we'll have a look together at the solution. Let's have a look at how we can create a solution to get this result. First of all, we want to get the first name as well as the last name from the customer table. And also, we want to have the staff ID. This comes from the payment table. And then we want to create the sum, of course, of the amount. So we've already said this comes from the customer table, and we need to join that with the payment table. So we use customer C and payment P. Of course, we join this again on the customer IDs. So we get these tables together. And then we can group this now by our grouping sets. So we say grouping sets. And now what are those grouping sets? Well, our first grouping set is just the total customer, let's say. So this means we have first name and last name as our first grouping set. First name and last name. And our second grouping set should be now the combination of the customer and the staff ID. This means that we use first name, last name, and now also the staff ID. So this is the two grouping sets that we are using. Let's see if we have everything done. Of course, we have a little mistake. We should say on those columns. And now let's try again. We get now our solution. So this was how we can use the grouping sets in our group by clause. In the previous lecture, we've seen how we can use grouping sets in our group by clause. And now we can use cube and roll up again in the group by clause to create predefined grouping sets. So this is just making the work a little bit easier for us. So let's have a look at how those two functions work as a subclause again in the group by clause. So for example, if we have the roll up and we use those three columns, then there will be just a hierarchy created between those columns. This means that column 1 would be the highest level of the hierarchy. So for example, this could be a hierarchy of the months and the quarter and the year. So the highest level would be the year. Then we have, for example, the quarter and the month. And then the result would, just as I've mentioned, create also a hierarchy of our grouping sets. This means we have as one grouping set just the overall total of everything, which we get by just using opening up the parentheses and closing them again. Then as the next level of the hierarchy, we have in our case the highest level of the hierarchy, which was, for example, the year. And then after the year, we have the next level, which is the combination of the highest level and the second highest level. For example, the year together with the quarters. And this would give us the subtotal of year and quarters. So this is how we can use this roll-up function. And of course, we have also then the lowest level of the hierarchy, which could be, for example, just every individual day. So we have the combination, for example, of year, month, and the individual day. So this is oftentimes used in exactly this scenario. When we have, in fact, a hierarchy, such as, for example, the months and the year and the quarter, and we want to create now a calculation, a query, that is returning all of the individual grouping values plus all of the subtotals and the overall total. So let's jump right into pgAdmin and immediately have a look at how we use this rollup function practically. In this case, we want to also create a hierarchy now in our payment table. So in this case, we want to have first the quarter. This is the highest level. Then we want to have also the month and the individual days. So let's first create these different levels of the hierarchy. We can start, as we've mentioned, with the quarter. So we could, for example, use the toChar function. We use the payment date and we want to get the quarter. So we use just Q to get the quarter as a format. And we can also combine that just with a standard Q. So this we can just concatenate. So just that it looks a little bit nicer. And this gives us then this result of these quarters. So we get Q1, Q2, and so on. And then we can also, of course, give this a name. So, for example, as quarter. And the same thing we can also now do with the month. So we can, for example, use the extract function and we say month from payment date. And again, we can give this an alias, for example, month. And this gives us now the combination of quarter and month. And of course, last but not least, we also would like to see the individual day. And of course, what we should not miss is, of course, also the aggregation. So we want to sum the amount. And then we have our different levels of the hierarchy. But now, of course, we need to group it. And we could decide to create our own different grouping sets, but this can be a little bit more complicated if we want to get exactly all of the individual subtotals and the overall total. This is why we would in such a situation decide to use just the roll-up function to create these grouping sets for us. So in our case, we can just now copy exactly those same levels of the hierarchy. We just have to make sure that the first column that we use is also the highest level of the hierarchy. Because in the roll-up function, as we have seen, the order really matters. So this will be considered the first level of the hierarchy, then we have the second level, and then the last level. So in here, it is really important to match the correct order in this roll-up function. And if we execute that, we get our results. But now, oftentimes, the order is not really that way that we want to have it. And this is why typically, if we use the rollup function, we use exactly this same order that we have also naturally in our hierarchy. This would mean that we start just with the highest level. So we use first column, quarter, then the second column, month, and then the last level of the hierarchy, the date. And now if we execute this, we get exactly this, what we were trying to achieve. So let's have a look at what we get. We get first the most detailed level. So every individual day. We start, of course, with the first quarter, the first date, and then once this month is over, we get the total of this month. And then we start with the individual days of the next month, till this month is again over, and we get again the total of that month. And that continues now until this quarter is finished. And then we get the total of this entire quarter. And then we go again to the next quarter until we are done with everything, when we also get the overall total. So this is oftentimes, as I've mentioned, used when we do have such a natural hierarchy. But sometimes we don't have this exact hierarchy, and it could be that one value, for example, the date, is an individual customer. And then the next level or the next column would be, for example, the staff ID. And in here we don't have a really natural hierarchy, because one customer can buy from multiple staff IDs, from multiple stores. So there's not a natural hierarchy that one customer can only buy from one specific store. So this is what we have in this natural hierarchy. One day can only occur in one specific month, and one month can only be within a specific quarter. If we have such a natural hierarchy, we can use the roll-up. Otherwise, we can also go with the so-called cube function. And that's what we are going to have a look at in the next lecture. In this challenge, you have the chance to practice the rollup function. So you should write a query in this challenge that calculates the booking amount, so a rollup of that with all of the individual hierarchy subtotals for the hierarchy of quarter, month, and week in month, as well as the day. So the result should look like this. We have the highest level quarter, month, and then week in month, as well as the day. And then the sum should be the booking amount. So you can, of course, if you don't remember or if you don't know the function to get the week in month, we have learned about a function that you can use. And a very common thing as a SQL developer, a SQL analyst, is also to just research something. And that's why I also want to give you here this chance to just research how you can get the week in month. If you want, I can give you a hint though, so that you don't need to research so much. But if you want, of course, you can also do it without the hint. Then just stop the video now and go about to solve this challenge. Here is otherwise the hint. If you want to use that week and month, there is a function we've already learned about, and as a format, the pattern, you can use just the W, which will give you the format of week and month. So this is the challenge. Good luck with it, and afterwards we'll have a look together at the solution. Let's have a look at how we can get those subtotals using the rollup function. We, of course, first have to open up our database. So this means that we have to go to our demo database, and in here we just right click and go to query tool. So make sure that if you have this query editor open, that in this window it says demo database, so that you are really operating in the correct database. And in here we now first want to create this level of these hierarchies. So we can start with selecting, first of all, maybe everything from the bookings table, so that we know how the data in here looks like, what are the column names, and so on. So let's start with creating the hierarchy. We use the book date, and first of all, our highest level is the quarter. So we use the toChar function. We could also use the extract function, so we can say extract quarter from book date, and then we have already our quarter. We can also, of course, name it as quarter, and then the next level would be the month. So we can again use extract month from the book date. And this is again now the month. And now the next level would be, in our case, the week in month. And for that we use the toChar function, because here we can define our formats. So we use the book date again, and from the book date we use the format of the week. So we have used the week, we have maybe researched that, or we have used the hint, and there we see that the W is used for the week in month. So if we have a look at this, we can execute it again, and we see there must be some little mistake. So we have not this A, and now let's try again. So now it looks good. We have now all of those different levels that we want to use. Last but not least, we also want to use just the date itself, and then we have everything. So now we only need to use the book amount, so that's the total amount. And then once we have also that aggregation, we can start with our group by. And in here we of course want to use the roll up. And now we just use that exact same columns. So we have already the correct order. That's why we can just copy it, and then we are good to go. Of course, we should not use those aliases in these columns, so we can just remove them in here, and then we have everything that we need. Of course, we can also add the order by, so we say 1, 2, 3, and 4, because we have 4 different hierarchy levels, and this will give us the overall result of all of the individual subtotals and the total at all. In the last lecture, we've seen how we can use the rollup function to create predefined grouping sets. And now the same thing we can also do using the cube function. Again, we use that as a subclause of the group by to create predefined grouping sets. But now we don't use a hierarchy, and we don't get only specific combinations in grouping sets, but we get all possible combinations of grouping sets of the columns that we have inserted. So here the order doesn't matter, because anyways we get all of the possible combinations. So for example, we get the overall total. Then we get also every individual column as a grouping set. And then all possible combinations of just 2 out of these 3 columns. And of course, we get also the combination of all of those 3 columns. So all possible combinations of grouping sets. Let's jump into pgAdmin and immediately see how this works in practice. In our case, we want to see what are the totals per customer, per staff ID, per day. And we want to see also all of those subtotals. But of course, in this case, there is no natural hierarchy, because one customer can buy with different staff IDs. So there's no natural hierarchy in here. So that's why we first want to use the columns that we want to see grouped by. So we have the customer ID, we have the staff ID, and also the day. So we use the date function and we insert payment date. So then we want to, of course, aggregate. We use some amount, and now we want to group by. And now we don't define our grouping sets, but we use the cube function. And in here we now just enter, as we have seen it previously with rollup, also just those columns that we want to create the grouping sets for. So then once we do that, we can also again order the result, because oftentimes again the order is not exactly what we want. This is why it can also make sense to order the data. In our case, we again just use exact that same order that we have also used the column with. So this makes sense in our case. That's why we are doing that. And now the result of that is, first of all of the individual sales per day for one specific customer and one staff ID. And then once this is done, we get the total of that staff ID. And then we get all of the sales again for every single day with the next staff ID. And then once we also have what was the total amount of that customer and that staff ID, we also get the last combination of how much this customer has made on every single day in total. And then once we have reached that, we also get the overall total of that customer one. So this is the next combination. And then again, we start with the next customer. And this goes on until we have all of the customers seen. And then in the end, we also see the last customer and how much the staff ID 2 in this case has made for this customer, and then how much this customer has made in total in every single day, and then overall in total. And then, of course, we also have what has every staff ID made on every single day. So independent from the customers. And then we get also all of those values. And then, of course, the total of what this customer has made. So you see, these are all possible combinations that we can get. And of course, in the end, we get also the overall total amount. So this is what we can do if we want to get also all of the subtotals, but there's no natural hierarchy and different combinations matter. So this is a situation when we can use the cube to create our predefined grouping sets. In this lecture, we want to have a look at the so-called self-join. This is in fact nothing really new, but it's just a common technique that we can use when we have a so-called self-reference in a table. This means we have, for example, a table like this, where we have all of the employees with their employee ID, and then an additional column with the manager ID. And that column is just specifying what is the manager of this employee. So this is basically just referencing the employee ID of the same table. This means if we have here a 1, we have the manager who is employee with the employee ID 1. So Liam Smith would be the manager of Oliver Brown. So what we could do is just use now a join with the same table again, where we just join the manager ID with the employee ID. And then from there, we could take also the name from that joined table, which is the same table again. And then we take here manager with the ID 1 is Liam Smith. So this is the idea of a self-join. It's nothing really new. And we now just step by step want to see how we can achieve that result in practice. So we have seen that a self-join is nothing but a standard join, just with the same table again. So we use just the same table twice. So in our case, this is the employee table. What we have to be careful with is that if we are using such a self-join, we always have to give an alias, because otherwise it will be exactly the same table name. And it's a good best practice to name it in such a descriptive way that the table name is representing the purpose or the use case of this table. So one table serves as the employee table and the other one serves as the manager table in our example. And then we can create the join on the columns manager ID from our original employee table, and this should be joined to the employee ID of the manager table, so of that second table that we want to join. And now we can just fill up these columns that we want to use from those different two tables. So the first one, of course, just from our original employee table, the ID as well as the name. We can also give this an alias, and now we can also use the name from that joined table. So this will be then the name of the manager. So you see that a self-join is nothing really new, nothing really complicated. And we now want to see how this looks like in practice in pgAdmin. And note that also you can find this code in the resources attached to this lecture. So you can just copy and paste it and execute this code along with me. So step number 1, we are just going to set up this employee table. And of course, we need to insert some values. So we are going to execute that insert command. And now we have this table where we have again the employee ID, the name of the employee, and then this manager ID, which is just referencing the employee ID. And now what we are trying to achieve is get also the name of the manager. So let's see step by step how we can achieve that. We start with selecting everything. We can just first start with everything and then we change the values later from the employee table. Now this is serving as the employee table, so our original table. And now we also want to create a join. Let's use a left join on the same table again, which is now serving as the manager table. And now this should be on the columns we have from our original employee table, the manager ID. And this should be now equal to the employee ID of the manager table. So we use that self-reference that we can see in that table. And now we can just decide which columns we want to see. So we can, for example, say from the employee table, we want to see the employee ID. We can see the name of the employee, name, and then we can also use from the manager table also the name. And now we can also give them aliases, so for example employee, and also in here we have, for example, manager. And now if we execute this, we should get our desired result, and of course we could also decide to order it in a different order if we wanted to do so. And now what we could also do is from here we could now create even a second self-join. So if we wanted to see now also the manager of that manager, so for example, who is the manager of Liam Smith? No one. Who is the manager of Oliver Brown? It would be in this case Liam Smith. So we have these 3 levels of the hierarchy. So in this case, we could achieve that by just using another join on the employee table again, but this time we call it manager2. And now we want to use from that manager table, so let's use manager, the manager ID. So what's the manager of the manager basically? So we say manager ID, and this should be now equal to the employee ID from the manager2 table. So now we can use employee ID from that second table. So this is now in the beginning maybe a little bit complicated, but again, if you just do this and type this out yourself, you will get familiar with it and understand how this works. So if we execute that, of course, we should now also add the manager of the manager. So we can say management to the name, and we can say this is manager of manager. Then if we execute that again, we should get our desired result. So of course, we have now no one that is the manager of Liam Smith because he's the top manager, and we have Oliver Brown, and of course of Oliver Brown, the manager is Liam Smith. This is what we can see also in here. We have Oliver Brown, manager of him is Liam Smith. So this is how we can create even such a multi-level hierarchy with the self-joins, if we have some column that is just referencing the same table again. In this challenge, you should now apply what you've learned about the self-join to find all of the pairs of films with the same length. So this means we want to get a list. For example, we have the title with that muscle bride, and then all of the films next to that have also the same length. And what you need to make sure as well is that something like this doesn't occur. So that the same title is next to each other just twice, because in that case, this is not a pair of a film, and this should be not present in your query output. This means you need to also add one condition in your self-join that is preventing that you have the same title twice. So this is your challenge to practice and apply what you've learned about the self-join in a new way. So good luck with this, and afterwards we'll have a look together at the solution. Let's have a look at how we can achieve this result by using a self-join. So first of all, we can add the titles immediately. So we have title, we can see that, and we have also the second title from the second table. And of course, we need to give them aliases. So we say F1 is our first film table, and then F2 is our second table. And of course, now we also want to get the length. And the length, it doesn't really matter where we take it from, because the length can be from table 1 or table 2. This doesn't make a difference because they should have the same length anyways. So I'm just using it from the table 2, and we use just the length from that table. And of course now we say from the film table F1, that's the first table. And now we make a left join on the same table again, but this time we just name it F2. And on what do we want to make the join on? Of course, from the first table, it should be the length, because this is what should be matched. And of course, in the same table, then again, we also want to use the length. And now if we execute it just like this, we get what we wanted to prevent. Of course, we can also order in a descending order by the length. So we say by length in a descending way. And then we see that there's something that we don't want to get. And this is that we get the same title again. So this is just matching because, of course, the same movie has the same length if we take those two tables. And this is why we should also add one additional condition. And this we can introduce with AND. And then we can also say our second condition is, for example, that the film ID or that the title should not match. So this is, for example, F1, title should be not equal to the title of F2. So we can use title again. So this should not match. This is the second condition, that we cannot have the same title twice. And if we execute that, we get exactly our result. Of course, now in this case, we get also setter name. So we could just filter it. So we could say where title is not equal to each other. And then if we execute that, we get also the same result. This is just now filtering out those titles that have the same name. So this is how we can use that self-join to get all of that pairs of the same length. In this lecture, we want to have a look at the so-called cross-join. This will basically just create the Cartesian product. This just means that we get all of the possible combination of rows. Let's have a look at the following example. We have one table with two rows. So the first value is A and the second row contains the value B. And then we have this number table where we have three rows, 1, 2, and 3. And if we create now the cross join of that, this means the Cartesian product of that, we get all possible combinations. This is now resulting in 6 rows. So if we have in one table 2 rows, in the second one 3, we multiply 2 with 3 and we get then the resulting 6 combinations. So it's always the number of the rows of the resulting table is basically the product of the number of rows of the first 2 tables. So this is always the case. And this is even the case if we have duplicate values, because this cross join is not looking at the values in these tables. It just creates all combination of rows. So not all combination of values, but all combination of rows. This means, again, we get the same number of rows in the output. And now, just as we have duplicates in the initial table, we also in the cross join result have those duplicates as well. And now let's quickly also have a look at the syntax, which is very simple. We just use the columns from the 2 tables that we want to see. And then we just use first table name and afterwards just cross join the second table name. And of course, we don't need to specify on because there's no relationship between those tables. So we don't need to use any columns to create a relationship between them. We just use cross join and then the second table name. So let's quickly jump into pgAdmin to see a quick example of that. In our case, we want to see from the staff table. So let's quickly see everything from staff. We see this is the staff people. So for example, we want to see the staff ID. And also we want to see from the store table, the store ID. So let's again in a separate query see everything from the store table. And there we want to get now those combinations. So in this case, we want to get the staff ID from the staff table and from the store table, the store ID. So this is a column that is also present in the staff table. This is why we use just the store prefix. So we make now the cross join to the store table, and then we should get now, because in both tables we have 2 rows, we should as a result get now 4 rows with all of the possible combinations. And of course we get now here a little mistake. So let's fix that and then again try to execute the query, and we get all 4 possible combinations. And of course, we can now add additional columns. So for example, we can say we want to see also the last name, and there we want to have this included. And of course, this is possible, and this is now just adding this column. Of course, we can now also make calculations. So for example, we could say we want to multiply the store ID with the staff ID. So we can use these kind of calculations as well. And then we get also the result of this multiplication. So this is what we can do using the cross joins if we want to get all possible combination of rows of 2 tables. And we just need to make sure that this is not the combination of values, but the combination of rows. In this lecture, we want to have just a look at the so-called natural join. This is nothing really new, but it can make our work much easier. So a natural join is just working as a normal join that we already know. But we can save a lot of work because in a natural join, just the columns for the join will be automatically determined by the same column name. So if there are two tables with the same column names for the join column, then we can use a natural join to join those tables without typing out the column names. And the syntax for that is also super simple. So we have, for example, just all of the possible columns from the payment table, and then we want to make a left join to the customer table, but we want to use just the customer ID because this is just the same name in both of the tables. So we could just use a natural left join. So left join will be just the join type, and then we just specify before that the keyword natural join. And then the columns will be automatically determined. If they have the same column name, they will be used. So this is also, of course, working with different join types. So for example, we could also use an inner join. But now let's immediately jump into pgAdmin to see how this works in practice. In our case, we want to, as we have mentioned, use now a join from payment to customer. We can use all of the possible columns from payment, and now we want to use a natural inner join. And this should be now to the customer table. And if we execute that, we get our results. So we would see that now there will be a few rows returned. And this is now everything from the customer table and the payment table. So for example, we could use the first name, the last name, and then also the amount. So let's use an aggregation, sum of the amount. And of course, we can also add a grouping. So let's group this by first name and last name. So note that we don't specify a column for our join. So if we would execute it like this, we get our join and our grouping without having to specify that we use the customer ID for that. So this is just helping us to avoid a long way of typing if we are sure that the column names that are used for the join are really the same. And that's something I want to stress, because in the next example, we will see that this can sometimes cause some problems. For example, if we select everything from address, and now we want to make a join to the customer table. We know that in the customer table, let's also have a look at that, we have also, of course, the address ID. So we could assume that we can use just a natural join to the address table. So we use a natural join, so for example, an inner join to the address table. And now we could think that this should work, but if we execute it, we don't get any result. So in some way, the join has worked, but we don't get any rows returned. And this is now, if we have a closer look at the columns, we can see in our table, if we go to the address table, so let's open up first the address table. We see indeed we have the address ID, and also in the customer table, we also have the address ID. So this is what we know. But now there's one thing, that there's also the same last update column that's also present in both of the tables. So we see this is in both tables, and this is why those two columns were used. And of course, then in this case, there were no matches found, and this is why there are no rows returned. So that's something we just have to be very careful with, because such columns such as last update or maybe also create date, these are columns that are typically in many tables. And that's why if we are using such a natural join, we really have to make sure that we get the results that we are expecting, and that they are really only those columns with the same name that we want to use indeed for the join. So that's just something to keep in mind. Otherwise, we can use it to just save a little bit of time. We can also extend the functionality of SQL by using so-called user-defined functions. Later on, we'll also talk about so-called stored procedures, which is something that is very similar, but we'll talk about that stored procedures later on. For now, it is enough to know that we can extend the functionality using those user-defined functions, for example, to make some more complex custom calculations. And for these functions, we of course usually use SQL, or to be more precise, it it is recommended, that's the standard, to use pgSQL. This is just an extended version of SQL and also has a better performance if we use that inside the user-defined functions or the stored procedure. So this is the default that we should go with here. And we can also use additional so-called sandbox languages like Python or C. Sometimes we need to install them, load them additionally, such as Python. And also this is something that is called unsafe languages, because we need to have access to external resources, and this allows to bypass some securities. This is why this is referred to as unsafe languages. And of course, we should be very careful with that, but usually we should just go with the safe language, so the standard pgSQL, which of course makes sense because we are working on a database. So how do these user-defined functions work? Let's have a look at how we define those functions step by step. So of course we use the create command to create the function. We add the name of the function and then of course also the parameter list. So these are then parameters we can insert into the function, and then they will be used in our calculation in the function. And afterwards, we need to specify the data type that is returned by that function. So this is something we always have to do. And then we specify what's the language we want to use. So as mentioned, the standard is just pgSQL. And then we start with the body of the function. And we start with using the S and then also these double dollar signs to start the body and in the end also to end the body. So this is what we do. And inside this body, we can declare variables. So something that we can use within the calculation to make it a little bit easier. And this is something we see how we do that. And then of course, the function definition itself. We do that by begin, then the definition of the function, and make sure to always, after all of the definitions and declarations, to use also these semicolons to end one command basically. And what we now want to do is we want to create a function that takes two arguments, in this case just the example 3 and 4, and this should now add those two values together and also add the value 3. So this is a number that will always be the same, always add 3 to this function. So in this case, the result, if we call that function, would be just, of course, 10. So let's see how we would create this example function. Of course, in the beginning, we use the name. We call this first function. And as you have seen, this is the name of the column that is then returned as well. So the name of the function. Afterwards, we, of course, have to specify the parameters. So first one is C1, which also has to include the data type. That's very important that we do not forget about this data type in the definition of the function. So we name the parameter and then the data type as well. In our case, we have two parameters, both of the data type integer. Afterwards, we want to return, so that's the data type that should be returned of the function, is an integer. And in our case, as usually, we use the language pgSQL. And now to the body of our function. In here, we declare the variable C3. And the data type, of course, we also have to mention, is an integer. And again, we use the semicolon to end our declaration. Afterwards, we have the function definition. In here, we can just now select C1, these are the values we have inserted, plus C2, plus the number 3. So this is now just a normal select. We end it with a semicolon. But of course, we should also return that value. And before we can return that, we use the variable for that, we store that select result into, and this is the syntax, select, and then after the select into the variable, and then we can just return that variable. And again, make sure to always use those semicolons after each command. So we select our calculation and write the result into this variable. Then we want to, in the end, return the variable, and then we end our function definition. So we have begin and end. And then after we have also added the semicolon in here, we also use now these double dollar signs. So this is how we define those functions. And now, of course, we want to, because I know this is a little bit more complex, we want to see this live in action. And of course, you also have an additional challenge to write a function yourself. Let's have a look now at a practical example to create such a user-defined function. What we want to do is we want to create a function that is calculating or counting the number of films that are within a specific range for the rental rate. So we want to insert two parameters, a minimum rental rate and a maximum rental rate, and then the number of movies within this range should be returned. This is the function we want to create. So let's start with create function. The name of the function should be count rental rate in our case. And we want to, as mentioned, insert two parameters. The first one is the minimum rental rate, and of course we should not forget about the data type. In our case this is decimal for 2, so we can insert the rental rate. And the same thing we also do for the maximum rental rate. So we just call this, in this case, maximum rental. And now, of course, after we have done that, we also need to define what should be the returned data type. So we use returns, and then in this case, it should be integer because we want to just count the number of films. And afterwards, of course, as usual, we define the language, and as this is the common standard, we use pgSQL. And then once we have this defined, we can now start with the body of our function. We do this always by introducing s and then the double $sign to start the body of the function. And now we can start with declaring a variable. So we say declare, and now what could we use as a variable in our case? We do it in the same way as we've done in the previous example. We just use that variable to store our final result. That's just a good best practice and helps with the readability and the usability of that function. So if we do that, we can, for example, call this movie count. And again, we have to define the data type. And this is an integer in our case. And now that we have this variable, we can start with the definition of our function in itself. So we start with begin. And now we just select count star from the film table. And now we, of course, want to add also our filter condition. So this should be where rental rate is between, and now our two parameters that we have inserted into the function. So this is the min rental rate and the max rental rate. And then, of course, what we need to do is we need to end this command with a semicolon. But now we have not stored the result into this variable, which we always do right before the from and after our selects. So this would mean we say into and then the variable names. And then this result will be stored in this variable. And of course, now that we have this stored there, this is what we want to return. So we just return and then the variable. And again, we end it with a semicolon, and then we can end our definition of the function. Again, with a semicolon after the end. And now in the end of everything, of course, we need to also end the body of our function with the double $sign. And now that we have all of that, let's just execute that and see if the function is created successfully, which indeed it is. And now we can see if that function is really doing what we want. So let's select that function. We have called it count_rr. And then if we insert that name, we of course also have to insert now our two parameters. So let's say the minimum rental rate is 0 and the maximum rental rate, let's say it is 6. And let's see now how many films we get returned that are within this rental rate. And as we see, all of the films seem to be within this range. But now what if we use the number 3? Let's see what happens. Now we have not so many films again in this range. And this is now really doing exactly what we have defined in here. And we can even see that if we use that manually, so if we say select count star from film where rental rate between 3 and 6, this should now give us exactly that same result. So let's execute it, and indeed we get exactly the same result. So this is how we can create user-defined functions. And now it is your turn to put this into practice yourself and apply your knowledge in the following challenge. In this challenge, we want to now create a pretty cool function that expects the customer's first name and last name as parameters. And it should return the total amount of payments this customer has made. So this means if we select a function and we insert first name and last name, we should get as a return this value of the total amount of that customer. And this function can then do pretty cool things, which we'll also have a look at then afterwards. But now it is your turn to apply your knowledge and create that function to calculate that total amount. let's have a look at how we can create this function. We start with, of course, as always, create function. The name of the function can be name search. And now we insert the parameters. We want to have, of course, the first name and the last name, but we should be a little bit careful to not use exactly that same column name. This is why we should use, in this case, first name, fname, and then the data type of that is varchar 20, for example, and then afterwards we have also the last name. We can just give this parameter name lname. And then varchar again 20. And now we can of course also say the return again should be in our case a decimal. We can say 62 just to be sure we have a large amount that is possible to be returned, and also make sure to use returns. And then the language as we have it usually is pgSQL. And now the body of our function, we start with s and our double $sign, and then we declare the variable, and again we can use the total, so that what we want to have returned by this function. We say total, and again the data type needs to be of decimal 62, again the semicolon we shouldn't forget, and then we begin. And now what is our select? So we say select sum of the amount, and now this should come of course from the payment table. But now, since we also want to insert and use the customer's first name and last name, we need to make a join to the customer table. To make it easy for us, and yeah, let's be a little bit lazy, we can use the natural join, because we know both of the tables contain the customer ID. So we can just use a natural, for example, left join to the customer table. And then we can now filter by the first name and last name. So where first name is equal to, now we use our parameter fname. And also we want to say the last name should be equal to our second parameter, the last name. And then of course we need to write that result into our total variable. So we shouldn't forget about this, as always, right before the from. So we say into and then total. And now we end our command with the semicolon, and afterwards we end the definition of the function and our entire body of the function. So this is the function. Let's see if this works, and indeed we have successfully created that function. And now let's of course test it if it works. So for example, we want to test it with Amy Lopez. So we say name search is the function name, and then we use Amy as the first parameter argument, and then we also use Lopez as the second argument. Now let's see if this works if we execute it like this. So we see this didn't work. And of course, this is now showing us that we have without return, because in fact we have forgotten about returning also our value. So this is why before we end this definition, we also need to return the value. So this should be total. And then we can end it. And now we can easily adjust that function by using create or replace. And now let's again execute it. And then we will have a function that should now work. So now let's again try to execute that command. And again, now we see that this function is giving us our expected result. And the cool thing is now that we can also use that function in our select in the entire table query. So we can say we want to see, for example, the first name, maybe also the last name, and then we can also use now our function. So name search, and we need to insert, of course, two arguments. So we want to insert the first name as the first argument and the last name as the second argument. And then we can just say from the entire table. So this should be now from the customer table, because we use first name and last name. And now what happens is we get all of those results row by row, because now just every column contains first name and last name, which will be also now inserted into our name search function, which is then going through this calculation that we have made in here. So this is how cool these functions can be, and I hope that this could demonstrate how this works and give you a little bit of practical experience with these functions. In databases, sometimes it's important to work with so-called transactions. A transaction is just one unit of work, and one unit of work can contain one or multiple operations, but they form a unit. A very typical example of that is a bank transfer. So this would be a transaction because we want to move for example, $100 from one account to another account. So we don't want to update the values one by one, so that just at one moment this one is, for example, 2,400, while in the same time we don't have placed the money in the other account, but we want to have this taking place as one unit of work. So this is when we want to use a so-called transaction. Let's see how this transaction works. We start our transaction, this is very important, with the command begin transaction. We can also use begin work, this is exactly the same, but most typically we even use just begin. This will also begin our transaction, and that's the most typical use. So then once we have started our transaction, we can use our operations. So for example, we update the first value and then we update the second value. And then if we have not committed that transaction yet, it will not be visible in other sessions. This means especially for other users. One session is, for example, if we as one user open up the query tool in the window. And then if we open up the query tool again in a separate window, this would be another session even if we are the same user. So one session is just what we are currently doing in our query tool. And then, of course, if there's another user, this will be always a new session. And what's important about the transactions is that if we have not committed them, they will only be visible in our current session. So we can see that those operations have taken place, but the other users will not see them. So it will not be updated for them. And then, of course, if we are happy with the result and we have formed those operations that form a unit, then we can commit it, and then the operations will take place also for the other users. So what we want to do now is we want to jump into pgAdmin and implement exactly this enc transfer to demonstrate how the transactions work. And again, you can use that code that is just attached in the resources in this lecture. So you can just go and work along with me. Of course, if you want, you can also just type this out manually. So the first step that we are going to do is we first just create this table with an ID, first name, last name, and then the amount that this user has currently. And we then want to also insert these values, and afterwards we want to see now those are those two values. And what we now want to do is we want to make this transfer. So this means we start our transaction with begin. We can execute that, and then we see, okay, now our transaction has begun. And now we can use our operations. So for example, we say update the account balance table and set the value amount to the amount minus 100. So we subtract 100 from the amount where, and now we want to take this from the user with the ID 1. So we say where ID is equal to 1. And this will be our first command. So if we do that, we execute it. Now we can have a look at the table. In our current session, we can see if we execute it, it has taken place. So we see ID 1 has been updated and there has been subtracted $100. But now if we open up the query tool in a new window, this will be a new session, and in here we have also, of course, this table available. So we can say account balance. So select, let's say, everything from account balance. This will work because the table is there, but this transaction is not committed yet. This is why we still see, of course, the original amounts. And then if we now also update the second value, we can do that as well. We can just copy and paste that. And then we see, for example, in this case, we now, of course, want to add 100 to the account with ID number 2. We update that again and again in our current session. We see the values are updated, but if we go to the other session, it will still not be affected. And now, of course, if we now are happy with it, we have formed our operations, we can now commit the work. So we say now it should be committed, and now it is also visible in the other sessions. So we see now those values have also been updated. So this is how we can use transactions to form units of work that belong together and that should only be committed after we decide to commit them. This is one important thing about transactions. We can later on see that they are also useful for so-called rollbacks, which we are going to have a look at in the next lecture. But before that, of course, you have now the chance also to practice and apply this yourself. In this challenge, the two employees, Miller McCarter and Christelle McKenney, have agreed to swap both their positions and their salaries. And now we need to implement this in SQL. So this is a table that we have used in an assignment before. But if you have not done this and if you have not created that table before, you can also just find this file in the resources attached to this lecture. So this is your challenge to implement this swapping of position and title using transactions. So good luck with this challenge, and afterwards we'll have a look together at the solution. Let's now have a look at how we can implement this swapping of the position and the salary using a transaction. So we can start our transaction immediately with begin. And afterwards, we want to update. Now, let's first execute this begin. And now we can update the values. We can also now just query and have a look. So now if we update the value first of the Miller McCarter, so we say employees set position title to copy that value from here, and we of course have to use the quotes for that, and then of course we say this is where employee ID is equal to 2 because we want to update Miller McQuarter. So the same thing we also want to do after we have used the semicolon also for the other person. So this is then head of BI, and this time we want to update the ID with ID number 3, and this should be then head of BI. And afterwards we also want to update the salaries, so we can also just implement this in the same transaction, and in this case we want to use the salary, and in this case we use the value of employee number 3, so this should be this value. And then for the other one, let's again just copy that. We say this is now for employee number 3, and we use the salary of employee number 2. So we paste that in here as well, and then after we have done that, we can commit our work. Now let's step by step update those values. We have already begun our transaction. Now if we update the values, we see it is updated already in our session in here. So we see the value just at the bottom. We could of course also just order it by the employee ID. Then we would see it is updated, but not in any other session. So if we would open up a new session, then we would see that in here, of course, it is not updated yet. And if we go to our previous session, it is of course updated. And now we do the same thing also for all of the other values. We can check now, this is another benefit, if this is really updated correctly. So we see everything looks fine. We have now swapped around those two values, and now since we have checked that this is everything correct, we can commit our work. And now it is also implemented in all of the other sessions. So this is how we can use the transactions also in our challenge. But now, what is after we have started the transaction, we have checked the update, and we see that there has been made a mistake and the results are not correct. How can we now go about that and take advantage of transactions in such a situation using so-called rollbacks? That's what we are going to have a look at in the next lecture. In the previous two lectures, we've already learned about begin and commit. Those are two of 3 transaction commands that we can use to control our transactions. So we have begin and commit, but we can also use a so-called rollback. This is just undoing everything within the current transaction that has not been committed yet. Because once we have committed that, it is committed and we cannot undo it anymore. But within a given transaction that we have not committed yet, we can roll back all of the operations of that transaction. So for example, if we have something deleted that we didn't want to delete, then we can roll that back in that transaction. Of course, sometimes we have a lot of operations and we don't really want to roll back everything because maybe at one point we have made a mistake, and this is why we can luckily also use so-called save points. So we can set them and then we can roll back to exactly this save point. Of course, the save point works only within a current transaction. So again, once this is committed, it is committed and we cannot roll back anymore to this save point. We can also, if we want, delete that save point by using release save point and then the save point name. Now there's also one small difference between rollback and rollback to save point. That is that a rollback, if we just use rollback, it's ending the transaction. So we are not within our transaction anymore. But if we use rollback to save point, we are still within our current transaction. We just rolled back to our current save point, and also those previous operations we have not committed yet. So we could also decide to roll back the entire transaction after we have just rolled back to the save point. This is how we can control our transactions. Let's immediately also have a practical example. So we first of all want to start our transaction. And now maybe we want to update a value. So we want to subtract 100, and this is correct. But maybe just by accident we have again subtracted that value. And this is not what we want. So we could of course also just remove that value or update that again. But maybe by accident we do something that is even worse. And this would be to delete a row. And in that case, we cannot get this back so easily. Maybe we don't know what these values were. And this is when we can just use our rollback, because we have not committed our transactions yet. And we can still roll back to the state before we have started our transaction. And then all the values are there again. Of course, we have to be aware that now we are not in our transaction anymore. So we have to start our transaction again. And then if we now again try to update those values, we decide to make a save point because we see that this result is correct. We have checked that. And this is why we want to create a save point, maybe as 1. And now again, maybe we have deleted something that we don't want to delete. So it's not there anymore, but this value should still be the same and we don't want to go through the other operations again. This is why we can just now roll back to our save point. So if we roll back to our save point as 1, we see that we have been rolled back. And now again, we see still this value of 1,600. And we have to be aware that now we are still within the current transaction. So if we would begin again, this is not working because there's already a transaction in progress. So if we now want to commit them, we still have to do that. And we have to say commit. And this would now commit all of our transactions. So now this would have worked, and we have used the save point also to just make sure that everything that comes after that save point, we can just go back to that state, and this can help us within our transactions if we have many operation steps in a given transaction. In the previous lectures, we've learned about the user-defined function. But the problem is that this user-defined function cannot execute transactions. This means we cannot make use of the commit and rollback statement. So if we, for example, wanted to make some transaction like a bank transfer, we could not do that using functions. So this is where we typically use stored procedures, because now they do support those transactions. And luckily, the syntax and the way those stored procedures work is very, very similar to the functions. So let's have a look at the general syntax of the stored procedures. We can just use again the statement create procedure, the procedure name, then of course all of the parameters including their data types, and also similar to the functions we can use create or replace. If this procedure name then already exists, it will just be replaced by this new definition. And now if we have a closer look at how this procedure is defined exactly, we'll see that this is now very, very similar to the user-defined functions. The only difference that we can spot in here is that we do not have this returns and then the data type. This is because the stored procedure does not return a value like the user-defined function does. So this does not work in the same way. And we have seen in the function that we have returns, then the data type, and we also have return in the end, and then a certain expression, a certain value that is returned. And in the stored procedure, this is not possible. So in the stored procedure, we do not have returns and then the data type, as well as we don't have return and then an expression. We can, if we want, use return just by itself. This will immediately stop the stored procedure, but we cannot return an expression like this. So now let's have a look at an example, a typical way of using a stored procedure. We have in the previous lecture seen in the transaction that we can make a bank transfer with a transaction. So we want to just transfer a certain amount from one person to another person. And this should be considered as one unit of a work. But now we don't want to do this over and over manually. We just want to specify in a stored procedure the amount that should be transferred and from which account to which account the transfer should occur. So we have like this one complete stored procedure that is doing this exact bank transfer for us, and we are only specifying the parameters. So let's have a look at how we can define that. We just first of all, of course, give the name of this procedure, then all of the parameters including their data type, so the amount that should be transferred and the IDs of the sender and the recipient. And now we can just define the body of this stored procedure. So we have, first of all, we update the sender's balance. So we can start with that. And afterwards, we have another operation that is now to add the balance to the recipient's balance. So this is when we can now commit our transaction in the stored procedure. And now if we want to call that procedure, we can just use call, the name of the procedure, and we can specify, of course, the values for our parameters. So if we want to now use our own defined stored procedure with our 3 parameters, we could, for example, say we want to transfer $100 from the sender with the ID 1 to the recipient with the ID number 2. And then this would have been transferred using our stored procedure. So let's have a look at how we can do that practically in pgAdmin. We see that if we select from our account balance, we have this amount in those 2 balances. And now we want to create a stored procedure. So we say create procedure. The name of the procedure is SP transfer, for example, and we can also, as we've learned, use create or replace if the procedure would already exist. And then we can specify what are now the parameters. So we can say we have the transfer amount, which should be an integer or a decimal. This is up to our definition. And then we have the sender and the recipient. And both of them should be in the data type of integer. So we use integer, and now the language we again can stick with pgSQL. And then we can just start with the definition. So we can now say begin, and now we have our first transaction. So we can again give some comment in this stored procedure so that it's easier to understand what this stored procedure is doing. So we can say add balance, for example, and like this we could now update the recipient first. So we can say update and then the table account balance. So we say account balance and set the amount column to amount plus now the value of the transfer amount. And this should be done where the ID is equal to our recipient. So we can just copy that, and then after that we have our first operation. So now we can also say we want to subtract the balance from the sender. So we now just have to change this to a minus because now we subtract from the sender. So we say where ID is equal to sender. And after that we can now commit this transaction. And then we can also end the body of our stored procedure. And like this, we have now, if we execute that, defined our stored procedure. So let's see if we have done everything correct. Of course, we have forgotten about starting our body. So we say as, and then we start with these double $signs. And now if we execute it, we have created our stored procedure. And now if we want to call that stored procedure, we can just use call and then the name of the procedure. So in our case, it is SP transfer. And now we can insert the values. So the amount, for example, we want to transfer, let's say $500 from account 1 to account number 2. And after that, we can execute that. First, we want to now check again if this transfer has worked as we expected. So we say select everything from account balance. And if we execute that, we see that now the transfer has worked. So we can now try to do it again. So we transfer again the same amount. And now if we check again, we see that again this has worked. And if we do it again, then we see it will be transferred again until almost there's no more value left in the account number 1. So this is how we can use a stored procedure. And as we can see on the left side, if we want to have a look at our existing procedures, we can just, of course, refresh again our schema. And then if we have a look at the procedures, we see that now there's this procedure available. So we can right click, go to properties, and in here we could now modify our definition of the stored procedure. So in the code, we could, for example, say we want to now multiply the amount with 99%, so 0.99. And then this is maybe some kind of cost that we have, and then we can save it. And now if we would execute it, we would have this implemented as well. So this would work now as well. So this is how we can use a stored procedure and how we can call that stored procedure again. And now it's your turn to apply this knowledge in the following challenge. In this challenge, you should create now a stored procedure called emp_swap, and this accepts now two parameters, emp1 and emp2 as an input, and this stored procedure should now swap those two employees with those two employee IDs, and it should swap their position and their salary. And you can test then the stored procedure with employee ID 2 and 3. So we have seen that in the previous lectures that we can do that using transactions, and now you should create a stored procedure that is doing that for us. So this is now a little bit more difficult, and this is why now I want to give you a little hint. So here comes the hint. The hint is that you need to use variables, because now we need to copy values from one place to another place. And this is why we want to use, in our case, 4 variables, because we want to copy basically 4 values. And then later on in the update, we can use those variables. So you can define them just by defining again the name of the variable, then the data type, afterwards a semicolon. So good luck with this challenge. Let's have a look at how we can solve this challenge, which is a little bit more difficult, because now we need to copy those 4 values, and for that we need to use variables in a specific way so that we can really make this copying work as we want to do that. So this is the tricky part, but we will see step by step how we can solve that. So first of all, let's start by using create. We can use create or replace procedure. And then we have the procedure name. We can, for example, use emp_swap, and then our parameters. This is just emp1 and emp2. So both of them are just of the data type integer. And the language, as always, will be just pgSQL. And now we can start with our definition. So we can just start with s and our 2 $signs. And now, as mentioned, we first need to declare 4 variables. So there will be 2 variables for the salary. So we copy the salary of employee 1 into salary 1, salary of employee 2 in salary 2, and so on. So let's start with that. We say declare salary 1, and the data type should be the same as it is in here. So we can use decimal A2 or numeric A2. This is exactly the same. We use decimal A2, and then we use the semicolon, and now we can just copy and paste it for salary 2. And the same thing we also now want to do for the position. So we have position 1, which is a text, and then we should also have position 2. So again, we can just copy and paste it, and then we have defined our variables. And now we can begin with our operations. And first we need to now copy those values into salary 1 and salary 2 and position 1 and position 2. So how do we do that? We've already seen that, how that works. We use select. Now we can use salary from the employee table, and this is where we need to also filter. So salary 1 should be now where employee ID is equal to 1. So we say equal to 1, and of course we need to also write this value in the variable. So we use salary 1, and of course we need to use into salary 1. So this will now write the salary of employee 1 into the variable salary 1. So now we can just, after we have done this operation, copy that. So we can also, of course, give it a name. We can say store values in variables so that it's easier to understand our code. And then we can again just copy that and now do the same thing just for salary 2 with employee number 2. And then the same thing, of course, we do again with our position. So in this case, we are just selecting, of course, position, so not the salary, and then the rest is the same. So we use position title, and we save that into position 2 of employee 2. And again, the second one, we can again just copy that, and I'm going to paste that in here. So in here, we just need to swap around those values. So now we have twice the salary, so salary 1 and salary 2, we have position 1 and position 2. This is how we have now saved these values into our variables. And now we want to update the values. So we can first update the salary, for example. So we use update the table employees, and now we want to set, of course, the salary to salary 2 of employee 1. So of employee 1. This is where emp ID is equal to 1. So we update salary 1 with salary 2. And the same thing, we can again, of course, copy that. We also do now for the opposite. So salary 1 should be updated for employee number 2. And now the same thing exactly we can also do for the position title. So we can again just copy everything. We say we now want to update the titles, and then we paste that as well. So now in here we just use position title, and in this case it should be position 2, and then we can again just copy that. Just make sure to not copy too much, and then we paste it in here. Of course, now we need to just swap around the values, and then we have defined all of our 4 operations, including the definition of our variables. So we have 4 definitions. We have then also 4 times copying the value from the right place and then updating those 4 values as well. And after we have done all of that, we can commit and then also, of course, end our stored procedure. So we use again the double $signs, and then we execute it, and we have created our stored procedure. Now, of course, let's test it if it's really doing what we want. So we have emp swap, and we also want to say, let's just test it with employee 1 and employee 2. We execute it and see there's some problem, so we need to fix that. So let's see, column salary does not exist. So let's see where we have this problem. We see that this problem is occurring in the definition, so it must be somewhere here. So we see select salary does not exist. Of course, this is now because the table is not called employee, but it's called employees. So let's also fix that. We see employees, 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 and in all of the places we have now corrected that, and this is how we can see that this is a little bit tricky because, of course, salary does exist, but not in the table employee. But we can see that we can find out those problems also. And now again, we just write the same procedure using create or replace. And now let's try it again and see if we have fixed all of the problems. Indeed, this has worked, but of course we should check now also the result. So let's select everything from employees, and we see if we also, of course, we should order it by the first column, so that we see all of the effects in the right way. And we see now indeed 1 and 2 have now changed their position. So now employee 1 is head of sales instead of the CTO. And we can again swap that back, and then we should see again that the first one is the CTO. And of course, if we have a look at the salaries, this is also working if we execute it again. So we see that also the salaries have been changed accordingly. So I know this was a little bit more difficult, but we are now also on a level that is pretty much advanced, and this is why I also want to give you sometimes the chance to practice something that is really a lot more difficult than in the beginning. Hope it was helpful, and see you in the next lecture. If we are working on a database, sometimes we need to deal with new users, and we need to assign some privileges to those users. We need to assign maybe certain roles to that users, and this is why we now also want to have a look at how we can manage the users and their privileges and their roles. So far we have only accessed the database as a super user. So we are basically the admin and we have all of the privileges. But now sometimes, as mentioned, we want to create new users that also have access to certain tables, and in this case they should not have, of course, all of the privileges all of the time. So some users should have a very restricted access, maybe read-only access to a certain table. So this is what we want to see how we can do that. In general, if a user creates a new object, by default, they are the owner of that object, which means they are able to modify and delete that object as well. But then for the existing objects, so tables that already exist, we need to assign those privileges, we need to grant them, and that's what we see how we can do that. So some of these privileges are, for example, the select privilege on a table, so that this table can be selected and view the data in the table. We can see the insert, update, delete, and truncate privilege and usage privilege on a schema, so that if that people don't have that privilege at all, then they won't even be able to see that schema. But we'll step by step see later on what exactly those privileges are and how we can grant those privileges. For now, we just want to get the overall idea. So the overall idea is that we can create new users. We'll see how that works in the next lecture. And then we can also assign privileges to those newly created users. But what we can also do is we can create roles, and then we can assign privileges to the roles, and then internally again assign those roles to the users. So like this, it can be a little bit easier to define certain groups and assign specific users with the privileges of a specific role. So let's see how this could look like in practice. For example, we have a new user called Sarah, and Sarah is an analyst, so we want to define a role with the select privilege on a specific table, and she should see a specific schema where those relevant tables are living in. So we assign those privileges to the role analyst, and then again we assign this role to the user Sarah. And maybe there's now another new user where we also want to assign this role analyst to. So this is the overall idea. And now step by step, we want to see how this works in practice and how this can be implemented on examples. So we want to start with having a look at how we create a new user. That's what we are going to do in the next lecture. In the last lecture, we've seen how the overall user management works, and now we want to see how we can create users and roles. The general syntax for that is very simple. We use, if we want to create a user, create user followed by the username, and then with password, and then this is the password of the user. And I want to mention two general things that are important to understand. First of all, per default, when we create a database, there's always the schema public included. And now for this public schema, when we create new users, these newly created users will always be able to use the public schema. This means that they can create objects in that schema, and they will be able to see those objects in that schema. And this is why later on we'll of course also have a look at how we can revoke certain privileges from users. So this is something that we should just keep in mind. In general, this is the schema that should be accessible for the public anyways. This is why per default this makes sense, but we want to also see how we can, if there's the need for that, revoke these privileges also from users. The second thing that is worth noting is that a user, when we create that, we get this message. So create role. And this is because a role is nothing but technically a user plus a login. And this means that if we want to get exactly the same thing, we can also use just create role with login. And then this will do exactly the same thing. Of course, technically this is the same, but usually a role will be just assigned to other users, and this is why a role typically doesn't have a login. So that's why we can just in the daily work stick with the intuition. A user is just create user, and if we want to use a role that can be assigned to other users and there's no login needed, we can just stick with create role. But this is just a little technical difference that I wanted to mention. And now before we see how we create this user in action, we also want to mention, of course, we can also use drop user, drop role to drop those users and roles again. So this is not very different from all of the other objects that we have already seen. Now let's jump into pgAdmin and see immediately how we can create those new users and how we use those users then. So for example, we have two additional users. First of all, we have the new user, Sarah. We set the password Sarah1234. Of course, this is not a secure password, but in our case, there's nothing sensitive, so we can easily use a very simple password. And then if I execute that, we see, as I've mentioned, create role. So this user has now been created, and we have here this password. And the same thing, we want to demonstrate that as well, is if we create role with login, then this will also create in the same way a user, and we will also demonstrate that. So let's also execute that second command to create also the user Alex. And now we want to use those two users. And how do we do that? If we go to our server, we are currently connected as the super user. So this is the user Postgres, the default user with all of the privileges. But if we go to this server, we right click and go to properties, and then under connection, we see that this is the current user, Postgres. But now, for example, if we wanted to use Alex, then we can just type in the username, and if we click on save, we see this message to apply changes. The connection needs to be disconnected, and then we need to reconnect to the server. So that's what we have to do. We click on OK, and now right click, and first we want to disconnect from that server. And now we can reconnect with these new credentials. So we go right click and then we go to connect server. And of course now this is a new user called Alex and we need to enter the password. So we have Alex1234 and we have, of course, in this case we don't need to save the password, but we could, and then we click on OK and now we are connected. So now we see again our database. So we see green cycles, and if we can refresh it, we see that this schema is visible, the public schema. And we can also see all of the tables inside. But what we cannot do is to query from those tables. So what we first need to note that this current session, this query editor window, this is the session that is connected to the Postgres user. So we could now not use this session with our new connection, with our user Alex. So if we would try to do that, we would see that the application has lost the connection and this was maybe idle, and we can try to establish a new session. So we do that, and then we see that we have not the permission to create the role. So this is not possible for us. And if we now want to use a new session with that new user, we can right-click on the database and go to Query Tool. And now in here we see that this username is now visible as well in this query editor window. So that's our session. And now, as mentioned, we can see the tables in the public schema, but we cannot select them. So if we say select from customer, for example, we would get an error message because we don't have the permissions for this table. But what we can do is we can create our own objects in the public schema. Per default, this is possible. So we can say create table, a very simple table name, for example, test table, and this just has maybe an ID column with a data type, let's say serial. And now if we create that, we can do that. And of course now this table we can select from, because this is now our table that we have created and we have all of the privileges. We can select everything from the test table. And then we can see that now we can select from that table. And we can also insert values, and of course we can also drop that table again. So we can just copy that and then we can drop that table as well. So we have all of the privileges on that table. But now we have seen that for the customer table and all of the other tables, we don't have those privileges. And this is why we now also want to see and learn how we can assign privileges to our users and our roles and work and manage those privileges. That's what we are going to learn in the next lecture. In the previous lectures, we've seen how the overall user management works, just an overview of that, and how we can create users and roles. And now we want to have a closer look at how privileges work, what they are, and how we can grant them. In general, they are what the users or these roles are allowed to do. That's what we call privileges. So for example, select a table, and this enables then the user with this privilege to see that table using a select statement. So this is the general syntax. We grant, for example, one specific permission, for example, a select privilege, on our database object, in this case, the customer table, to then the user or the role that we want to assign this to. And some of these privileges are applicable on table, some are applicable on schemas, and some are applicable on a database. So we will later on see this in a little bit more detail. In general, we want to already mention the usage privilege is very important because this enables the user to see a specific schema and all of the objects that are in this schema. So per default, every newly created user has the usage privilege on the public schema. This means they can see the schema and all of the objects in that schema. And we can also grant permissions on all tables in a schema. We use for that on all tables in schema. And we can even grant all privileges on specific database objects or also on all tables, for example, in a schema. In general, only the super user can grant privileges to other users. But there's also the so-called owner of an object. This per default is the one that has created this object. They can also grant privileges on that object to other people. But we can add in our grant the statement with grant option. And this then enables the user or the role, for example, in this case, Nikolai, to grant this privilege again to other users as well. This is when we add with grant option. And in general, of course, we can also revoke privileges. The syntax for that is very simple and very similar. We just revoke a privilege on an object, and now instead of to a user, we say from a user or a role. And again, we can use public, and then this is the public default that also everyone that's newly created can do. And now we make it very, very specific. We can even revoke privileges that were granted by a specific user. So for example, we can revoke all privileges on a specific table that were granted from one specific user. So that's something that's now a little bit specific, but we have also already mentioned that. And the same thing we can also revoke for the grant option. In this case, we say revoke the grant option for the privilege on the database object from one specific user, role, or public. And again, we can use even in here granted by one specific user or one specific role. But now let's make this a little bit more practical. So let's have a look at this list of the important privileges. We see in here that most of the privileges, and this is very intuitive, are applicable on tables, or the select is also on table-like objects. So of course, select can be also granted on views or on materialized views. But we can even, for inserts, updates, and also for selects, grant the privilege on table columns only. But of course, if we have a look at usage, this is applicable to schemas, or create is also applicable, for example, to schemas. And then execute, of course, to functions and procedures. So this is not so complicated as it looks in the beginning, because in general, this is very intuitive. But now let's have a look at the most important privileges and the most commonly used privileges, how this works in practice. How do we do that? We can, of course, in the beginning create a user, Amar, with one password. And then we can now, as I've mentioned, grant usage on a schema. This is what we usually do in the beginning, because usage enables that user to see that schema even, and to see the database objects in that schema. So otherwise, we have not the access to the schema, we don't see the tables, and then everything from there doesn't make any sense. So this is why in the beginning, unless it's the public schema, we should grant usage on a schema. And afterwards, we can grant all of the privileges, so for example, select and update on tables that we want to do, and this is how we can start. But we can also say we grant all permissions on all tables in the schema. And we can also even do that on a database level. So that's also possible. And we can also, per default, this is not available, grant the privilege to create databases. So this is something that's a bit specific. That's why I want to mention it. We use for that alter user or role and then create DB. And this will give the privilege to create databases. So that's something we just do on a user level. And we can also, as we have learned, grant roles or users to users. So as we have mentioned, a user and a role is technically not so different. This is why in general it works with users as well. But of course it is more common, more typical to grant roles to a user. So for example, we create the analyst role and we want to now grant all of the privileges of that role to, for example, the user Amar. And of course, we can also revoke our privileges. So for example, we revoke the insert on one table from the user Amar. And again, we can revoke all privileges on a table called customer from public even. So that's something that we can also do for all of the users. So this is sometimes also, of course, important. And again, we can revoke the entire role as well. So revoke analyst from Amar, for example. So this was now what is important about the privileges. And of course, let's apply this knowledge and put it into practice in pgAdmin. In this lecture, we now want to have a practical example of how we can create users. We also want to create roles. And of course, we want to grant privileges to those roles. And then in the end, we want to, of course, assign the roles to our users. So this is the entire process that we now want to have a look at step by step. And you can, of course, as always, find in the resources the code so that you don't need to also type everything yourself, but you can quickly work along with me. So the first step is to create our two users. The first user will be Ria. We create her and also the password along with that. And then secondly, also user Mike. And now we want to set up two different roles. And of course, we want to define different privileges to those roles. So the first role will be read only. And here we only want to grant the select privilege. And then also we want to have on top of that another role that should have the privilege to update also our tables. And then the next step is usually, of course, in the public schema, this is not necessary, but otherwise we would have to grant usage privilege on the schema that we want to work on. In our case, the public schema has this per default, so it wouldn't be necessary, but this is just an example for that usage. And now the next step would be to also grant select. Because now at this point, we would not have the permission to select the table to query from it. And this is why we also need to use the grant select on all tables in the schema public, and we want to assign this to the read-only role. And if we execute that, we should now see that this role is able to select the tables. And now if we want to also assign the people, so the users, to our roles, we can say grant, and now we want to say read only to, and let's say for example Mike should be read only, then we can assign this to Mike. And if we execute that, we see this works, and now we can test Mike at first with this role read only. So what we do is we just disconnect from the server, and then we just change the properties. So we go to properties, and in connection, we now just type Mike that we have just created. We save that, and now we can just reconnect. Of course, now we need to enter the password. So we can say Mike123 if we want. We can also save the password. And now if we open up a new query tool for the GreenCycles database, we will see that now Mike is connected. And now we can, for example, select everything from the customer table, for example. And then we will see that this will work because Mike has select privilege on the tables. But of course, he could not delete from that table. So if we, for example, say delete, and I put also a filter from customer where customer ID is equal to, I use the value 33, and this should not work. So we see permission was denied. And of course, also update won't work. So we can also say update the customer table. And in here, we should, for example, say the address ID should be updated, and this should be set maybe to a value like 2, and then we would also see that this would not work. So if we do that, we try to do it, we see again permission was denied for that table. But now we want to also set up our second role, and we want to test if that second role is able to update this table then. So for that, we want to first of all disconnect from the server again and connect again using our super user. So if we do that, let's change the properties first, then we go to the Postgres, and afterwards we need to just again disconnect and connect again. So we go to disconnect, and afterwards we go again to connect. And then we can now try to continue, and we want to set up now also the read update role. So first of all, we can use the read only role to give all of that privileges from the read-only role also to the read update role. So with that second role, we can also now select the tables. But now we want to have additional privileges for that read update role. That's why we use grant all on all tables in the schema public. That's what we are doing in here. But now all is a little bit too much. This is why we decide to revoke, delete, and insert from that read update role on all tables in that schema. So if we also execute that, we see this has been now revoked as well. And now, last but not least, we also want to grant now this role to the user Ria. And if we execute that, we are now ready to have a look at Ria and see if she is now able to update the values in this table. So if we now open up again the properties, we can change the connection to Ria. And of course, now we need to disconnect and connect again. So disconnect, and then afterwards again connect. And then we enter again also the password Ria123. Again, we can save it if we want. And now if we open up the query tool again for the GreenCycles database, then we can now try again to delete values which should not work, and we can try to update values which should now work. First of all, let's select everything from the customer table, and then we want to see if that works. So this works indeed. That's very good. But now we want to also see if we can delete values, which should not be possible. So we want to say delete from customer, and we can also say where customer ID is, for example, equal to 33. And this should now not work. And indeed, permission denied for table customer. But now we should be able to update the table. So let's say update customer, and we want to update maybe, let's say, the customer where first name is equal to Mary, and maybe we want to say this should be renamed to, so we say set first name to Maria. Maybe there was some renaming, and this is something that we now want to try. So let's execute that, and we see that we have, of course, forgotten about this equal sign. So let's fix that. Let's try it again. And now we see this indeed has worked. So this is now possible. And now we also, let's disconnect again and connect to our super user. So we use again Postgres, because we now want to see if we change quickly here this connection. So again, first disconnect and then connect again. And now we want to see how we can also drop roles and drop the groups also. So this can sometimes be a little bit problematic. For example, if we want to drop Mike, this works. But now if we try to drop the role read update, this will not work. Let's also use drop role read update. Then we will see that this is causing some errors. We can see that the role cannot be dropped because some objects depend on that. And this means that this has been assigned to a user, and we have also used privileges that were granted to this role. And these dependencies now make it difficult for us, at least, to drop this role. But if we have this problem, we can first remove all of those dependencies. So we can say drop owned by, and then everything that's depending on that role is dropped, and we can now also drop that entire role. So this is then possible. This was now a practical example of how we can manage our users and our permissions. If we talk about indexes, we usually want to increase the performance of our queries. And if we talk about query performance, so how much time a query needs to be executed, we can distinguish between two different types of operations. First of all, we have read operations. So whenever we select data, we want to return data, then we talk about read operations. But sometimes we also have write operations. So we want to insert data, we want to update data, and if we want to use indexes to improve the query performance, we talk about read operations. So those type of operations we can increase the performance of using indexes. This is why in the next few lectures we want to start to first of all understand how are indexes actually working, what's the technical background, and we want to understand this so that we can talk about different types of indexes as well, and we want to make it of course practical and give some guidelines, because sometimes this is a little bit tricky how we should use indexes. This is why we want to give also these practical guidelines. And of course, we also want to have a hands-on demonstration of using indexes in our database. So let's get started with the background and understanding what actually are indexes and why do they help us to improve the performance of our query. To understand the indexes, it's a good idea to have a look at how the data is actually stored in our database. Because of course, on the outside, we see a table with columns and rows, and everything seems to be in a well-ordered place, and this is actually not how the data is stored in the background. Because in the background, the data is stored in such rows, in blocks on the database, and the data will just be placed, so those rows, wherever there's currently some free space available. So the important thing here is that there's no particular order of our data. And this is not so efficient if we now want to read the data. Of course, if we write the data, this is very efficient because we just write where currently we find some free space. But now if we, for example, want to execute this read query, we want to see, for example, the product ID of one particular customer. And now if we want to fire up this query, what the database system is doing, it needs to look all around the entire table and scan wherever there's a customer with the ID number 5. And this so-called full table scan is taking up most part oftentimes of our query. So this can take up a lot of time and really reduce the performance of our read queries. And this is where we can now benefit from indexes. So what is an index? If we, for example, place an index on the customer ID, the data will be sorted and we will have an additional table with the location of all of the different values. So for example, we have customer ID number 4. We can see in the first row, we have this customer ID with the value 4. So location is 1. Row number 1. And then we have the next value, which is a 5, and this starts at row number 2. And like this, we can just use that table to avoid a full table scan and quickly see where are the values and retrieve those data rows much, much faster. So that's the general idea of indexes. We can use them to make data selecting, so data reading, much faster by avoiding those sometimes very time-consuming full table scans. But on the other side, also we need to mention that these indexes can in fact make data writing a little bit slower, because now we also need to maintain this additional index, this additional table, and also this additional table can take up some additional storage, but oftentimes we have to say that storage is not the big issue nowadays, because storage is very cheap and oftentimes is not really what we are concerned with. So this is why we want to use indexes. And in the next 2 lectures, we now want to dive a little bit deeper on the different types of indexes. So the first one, and that's the most important one, is the so-called B-tree index. That's the default standard index that we usually talk about. But we also want to talk about the so-called bitmap index. And that's what we want to start with now in the next lecture, to understand those B-tree indexes. In the last lecture, we've talked about the general concept of indexes. And now we want to dive a little bit deeper on the different types of indexes, because they are good in different types of situations. And it's good to just also understand that there are in fact different types. So if we talk about an index, we usually mean the so-called B-tree index. So if everyone is talking about placing an index, what they mean in general usually would be the so-called B-tree index. There's also the so-called bitmap index, which we also quickly talk about in the next lecture. But now we want to focus and get a little bit of a technical understanding of what's going on behind this B-tree index. This is just good to understand how this general concept of a B-tree index works, so that you know what you're talking about if someone is mentioning a B-tree index. The name of this B-tree index comes from how the structure of this index is, because in this it is structured into a tree. So the data is basically broken down into these different tree structures. So let's assume we have, for example, a text column, maybe some names. Then we can just break down those names into the first character starts with an A, and then maybe we have the different second characters A, B, and A, C, and then we have the list of all of the different values that are in this leaf of that tree. And now maybe there are 10 or 15 values. So here we would start, of course, with the first row. And this is then therefore getting the value 1. And now maybe there are 14 different values. And then in the next leaf, we start now with the number 15. And maybe here there are now also, let's say, 5 different values. And then we go to the next one. And then we have 20. So row number 20. So those numbers are basically just referring to the row number. And we use this tree structure to break down our data into different buckets. And now the main question is, when do we want to use this so-called B-tree index? This is always when we have a so-called high cardinality. High cardinality in this case means that we have a lot of different values. So for example, typically a primary key is of course unique. So every value occurs only once. This means we have a high cardinality. And this is why we have usually on the primary keys, because they have a high cardinality, means every value is different. This is why this is a candidate usually for the B-tree index. And also what we have to mention, which is true in general, we should not place this kind of index, in fact, no type of index, on an entire table, on all columns in a table. But we should be very specific about where we want to place those indexes. And that's also what we want to have a look at in the guidelines. But for now, we first also want to have a look at the different index, which is the bitmap index. And after that, we want to have a look at the practical guidelines and then also a hands-on demonstration of how we can set indexes in our database management system. In the last lecture, we've learned about the B-tree index, which is the standard index. But now there's also the so-called bitmap index, which is a special type of index that can be especially good if we are working on a data warehouse. So this is a type of index that is beneficial, especially for large amounts of data in combination with a low cardinality. So for example, if we have only a few different values in our table, but the table itself is huge. So for example, one column can only take 3 different values or maybe only 2 different values, then this is a low cardinality, and then a bitmap index is a good choice in our data warehouse. Because the benefit of that is, since the data is stored in so-called bits, we will see later on how this works in a little bit more detail, it is very storage efficient. And on top of that, it is also very good for the read performance, with the downside that it is not so efficient for our data manipulation. So if the data needs to be updated or inserted, in this case, it is not so efficient, but we can basically live with that a lot better because we are in a data warehouse and the most part is getting the data out, so reading the data. And that's why a bitmap index is usually a very good choice if we have a low cardinality in our data warehouse. But now, how does this bitmap index work? So we have this table, and of course we now also want to create a structure that helps us to avoid full table scans. And in this case, we don't use a list, but we use bits. So this can look something like this. We have the different payment types, and we see that there are only 2 different types in our case. And this is why we can now create different maps basically that are telling us in which rows we find which values. So for example, for the value Visa, we can find this value in row number 1 because there's a 1, and in row number 2 also because there's also a 1, in row number 3 there's also a 1, and then in the next row we see that in row number 4 there is a 0, and that's why we cannot find the value Visa. But if we now go to the value Mastercard, we find in row number 4, yes, it is turned to 1. That means, yes, there is a value Mastercard. And this is then how basically there can be a map created that helps to find in which rows we find which value. And as mentioned, this is a very good strategy if we have not so many repeating values, because then this is a very efficient method. So now that we have had a quick introduction into those 2 different types of indexes, we now also quickly want to get some guidelines on how we should go about using those indexes. For which columns, in which tables, in what situations do we want to use which of those indexes? So that's what we are doing in the next lecture. In the previous lectures, we've already learned that indexes can help us to get the data faster out of the database and with that increase the performance of our database. We've heard first about the B-tree index, which is the default index. So if there's nothing else specified and we just talk about an index, usually we refer to this standard B-tree index. And this is a good choice if we have unique columns, or at least columns with a very high range of different values. That means a high cardinality in this column. And this is typically something on the surrogate keys. This usually just means the primary key in our tables. And for example, also on phone numbers, on maybe addresses, on names, if it's a full name, because those are usually very rare in having duplicates. So this is something that can be helpful there. And note also that this B-tree index is usually also per default set on our primary key. So we don't always need to explicitly denote this index, but it can be already set up automatically on our primary key. If, for example, we have our primary key in our database, then there will be also usually automatically an index created on this column. Then on the other side, we have the bitmap index, which we've learned has the downside that it is slow in the updating and inserting, and we have the benefit that it's super storage efficient due to saving the row locations in bits, and it is also extremely good in the read performance. And with that being said, we now want to also understand how should we go about creating indexes. The first question is, should we put now, since we have these benefits, an index on every single column in our entire table? So of course the answer to that is no, because we've already seen that those indexes come with a cost. First, because they can really require significant amount of additional storage, and also in the creation and the updating it is really a bit slower, and that's why also we don't want to go too far into just creating an index for every single column, because this will then also slow our update and our inserts down, and all of that needs to be maintained. So that's why we should really think about when we want to use those indexes, and we should only use them if they are necessary. That means if we experience slow query performance due to the full table scans, because with these indexes we have learned that we want to avoid those full table reads. And this brings us to our first guideline, and that is small tables don't require any indexes, because even if we have an index on them, usually the query optimizer is not even using that index, or it is not giving any additional benefit in comparison to a full table read. So this is our first guideline, to use only these indexes on large tables, especially if we experience a low query performance and we need to filter the data a lot. So with that first rule of thumb that we should only use those indexes for large tables with a low query performance, we then want to ask the question, now on which columns should we place an index? And the answer to that is to those columns and also to those tables that also often need to have the data filtered. And then if we, for example, use a filter on, let's say, the customer ID very frequently, and this is a column that is used to just get maybe 10% of the table, then we can place an index on that exact column, because this will then help to avoid this full table scan if we only want to retrieve, let's say, 10% of the data. So this is the column that are then the good columns for using an index. So these are the very general guidelines that we can use to increase the performance of our data warehouse by using indexes. And in the next lecture, we now quickly also want to see a short demonstration on how we can set up such an index on a specific column in our data warehouse. So that's what we are doing in the next lecture. Now that we have learned when we want to use an index, this is if we have large tables, we should not use indexes on small tables, and also on columns that are not frequently updated. So if we have a table that has a lot of write operations, we don't necessarily need those indexes. But if we experience a bad query performance on large tables, then we should use the indexes on columns that are oftentimes used, for example, in where filterings or in joins. And we will now see a hands-on demonstration of how we use an index and how this can increase the performance of our queries. So first of all, let's have a look at the general syntax of creating an index on a column in a given table. So we just use the statement create index, the name of the index, on which table we want to create this index, and then we can optionally specify what type of index we want to use. So we can say using and then the type of index we want to use. But again, the default, if we don't specify that at all, is just the B-tree index, which in most cases is the best choice. This is why it's also a default choice. And then we can place in the parentheses the column names that we want to place this index on. So we can optionally create an index on multiple columns. But as I've mentioned, if we just want to go with the standard, we just use create index, the name of the index. We don't need to specify the method, but we just go with the default and then also the column name. So usually we place an index on one column. But as I've mentioned, it's possible also to place it on multiple columns. And this we would do if we would, in general, oftentimes use in our queries multiple columns, for example, in the where filtering, all in one query. So in that case, we could also consider a multi-column index, so multiple columns in that index. But now we also just want to see how this works in practice, because oftentimes we just need to test things and see how much this is improving the performance of our given query. And that's why we now immediately want to jump into pgAdmin to see how we can work with this index and how this can improve our performance. So first of all, we just want to get a quick look on our payment table. We see the query performance is good. We don't need to wait very long until this query is returned. Of course, our table is also not very large, so only 16,000 rows. But for example, if we want to use a subquery that we have already seen is a bit expensive, so for example, we want to take the average on the amount on, for example, the column rental rate. So this means we create from payment, and now let's use this correlated subquery, which we have learned can be quite costly. We say this is P2, and now we say we are P2.rental ID. So we want to make this based on the rental ID. Then we can see that this will take a long time. So if we do that, let's close the subquery in here. And now let's give this also P1. So in this case, we just create a correlated subquery. And let's see how much time this needs now. So we can wait basically very, very long time. And this can take a lot of time. So I have fast forwarded, and in fact it was 24 seconds. So you see, in your case, of course, the number can be very different, but it takes a long time. And this is because over and over, we need to make a full table scan to find all of the right rental IDs. So this could be a situation where if we want to place an index on that rental ID, we can avoid those full table scans and improve the performance of this specific query. So if we have many queries that are of this specific type, where we use the rental ID in a filter, then we could improve that query performance for such type of queries. So let's use now an index. We create index. We can call this index, let's say index rental ID, and maybe also the table, so payment. It's a very long name, but we want to place this on the table payment. And we use the default index, and we just specify now the column rental ID. And if we create this index, we see the index has been created. And now let's execute this query again and see how much time it needs. Wow, now it's less than 1 second. So it's now super, super fast. And if we now drop this again, so we say drop index, then we just copy and paste that, and then we see that this will now again take a very long time until it's executed. So now we've dropped that index, and if we execute our initial query again, we will see this will take again around 20 seconds. So we can see that if we use an index, we can really improve the query performance quite a lot. And now that we talk about the query performance, we can also use that so-called explain tool, which is just breaking down our query in the different components. So the table scan or the index read and all of that different components take up some time. And this explain tool will help us to better understand how our query has been executed and maybe also how we can improve the performance of that query. So that's something we also now want to have a quick look in the next lecture. So if we execute it, we have our code selected. We can see that in this example, we see that now here this index has been used. Whereas if we wouldn't have this index, so let's again drop it. So I'm selecting that and executing that. And now I select that same again, and I'm again explaining. So this is F7. We see that now this index is not used. So this is something that we can use to better understand how this query is executed internally, what are the steps, and how we might also improve our query performance. That's what we want to have a closer look at in the next lecture. In this lecture, we just want to have a quick look under the hood of our database system. In this case, we want to have a look at the so-called execution plan, the query optimizer, and the explain feature in pgAdmin. So if we want to understand how our query is executed under the hood, we need to have a look at the so-called execution plan. The execution plan is telling us what has been done internally to retrieve the data so that we can see it in the data output. So for example, if we make a table join, we can have maybe 3 tables that have to be joined. And in this case, there can be maybe the first table that is first joined with the third table. And then after that, the second table is joined. So you can see that the sequence, the order can be different. And also maybe there can be different methods, different algorithms to join tables. Sometimes there can be an index used, and sometimes we just use a sequential scan. So you see that there can be different methods, different ways of getting our data into the output. And the query optimizer's job is to find the best way, the best path to retrieve the data with the best performance. And we can now use the explain tool to have a look at this execution plan. So let's have a look at how we can do that. For example, if we have a look at this very simple query, we can use explain, and in here we see the execution plan. And this is now not really how the query will be executed for sure, but this is just an estimate. So for example, if we use that estimate on our very complex query, we can see if we use explain that the result will be there very quickly. But if we want to get the actual plan that was used in fact in real time, and also how much time was actually needed for every individual step, in that case we need to use explain analyze. And then the query will be really executed in real time. And also you have to be aware that if you make some updates in this query or some inserts or some deletes, this will actually also take place because the query will actually be executed. But we have much better estimates of how long every step takes. And this is why sometimes we can use the explain analyze tool to get real results. And in this case, if we want to see the exact times, we just need to check this timing box. And now if we have this checked, we can also analyze this query. Of course, in this case, this query takes a lot of time, and this is why we also now need to wait until this entire query will be executed, and then maybe we can find some way of improving the performance of this query just by analyzing our execution plan. So in this case, again, 22 seconds, and we can see if we have a look at this first step, which we want to select, we can see this is the node type of sequential scan. And afterwards, there was an append, so all of the rows have to be appended. Then we have to have this aggregation, so we take the average, and all of those steps we can now see in this execution plan. And in this case, we see the table scan. If we scroll down, there has been a lot of time, so the total time that was needed for this individual step. And we can see that also if we go to the statistics. Here we see the time spent. If we scroll to the bottom, actually in here we have to read it from the bottom to the top. So the bottom step is actually the first step. And in here we can see that this sequential scan, so every row is just scanned in a sequential manner, and this will be done in our case for the entire table. And this sequential scan is sometimes, as we have learned, not the most effective way of looking at the data in the table. And this is why, if we again have a closer look at this step and we scroll down, we see this is where we have lost most of our time. And now in this filter column, this can oftentimes give us a good indication of which column could benefit from an index to improve the query performance. So in this case, we see the rental ID has been used. So if we now use that information, we could place an index on the rental ID. And now we could again analyze the query plan. So in this case, we use explain analyze again, and we see the result is now much faster. And in here, we have not used this sequential scan, but we have used an index scan. We can also see that in the statistics that now this is much faster and the sequential scan is now also much lower. And you can see that after this quick sequential scan, there's this index scan. And in this case, the query optimizer has also decided to create a bitmap and use also a bitmap index scan, bitmap heap scan. And this is just something that has been done internally. And this is, of course, creating some kind of overhead that this bitmap has to be first created. But apparently, the query optimizer has figured that this would be the best solution to get a good performance for this specific query. And in our case, we want to now also go back and have a look at another query. So for example, if we would just make a quick select on this rental ID column, and we also have maybe some filtering, and then we can see if we now again explain analyze, we can see again there has been this index scan, but now if we have a look to the statistics, we see that this is now an index only scan. And this is now because we have only that column that is the actual index column. And this is now enough, so we can get all of the information just by looking at the actual index, because the rental ID is the index, so we don't need to look at the table itself. We can just look at the index table. And in this case, we get this index only scan. And now I think it's also interesting to have a look at a join. So if we execute this join with explain analyze, we can see that again, in this case, there has been this table scan and then this type of left join. And you can see that in this case, there's a so-called hash left join. That's just one type of algorithm that is used for a left join. Usually this hash join is the best in terms of performance, but we can have also some situations. For example, in here, if we also have maybe some filtering, some limits, then we can also have a different type of join. So a different algorithm that is used, which can give, in this case, better results. And that's what the query optimizer has decided and has figured out, that this could be in this case a better solution. So in this case, it was a merge left join. And of course, in this case, we also had some limit. So if we limit the data by 100, we also get this limit step. And maybe we can also say we want to order the data. So we say order by 1. And in this case, we of course also get an additional sort step. And in this case, even now we have used again a hash left join. So it's sometimes not so predictable what the query optimizer decides to do. But in most situations, if we want to improve the query performance, we could do so by, for example, using an index. If we, for example, see that some table scan, some sequential scan takes up a long time, and then we can figure that for this query, we, for example, might benefit from an index. So hope this was giving you a quick and short introduction into the execution plan and into the query optimizer and how you can use this explain tool as well as the explain analyze tool.